just like that. But everything you can manage that through Wi-Fi. You use that on vSphere client or something like that. Okay, another one is about this device, similar thing. This device can plug into this display directly with that HDMI. Set up my Wi-Fi environment in my home, and then can use my laptop to use that vSphere client to log into that EX host to manage that. I'll show this one. Even you can use yourself to log in Wi-Fi to manage this EX host. So you still use that vSphere client. Last one is about, as I mentioned, I can remote upgrade the EXI on this platform. This web UI is very simple. One is in this device, another one in the VMC cloud that has a public IP address. Web UI in this agent, actually they can manage the local, it can connect many that devices in the one local vessel to manage that. What do you need to do? Just upload which new EX version should be uploaded right there and send out that command. You can see ESI command successful created, upgraded, command created. In another screen, you can see when I connect to this device that EXI 6.5 will be shut down and then reboot, and you can see EX 6.7 is running, and all VM just back up. Okay. I think this is something I was trying to talk about today. So, do you have any question? Or? Not Raspberry Pi. Both are x86 based platform. Okay. But I think this solution is CPU architect agnostic. So we have that EXARM export right there. Hardware configuration, right? Results. This platform can be depend on your order. You can order 2 GB memory or 4 GB memory, yeah. Even 8 GB memory. Sorry, I cannot hear you very clear. Cost, hardware cost, 3,000 RMB. I got $400 and $500 for $400 or $500. Yeah, I have another platform, just 1 GB memory. Yeah, similar thing. Sometime, okay. Thank you, Aaron. Thank you.
Hello, everybody. We are talking about eliminating VRA blueprints sprawl today.
So my name's Brett Rath. I'm been with Sheets for 15 years. I'm basically a big tech geek. I work on all kinds of different things, not just VMware, but love speaking about this stuff. Excited to get started here.
Jason Williamson is my name. You might know me better as Admin Willie on Twitter, on GitHub, on pretty much everything. I got 14 years with Sheets. Started as a computer tech, went to Windows administrator, VMware administrator, and now buzzword administrator. Automation, DevOps, the whole cool thing. And I was honored with the expert for the first time this year.
So one thing we wanted to show you first is...
Before you get started, I want to tell them what a Sheets is. So does anybody have a My Sheets card? Okay, you get to start. Grab a goodie and pass it down.
Yeah, so Sheets is a convenience store, East Coast, Pennsylvania, 5 other states. Been around since the 50s. We got about 600 stores, so if you're ever on the Eastern Seaboard, you'll probably run into one of our big red canopies and see us from the highway.
So we made an initial deployment of 1.0 of VRA just for a server build, and it was messy. What you see here is just a fraction of the blueprints that we had built just to deploy virtual machines. So if it was a SQL Server box versus an IIS server, whether it was prod test dev, everything started with a different blueprint. And it usually worked. The customer usually got what they wanted, but it was starting us down a bad path, and we didn't want to continue.
So one of the things we started with was a form that was base out of the box, no custom forms available in this version. So the user had to really know what they were asking for, and as we all know, a lot of times people that need servers don't know all the specifics. They just read what was in the release notes for their application. So we wanted to make that a lot better and take as little input as possible from the customer.
So we knew that we wanted this to be very minimalistic. We wanted to get as much as we could from the customer, or as little as we could from the customer. Just extract exactly what they need, and we wanted to generate the rest. And we wanted to cut down from this to this. Everybody that needs a server just starts with the single, I need a server blueprint, and we'll work from there.
Mm-hmm. So one of the things we were sure we wanted was, as Willie said, we wanted as little input from the end user as possible, generate it. We started with this form asking for CPUs, memory, storage, all kinds of information that most of the users don't know that we would have to fill in or correct later. So we went ahead and said, this is our goal. We're going to start with one form. We're going to ask some simple things, make sure that they can fill it out, that we do all the heavy lifting on the back end. It was a lofty goal. We didn't know if we could actually accomplish it because everything we'd seen was you have to have all these different blueprints for what you want. But we started down that path and we got there. We asked for various things, and as you can see, it's a lot simpler, a lot more user-friendly. We wanted to do the nice Clarity UI justice and actually try to make it as easy as on the eyes as possible.
So we knew that we had set a lofty goal. We knew that this wasn't going to be our all-day, everyday job. It was going to be tough. It was going to take a lot of time. We were going to have to learn a lot of new stuff. We were right. It took a long time, and we had to learn a lot of stuff. So one of the things we found very quickly was that vRealize Orchestrator was the foundation for most of what we were going to do. While vRealize provided, or automation provided the front end and a lot of the service broker functionality that got the inputs back to the back end, all the work was happening behind the scenes, whether it be within Orchestrator in the native JavaScript, or if we needed to call other tools like PowerShell or Python, or even batch scripts that we were given. We heavily leaned on what was provided by our vendors. So what you see here is actually something that Infoblox provided to us. It's how we obtain an IP address and register the DNS entry directly with our IPAM. I didn't want to have to go write this by hand. Luckily, Infoblox did the hard work for us. All we had to do was import the module and feed it the variables that it was looking for.
And then we found actions. So a lot of the things that are done in the custom form, to be able to get them to basically do what we're asking, and to do a lot of the work behind the scenes, we had to use actions. So as something is input into a field or a drop-down item is selected, it all gets pushed back to an action, and various other variables are set, or information is returned back to the form dynamically. So we can present back, you know, is this a valid host name? Is this already used as a host name? You know, how do you really want to have 24,000 cores? You know, we need to be, you know, interactive, if you will, and dynamic. So.
Another thing that we require at our in our shop is when you build a server, you have to tell us the maintenance window. We no longer build, you know, 24/7 servers. We didn't want to, you can see from the list there, we have a ton of windows around the clock. We've got to be flexible for the applications. Nobody wants to maintain this list by hand. So what we did instead was we wrote an action to pull the, or I'm sorry, a workflow to pull the information from our patching system that then populates this drop down for us, so that the user just picks their window, and then VRO on the back end will configure that machine to be to have that maintenance window.
So one of the things we were most worried about is how are we going to populate that list? Are we going to do it manually by hand and keep up with the hundreds of windows we have? So what we decided to do was use a workflow to create and pull down all these maintenance windows from our patching system, which are labels. But we pull those down nightly, make sure they're up to date, and then what we do is we created files on the back end and store those in our code repository, and we use that to we use a workflow to also push those files onto the specific servers, and the agents that are installed can read those. So the patching agent can read them as well as other things. So one of the big things was Splunk. We use Splunk for a lot of our monitoring, and that agent is reading the maintenance windows. So that way we don't have to worry about saying manually, what time is this going to patch? Don't alert and spam the admins at this time. It's all done automatically. It reads it in, and alerts are turned off during that time period.
So one of the last things that really clicked for me was, how do we bring this together? How do I do the work in VRA, do the work in VRO, and get those things united cleanly? And what we found is the event broker. The event broker logs all the events that happens in VRA, and then what you can do is create a subscription based on criteria. So every time we build a machine, as soon as it's provisioned, we use a subscription for all of our post-provisioners, which are our workflows in VRO, to install asset management agents. We can install our antivirus and other post items in that way.
So as you can see, I'm not going to read through the list. We've done a lot of things with it. One of the current things we're working on is integrating with our password vault. So as we provision new users, say on a Linux system, that user gets a dynamically generated password that is controlled by the password vault. We're going to and add those systems, you know, those users to systems, put people in admin groups or service accounts in admin groups that need it, mapping drives, mounts, decommissions, and then we're going to be done with servers, and we're going to move on to network devices and store devices, and everything else we can possibly think of is coming. We just don't know when yet. So this is kind of how you can find us. We're going to put this presentation, some of the code out on the GitHub. You can find me at PA_SRE on Twitter. I have a blog that is empty if you'd like to look at nothing. Also, you can email us.
Yep, I'm, like I said, Admin Willie on everything but email. You can remember that I'm thebeard@sheets.com.
And that's us. Thanks.
All right. Good afternoon, everyone. I think it's afternoon, it's lunchtime. So my name's Anthony Spiteri. I'm a global technologist at Veeam Software. And today we're going to take you rapid fire through infrastructure as code, a working example. So I'm going to use Terraform. I'm going to use vCloud Director to show you a working example between what it is to actually code with APIs and code with Terraform. So before we get to that, let's go through. I want to give a bit of a definition, because one of the assumptions in our industry that everyone knows what everything means, okay? Because for guys like me that have been in the industry for 20 years, for guys at 10 years, 5 years, we're at different levels, right? So guys that are just entering might not know the difference between an API and whatnot. So An API is application programming interface. It's basically a set of subroutine definitions and communication protocols that are used to build software, okay? Now the key here is that a good API makes it easy to develop a computer program by providing all the building blocks, okay? And typically any piece of software that's written today is going to have an API of some sort, okay? Infrastructure of code is different, okay? Now this is a long definition, but I think it's important for those guys who are looking for infrastructure as code to understand exactly what we're talking about compared to APIs. So infrastructure as code, or IAC, is a process of managing and provisioning computer data centers or infrastructure through machine-readable definition files, okay? And I've highlighted the key terms here if you have a look at the screen, okay? So we're not using physical tools, we're not using manual tools, we're using these predefined files. The IT infrastructure managed by you guys is basically declared through scripts that are procedural or declarative, okay? So this is all basically taking the manual process of what are essentially repeatable tasks. Now, interestingly enough, when we look at infrastructure as code and the relevance, you can see here that I pulled some Google stats, and basically since 2013, 2014, the web has gone crazy for infrastructure as code. So obviously for you guys as IT operations guys, you're really interested to find out what's happening. The stats don't lie there. In terms of the tools of the trade, okay, what you see here are generally the most popular ones. They're not all of them, but I'm sure the audience and the guys looking live have seen and heard of Chef, Ansible, Puppet, SaltStack, and then Terraform. Okay, Terraform is the one that I'm going to focus on. It's one that I have a particular interest in and love, actually. So Terraform is created by a company called HashiCorp, and I'm going to show you a little bit about how that works in a very, very quick way. Before we do that though, it's important to understand this differential, because this is what basically defines the difference between some of those tools that I showed you in the previous slide. So procedural definition. Now that approach is basically when you write code that specifies a step-by-step action to achieve a desired state, okay? Chef, Ansible are examples of procedural definition tools. Declarative is an approach where you write the code that specifies your desired end state, okay? And then the infrastructure as code tool is responsible for getting out that state. And this is where Terraform, CloudFormation, and Puppet as examples do its thing. So if it's not clear as mud in terms of what the definition there, it's basically more about what the end goal is and how it's achieved, okay? Do we write code step by step to achieve a desired state? Or do we write something that tells a tool to achieve that state? Now, because it's a lightning talk, I wanted to go through an example in real world of what it actually means to program something with an API versus using an infrastructure as code to. So I'm going to actually use something called Terraform, which I've talked about. I'm going to integrate that with vCloud Director, NSX, and then finally show you how, from a Veeam perspective, we can put it all together. So initially, we've got a API tool, Postman, okay? When you're talking to APIs, you can talk to APIs in a number of different ways. You can talk to it via command line tools like curl. You can talk to it through browser extensions. Google has a browser extension as an example where you can actually talk to the API endpoint. I like to use Postman as an example. Now basically with an API, what you have to do initially is authenticate to it, okay? You've got to tell it that you're responsible and you're authenticated to make calls against that particular endpoint. So in the case of Postman, what you can see here is a call. We feed through basic authentication, a username or password. It then sends back, in the case of vCloud Director, a little authentication token, which you then feed back into the API to say that you can do things against that API for a number of minutes, okay? Typically, the tokens are time sensitive, okay? Now that can be really annoying in itself. And one of the things that I'm going to actually get to by the end of this is to show you that while APIs are great and everyone's saying that you can code with APIs directly, there are other ways to do it more efficiently to get to that point. So with regards to the authentication, obviously, because you have to actually go and re-authenticate given that token runs out, you want to do it programmatically. So Postman has an example in this case where you can write some script to actually go and get a token automatically every 15 or so seconds and keep on feeding that in and using that value that you derive out of that script and feed it back into your code, okay? That means you don't have to go in every 15 minutes or whatever the timeout period is and re-get that authentication token. So once that's all sorted, you also have to understand the schema. So you have to understand exactly what you're trying to get from the API. And obviously there's great documentation out. We've got things that actually are online now that actually let you go and actually view the API live. But for the most intensive purposes, you have to understand exactly what the schema does. When you've got that, you usually make a GET request. You get the current state of what you want to configure. Now in this case, we're looking at an NSX edge placed within a vCloud Director virtual data center. So what we can see here is we've got a couple of rules that we've got to go. I think we're configuring NAT rules in this case, or firewall rules. You can see we're doing an initial GET response. We want to see that current state. And then what we want to do is then construct an XML response in this case. I mean, it could be JSON, it could be another format, okay? But in vCloud Director, primarily, we're going to be using XML responses. You then have to understand exactly what every little construct means, okay? So this is no different this is where the programming comes into it. You then feed this via a post request, and then what you get is a status 200 OK, which means that we've fed the configuration that was in XML back into the API. It's touched the NSX edge and it's configured what you're doing, okay? So you can start to see this gets a little complicated in the point of view from us as infrastructure guys. You know, to do this repeatedly is actually annoying and subject to many errors, because if you get one little part of that XML wrong, it's going to spit back an error, okay? And what that ends up with, from the point of view of vCloud Director, it ends up with this, where you can see that what you've configured and told it to do via the post request in the XML, it's now configured within vCloud Director. Now, quickly to Terraform. So Terraform is a tool for building and changing and also versioning infrastructure efficiently, okay? Configuration files with Terraform are what you use to declare its state. So when you see Terraform examples, and we'll see it in the video very shortly, it looks like you're actually coding, okay? You can use Visual Studio that has plugins to basically use and construct these files. Now, it generates an execution plan, which you then run, you validate it, and then you apply it. And when it applies it, it checks and it talks to the API. So the biggest thing about Terraform and what it's doing compared to an API is that the tool itself interacts with the API. It's basically a black box. You tell Terraform what you want it to do without you having to understand what the API is actually doing. So all the schemas and everything that we saw, you don't need to worry about that. So it actually simplifies the way that you interact with that endpoint. All you've got to understand itself from the point of view of the provider that it has. So Terraform has a bunch of providers that are basically set for many different platforms. Providers can be done for AWS, for vSphere, Google Cloud, Kubernetes platforms. It doesn't really matter. They've got a wide array of providers. And actually down below you can see that I've got a link there to the different providers. The specific one that I'm using in this example is the vCloud Director provider, up to version 2.4. The provider itself understands how to interact with the vCloud Director API, okay? And then what we're doing with that in the code, and what you'll see in the next few steps, is we will code it and we'll say, configure an NSX to have particular firewall rules, to have particular NAT edges settings, and just execute my plan. And then tell me if you've been successful with that. So what I'm going to do is show a quick video that's going to show that end to end, and we will play. Okay, so initially here what we're seeing is basically the fact that we've got this NSX edge without any configuration, okay? It's an empty configuration. We've got nothing configured by way of firewall rules or NAT rules as well, okay? What we're going to do is basically go into Visual Studio Code, and you can see up there a few examples. We basically tell it to go and say, how do we connect in to the provider? So you need to give it a username and password. You need to tell it a few basic things. And what I'll do is I'll just pause that there before it goes through. So you can see that we've got a bunch of files on the left-hand side. These are the Terraform declaration files. This is where you're actually telling Terraform what to actually configure. And what you can see on the main pane there is actually the variables that we're feeding in. So you've got to still understand what variables to feed in, much like with the XML. You had to actually understand what you were coding there. But what we're doing here is presenting it in a much more easier and consumable way. You don't need to understand how to basically format that XML or the JSON. This is doing it all for you, okay? What we've done there is we've basically gone and said, let's test it so we can check to make sure that the plan that we've got is good, okay? What we're then going to do is basically hit apply, Terraform apply. And then what that's going to do is then execute our plan, okay? And this is going to go and use the declarative state that we've done within the code. And we're now actually going to confirm. So it's going to say, we want to confirm everything. It'll go through in a matter of seconds. It's going to start to talk via its provider to the API endpoint of vCloud Director itself and start to actually work on these actions. And you can see below in the actual task pane, you can see actions happening. And if everything's going okay, you can now see that we've got those rules set up, okay? Understand that this was a lot more simpler than what I showed you guys in the example of the actual API itself, okay? So that's pretty cool, and this is a great example there. And then what you can see is outputted there in the output, you've got the current state. You can actually do a Terraform get to actually see what's configured as well. Now the great thing is, if you actually change that in any way on the actual vCloud Director itself, you can reapply it via this particular command. If you hit apply again, it's going to tell you that something's been modified. I want to get it back to that state. So desired state and repeatable code is what we're after here. Okay. Now, to finish off, again, gone through it very quick because there's a lot to process in 12 minutes. What we then apply this to in a real world example is that we can then create a PowerShell command to execute that Terraform. Now in Veeam, what I've done is that we've got a job definition, and in job definition we've got post and pre-scripts. So what I've done in this particular example for a Cloud Connect replication customer who's actually replicating machines into a virtual data center of a cloud provider, they want to configure their networking automatically, okay? And they don't want to do it with APIs. So what they can do is they can use Terraform to basically do what we saw, okay? And then run this PostScript, so when the replication job finishes, we execute the Terraform. The Terraform then configures the edge with all the firewall rules that they want and the NAT rules that are relevant to the VMs that are running. So in the case of a disaster, if they actually had to execute and fail over, all that networking would be in place. Now the key part about it here in this particular job is that we know that it's going to be as we want it because Terraform is keeping that in play. And as part of the job here, it's hard to see, but PostScript, we're going to execute the PowerShell and then go from there. Okay, wrapping it up, I've got 1 minute. So, a few controversial statements. In terms of industry reality versus influencer hype, if I was to ask any audience, how much are they leveraging using APIs versus a GUI or anything, the numbers would be really low, okay? DevOps worlds and whatnot have perpetuated a little bit of a misnomer that we basically need APIs to survive, okay? What I'm trying to say is that as an infrastructure guy, you can not need to rely on APIs, but there are the tools out there to make your jobs easier. Terraform, infrastructure as code, is that, okay? So instead of going and understanding the API, go to the tool that does all the work for you and make your life easier, okay? And that is effectively the essence of infrastructure as code, okay? It's the middleman that makes your life easier. And with that, we're done in very lightning session. Here's Veeam. Thank you very much.
Natural disasters are on the rise. Whether it's hurricanes, flood, earthquake, all of them are affecting the ability for data centers to remain online. Yet, there are many data centers who are not ready for disaster events. In fact, a 2018 study by Uptime Institute shows that more than 70% of the data centers are unprepared for disaster events. Yet, when your data center goes offline, it is not only lost revenues, but also it impacts your business reputation, customer loyalty, and so on. Now, with the advent of cloud, making the disaster recovery happen there, making it much more affordable because now you don't need to have a secondary data center. There are additional benefits as well. So for example, you can take advantage of the geodiversity that public cloud providers like AWS provides. The software for disaster recovery is also getting very advanced. Now, electronic versions of integrated runbooks are very sophisticated with complex ordering, checkpoint, custom scripting, network modification, so on and so forth. But then, these cloud-based disaster recovery solutions have their own set of challenges as well. The first and foremost is, in a lot of situations, it undergoes a transformation, or translation. So for example, if the disaster recovery to cloud software takes advantage of vImport feature of AWS, that means the VMware VMs is getting translated into native AWS AMI format. And if it is happening when you are in the middle of disaster recovery, then you know what? You might have a disaster while having disaster recovery. And then the new processes or technology also plays a role in terms of how effective and how quickly you can bring up your environment to the cloud. So let's take a scenario where you can actually have your on-premises data center recovered into the cloud, leveraging your the same set of operations with a consistently familiar environment to get there. So you know of VMware Cloud on AWS. It helps you extend, migrate, and protect your on-premises vSphere-based environment to the cloud. And you can actually take advantage of the native AWS services as well. Now, here are two issues. First is the storage in VMware Cloud on AWS is actually tied to the compute nodes because it's primarily vSAN based. And the other part is this is non-persistent, meaning when you take a node out, the storage associated with it goes away. So it is not only complex but also non-persistent. Now we are going to talk about a solution where VMware and VMware Cloud on AWS provides a feature called external storage via managed services provider. What it does is it lets you have storage directly connected to VMware Cloud on AWS from a managed service provider, and this AWS Direct Connect is actually managed by the service provider with patented layer 2 technology, and the access to this external storage is less than 3 milliseconds. So let me build this out. So you have your on-premises data center, you have your VMware Cloud on AWS, which through which now with the cloud control volumes, this is the NFS data stores that we are exporting out from the managed services provider directly attached to the VMware Cloud on AWS. Now you are getting enterprise grade storage access as like on an on-demand basis. And in fact, this is persistent, durable storage managed by the cloud services provider, guaranteeing you give or take less than 3 milliseconds of latency. Now, how you can leverage this to build out your disaster recovery solution? So you can actually have a pipe or connection from the your on-premise site to this managed services cloud. You replicate from your on-premises Dell EMC storage like Dell EMC Unity to the Dell EMC Unity that's on the managed services provider side. Okay, native replication gives you your data and VMs are replicated to the secondary site, which is this managed services cloud, and then the cloud services here can help you get those cloud control volumes mapped to VMware Cloud on AWS in the case of a disaster. And that this becomes like your automated DR operations where the entire environment from on-premises to in the event of a disaster are getting up and running on VMware Cloud on AWS. And here you are actually not needing any additional storage. You are consuming compute in the case of the disaster on an on-demand basis. It is lowering your both RPOs and RTOs, bringing up your environment. And this is actually first and only storage for VMware Cloud on AWS services leveraged for the disaster recovery. Here is another version of it. Here you are leveraging VMware Site Recovery Services in VMware Cloud on AWS to have your both data and VMs replicated to the VMC on AWS, and in the event of the disaster, you can actually have your data center up and running leveraging say Dell EMC Unity or Dell EMC PowerMax as the external storage on which you are running your workloads in a consistent manner, like your same vCenter and everything else is going to work again. This is the first and only solution where you can leverage purpose-built storage for your DR applications running from VMware Cloud on AWS. Let's do a demo. So what you are seeing is this is the Dell EMC Unity interface. It's operating in your on-premises data center. You can see it is up and running. You can see the IOPS average, bandwidth average, so on and so forth. Now let's see what's being replicated. You see the bottom three data stores marked as file systems. So this is your on-premises data store, and then the top three shows up as NAS server. This is the replication partner, and this is in the cloud. Now suppose I want to fail over one of the data stores from on-premise to the cloud. The replication is asynchronous, so it is ensuring all the data that is on-premises now actually like moved over as I'm doing this failover. I'm going to failover this data store into the data store that's here on the cloud. So let me ask it to failover. It's going to ask me whether I am sure. Yes, please. Now, looking at the Dell EMC Unity user interface, I can see this on-premises data store has now failed over to the data store on the cloud. Let's take a look at the vSphere. Now, this is the data center running on VMware Cloud on AWS. If I take a look at the data stores, this data store 3 is where the files are, and let me go there. Now these are the VMDKs that are on that NFS data store. If I come back here, now let's take a look. This is where in the cloud all the VMs are going to get moved over and powered up. Look, the CPU usage, memory usage, the DRS load balancer is perfectly balanced at this point. Okay. Now, if I take a look at the compute resource pool here, you will see here are the VMs that are getting registered and reconfigured in VMware Cloud on AWS. And these are still not powered up. As it moves through, you will see the green dots coming in, and keep an eye on where the CPU usage, memory, and the load balancer goes. So you will see as the VMs are coming along in green, the CPU and memory usage is going up. The DRS load balancer, it's trying hard, but now it has a lot of new VMs in the same cluster. So it is balancing as much as it could. And with these green VMs, you can see that all of these VMs which were running on-premise are now up and running in VMware Cloud on AWS with just a few clicks. So to conclude, this is Dell EMC Cloud Storage Services for automated disaster recovery for VMware Cloud on AWS. This is a new service, and you can come to our booth to learn more. We have lots of more demos, and then we have assessments in place that will help you understand what type of workloads you can actually migrate to the cloud, to Delta Cloud, and can take advantage of this Dell EMC storage cloud services. Thank you.
Hey everybody, this is Pie in the Sky using Wavefront to analyze Pi-hole data. My name is Nick Cordy. I'm a solution engineer with VMware. This Pi is not actually the Pi we're going to talk about, but I used to be a former math teacher and couldn't help it. So this screenshot you see here is the popular interface of Pi-hole, an ad blocker that many of us have on our home networks. In my network, it's running on my Raspberry Pi at the house. You can see I have 15 clients, a lot of queries, good percentage of blockage here. And from this data, I can get a little bit of insight in the charts. How many queries over the last 24 hours, how many things were blocked. Notice it's in 10-minute intervals, 10-minute totals here. Same thing down there in the clients over time. How many queries per client? That's pretty good visibility, pretty good analytics on your home network. What if I want to customize that particular data analytics window? I can do that. Here's a 2-day snapshot. So what I found was that Pi-hole was pretty good, but there's something that's better. So this chart right here is a chart that I made from Wavefront metrics. I used the logs from Pi-hole, sent them to my Wavefront instance, and pulled out the total query count per device, as you can see here. But I actually looked at the rate of change over time, making 0 the start of my interval wherever I want it to be, however small, however large. I get some excellent visibility here. And notice that timestamp, 3:50 with 39 seconds. I can check out what the counts are at any given second. Okay, let's take that a step further. What if I want to see the difference in the rate of change of query count per device between today at this time and 24 hours ago? Maybe my daughter watches heavy Netflix on Saturday, but she doesn't do that on Monday. Some pretty interesting trends that you can gather here that Pi-hole just wasn't going to give you. But you know what? Maybe we should back up and talk about how this happened. How did I get to tinkering with Wavefront? Well, a lot of these things happen from nerdy conversations, right? I was talking to a friend of mine, this handsome devil, Aaron Bolthouse, and he was telling me about this cool thing called Pi-hole that he used on his home network. And I said, okay, how do you do that, Aaron? He said he was running it on a Raspberry Pi. So he told me what to get. I bought the kit, installed it, set it as my DHCP server, no problem. I was able to get that first page of analytics that you saw without too much trouble, maybe a little bit of customization. And we even talked about, oh man, wouldn't it be cool since we work for VMware to send the logs from that to Log Insight? Yeah, it would be, but there wasn't really an easy way to do that. But there's this Wavefront thing, one of the coolest products I think that we have. It's all in the cloud, man. It's a SaaS service. You don't really need infrastructure to run it unless you want to do certain things. So I wanted to learn that, but the question was, how do I get data from Pi-hole into Wavefront? It turned out to be a few more steps than I thought. So Wavefront, real quick, is a time series metrics analysis engine. Okay, things that change over time. I can make a counter, something that steps up over time. It's either going to increase or decrease. A gauge, a specific value, like a latency value of something over time. A histogram. Wavefront is built for massive amounts of metrics to be ingested even per second. If you ever look at your Pi-hole logs, you'll see that a number of queries happen in the same second even. So histograms can give you a distribution of that high volume data over time. A delta counter, if you're absorbing many different points per second, you can aggregate all those together and get an average or a median or a mean. Traces and spans are more for troubleshooting distributed applications, API calls that affect different services. That's just an idea. And there's no data rollup. Like in VROPS, you have data rollup over time. I get all the data I want. I can choose to roll it up with special functions. Again, how do I get there? How do I get the data in? Well, there's no integration with Pi-hole. And what I mean by that is no one has set up special dashboards specifically for Pi-hole data. There's no fast way to just turn on the synchronization between Pi-hole and Wavefront. So I had to build that from the ground up. There are a couple different paths for metric integration. I can send it directly to my Wavefront instance in the cloud, maybe through some API calls, but that's only the Wavefront data format. But if I use a proxy, which is usually a virtual machine that runs Ubuntu, Windows, could be Mac, could even run in a container, I can use different formats. And I can send logs. Well, I can find the Pi-hole logs just in Raspbian, no problem, so maybe I'll try that. Well, I needed to ship the logs, and I didn't know how to do that because I don't do a lot of Linux work. So there are a couple different supported methods to ship my logs to Wavefront. I can use FileBeat, that's a popular log shipper, but you know what? Nobody developed it for ARM. Some people had custom compiled it. I didn't want to go there. But you can also send your raw TCP logs. Okay, cool. I could use this free tool from Splunk, but you have to sign up for it. Our syslog actually comes with Raspbian, but after reading through the Linux man pages like a nerd, syslog ng seemed like the way to go. But all those metrics I talked about before, if you're going to pull metrics out of logs, there are only 3 metrics supported today with Wavefront. That's counters, gauges, and histograms. And based on the Pi-hole data, those are fine. But where do I put the proxy? I don't have that many devices at my house. I'm not going to run a Wavefront proxy on my daughter's iPad. Maybe I put it on the Raspberry Pi. Not supported. Maybe I put it on my wife's computer. She has a Windows box. That's probably not a good idea. Don't want to be messing with her stuff. So when you run into problems like this, what do? You ask somebody that knows. Well, there's this guy named Bill Roth who worked heavily with Wavefront after we acquired them and before. He said, hey man, why don't you put your proxy in AWS EC2? Well, cool. Now I don't only get to learn Wavefront, I get to learn AWS and something else. So it didn't cost me any money yet. Here's my to-do list. The first thing I did was deploy the proxy. I deployed a Ubuntu VM in EC2. That's not too bad. Had to set up the security rules so I could access it from my house. I had to install the Wavefront proxy service, which is a simple apt-get in Ubuntu. I also had to synchronize it with the Wavefront instance I was using. So that's 3 different places I had to go already. I had to ship the logs. Remember, this Raspberry Pi is running on my home network. I'm pulling the log file, piehole.log, from Raspbian. I had to configure syslog ng to send it up to my Wavefront proxy. But I also had to tell the proxy, hey, you're getting these TCP logs, so open up that port. Can't forget that. And then, how do I even know that the logs are getting there? It's one thing for me to send them somewhere, but if they're not getting there, I don't need metrics because I'm not going to get anything. So I had to make sure the path was clear in terms of AWS networking, the Ubuntu firewall here, the proxy configuration, and that Wavefront was actually seeing it. So check this out. This is actually a chart from Wavefront of my proxy, and it says that it's getting raw logs from my proxy. So they're being sent to the proxy, and it's telling Wavefront, oh yeah, you're getting logs. But I'm not doing anything with them yet. I have no metrics at this point. It's a little bit small, but hopefully you can see a little snippet of the Pi-hole logs. A lot of different things happening, queries, cache hits, replies, all those things. I had to use something called grok patterns. And a grok pattern is simply a data format description. I have to find a pattern that matches the unique type of line I want to count or take data from. For example, this query line here, it fits a specific format. So every time that line comes up, if I make my pattern unique so that it matches that format, I can create a metric based on that type of line. But I have to know what the logs look like because the patterns are whatever I want to make them. It's kind of a choose your own adventure. Measure what you want. I had some ideas for metrics. Some of the ideas came from looking at the Pi-hole. Others, how long are DNS queries taking? Maybe that's a cool one to explore. Here's an example. One log line from Pi-hole log file is at the top there, and then there's my grok pattern. So everything inside the curly braces is a grok pattern. If you want, you can go online and look at the open source definitions of these grok patterns, and it's enough to give you a headache at times. But I can take words, I can take numbers, I can take an IP address. It will pull an IP address out of a log line, whether it's IP6, IP4. The formatting is already there. I'm just saying pull that out of this particular log line for me. So these words after the colon, those are really just IDs. Think of them as field names that contain data after the pattern is applied. So I wanted to capture interesting information from each log line so that I can use it as a metric. What if I could count the number of queries per IP address on my network? I need that information so I can do the group by and the analytics in the interface. And there's actually a really nice Grok debugger online that I used to make sure that my syntax was right. Because as you know, if your syntax is wrong, you're in some trouble. Here's an example. On the Wavefront proxy itself, you actually have to configure a file that has all your Grok patterns in it. We talked about the type of metrics supported. One of them is a counter. And in this chart below, I used a counter metric called query count dash total. That's that second one. I've got the host name as device address. So every one of these lines in this period, starting from 0, is a different host on my network that's making queries. I'm gonna guess that my work computer is probably the one on top, because sometimes I like to work in the evenings. That first particular pattern that you got up there is, notice that inside the metric name, I used the device address. So that makes a metric for every single device address on the network. And this is just the beginning. I could do all kinds of other things with Wavefront and the analysis thereof, but it's based on whatever metrics I want to feed it. So what will I do next? Maybe I'll make some dashboards for Pi-hole or create an integration. That's probably not really popular because not many of us are using Pi-hole in our enterprises. Maybe some automation, maybe a little bit about the Wavefront query language. A lot of supplemental information out there, a lot of documents you can read. And I actually blogged about this step by step as I went through it. I'm not finished with all of them yet, but I want to keep going because I have to say I learned a ton from this little nerdy experiment. So if you want to talk about it, feel free to contact me. Otherwise, thanks for coming. Appreciate it.
Hi everyone, my name is Mike Morris. I'm a Manager of Solutions Architecture at Expedient. And today we're going to talk about how to get started with infrastructure as code using Terraform and vCloud Director. So for anyone not familiar, what is VMware vCloud Director? So this is a multi-tenant management front end for the VMware ecosystem. So HTML5 portal that sits in front of vCenter, NSX, vSAN, you know, the whole VMware stack. So it's only available to VMware cloud providers. So if you're utilizing a VMware cloud provider, chances are this is probably the way you're going to access your resources. Like I said, it's completely HTML5, so no Flash, which everyone will be happy about. It has a really great, rich API, so most everything kind of available you can do through the GUI. You can also hit via their API. Product's been around for a long time. It was initially released in August of 2010, and the latest release was announced this week. It wasn't released this week, so that's version 10, should be coming soon. Terraform. So Terraform's an open source infrastructure as code tool. So it was created by HashiCorp, and they said, hey, we're here at VMworld, booth 262, come check us out. So they wanted me to plug them, so definitely check them out if it's interesting. It's written in Go and available on GitHub. And the whole idea behind Terraform is creating and changing infrastructure using easy to understand code. So dropping configuration into essentially a text file, run Terraform, you get VMs and infrastructure out the other side. It ties into pretty much all the major cloud platforms, the VMware-based clouds, AWS, Azure, GCP. If you go on their website and look, they have providers for all kinds of crazy stuff. So this is a little bit newer. It was initially released in July of 2014, and they had their most recent release 2 days ago. So the GitHub is super active. There's a huge community around it, and they're constantly iterating and adding new features. So what can we do with it? Create and remove VMs, edit the configuration of those VMs. We can create, manage NSX edges, NSX firewall rules, and a ton more. So anything you're going to be able to really want to do through vCloud Director is going to be available to kind of do with Terraform. So how do we get started? It really is this simple. So go to the website, terraform.io, download Terraform. It's a single exe that just has a compiled binary in it. So obviously if you're on Windows, it's an exe. If you're on Mac, same equivalent. It's just a single compiled file. you write your first Terraform file and then just execute Terraform to create your infrastructure. So it's going to pick up that Terraform file, pull it over, and start building your infrastructure. So this is an example of what a Terraform configuration file looks like. So this is just Visual Studio Code, another open source piece of software. And the first section is the provider. So in this case, VCD for vCloud Director. If you're not using vCloud Director, you can do the same thing with vCenter. So there's a vCenter one as well. Just kind of go down through here. So logging true is nice, like when you're trying to initially get started, make sure you have things set up right. Username, password, org and VDC are vCloud Director specific. That's the organization you're kind of provisioning into. The URL for the API and the max retry timeout is just to extend that a little bit. So if something takes a little while, it's not going to time out on you and give you an error. The next section is creating the VApp. So in vCloud Director, there's the concept. They're utilizing VApps. You create a VApp and then your VMs live inside of it. So in this case, we're going to create a VApp just called VMWorld VApp. From there, we'll actually start creating the VMs. So this is, in this demo I'm going to do, there's 3 servers. There's 2 web servers and a database server. This is just the Web 01. And you can see we have a variable reference. We're just referencing the VApp name that we created above, giving the VM a name. The catalog name is where we're going to pull that Server 2019 template from, and then 4 gigs of RAM, a single vCPU, and we're going to go ahead and stick it on our demo network. So that's kind of all you need to get started here. So I'm just going to jump right in and kind of show you what that looks like. All right, so you can see the same file we just created here. Really easy to read, easy to understand. So we'll open up a console, just Terraform init. So what that's going to do is it's going to look at your Terraform file and say, hey, what providers do I need? What do I need to download? In this case, we need the vCloud Director provider, so it's going to go ahead and pull that down. There we go, Terraform is successfully initialized. So the first step is we can execute and say, hey, let's look at the plan. So it's going to go through, look at your Terraform file, and spit out this plan of all the changes it's going to make. So you can see here, creating a couple VMs, all the green plus signs, these are all going to be additions into our environment. From there, we're just going to go ahead and apply the actual Terraform file. So again, it's going to spit out what it's going to do. Yes, I want to continue, and there we go, we're off. So we've go ahead and created the VApp, and we're creating our first VM. So obviously sped this up a little bit, so we didn't have to sit through the whole thing. And there we go, there's our 3 VMs created. So if we just pop into vCloud Director here, you can see we have our VMworld Web 01, Web 02, and WebDB. So great, that gets it created. Now what happens if we want to go through and modify it? So again, we're going to look at one of our VMs here. This is the WebDB VM. Look at the hardware configuration. Just have a single core CPU, 4 gigs of RAM. All right, so we'll come into our Terraform file. Let's go ahead and edit this. So we'll change our database server to 8 gigs of RAM, 2 CPUs. And just go ahead and save that. You see our plan now is going to show that modification. So up to 8 gigs of RAM, 2 CPUs. And we're going to go ahead and apply that. So it's going to go through, refresh the current state of the VMs. We'll say, yes, we do want to execute this. And there we go. So you can see it's really easy to do. It's going to go ahead and just shut that VM down, make the modifications, and bring it back up. The perils of doing a demo. All right, well, this may not come back. What I was going to show you, if it does come back here, is, there we go. I got to minimize that, come back, look at our virtual machine, database server. And we can see here, there we go. There's our change. So it's pretty easy to get started with, easy to understand. The Terraform files are pretty straightforward. So that's kind of a quick overview. If you guys have any questions, so I'm with Expedient. We do have a booth here. Feel free, come by, ask questions. I'll be around probably for the whole conference. Thanks, everyone.
Hi, my name is Mustafa Khalil. I'm with Cloud Simple. I'm going to show a quick demo of our Azure VMware solution that we shipped back in May. Quick history about me. I worked for VMware for over 18 years, and I spoke at most VMworld events. And I left VMware about 2 years ago to join Cloud Simple to start the customer success engineer management team there, which is the combination of tech support and solution development team. I authored 2 books, Storage Implementation in vSphere 5 and Storage Design Implementation in vSphere 6. This is where you find us at the exhibit hall. We are at the Azure booth as well as the Google Cloud booth, and a few of our partners are showing our solution using their products. So let's dive a quick into the demo. Me here need to open a browser. So I'm going to go to portal. .azure.com. And I'm going to log in with my account there. So if you're familiar with Azure Portal, you deploy services by searching for the given service. And in this case, if you want to add the Cloud Simple service, you just search for Cloud Simple. And you will see here a list of services. There's Cloud Simple nodes, Cloud Simple services, and Cloud Simple virtual machines. To subscribe to the service, you select the Cloud Simple service, and then from there you click on Add. And then you enter a name for the Cloud Simple service that you want to add, and then you select a resource group. This resource group is where you deploy the virtual machines that you want to run on the Cloud Simple service. And the Cloud Simple service is actually a vSphere cluster that's running on the physical nodes that you have as dedicated nodes that you purchase as part of the subscription. So you can either select one or create a new resource group. And then you enter a name and you pick the region where you want to have the nodes deployed. Currently we have East US and West US, and we are launching West Europe in Amsterdam. And we're expanding globally as we go. And then you enter your CIDR for the accessing this this service. This one is used by the VPN connectivity as well as by other network connectivity choices that I will show you later. So I have here a service that I have deployed. So after I deploy the service, it would look like this. And at this point, the next thing you need to do is to add the nodes. So to add nodes, you need to purchase the number of nodes that you want to subscribe for. And do you already have the resource group that you created the service in? You need to add the nodes in that resource group. Then you give it a name, and then you select the location where you want the nodes to be deployed, and then you select the node types. We have two node types. There is CS28 and CS36, which are 28 cores versus 36 cores. The 28 cores is like an entry level with lower capacity of the storage and RAM. The CS36, you have 36 cores with hyperthreads, would be 72 cores, 72 hyperthreads, and you have double the RAM and double the storage capacity compared to the CS28. So depending on your vSAN cluster that you want to deploy within that private cloud, this is what we refer to as the SCDC. The more capacity you need, the larger the server you want, or you can use the lower end servers and add more nodes. So you pay per node, not per use. So once you purchase the node, you select, is it monthly, or is it pay as you go, or is it annually, or every 3 years, and so on. And then you click review and create. So I'll show a quick demo here of how this process works. So this is what I've done so far. So let me fast forward. So I created the private cloud. So to create the private cloud, you need to select, so let me pause this here. When you go down here to the service, after you select the nodes that you purchased, then you click on Create Private Cloud. And the Create Private Cloud is the same UI where you select the region and the number of nodes that you want to deploy. Minimum nodes required are 3 nodes. That's the requirement for vSAN. But you can have more. So here you give the name to your private cloud, and then you select the region and the availability zone. So you can have a cluster deployed in one AZ, and you have another cluster deployed in another AZ, so that you can have your workload distributed between different AZs to have higher availability. Or if you want all your VMs running in the same AZ to have more proximity to each other, running on the same cluster, you would have better network performance there. And then the node type, this is what I was showing you earlier. I was saying earlier, CS28 or CS36, and then you specify the node count. And then you click next. You go to the advanced advanced options, where you specify the network. This CIDR here you provide is your management CIDR. That's the one you're going to be accessing your vSphere client via VPN to manage your vSphere cluster. And this CIDR should not overlap any other network you have on the on-prem, because once you connect from the on-prem to the private cloud, you will end up clashing. So after it's created, it will show, like I showed you, you end up getting the notification on the top says it's created, and you get to your private cloud, and you get to now, this is the creation part. I may skip that. So now we want to review, configure your network. So let me pause this. So let me go here for the live one here, and I'm going to go back to so I go to my Cloud Simple portal, So this is the portal that we have developed and built. That's part of our IP, and its component of it are running in Azure, component of it are running on the private cloud itself. So this UI is running in Azure. You select the network, and the network choices you have once it loads. So you have a firewall configuration where you can configure firewall rules. You can configure a VPN gateway where you can configure a site-to-site VPN to connect between your gateway to the from on-prem to the private cloud. And then you can configure your firewall rules on this tunnel. Or you can create a point-to-site VPN where you configure it on the portal per user. So you configure one point-to-site VPN, but each user gets their own VPN configuration bundle downloaded with the user's name and with their password. You can import that VPN bundle into the VPN client. We support OpenVPN or any other client that's based on OpenVPN. So I'm not sure here why this is. I'm using the wrong button here. So this is not working, network problem. So if I go here, you will see that here I have the firewall tables, the VLANs, subnets, and public IPs. The public IP is when you deploy a virtual machine in the private cloud, you can expose it on the internet by acquiring a public IP from Azure and assign it to an internal IP address that this VM is using. By default, this public IP is blocked, traffic is blocked from inbound direction. You have to create a firewall rule to enable the traffic on a given port. The application that runs on that VM wants to be visible from the internet. And you can create firewall rules for other things as well. But for the purpose of the public IP, that's specific to the VM traffic. Outbound traffic is open by default, so any VM running in a private cloud can access any site on the internet. But it's your choice. You can block that using the firewall. Once you configure your site-to-site VPN, you can route all of your traffic through your site network. So this way, none of the internet access for the VMs run on a PC will go directly through Azure, will go through your site and then out through your firewall. The Azure network connection, this is an option where if you have Azure native resources running on Azure and you want to provide connectivity to these resources to the private cloud, you would request from Cloud Simple an authorization key and a resource URI for the express route that we deployed for your private cloud. It gets displayed on the UI here where you can copy both the authorization key and the resource URI, and then you go into Azure and configure your subnet and the gateway connection to the private cloud using this authorization key. You will claim that authorization key. So this is an example of how the firewall rules look like. So this rule here is for a private cloud VPN. You can configure this as a site-to-site, or you can configure a point-to-site. If you configure a public IP cloud firewall rule, you will select that other box for public IP. And then down here you have the directions and so on. This is a typical firewall rule configuration. It's all provided in the UI. Let me see if this one is back. Okay, so after you configure your network, then you go to this home page on the portal and you click Launch vSphere Client, which will launch the vSphere HTML5 client. That would look like that. But you need to have your VPN configured before you do that. So you can have this point-to-site VPN on your desktop where you can have access directly to it, or if it's on your site, everyone on your site can click on that link to access it. So this one here, when you connect, you will see the number of hosts and you have the workload resource pool that's defined for your workload. This is all your domain there. Anything else you have no control over. We manage, monitor, and maintain, and update, and monitor security, and configure security for all the infrastructure. So you would not see the vCenter server VM there. It's hidden from you. But if you have an application, a solution that you want to install that requires administrator privileges, you can request elevated privileges for a certain period of time that you define in the UI. And once you're done creating your service account that you're going to use to install this application and run it, elevated privileges will get reduced again after the expiration time. And the application will continue running with that elevated privilege. We monitor this account, make sure that no user is using it to log in with it at the actual vSphere client. So from this point on, if you deploy a VM within this resource pool, you can go onto the portal, and we have an ability to map a resource pool to an Azure resource group. Whatever VM that's deployed in this resource pool that's mapped will become visible in the resource group. So for example, if I go here and I go to my Azure portal and I go to my virtual machines, I have a VM here that is a set of VMs. I have two Oracle Rack VMs here. These are actually deployed in the Cloud Simple private cloud. When you click on the VM here, you will see all the controls here, the way you have it in vSphere. If this were a pure Azure VM, you wouldn't have the suspend button. It's available there because it's actually running on the private cloud on vSphere. And here you can monitor all the performance like you do with on vCenter. Access control, you can provide access control from Azure to this VM that would apply to the users using the VM on the private cloud. So the integration is done between both Azure and Cloud Simple to make it seamless whichever direction you're coming in. So you can have your user deploy a VM on Azure to that resource group, it ends up being deployed onto the resource pool in the private cloud on vSphere. So I think I'm out of time. I'm out of time? Okay, thank you. So I don't think there's any time for questions, right? Okay, all right.
Okay. Welcome everyone. How's the show been? Good? Awesome. So this is my version of BCDR, Dirty Deeds Done Cheap. I was hoping to play a little AC/DC for you, but of course that breaks the rules of the conference. So if you want to hear the song, you'll have to go play it on your own after the session. Maybe you'll be in the mood for it. No, no. So anyways, my name's Teresa Miller. I'm a principal technologist with Cohesity. I also have a community website if you're looking for some up-to-date, latest and greatest information on various IT topics. I'm at 24/7 IT Connection, and I'm on Twitter as 24/7 IT Connect. I also like to just share a little bit about me from a personal perspective. I think it's nice to look beyond the technology, right, the technical side, because I did have some of my industry recognitions up on the first slide, but there's always more to the person. So I've taken a liking to mojitos. I enjoy a nice tea or a latte from time to time. I did my first tandem skydive a couple years ago. Recently I was introduced to Cajun food, or Cajun food. It was phenomenal. I'm surprised I had never had it before. And I like to grow roses. So let's get right down into the topic. So I wanted to have a little bit of fun with this since we were going after the AC/DC theme. So I rewrote the titles on the record here. So what we're going to cover today is BCDR. We're going to just take a look at what that means from a definition perspective and talk about it from a current state perspective. We'll talk about the problem that organizations are faced with, and then we'll talk a little bit about how you can avoid the pitfalls and be successful with business continuity and disaster recovery. So as promised, just to do a level set on what these each are. So the business continuity piece, according to Wikipedia, basically is that you're going to keep your business up and running no matter what you're faced with, right? It's about continuing business, keeping the users running regardless of what's going on around you. Then there's the disaster recovery piece, and of course that's very important to business continuity. It's your ability to make sure that all of those computer systems come online wherever your disaster recovery setup is. So disasters come in many different forms, and we never know what we'll be faced with. So it could be protests, it could be flooding, fires, it could even be security breaches that put us into a disaster of sorts. And even something like a lightning strike could really cause some chaos for our enterprises. And I want to focus on the weather a little bit further because I found this to be very interesting. So the National Oceanic Organization put out a map. Now this doesn't have all 11, but in the last year there have actually been 11 weather-related disasters that have created over $1 billion in business loss in terms of profits. So when you really think about that, it makes you kind of step back and say, whoa, if I don't have disaster recovery or business continuity, how is that going to affect my business? Or if I do have it, am I doing it in a way that I know it will work? So let's talk a little bit more about the problem. So I certainly don't want any of you feeling like you're hanging from a cliff, right, when it comes to this topic and the decisions that you may be faced with. So Spiceworks did a survey recently, and one of the statistics that they shared was that 5% of companies don't have any disaster recovery. At the end of the day, that sounds a little bit low to me, but when you think about it, I mean, disaster recovery comes in many different forms, right? So it could be that you've thought about it, you kind of have a plan, maybe it's just not as automated, as seamless as it should be, or maybe it's not tested. The other thing that I thought was pretty interesting statistically, Gartner did a research study, kind of tying back to what I talked about with the business profit loss with weather. If you experience a disaster, it is $5,600 a minute in cost. That's the average cost. Now, of course, every different organization is a little different, but that's a lot of money for downtime, and it adds up pretty fast. Now, from the technology perspective, I think some of the challenges that I've personally seen in the enterprise come from even just getting disaster recovery off the ground. I know I worked in multiple organizations where disaster recovery was always like part of the annual planning, it was part of the budget, and it would get cut because there wasn't the funding to support it. And getting cut can be pretty significant when you think about the business impact we just talked about. The other thing is where I have worked in enterprises that do have disaster recovery, I think some of the challenges that I've experienced come down to the environment is always changing, right? If your company's growing, you're always adding servers, you might even be re-IPing things, but you're growing and expanding and it's changing. And a lot of the processes and products available for disaster recovery are actually quite manual, or there's scripting involved. So you really need the right team of people to put disaster recovery in place in a successful way. And then the other thing that I see as a big problem is the testing. So it's great, it's one thing to say you have disaster recovery. And actually, just a quick show of hands, who has a disaster recovery plan of sorts today? Something. Okay, that seems to be That seems to be the magic number. This is the third time I've talked about disaster recovery in the last couple days, and it's always 4 people in my audience. And of course, the crowd size has been a little bit different across the board, but for this audience, that actually, you know, that's actually pretty decent. I'm glad 4 of you have it. All right, so then back on to the problem. So I think testing is the big one. And then tying into testing, there's the users. When you're testing, are you making sure that the user experience is similar to what they're doing, right? Or right, and you're shaking your head no. Are the users going to know what to do if you fail over? They may not know how to access their systems. And then one other major consideration, this goes beyond the users. What about your IT team? What is the communication plan if all of your systems are down? How are you communicating with each other? Interesting thing that I went through, so enterprise that I was working in, we had disaster recovery and business continuity, and we tested it. But we had a miss, and our miss was we were going to use email for communication. Well, there's a delay in the email coming up online in disaster recovery, and what we realized is that we needed an external system that was actually, it was a cloud-based product is what we implemented, something that wasn't tied to our local infrastructure to make sure that the teams could communicate successfully in a true disaster. So I think those are the major problems that I've seen. So on this next slide, then, I really just want to step back and talk about how I think you can work to avoid the pitfalls of disaster recovery. We talked about a lot of the gaps and challenges that enterprises face. So how do you be successful with disaster recovery? So one, don't cut it from the budget, right? I think that's the major first step. Now I know that can be really hard just because I've seen the struggle. The struggle is real. But what I've also seen is that there are a lot of really great new product offerings out there that can help you be successful and actually leverage the cloud. There are tools, and as you walk around the expo, there are companies that are offering the ability to access your on-prem virtual machines and convert them to cloud format and have them ready to go, sitting on just disk. You're not leveraging any compute in the cloud until it's time to wrap things up. Was that I'm out of time? Can I have 30? Okay, give me 30 seconds and I'll wrap it up. So anyways, there are, like I said, there are products out there that will help you pre-launch the disaster recovery that you need and make sure that you can cut over in a quick and efficient way without spending a ton of money up front. Because I think the biggest thing I've seen is a lot of organizations try to do it with a colo, and that's where the cost comes. So I think if you can leverage the cloud, that's a big deal. So I was told I'm at time, so what I'm happy to do is stay. If anyone has any questions, we can definitely talk offline. And one more just quick final thought. So I added another track to the record. And so I think the key to success with business continuity and disaster recovery is really to start before you're ready. You don't want to wait till that disaster strikes. Get out there, start looking around, and figure out how you can keep your business online so you don't experience the losses that many organizations have when they've experienced a disaster. So, thank you.
All right, welcome. So I'm Jaap. I'm a developer advocate with Rubrik. I do a fair bit of blogging, speaking, and I'm quite enthusiastic about automation. And when I say enthusiastic, I want to be as enthusiastic as this guy, but obviously he has way more commits on GitHub than I do. Anyone contributing to open source here? Couple of people? Yeah? Good. So, what we have for you today, I'll be starting a bit about infrastructure management, where we came from. Then we'll dive into the tools we have available with VMware. What can we use to actually manage vCenter, vSphere? VMware code, what is it? What can we do with it? And then at the end, I'll end with a demo on the Python SDK. Cool. So we're coming from a time where it was many to one server. So over 50 years ago, whenever the mainframe was supposed to be managed, there were dozens of people managing a single system. And nowadays, with the advances in automation and manageability of systems, it's actually quite common that we manage where a single administrator is managing hundreds of servers. And in some cases, when the environment is very uniform, it can be a single admin for thousands of servers. I think I heard a number of AWS where a single admin manages more than a couple thousand servers. So, sorry about that. So managing VMware, there's obviously a lot of different tools available to us. We have the vSphere client, the web client, and the FAT client. We have Power CLI, ESX CLI, and we have the APIs and SDKs. So what are some of the downsides and upsides for the different tools we have available? So for example, if we work with vSphere, it's obviously, when you're using the web client, it's going to be cross-platform, because any platform that has a browser, you can manage your vSphere environment. It's easy to use, because everyone can click around in a graphical user interface, but it's limited in functionality in the sense, if you want to do more than one thing, for example, you want to create 50 different VMs, it's obviously not going to be the right solution, unless you're paid by the hour and you really like to click using your mouse. So there's no potential for automation there. And also, because of the FAT client and the web interface, there were also differences between how it looked and how it worked, and some of the functionality was available in one client and not in the other. Then we have Power CLI. So Power CLI is the module that obviously runs on top of PowerShell, and ESX CLI, and both have a steeper learning curve, because if you want to be able to use Power CLI effectively, you need to know PowerShell, and that will take some time. And if you need to use ESX CLI, you'll have to know all the switches and in which combination you can actually use them. There's a lot of functionality exposed this way, and you can completely automate it. Cross-platform, I put it as yellow. So with PowerShell being open source now, you can use Power CLI on Linux, you can use it on your Mac, but not all modules not all Power CLI modules fully support PowerShell core yet. So a quick demo to showcase what the advantage of PowerShell is. So if we look here, we can see the OS, what's it called? And new VM. And with new VM, we can see there's a lot of parameters here. And if you wanted to put all this into a GUI, obviously you would end up with a GUI where you just have too many options. So that's the power of automation and scripting, is by having a single command, you can actually you can expose a lot of functionality that if you would put it in a graphical user interface, it would be very confusing. So this was a single commandlet that already took up a couple of screens of information, and there's over 600 in Power CLI. So I think that's a strong case for automation. So moving on, we have APIs. So APIs are cross-platform. I think it's the steepest learning curve, because you have to directly interact with the APIs. And similarly to Power CLI and ESX CLI, you have all the functionality and you can fully automate it. So if you want to learn more about the APIs, there's a VMware Code website. There's extensive documentation available here. And if you want to get started, the bottom left corner has the API Explorer. So moving on, there's also the Python SDK. So that's our fifth option. And using the Python SDK, so this is more focused for developers that want to write their own integrations with vSphere. Can clone this GitHub repository, and in the next demo I will give a short introduction to how you can get started and actually deploy a VM using the VMware Python SDK. So we start out with a shell. We do a git clone, so we clone the repository. I've already done that here because it's quite a big download. And then we'll switch over to VS Code. So VS Code is just a code editor. And what we'll do is we'll jump into setup.python, and if we take a look there, I don't have all the correct plugins installed. You can see all the requirements that will be installed the moment we kick off this setup script. So after we have all the required software installed to run this Python module, we'll dive into the samples, and we'll take a look at how we can actually deploy a VM to vCenter. So you can see we go into vCenter, we'll go into the setup, and we'll go down to testbed.python. We go to the top, we can see we can put our credentials here. So I'll replace admin by my own name. I'll put a password in there, and I'll put the correct server in there. After that, there's a couple more options that we can configure. We don't have to. For example, data center, which data store we want to use. I'll scroll down to that one in a second. So you can see we have the config blocks here. We can replace that, put some quotation marks there. And then after this, we'll jump over to the samples. And in the samples, I'll show the create VM command that's available. So the setup file is now saved and stored. So we're in vCenter, we're going to create a VM. You can see at the top are all the classes that we are importing. And if we go down, we can see there's a couple of required values, because obviously you need to name your VM and you need to supply what kind of data store you want there. And now if we would run this command in Python, we would create a VM, and I'm scrolling down right now. What we can see here is that it will actually output what kind of configuration is applied to this VM. So in summary, if we want to manage VMware, vSphere, it doesn't matter what kind of tool you like to use, but the direction we're moving in is it's going to be more automation rather than less automation. So if you're still completely focused on the GUI, go to VMware Code, take a look at the starting guides that are available, the SDKs, whichever language you're most familiar with. Consume the resources that are there, and if you end up building something cool, contribute something to either VMware Code or on GitHub, because it's a learning experience for you and you help the broader community as well. And that's it for me. Thank you very much.
Hey guys, so I'm going to start with, welcome back. Welcome back to you're like, oh. So I'm going to start, and before I even get into this deck, I'm going to ask one question that is either going to determine if this deck takes 10 minutes or this deck takes about 30 seconds. You like 30 seconds? How many of you actively watched Fraggle Rock as a kid at least? That remember Fraggle Rock? Okay, maybe we'll go like 6 minutes, maybe 7. We'll see. So I thought the title was funny. I thought, and I integrated some stuff into it for Fraggle Rock, but then as we were talking about it, if you're under the age of about 30, you don't even know who Fraggle Rock is. So that was hence this slide. So there are 4 different creatures in Fraggle Rock. Y'all remember this? Okay, so we got the Fraggles, my personal favorite, the Doozers, the Gorgs, which always, as a kid, kind of creeped me out a little. Like, this was not a kid's show, by the way, if you've gone back and watched it. Like, I put it down for my niece and nephew, and then realized I don't really want them watching it. And then the silly creatures from outer space, which hopefully you appreciate my graphic for that. So if you don't know, that was VM Underground 2 years ago. So we've got, obviously there's different setups and different groups that really work in with that. And they all manage to live in this one single universe. This one single group where you've got the Gorgs up on the top here, you got the creatures from the outer space over on the side. The Doozer's kind of around it, building out a little bit, and then the Fraggles in their main space in the middle there. Does this map look accurate to you guys from what you recall? I like how you're all like interpreting the map right now, like really digging in to see whether this map is accurate, as if you really remember that detailed. If any of you do, wow, that's impressive. But I had to look. I really spent quite a while to try to find a map of Fraggle Rock. It took me a while to find one, and apparently somebody thought to sketch one out. It's the best one I found. Now, if I take that away, now I need all these things to play together. I've got, say, we'll go back, the Fraggles, kind of like your primary, your file and block. They were the main important ones. The Doozers, these guys are the ones that are always building stuff and testing stuff. That's my test dev guys. Always trying out, figuring what the heck they're doing. The Gorgs. Now, Gorgs to me look like an old Jewish grandmother. And not a good one, but one that manages to keep everything and all of your backup data. And then you get these silly creatures from outer space that just, I don't know, I couldn't come up with a better one, so they're the archive data. I didn't have a good analogy on that one, so that's what you got. Now, if I try to take all of that and make that all live in one world like we had for Fraggle Rock, how do you think that really works out? It really doesn't. You've got it in a lot of different spaces, it's really fragmented, it's really separated. So we end up with what we would look at as mass data fragmentation. So how many of you have heard of the term mass data fragmentation? That's not a very lot of you. So I'm just going to go ahead and put the definition up to make it easy. So mass data fragmentation is that growing proliferation of data across many different silos, many different environments, including as you get into multi-site, multi-cloud, and it's not utilized to prevent organizations from actually utilizing it to their full value. So what can we do about mass data fragmentation and what causes it? So the first thing that causes it is having fragmentation across different silos. Now I talked about it with the Doozers being your test dev and the Fraggles being your primary data and your file, your object. You've got your archive. I thought about potentially saying that the creatures from outer space, maybe they were the searches and the analytics, but it didn't seem to fit as well as archive. So you've got all these different pieces of data, but you can't really search across them. You can't figure out what's in each one. They're all used for different purposes. But now what if I take all that and I put it down within a silo and dig in even closer? Now I've got data, say, even within just file and object that's sitting on software, it's sitting on different shares. Maybe I have a NAS here, I've got a block share over here. Then I look at backup and recovery, and maybe I have stuff sitting on tape still. If it got sent out to Iron Mountain and I have no idea what's on that tape, because you guys don't keep like a spreadsheet of what's on every tape, right? I mean, that would be weird. I was hoping none of you said yes to that, because then you really, really need a hobby, especially if it was the same person that knew the map of Fraggle Rock. That would concern me, and you should move out of your mother's basement. So we know you're not doing that, so you can't find all that data you're looking for, even within a silo. But then I don't have just one silo anymore and just one space. I've got multiple data centers that I'm replicating across. I've got multiple locations. Now I add in and I've got all these different clouds. I've got data out in AWS sitting somewhere. I've got data in an Azure blob somewhere. And then I've got all these remote offices also. Now, if I've got all of this, it's not just about all the data being in different spots, but now I'm putting multiple copies also. Think about it, I've got a branch office. Most likely I have that HR document or the hiring document that sits out at the branch office. So it's easy for them to get it. And it's at every branch office, and it's at every HQ, and there's probably a copy of it in every backup that you have done for the last 27 years. And then it's probably sitting on a cloud someplace because somebody copied it up to Dropbox. All of those copies just become redundant data that you have to find some way to work around. All of that really is creating this world of mass data fragmentation. And it's not the map of Fraggle Rock that allows you to really see very simply where everyone is. There are pieces all over the place that really spread out where your data is. Now, we're going to have a little audience participation. Because why? Because it's fun. So more than how many organizations use 6 or more solutions for all of their secondary data operations? How many do you think? What percentage? Audience participation requires you guys to say things, just so you're aware of the term. Take a guess. Somebody throw a number out. 60%, 80%. Only 35%. So not as high as you thought, but 10% of them, so 10% of organizations have 11 different applications. So where are they keeping all that? Number one, I have no idea what 11 they could possibly be using, but that's what the survey came out to. So now, this one's another one. How many percentage of organizations have between 4 and 15 copies of the same data sitting out somewhere in the organization? Keep in mind that I'm going to give you a little hint on this. When the 10% have 11 or more copies. Now this one you could have gone higher. Y'all are not doing well at this game at all. Wow, is it because it's late on Wednesday? I'm between you and a beer? It happens. So 63% of organizations have all these multiple copies. Again, too much data sitting out there. So now this, you guys were so bad at this, I'm just gonna give you this one. So 85% of companies store data between 2 and 5 different public clouds. Now, keep in mind, 2 and 5 could be your local regional cloud. It could be a local partner that's specific to something. Or it could be AWS, it could be Azure, it could be Google. So these clouds don't necessarily mean they have to be the largest places. Could also be multiple locations within, so maybe many data centers inside. I think the key to this, though, is on top of that, 74% say that they have a redundant copy of their data stored out in the public cloud. Now, last time I checked, in the public cloud, we pay by how much we put in it, yes? So it makes perfect logical sense that we would keep multiple copies and keep paying for multiple copies. I don't know about you guys, my mom told me that was a bad financial decision. Yet, that is what companies are doing because they're scared of what's going to happen with it. And they don't have a solution around getting that data fragmentation solidified. And they're scared of it because that extra time it takes right now, if you had a cost-effective tool to manage that fragmentation, it could save on average 16 weeks worth of time for most large enterprises. Not only that, but that's scared of it, that CIO, that IT director, the CISO are concerned because most of them, 91% of the people we surveyed came back and said that they were concerned about their level of visibility into where their data was. It's not just about, I know this is my compliance data, but if I don't even know where my data is and where the copies are, I can't search for them, how in the world am I supposed to confirm to an auditor that I'm meeting PII and HIPAA and GDPR and every other regulation that every non-technical person has decided to throw on top of us to make sure that we can see our own data? It's almost impossible. Those same people that are worried about the storage are also looking at this saying that it's not only not safe, but they're blowing their budgets trying to manage all this data. They're having turnover because there's just IT burnout of people just going through it and through it and through it. So it's just not working, and it's causing people to quit. All consequences of having this data scattered all over the place. Now, you would think that if people don't want to listen to that, maybe solving this mass data fragmentation issue will be looked at when we see that there is opportunities in this between $800 million and $1 billion just in new business revenues, not accounting for even the lost revenue that you're having on those weeks you're losing, but potential increases. 20% saw that they would have a 6 to 8% increase in their revenue if they could actually manage their data. So it becomes a financial improvement to do this. So really what we're looking at as a whole is we've got to find a solution to get rid of this fragmented data, get beyond Fraggle Rock, and bring the world together and stop the fragmentation. Make it a nice, pretty globe. Not Fraggle Rock. Pretty globe. Not Fraggle Rock. Got it? Stop the fragmentation. Thanks, guys.
All right, good morning, everybody. I'm Tim Smith. You can find me at Twitter at tsmith_co, but today we're going to talk a little bit about growing into your IT role. Now, the reason I chose this topic was because 2 years ago, I worked for a reseller technology company that decided to just let everybody know, hey, we're going to close the doors, have a good day. And they didn't even let the customers know. I didn't even get paychecks. We didn't get W-2s, all that fun stuff. So I was in a situation where I needed to find a job. So what I realized was I had a little bit of free time. The job hunting, however, was not going so well to start with. I was looking through different job openings, right? And I'm looking down through the requirements, the qualifications that were there. And all those qualifications seemed to be higher than what I wanted, or higher than what I had, I should say, or they were things that I would be considered overqualified for. So, you know, print administrator, or, you know, like level 3 top guy, CTO, that's not me. So throughout this journey, I've realized a couple things. And one of those is that in qualifications that are on the resumes there, those are mostly for the employer. That's a best case scenario for the employer. What you're going to see on those requests are not necessarily what they're actually looking for, if that makes any sense. So what I mean by that is, one, the qualifications I find on job requests or job postings are rarely written by somebody who actually knows the role. You know, we're going to need 6 years of Kubernetes. You're not going to have that. Nobody's going to have that. Or you're going to see, like, I need you to have your CCIE, you need to be a master certified automotive technician, and you need to have a Pulitzer Prize. What they're really looking for is for somebody that can hit maybe one of those. And obviously those are very bad examples, but they're looking for somebody that can hit one of those, maybe 2 of those, or they're looking for somebody who can hit one of those and grow up into one of those others. So when I started looking at qualifications listed on job openings, what I decided was those should be targets for me to hit within being in that role for 1 year. So if they said you need to be able to administer NSX, I am not an NSX admin. I have very little networking experience. I'm the IP any on the firewall guy. So my goal is if they said we needed a vSphere admin, but you need to have NSX experience as well, my goal would be within that first year to have obtained VCP network virtualization, to be able to have the education and certification to show the requirements that would be met. Now, don't forget, in job hunting, negotiations are everything. Everything is negotiable. So you're going to go in, you're going to talk about salary, right? You're going to talk about time off. You're going to talk about all those things. But don't forget to talk about negotiating the qualifications, because you might have maybe educational experience. Maybe you've never had hands-on experience with something. A lot of times that's good enough where you can say, look, you know, I've got this particular course or training material I've taken, Let's go ahead and say that within 6 months, I need to demonstrate some sort of deliverable that I do actually have the equivalent hands-on experience because of my book knowledge of the subject. And a lot of times you might find that they'll say, okay, well, let's go ahead and say, we'll start you off at this salary, but once you prove that within a 6-month time, then we'll be at the target salary that we negotiated for. So we're already starting to grow into our IT role before we've even taken the particular IT role by setting a goal of that learning path or where we want to be within that time. Also, when we're talking about growing into your IT role, complacency is going to be our enemy. So whether you're getting lazy in your job, so let's say you've been at your job for a couple years and it's the same thing day in and day out. They're going to have you check the backup reports every day. You're spending maybe an hour doing that. You're going to spend another hour doing this, and it's the same thing over and over again. You've gotten to the rhythm and nothing is new. Well, if you don't have time that you're dedicating to challenging yourself, you're going to get very complacent in your role, and you're going to find out that the rest of the field is leaving you behind because they're learning the new technologies that are getting released. They're learning the new technologies that your company's already implementing, and you're sitting here staying with the legacy technology that keeps working its way out the back door. So, try not to get complacent or lazy in the role you're at. You want to challenge yourself. So I like to say, always be learning. That's kind of the thing I always tell my wife. I always tell my kids and my coworkers. It's my theme in my life is try to always be learning. So in my case, my role currently is a solutions architect at Veeam, and I have nothing to do with Kubernetes. I have nothing to do with Python. However, I've set goals to learn Python, take some Python courses, training within the next couple weeks to get that started, and then also to start learning Kubernetes maybe 6 months from now, because I see that those are places, right, that the technology is heading for. So even though they're not requirements or any necessarily thing that's going to do with my current role, I want to make sure that I'm always learning something new. That way, if something does come up, or if my job role changes, then I'm going to be prepared perhaps for those changes. So, and likewise, to always be learning is really almost synonymous with that last bullet point, right? Keep yourself challenged. Keep your job challenging. Now, what I mean by that is don't go taking on roles and responsibilities within your current role that you shouldn't have. What I mean is if you're a administrator for a company and one of your things in the morning is to make sure that the backups are all completed successfully, and that normally takes maybe an hour and a half of your time. Let's say it's a large organization. Well, one thing you can do is start automating that particular part of your job. Maybe you don't know much about automation, so now what you're doing is you're taking your current responsibilities that you've been doing and you're adding a new challenge into it by learning another way to do it to free up more time. So now you're challenged, you're using your natural problem-solving skills, right? Because we're all in IT, we're all natural problem solvers. It's kind of in our DNA. We want to solve problems. One of those problems should be ourself. Now, when we're talking about job challenges, and job hopping is something that comes up, right? Well, what if your current job is not challenging? Should you jump to a different company? I've read that on average, it should take between 2 to 4, so I like to say an average of 3 years, to master the current role that you're in. So within 3 years' time, you should be able to say, I am a master of this role. If somebody new is coming into this role, I should be able to fully train them and have the confidence to tell them what all is required of them, how to do it, and so forth. So within 3 years' time, if your role or what you need to do has not changed, you might need to look at hopping. Now, some people say that job hopping is a bad thing. Some people say it's a good thing. And as time has progressed on, there's been more and more job hopping, right? Some people say, well, it's the millennial thing to do. You need to stick with one company. And on the other side of that, the millennials, we might say, well, why should I stick with this company when they might fire me and give me no notice? Where's the loyalty? And there's actually a nice happy medium to that. So what you might find is if you want to challenge yourself to learn something completely new, you're probably going to jump out to a completely different company. But a lot of times people forget, job hop within your own company. If you like the company you're working for, if you meet the 3 requirements, right? Good money, good boss, good culture, you know, if you've got that golden company that you're working for, stay there, but hop within it. So maybe you get started as a help desk. Maybe you then jump up to junior admin. It's kind of a natural growth. Maybe you work over and jump to kind of a sideways role. Maybe you want to work with the development team a little bit. You can do that in this role, start learning some of that. So maybe you do that sideways hop. You're challenging yourself in this current role to be prepared to jump sideways into dev. Maybe you don't like that or it's not working. If it's a good company, they're probably going to let you come back into your one role. You'll also see a lot of times that people might jump out of their current job to go somewhere else for 6 months just to come back to get a pay increase. It happens a lot, and sometimes that's the only way to get a pay increase. So you kind of have to find that fine line between where you need to go for growth versus where you need to go for knowledge and stability, though, in your career. So if you're going to hop, don't burn bridges. Now, when we're talking about job growth or personal growth, you might see this a little bit, the Dunning-Kruger effect. Now, what I like about this is this is exactly what I went through. You know, I was lucky enough to have Microsoft courses at my college, so I was able to take those and go through the whole MCSE training course in the university. So when I got out, when I started, I had no idea what was going on. When I got out, I'm like, well, I am an IT god. I have completed the MCSE certification track. I just didn't take any tests, but then over time I realized, well, no, I don't know anything here. And then you start to hit that slump, and then you start working up, and you get more confident in your skills as you gain that. And you gain that confidence, and you say, oh no, I am a master of this now, or I am confident in my abilities to do this. And so during your growth as a person, you're going to go through this. The other thing that you might hear about is imposter syndrome. And sometimes people will say that it's the same thing as the Dunning-Kruger effect, but it's not. So Dunning-Kruger is more of the growth of yourself in that particular track. But imposter syndrome is something like what I had for this, right? Well, there's more people qualified to talk about this, you know, like I've only lost one job. These people have lost 5 jobs. I am not the person to talk about how to grow yourself or whatnot. And it's natural, and it's actually a good thing. And everybody has imposter syndrome. You might look up to somebody like William Lamb at VMware, and you're like, man, look at those blog posts he does and all that programming he does, and I want to do that. But I guarantee you, and he's talked about it before, he's had imposter syndrome. Everybody has it, but it's a good, healthy check to say, I need to stop, evaluate myself. Do I actually have knowledge? I cannot dismiss this knowledge I've already learned from the knowledge that I'm looking at up here to obtain. So don't judge yourself and your knowledge ability based on what other people have already obtained. Use your imposter syndrome as a force for good to give that constant check to say, yes, I am knowledgeable. There's places I need to grow. I'm working to grow those because I have a plan. So wrapping it up here, never be 100% qualified for the job you're in. If you're looking for a new job, make sure you negotiate. Yes, I can meet those qualifications within a year for you, Mr. Employer. You know, don't get complacent in your current role. You're going to get lazy, you're going to get bored, you'll get left behind. Sometimes the bad things can turn into good things. I was very happy in the company I was at. When they went under, it forced me to hop from the reseller side to the vendor side. Pay increase, satisfaction, time off, all of those things increased for me. And it ended up being a lot better than I could have ever imagined. Thank you.
Hello everyone, my name is Hans Bernhardt and
I'm Simon Hamilton-Wilkes.
And we're here with Mark the Caveman to present to you multi-cloud for your caveman. So, as an introduction, as we know, multi-cloud is the new normal. And just like clouds in the sky that have many different characteristics, we are quite aware of the fact that the clouds that we use in our compute world are also quite different and have many different characteristics.
So we have this complicated world where every cloud has different intrinsic properties, and there's no way to transfer stuff between them at all easily. Pat sort of called out this morning that 97% of organizations are planning multi-cloud for their mission-critical apps. 70% foresee the ideal end state being multi-cloud. So there's this thing where rather than just the simple migration from on-premises to the cloud, there's lots of clouds, and on-premises has become a cloud as well, as VMware likes to preach with the whole SDDC. So those migration and mobility challenges, mobility in the sense of the mobility of applications and VMs, everything's incompatible. They're all running on these different stacks from different vendors and developed over different timescales. There's all the different networking and security bits where the underlying IP address network is different, so it's very basic, up to more complicated things such as instantiating security policy and making sure that workloads are equally secure in one site or another one. And then there's application dependencies, and where applications are dependent on multiple components for the application, or where the application is dependent on an external thing like a big data repository or a whole bunch of other things. And then all that leads to disruption, because instead of being able to migrate workloads transparently, you have to take an outage and figure out how to get them from A to B and translate whatever you need to translate in the process.
So what this comes down to is we have all these, we'll call them disparate clouds that we have to work with, and our caveman says, cloud, big, many, must move workloads. And that's fundamentally our goal, to be able to move any workload, whether it be a virtual machine or containers or pieces of apps, vApps, which would be virtual machines in different clouds actually working together across clouds. So our caveman is getting smart, and he starts thinking about it. Now that I think about it, I really am interested in making all these clouds work together, but I gotta note that the underlying plumbing is pretty complex. It would be great if it seemed like it was all unified, like in one single pipe. And speaking of pipes, well, not really a pipe, but let's start with VMware as the company to deliver multi-cloud and look at what looks like this big pipe here. And Simon and I went back and forth on this because this is actually rock stick candy. So Simon, if you would explain this metaphor.
All right, so to explain from an American who calls it rock stick candy, which makes no sense to me, this is called a stick of rock. And there's places in England, specifically Blackpool, but other places that sell this type of candy, which is a solid sugar thing like a candy cane you'd have here on a Christmas tree. But the neat thing is in the manufacturing, they put the same text all the way through. So as you eat it, you reveal the same text all the way through.
But in this case, the metaphor is not the same text all the way through, as you can see. It's actually the same cloud abstraction layer that goes through the entire rock stick candy. So there's your metaphor. And of course, Caveman Mark says, forget pipe, consume candy. Abstraction is good. Shall we start at the bottom?
So the whole origination of VMware is abstraction. So back in the day when Hans started at VMware,
19 years ago,
the hypervisor came and you were abstracting from the hardware. And then as time has gone on, there's been abstraction from the networking layer and abstraction from this and abstraction from that as we've put more automation layers in and other stuff. So we're now trying to figure out what extra abstraction we can get in order to do the same thing that abstraction is accomplished everywhere else, where it's made this, it's become this buffer to enable flexibility.
Basically, but here's the deal. You know, we have this abstraction from physical to hypervisor to data center to cloud, but every time we abstract, I'm sorry, I need to speak like a caveman. Every time we abstract, we add a cool new layer of functionality which automates and simplifies at one layer, but then adds another layer of manual tasks. Those tasks then need automation. It's a simple reality as a cloud matures and can get complex. Now, restated, The way I like to say it, and the caveman will say it, is when you add a layer of automation, it adds another layer of cool things you can do, but it also adds another layer of manual things you can do. So restated, it's manual, automatic, automatic, manual, manual, automatic, automatic, manual, manual, automatic. I see heads nodding out there. Bingo. So we're at the point where we need to put an abstraction layer up above all of these clouds, and we need help at our existing and the new layers. And
so integration is sort of the key thing. So having this abstraction layer, integrating all these different component parts to enable that workload mobility without having this huge short list of manual steps that you have to go through. Because it's no good being able to accomplish this if the way to accomplish it is a 30-step process for every VM migration.
And Caveman says, layers, integrate, yummy. So what it comes down to is HCX is going to be the icing on the multi-cloud cake. And of course, Caveman says, good, hungry, consume clouds. HCX is going to be that abstraction layer above all of these clouds. And this is where I hand over to Simon.
So HCX has got all these great features, and we're going to gradually delve into a few of them. But the basic idea is to be this layer that is able to migrate workloads between different clouds and different on-premises environments too, and fudge the differences enough that the workload is moved in like a online migration vMotion type way, even though there's a lot more going on behind the scenes. Because you might be going between disparate vSphere versions at least, if not going from one completely different environment to another. And in so doing, you can fudge all kinds of other things, like you can have like a single VM-based enhanced vMotion compatibility flag, and all these different things that they've built into the product to facilitate this sort of interworking that previously was infeasible. So previously we'd have to cold migrate a workload, and that would be the only way to do it. And even if you could cold migrate it, you might have to put it through a transformation process as well. HCX does it all online, which is pretty neat stuff.
Cool. Oh, is that basically the same thing? Whoop. Okay. So I will leave that up to you.
In order to accomplish this, HCX does all this stuff. And this is where HCX was 3 weeks ago prior to the most recent release. And HCX is on a kind of continuous release schedule where they push new builds every 6 weeks or so, and they just show up in the release notes. And I'm constantly hitting F5 on the release notes to see what new stuff has come. But the cool thing here is you can kind of start to see the problems that HCX is solving, because it's in order to retain the IP addressing between environments, it's doing layer 2 stretch. In order to do redundancy and bandwidth management, it's doing WAN optimization. And all this stuff is happening in the various virtual appliances. And then the new stuff in the enterprise SKU, which just launched a few weeks ago, is non-vSphere migration. So this is operating system agent enhanced vMotion or migration, where we're installing an agent into a virtual machine which is running on a non-vSphere environment. So KVM and Hyper-V right now, more presumably to come. Large-scale migration, so where previously you could do large-scale migrations and you could script them, that stuff has been enhanced even further. It's using vSphere replication usually to pre-stage the bits as much as possible in the destination environment, so it's not having to send them all down the wire at the time of the migration. And then HCX already had basic DR, and it had a nice, very simple interface where you could right-click on a VM and say, protect this VM, and it would set up the vSphere replication in the back end and make sure everything was plumbed correctly, and you'd have a basic recovery plan for a handful of VMs. But it was really just for a handful of VMs, and it didn't have the sort of enhanced scripting for recovery plans that you have in SRM, where you can change DNS and go off to various other resources and make sure other stuff is reconfigured to point at the new destination of the VMs in a more optimal way. So that integration with SRM has been added.
So now that I know that I can move my virtual machines around between multiple clouds with this HCX thing, how do I hook all this stuff up? Ooh, this is where I get to talk, because I like to be a virtual plumber. I'm going to simplify this. I like to take things down to the root nugget of what we do here, as opposed to getting into all the bits, bytes, and feeds. So HCX is simply an abstraction layer above our clouds. Now let's think about it for a second. An abstraction layer above a physical server is a hypervisor, and that abstracts us from the physical resources to the virtual resources. And then we can stick agents inside the hypervisor, and we can also use management appliances to combine multiple hypervisors into a private cloud, and you think of that as an abstraction layer above our hypervisors to give us private cloud. But now we have all these different clouds, and we don't have the ability to say, hey, give us the same hypervisor across all these clouds or agents in those hypervisors. But what we do have the ability to do is stick appliances, virtual appliances in our environments to meet key cloud functions to tie all of these clouds together and act as an abstraction layer above them. So we have to be able to manage, one of these functions is we have to be able to manage this entire environment. The second thing is we have to be able to connect all of these clouds. The third thing is we have to be able to optimize a connection. We have to be able to keep some kind of high-speed networking going between all of these clouds. And then we want to be able to extend networks between the clouds, our existing networks that our virtual machines are on. And then Simon mentioned the OS agents for virtual machines to move around. There's different ways to move our virtual machines around, but the bottom line is when we move a virtual machine from one cloud to another on those extended networks, we want them to keep their same IP addresses. We want them to keep their same functional characteristics for our applications. So take it a step further, these are the actual virtual appliances, the names of the actual virtual appliances that meet these functions. The HCX Enterprise Manager and Cloud Manager to manage the entire environment, the interconnection appliance, the WAN optimization appliance, and then you have the HCX Network Extension Virtual Appliance, and then you finally have the HCX Sentinel Gateway Appliance, which again works with virtual machines that have agents inside of them to be able to move virtual machines that way. So that's the simplistic way of describing HCX as an abstraction layer above these different environments, these different clouds. And of course, Caveman says, oh, I see many clouds, virtual appliance to manage and connect between clouds. Optimize a connection, extend layer 2 networks, and then connect to and move VMs between clouds. Yummy clouds. And this is where Simon will go into greater detail about some of the capabilities here.
And I want to make clear that though this starts to look really complicated because there's so many VMs and virtual appliances involved in HCX, they're actually very straightforward to deploy and configure. And it's all a fairly automated process once you've deployed the initial manager, be it HCX manager or cloud manager as it's called when it's in the cloud. So you deploy the multi-site system software, which is deploying the manager and then going within the manager and saying, deploy me a WAN optimization appliance here and one there. And then the various appliances, some are per different configuration boundaries. So the network extension appliance is per distributed virtual switch, for example. The WAN optimization appliance is per pair of sites. So if you're setting up a ring, like we saw in the earlier diagram, each site would have a WAN optimization point appliance for one traversal to one cloud and another one to another cloud, etc. So those are the interconnects. Extend the networks. So again, that's a network extension appliance, which goes across the whole distributed switch. And then in this case, this is a migration off KVM or Hyper-V. So this is where we use the Sentinel agent installed into the operating system to do an operating system assisted migration. So because the hypervisor isn't vSphere, we don't have vSphere to do a migration, to do a vMotion. So therefore we have to do it another way. And the other way in this case is to use an agent. because the only other way would be to use to power the machine off, and then use like vSphere converter to do the biz. And then you can migrate VMs from KVM and Hyper-V into vSphere live, which is a pretty cool trick. Disaster recovery as a service. So again, this is an enhancement that's recent as part of the enterprise SKU, which was just released a few weeks ago. The automation capabilities of SRM with the existing stuff in HCX for the most part. And the cool thing is then you get the powerful runbooks that you could do in SRM to go off and do things like change load balancing rules and change usually external facing DNS. So HCX is really good in terms of when it does network extension, it can do local egress. So the traffic, once the VM has migrated from site A to site B, will egress at the local point, which is great because it's better than hairpinning it all back down the WAN optimized link. But somehow the new connections have to get to the workload. So that's where being able to change DNS entries and stuff is a good thing. I think that's all there is to say on that.
Aha!
And then the future, so with the big disclaimer that we're not PMs, we're not within the HCX team, we're not talking futures, we're purely being
speculative,
futurists, fantasists.
Imagine if.
But wouldn't it be cool if VMware's huge portfolio, which has increased in the past several months even more appropriately, everything's API driven, if you could orchestrate taking cloud health alerts or the cost comparisons of different clouds and plugging that into HCX to do workload migrations auto-magically, and then concurrently changing load balancing rules and distributed load balancing in AVI networks, you could do some really cool stuff. And you could have workloads that migrate from cloud to cloud according to cost or availability constraints, or according to the characteristics of those particular clouds. So you could say, oh, I need to have access to this gigantic S3 bucket. Let's migrate that workload into Amazon for the moment, or VMC on AWS, because we want the proximity to a huge S3 bucket. And then, oh, well, now we need tons of AI compute power. Let's migrate that into the Google Cloud, where we have better access to raw GPU power.
And that's where, when Simon was talking about this, I was like, oh, this is so cool, because this is where you start to realize, when you start to think about the layers and how we keep building and building and building, you go from hypervisor to multiple hypervisors connected by some manager to multiple different clouds, and now we're up here putting a layer above all that, private and public clouds. Well, back in the vSphere days alone, you had, great, now we can do distributed resource scheduling where we're managing at the private cloud level resources and moving virtual machines around automatically. Then we got into, hey, DPM, distributed power management in vSphere. Well, now we're surmising that at a higher level, and again, we're not PMs and have no inside info, but we're surmising that as we add this HCX level, allowing virtual machines to move around amongst clouds, that AI will be added to that with things like Cloud Health, AVI, and whatever else, to be moving virtual machines around intelligently, from a cost perspective, from a resource perspective, from a networking perspective, and so on and so forth.
Yeah, the workloads, the use cases just proliferate the more beers you drink. But there's an infinite number, and you think, oh, you could park workloads in low cost, on-premises, low performance silos when you're not using them, and then particularly for workloads that are seasonal in nature, and then you could roll them out to a high performance environment later or wherever. I mean, there's all kinds of
cool stuff.
Cool stuff, exactly.
I should have, I'm sorry, the caveman's not in there saying cool stuff. My bad, I should have put the animation in there. So, more stuff, or more, how do I learn more?
Obviously, the HCX site. I wrote a white paper on this for the partner that I work at. After 5 years at VMware, being at a partner gives me the freedom to write things in white papers that I could never get past VMware Legal when I wrote white papers working for VMware, which is kind of cool. So,
And last but not least, well, definitely go try the hands-on labs. We want to make sure that you get some hands-on there. And whoa, that's it. Thank you. Make your mark. And Mark the caveman is back, and he says, "Make Mark big." So thank you very much.
Any questions?
Questions?
All right, hello everybody, and I appreciate you coming to my session. I know that you have a lot of different choices on what to do, so I appreciate you coming here. Today I'm going to be talking about my experience building and maintaining a vSAN with certified components. So the agenda for today is I'm going to talk a little bit about me, why we chose vSAN, my preparation for building, and then building vSAN, maintaining it, and in a few minutes maybe for some Q&A. So a little bit about me, you're not going to go over all this, but I am on social media, and there's my Twitter handle. I work for NJVC as a systems engineer, been there about 8 years. I'm the St. Louis VMWorld leader, been doing that for about a little over 5 years. I have a lot of certifications. I got my first certification back in '98, and I have 3 patents, but they're nothing to do with virtualization. So if you want to talk about those later, just come and find me. So one day my boss said, hey, I need you to come in my office and talk about something. And so I sat down and he said, yeah, we lost this big government contract that we had, and most of the equipment that we have was tied to that contract, and we have to turn it back in. And I said, okay. I said, well, do we have a budget to replace all this and maybe 6 to 8 months to do all this? He's like, no, we don't have any budget, and we have to do this in like a month. And he's sitting there like everything's fine, and I'm just like, I can see the building's getting ready to burn down. So after I got that image out of my head and calmed down a little bit, then we decided that we had to basically discuss these main 4 things. We had to talk about budget, requirements, constraints, and risks. And so because basically we didn't have any budget, we had lots of constraints and some risks. It come down to basically vSAN was sort of our number 1 choice. We really didn't have a big budget to go out and purchase a huge SAN. And so one of the main reasons that we chose vSAN was we already had a bunch of servers that we didn't have to turn back into the government that were not being used for anything else, and they had a lot of RAM in them. And so this was one reason that we chose vSAN. Another reason that we chose vSAN was we had an ELA, and we had some vSAN licenses that we could use. And so we didn't have to go out and purchase vSAN licenses. And so we had servers, some equipment, and we had the licenses. And so that helped us make that decision to use vSAN much easier. It would have been easy if we had the budget and we could just went out and purchase VxRail or a vReady node solution, but we didn't have that option. We had very little budget to work with, so this was sort of a no-brainer. And so once I made that decision that we were going to use vSAN and we started heading down that path, a couple of things I had done was read as much as I could, and luckily I had already been reading some of these materials already. If you haven't been reading anything on vSAN yet, these are 2 very good books to go out and start reading. And this is a website that somebody put together that's got a whole list of all kinds of vSAN resources that you can go out and look at. Obviously I didn't put, if you scroll down in this list a little bit, there's all kinds of documentation and resources. If you're thinking about building vSAN, this is one you definitely need to go and look at. So once we decided that we were ready to start building that vSAN, one of the first things that we looked at was the licensing that we had. Because ESX licenses are different than vSAN licenses. And even though we had some vSAN licenses already, we had to look at what the differences were between the different tiers of licenses. So we had the standard licenses already, and I really wanted to do erasure coding. So if you look down in this chart up here, erasure coding is not in that standard license. So we went out to our TM and looked about how much it would cost us to upgrade to that advanced license, and it just wasn't in our budget. And so that was one of the constraints that we had. So we had to stick with non-erasure coding. So it was something that we had to plan for when I was thinking about how many SSDs we needed to buy and how many servers we actually needed for our environment. So one of the things, if you're thinking about building vSAN, definitely look at what license you can afford and what features you really want, because obviously all the licenses don't have all the features. So once we figured out what licenses we had to work with, the next thing I had to do was figure out the servers that we already had. The controller that was in them was not compatible with vSAN. So we had to go out and purchase controllers, and then we had to figure out which hard drives were compatible with vSAN. So the way we did that was you go to the VMware HCL website, and then on the HCL website, there's a link in there to go to vSAN. And so you just select that link, and that'll take you to the vSAN HCL. Because until I started getting deeper into vSAN, I just thought that if my equipment was compatible with the ESX HCL, that we were all good, everything would work fine. But that's not true. So you have to make sure that all your hardware is compatible on the HCL list before you start going down that path. And a lot of people say, well, even though it's not in the HCL, I can still get it working. And that may be true. You might be able to get it working, but your health checks are not going to pass. And then if you have an issue and you call support, you're probably not going to get support either. So it's best to just make sure that the hardware that you use is on the HCL. So once you get to the vSAN HCL page, I really hate this page, but you have to use it. And one of the reasons I hate it is that if you're going to build your own vSAN, you have to find down in that real small print down there where that green arrow is. That's the link that you need to click on if you're going to build your own vSAN. So this page is really designed if you're going to buy a ready node or a VxRail, that type of thing. So you have to scroll down to that green arrow if you're going to build your own vSAN. So once you click on that link, then it'll take you to this page. And the three main components that you need to make sure that are compatible with the vSAN link are your controllers and your spinning disks and SSDs. And so we made the decision that we were going to build an all-flash vSAN. Luckily, we did have the budget to do that. So if you have your hardware and it's online already, this is a tool that will help you determine if your hardware is compatible with vSAN already. So you can just load this up. It's a command line tool, and it will tell you if it's compatible or not. But unfortunately, because of the time constraint that I had, I didn't have time to get the servers all online and load this tool. And so I did the work manually already, but this is a good tool that will help you sort of automate that process. I'm sorry, very hard. No, I don't think it does. Yeah, sure. So this is the controller that we end up using. The SAS 9361. There were some other controllers that our VMware TAM had sort of recommended, but when we worked with our local Dell rep, he told us that they were not supported in the configuration that we were trying to use. So after a lot of research and talking with different people and checking the HCL, we determined that this card was the one that we were going to use. And when you're looking at choosing different controller cards, you want to make sure that they support pass-through, because you're not going to use any RAID 5, RAID 6, anything like that. They have to support pass-through, and you want to look at queue depth. So those are the two main things you want to look at when you're trying to determine what controller card you're going to use for vSAN, if you're going to build your own. Correct. You also have to worry about if you're going to do an all-flash array or a hybrid. And then when you're on the HCL, that will, if your controller is on the HCL, it'll tell you that in the information. So these were the SSDs that we chose. We did have the budget to do an all-flash, but these are not the fastest enterprise SSDs. So these were really the ones that we could afford. And one of these are for the 480 gig we chose for the cache, and then the 960 gig was for the data. And so you have to make sure that the ones that you choose for cache are on the HCL for cache, and then the other ones are compatible with data, because not all the drives are compatible with both. So you want to make sure that the ones that you choose are compatible with what you're going to use them for. So once we had all the hardware, we had all the controllers and the drives, and I got everything put in the servers and all racked online. I got ESXi loaded up, and got it all in vCenter and everything like that. I thought I was ready to go. I thought I could just run and start make data stores and everything like that. Well, that's not really the first process that you should start doing. You want to make sure that vSAN is healthy, that you have all your drivers that are correct, and it basically tells you that your hardware is correct and everything. And you'll see on this next slide right here, basically you want to make sure that everything is green, that it says the vSAN configuration is correct, that all your hardware is good, and all your cluster is good. And then basically once you've see that the hardware's passed all the checks and everything, then you're ready to start doing some more of that configuration. And this is another screen that shows you basically you've got it all configured correctly, and you're ready to start making that data store that you can start putting things on it. And then this is a different check. This is in the this was the 6.5, I think, non-YouTube version. In the YouTube version, the screen was a little bit different. So after we got it all configured and we're confident that everything was all healthy, the next thing I did was I configured every alert that there was for vSAN, because I wanted to make sure that if something happened, I was going to get an alert for it. So I went through all the alerts that were, and I configured every one of them. So after we had it all built and we were fairly confident that it was configured correctly, and we thought we were ready to start putting data on it, one of the tools that I wanted to use was HCI Bench, so that we could do a little bit of stress testing with it and making sure that it was going to be production ready. But unfortunately, because of the time constraints that we had, I was not able to use this tool. So, but if you are thinking of building one on your own, this is a good tool to use. It's a Fling. Just go to the Fling website, download it, and you can run that and test it out. So once we had it all built and we were fairly confident that it was ready to go and start moving production data to it, we basically had the servers from our old cluster, and then we had a new cluster, the vSAN cluster. Basically, I just selected the VMs from the old cluster and did a storage migration from the old cluster to the new cluster. And luckily, we had a 40 gig backbone, and so we weren't worried about bandwidth. And I didn't select a bunch at a time. I just started with like maybe 10 or 15 VMs and started migrating them over. But one thing you'll have to watch is that if you can see up there on the right-hand side, there's two little triangles that was telling us that that there's a warning up there. Basically, when we started migrating a whole bunch of data over to it, it had to replicate all that data over. And so that's what that warning was telling us, that it was replicating what's the right word? Basically, it was putting multiple copies on different servers, and it was trying to migrate all that data to different servers. So it took us, I think it took us about 4 or 5 days to migrate everything off of our old cluster onto the vSAN cluster. So I would continually watch this while I was migrating data to make sure that I wasn't migrating too much data at one time, and I would give it some time for it to replicate out all that different data. And so one of the things you can do is, while I was replicating that data, you could come into this screen here and you could see what data on what server was being replicated. That way you didn't have to just sort of guess on how long it was going to take for that replication to happen. You come in here and it'll show you exactly what it's doing. So once we had all the data migrated and we were ready to shut down those old servers, it was running really well and we were really happy with it. And then initially we were on 6.5 and U1 came out, and so we were ready to basically to patch it up to U1. And so I wasn't real confident on my own to actually do that myself. So I opened up a ticket with VMware, and they talked to me some steps that we needed to plan to make sure that on how we can patch the servers to make sure that there was no data loss. And one of the things that they told me was that you want to make sure that when we put the host in a maintenance mode, these are the 3 options. And we chose the full data migration mode, mainly because that if something happened during the patching or the upgrade and this host doesn't come back online, all that data is already migrated off and we won't lose any data. So if you're just doing a simple reboot, you can choose one of these other options. But if you're going to do an upgrade or a patch or whatever, you want to make sure that you're going to migrate all that data off. That way you don't lose any data. I've given this presentation at a couple other vMugs before, and one of the questions that I usually get is, if I had to do this all over again, would I choose vSAN? And yes, I would definitely choose vSAN, but if I had the budget, I would love to buy VxRail or a vSAN Ready node. But if you don't have the budget, I mean, it's definitely something you can do to build it on your own. Any other questions? No, I'm pretty sure that the last time we did we did a U.2 and we did the migration, it only took us a couple hours to migrate all our data off. I mean, we only have about 16 terabytes of data, and so yeah. Yeah, so, yeah, that is. So yeah, we're not doing any stretch clustering or anything like that. All of our hosts are in the same data center. So, and luckily we have a 40 gig backbone, so we don't have any issues with bandwidth or anything like that. What type of backbone do you have? What's that? Oh, okay. Yeah, I'm not sure I'd be interested in to see some of the details. Yeah, that's something we're always concerned about when we do a patch or an upgrade to make sure everything's all compatible. But we have some other tools that we use to run afterwards to make sure that they are all compatible, and we run that tool periodically. It's a third-party tool that we use, but yeah, Runecast, they're in the Solutions Exchange, and they just released their version 3.0 tool. But yeah, it's definitely something that we're always concerned about, so to make sure all hosts are 100% the same. No, luckily not. I mean, I was just worried that the hardware was basically going to work like I thought it would, and I guess there was one surprise. Those 2 warnings that I got when I started moving data over, I didn't realize it was going to take as long as it was to replicate some of that to all the other hosts. So that was really, I guess, the only surprise. I knew it was going to take a while, but I didn't realize I was going to get that little triangle. But I mean, other than that, I was happy with it, and I was happy that it only took us about 4 or 5 days to get everything off of it. So, yeah. And luckily, we met our deadline to shut down our old equipment and get it turned back into the government. So, yeah. It's been a little over 2 years now that we've had it up and going, and we're looking at a hardware refresh right now. But because of the environment that I work in, we don't have a lot of budget, and so we're hoping we get some fallout money at the end of the year to possibly buy a Ready Node or even a VxRail would be awesome. No, we are not doing encryption. We've talked about it, but it's not a requirement for us, and so because of some of the performance that comes with it, yeah, we just decided not to do it. And some of the complexities also. What's that? Yeah, exactly, yeah. And I've heard some other things are coming down the pipeline with the key management stuff and encryption that might make it easier, so. Exactly. Yes, yes. Yeah, restores, yeah, it can be tricky. Yes.
Good afternoon. Wow, that was impressive. They had no idea how loud I was going to be when I said that. So, oh, thanks. All right. My name is Josh Atwell. I'm a senior technology advocate at Splunk, and I spend a lot of time thinking about and talking about failure, which makes me very popular at parties. It's an inevitability in what we do that at times we're going to fail. But I believe, holistically, we have a very poor perception and viewpoint about failure, what failure means, how we respond to failure, and how we can utilize failure as a forcing function for good, okay? I do the Twitter thingies, so if you want Josh_Atwell, if you tweet a picture of me, my boss knows that I actually did some work this week. All right, let's give a little quick tale of an almost failure. Many years ago, that time span continues to grow. I used to operate a data center, and I did a lot of automation in that data center. And so I would write scripts that would handle large-scale implementation of changes, which can be very exciting, until it's not. In this one situation, we were doing a change window. I was making significant change in the environment, And it was one of those where the ESXi hosts have to disconnect and be reconnected, right? Changing certificates. Now, in and of itself, it wasn't that big of a deal. Like I had scripted it, I'd run it in the test environment, everything was fine. Morning comes that we're ready to run it. We're doing it actually over a holiday weekend. Execute, things drop. Things don't seem to be connecting back again. Now we're talking orders of magnitudes of thousands of ESXi hosts being executed on multiple geographies all at once. How do you think I felt when I didn't see my ESXi hosts coming back? I was very excited. I wasn't. Turns out everything was running just fine. I just needed a refresh Virtual Center server because I had outdated its certificate as well. Okay? I just had to do a refresh. Right? Everything else is so it was almost a failure. But let's talk about what happened in that moment. So, in our brains, actually I gotta make sure I don't overtalk too long. All right, in our brains, when we fail or we have this scenario, the first thing that happens is we say, oh, four-letter word of our choice, right? That's our natural response for most people. When we succeed, what happens is we release endorphins into our system. We are chemical beings, right? So endorphins get released into our system. Dopamine, serotonin, we get euphoric, we get happy, right? And as a result, we feel encouraged, right? We feel like, wow, yeah, I really nailed that. It's going to go. I'm going to do that again because it felt great. When we fail, though, we release cortisol. And what happens when cortisol is released into your body, it kind of kicks off that fight or flight reflex. What ends up happening is that your higher level functions become less important, right? They get deprioritized. Your brain has its own little QoS, and it says, look, we don't have to think about, existential things like, our being and our future and our life, except for maybe this is really, really bad. And then our lower level functions kick in, right? And we become very defensive. We also will feel hopeless or demoralized, and we feel terrible, right? Like that's what happens. Like you get that gut feeling, right? Like your stomach just fell out whenever you failed or you've made a mistake like that. So in preparing for this talk, I did some research. I researched IT professionals, and I said, tell me about a time that you screwed up, where you broke something in production. Raise your hand if you never broke anything in production. I don't believe you. We've all done it at some point, right? So there we go. When people make mistakes, and when I interviewed everybody, one thing that was consistent every single time is that when they made a mistake, everybody said the same thing. I feel like I've let someone down. Whether it was a customer, whether it was a peer, whether it was a vendor or someone that you were working with, somebody that was depending on you. Universally, every single person said their first response was they felt like they let someone down. And this isn't an unnatural response, right? We take pride in the work that we do. We've invested in our discipline and our skills, and it's uncomfortable to fail and make mistakes, specifically if you feel like you let someone down. My follow-up to this was, how did the people that you felt you let down, how did they respond to your failure, right? How did the organization respond? How did your boss respond? How did your peers respond? Without exception, every single person I interview said, let's just get things back up and running, let's figure out what happened, and let's learn from this scenario. Every single time, okay? Now, being in IT, we always have this existential fear that we're going to break something and get fired, right? We read about it in books, we read about it in stories, right? It happens from time to time. But in all my research, every time I talk to people, these are the response. Now, when we think about failure, I love this quote from vBrownBag. She says, I'm not a failure, I failed at doing something, okay? What she is saying here is that simply failing at a task does not make you a failure, right? Not learning from that is what's more likely to lead you to being an actual failure. her approach towards failing, because if you research her career and read about her career, she had some pretty epic fails along her way before becoming a renowned columnist, okay? And she used those as opportunities to improve what she did and to get better. And as a result, she found success. When we look at what we do for IT, right, in our virtualized environments and our systems, we can actually set ourselves up to be better prepared for those moments where we might fail, or more importantly, when those systems fail, okay? And you want to ask yourself some questions about that, because in order to have a system that is prepared and equipped to check for failure, you have to implement work in processes, in people, and in technology. You know, you'll hear about someone executing a command, it causes a major outage. Remember the S3 brownout that happened a while back, right? The net result of that was somebody executed a command. They executed a maintenance command that they had done dozens of times before. But this particular instance, the person executed it and it shut down systems more broadly than was intended or expected. Now, the question is who was at fault for that failure? Was it the person that executed the script? Was it the script? Was it the process? Was it the technology that was being in? Or was it the fact that the technology was even allowed to shut down that many systems all at one time? When you look at the post-mortem on that, they said specifically, it's not the person, it's not the process. It was the system's inability to know that it should not shut down that many instances at one time. And as part of their remediation, they said, we won't let that happen again. They learned from that failure, right? But it was a reconciliation of, we have to look at the people, the processes, and the technology. Because failure does not happen simply because of one thing. It's a cascading effect. In order to determine how failure has occurred and how you should respond to failure, you need to ask yourself whether or not you have sufficient information to answer that question. In that scenario, it's very easy to say, Bob broke it, he executed the script, and then it was down. It's Bob's fault. Is there any Bobs here? I hope not. Okay. So in order to successfully identify that scenario, identify what happened, and learn from that failure, you have to have information. That means you need to collect data, you have to have visibility, this is where you get your dashboards. There's no such thing as a single pane of glass. It's all a fantasy that they try to suck you in with, right? But you need to be able to identify the information for what happened so that you can learn from that scenario. Now, we also have to keep in mind, that in the environments that we work with, we are not dealing with what Gene Kranz is talking about here. If you're not familiar with this scenario, Apollo 13, right? They had an issue. They're hundreds of thousands of miles away from Earth. They have an issue. They had an explosion. They're concerned. The failure had already occurred. They had already had a failure. It had already occurred. What he was talking about is how they were going to respond to that. They could not afford to have a second failure, right? In the environments that we deal with on a regular basis, our failures don't have the same implications as what you might see for trying to bring back astronauts safely back from a mission, right? Most of the work we do have revenue impacts, right? So it's very important to make sure that when you look at your failure and the times that you have failed, put that into context as to what that failure actually means. Because remember, our natural response is, oh, this is terrible, this is going to ruin everything. Nope, just be prepared. Like, things are going to break, and how you respond and what's really at stake. Best way of doing this is to focus on the variables that you can control, right? Now, with Apollo 13, there was a lot of things that they could not control. One thing they could control were the items that they had in the capsule, right? In the spaceship that they were traveling in. And they worked to devise a solution from that. When you look at how you are going to adjust to failure and the times that you fell and learn from those situations, focus on these variables that you control. First off, improve your skills. You're here. That's what you're working on now, right? Improving your skills, getting better at your trade, getting better at your craft, getting better at the work that you do. learning valuable lessons and applying them, increasing your knowledge, particularly today as the systems that we support are infinitely more complex than they were 5 years ago or 10 years ago, right? Our ability to increase our knowledge and awareness of those systems is very important. I also highlight more planning. Now, this is not to say that you should plan your projects to death, but this is a scenario that you can control. By applying sufficient planning, you can minimize your opportunities for failure, okay? Because you are more likely to catch things that you might have missed had you not planned more successfully. When I talk about improving relationships, right, that's actually improving the relationship with the people that you work with. Because remember, that number one response was, I feel like I let someone down. The response to that response is, let's just get things back to normal and learn from it, right? I highly recommend that in your environments, you do not try to hide the times that you make a mistake, right? You take those as opportunities to share with others so that they can maybe not make the same mistake. Improve your processes, improve the people, and apply the technology. All of these things are going to give you better preparation for those inevitable moments when something's going to fail or you're going to fail at something that you're doing. If you want a great example of this being applied that you can read along and be able to share maybe with your coworkers or your boss, and to try to build this better culture around failure, Beyond Blame by Dave Zweibeck, he gets into this same kind of scenario where a IT networking professional executes a command, common thing, does it all the time, knocks out network traffic for this financial institute, and they fire him for it. But once the people start digging into what's happening, they start asking the question, was it the person or the system that was to blame, right? Was it the system or the process that was put in place that was to blame, right? And how can we now instead set up ourselves for success? Because in this scenario, spoiler alert, it was a little bit of everything, right? It wasn't one thing. That command that he executed wasn't something that was nefarious or bad. It was doing the job that he had done and he had planned for in the past. There was a variable that was outside of anyone's control, right? A very wise sage once told us that failure, more than anything, is the greatest teacher. Yoda was a very, very wise Jedi Master, but what he was really instilling on Luke Skywalker is that your desire, your attempt to achieve a certain level or a certain standard, it can cloud your judgment on how you actually respond to failing. Okay? I've failed a lot in my life. I'm not going to list out all of those scenarios because I don't have that much time left. But the main thing that I took away is that any time that I was unsuccessful at something, I wanted to learn, like, what can I do to be better prepared to avoid that in the future? Now, it doesn't mean that I'm scared to go out and try something new or extend myself beyond what I've done, but that's how you grow. Will Smith has this great video online where he talks about this exact topic in this framework about learning and growing. And he uses a great analogy of why failure is so important for growth. And he says that if you are exercising and lifting weights, that pain that you feel and that soreness that you get, that is your muscles breaking down. They're failing, they're deteriorating, right? And it's after that that they grow back, they heal and they become stronger, right? They get better and stronger as a result of that failure. If you don't bring yourself to failure, you do not grow as strong. You do not learn and grow as strong. A good friend of mine, Leah Shobe, she also articulates this well. Failure is a golden nugget to be cherished and learned from. And if you don't learn from it, it's a wasted chance to grow. This is the type of perspective I think we should all have when it comes to talking about failure. Right? We should welcome it. Not that we're looking for it, right? But we should welcome it for what it is. It's an opportunity to learn. It's an opportunity to grow. In our industry, we have this strong tendency to try to sweep our mistakes and our failures under the rug, hide them and mask them, right? It's just the way we operate. But I think by looking at these as opportunities for us to grow and to help other people grow, like, it's a much healthier perspective. It's also important to know that how you respond to failure and mistakes is very contagious, right? If you are the type of person that's going to beat yourself up, or you're going to hide what you do, or you're going to have a negative response or a negative view towards your failures, other people are going to see that. And they may judge you based on that, but more often than not, it becomes a culture. It's one of the reasons why I think IT culture in general has this so rampant throughout it, and why I want to have a talk about it, right? It's much better to lead by example, right? If you're Bob and you screwed something up, sorry Bob, but if you did that, right, and you work hard to deflect that from yourself and your opportunity to grow, that's not good. But if you use that and say, hey, I messed up, this is what happened, this is how I resolved it, here's what I think we can do from a system, people, and process, and people, process, and technology perspective, so that somebody else doesn't repeat this, that's contagious. Other people will do that. Another way to handle this is create safe to fail environments. Okay? Now, this is not to say that you should have a test area, right, or a development area. Obviously, test everything in production. Do not test anything in production, generally speaking. But what I'm saying here is make sure that when you are trying to push the envelope, when you're trying to do new things, when you're trying to build new skills, new processes, implement new technology, understand that things are going to fail, and work to make sure that any individual failure is not catastrophic, right? Make it safe and comfortable to make a mistake, right? Make that part of your planning process and your implementation process. I'm also a huge advocate of blameless postmortems. In doing that, you say, nobody is at fault for this outage. There is no blame. It is a system where a variety of things happen. So for instance, with that outage with AWS, I believe I may have mentioned, he executed a command he had done numerous times, right? It was just part of regular operating procedure, right? The process was okay. The system wasn't quite okay because it allowed a unexpected and a bad behavior out of the technology that was being used. In a blameless postmortem, you focus on looking at all the causation for the outage, right? So, we had a power issue. Was the power issue because isolated, or did we fail to do some operational debt, to handle some operational debt, right? Do we have some technical debt that we need to deal with? Like, what was that cascading effect that got you there? Thomas Edison, one of the greatest failures in history. Now, some can argue about the efficacy of some of his inventions and how he got where he got. I'm not going down that path. What I do want to talk about is how he recognized that his failures were just him being one step closer to his goals. Okay? And I love this perspective that most of us, when we feel like we're giving up and we just fail too often and we're just not getting it, more often than not, we are so close to like just cresting that wave and being successful. Right? Now, this is not to say that you should, run yourself ragged. At some point, you have to reconcile whether or not you're going to make that impact. But whatever your first instinct is to give up and just consider yourself a failure on something, give yourself a little bit more time. Right? He went over 1,000 different ways to not make a light bulb, right? Or was it 10,000? I think it was actually 10,000. Huge number of ways of not doing it, but he found the one way that did work. All right, we're going to take it home. Other thing I love about failure is the 404 responses you get for a lot of websites. People have gotten really, really good. That is putting a positive spin on failure. So when you fail, work to have a positive spin on the failures that you have, right? It doesn't have to make light of the fact that you've made a mistake or you failed in some way, but to recognize it for what it is. It's just part of the human condition. So make failing a positive forcing function. Leverage failure as an opportunity to grow and learn and to improve yourself and strengthen yourself. Create those safe to fail environments. That's both within your systems and all the work and the interactions that you have, right? Have failure as part of the contingency plan. You know it's going to happen. Let's minimize the risk of any failure that we have. Let's reduce that impact. Huge part is helping others on how to handle failure. If you can be a positive influence on others and have a positive response to when people mess things up. I know the greatest mentors I had when I worked in IT operations were the people when something broke, they came over and they simply said, okay, well, let's figure this out, right? You know those people. They come and sit down with you and like, all right, let's solve this. Let's figure this out. Be that type of person. And then most importantly, don't quit. Don't give up. Just because you failed, just because you've had a downturn. I mean, we saw Lindsey Vonn and Steve Young today during the keynote. Their success was a result of numerous failures, but they never gave up, right? They just persevered and they learned from those failures and they got stronger and they got better, right? You can do the same thing. So with that, I hope when you leave here today and you make a mistake, you don't beat yourself up too bad. You find people around you who can help reinforce this positive view on failure, because you can absolutely be a failure and still succeed. Thank you very much.
Hi everybody, my name is Corey Romero. I work for VMware. I've worked for VMware about 12 years. We're going to make this a short session. I know we need to make up some time, so I'm going to try to do this in under 10 minutes. Who here has heard of the vExpert program? Excellent. So I'll go over the vExpert program, do an overview, and then how to become a vExpert. And so vExpert is our global evangelist program. There's about just under 2,000 vExperts total. And the vExperts are VMUG leaders, customers, and partners. Some of the vExperts run some of the largest data centers, as well as consult for data centers, as well as do manage and config the software and solutions. Awards are for, the vExpert awards are for individuals and not companies. And so what we really look for is individual contributions. And what that is your wins and your losses, and how you fixed mistakes, and how you share that information out to the community for your solutions. The application process is twice a year. It's in November as well as June, and the award announcement is in January as well as August. We like to do the awards right before VMworld. That way you can come to VMworld as a vExpert and go at our vExpert party and meet Pat Gelsinger as well as the rest of the vExperts. In the vExpert program, we've actually created a sub-program of vExpert as well, and the sub-programs that we've created are for NSX, vSAN, as well as cloud management. And the purpose for those sub-programs is so you can have a tighter, closer, integrated relationship with the business unit. Some of the programs, actually all of the sub-programs, run NDA meetings here at VMworld, so prior to announcement as well. And so if you want to write your blogs or you want to do your social activities around announcements, the BUs are designed to help and aid you in that. So some of the benefits of vExpert, one is networking. We also have licenses, so we give all of our vExperts access to all of our products and licenses for everything up to NSX, to vSphere, to pretty much every product we have. We have a vExpert directory, and so we actually have on vexpert.vmware.com, you can go and see, you can see who the vExperts are, who's in the sub-programs, as well as who's in the pro program, and I'll cover what the pro program is in just a moment. You will also get invites to private betas, and if you do blog, we actually drive traffic to your blog as well. We want to help you get your message out to your audience. So we have a website, a portal called vexpert.vmware.com, and we have this is off here. We have 5,000 plus user accounts for the program. We have in 2019 we had over 2,100 applications submitted for the vExpert program. Some of the goals for 2019 was to really kick off the sub-program applications in the portal, and the reason why we do that is so the BU can process the applications much faster. It used to be in an Excel spreadsheet, which was pretty difficult to manage data-wise. So some of the stats on vExpert is we currently have 1,863 vExperts in the program, and you can kind of see what they specialize in here. So we have them represented for 73 different countries, so we've got vExperts literally all over the world. Some of the seniority I just want to touch base on a vExpert program is you can kind of see this. We've had the vExpert program for, this is actually our 11th year. So we've had vExperts that have been in the program the entire time, which is, it can just show you the benefits of this program. This is just a graph about the application kind of growth, program membership, as well as sub-program membership. So you can see that it's growing. This is a very, very active community. And if you really want to get into community, this is probably the #1 program to get involved with. So how do you apply to become a vExpert? So I kind of covered the application periods. What does a vExpert application look like? So one challenge we have at vExpert applications is sometimes, let's say you have a speaking engagement that you want to talk about in your application. Now, hey, I did a speaking engagement at Dell EMC World. And so what we're looking for is not just I did a speaking engagement. We're looking for I did a speaking engagement. Here is the topic, here is a link to the session, and here is the audience. That way we can get a better concept and a better understanding of what you actually did in the community. If you are a blogger, we like to have blogs, your blog URL, as well as details on your blogs and on what you write about. And we review every single application very detailed to make the decisions. Something very important also to put in your vExpert application is a reference. And it's a reference, it might be a vExpert, it could be a vExpert Pro. And so I'll cover Pro for a second. So vExpert Pro is a program we put together of vExperts who are in very many regions around the world. I thought I had the stats here, but apparently I don't. So vExperts help non-vExperts become vExperts. So they'll kind of guide you in what you need to do in the community to become a vExpert. Also one of the things you can do prior to becoming a vExpert is reach out on Twitter, join the community, talk to people, network. That's really the best way to get yourself in. I know we've got Ariel Sanchez kind of kicked off the idea of vExpert Pro. Ariel Sanchez is a vExpert that's been with us for a while, and he came to us a couple years back and let us know what he was doing. And he was actually helping build the vExpert community by mentoring folks on other applications, what they should do in the community, how to share the information. So everybody has a win and a loss and successes in your journey of your position, right? So we're really looking for those community contributions of, what was the issue? How did you solve that? And even if you write scripts, you can share that information into the community. Because everyone is unique. You guys all have your unique experiences. And so we would like to see those unique experiences out to the community because sure enough, it's going to help someone that has the same issue or similar issue that you have. So again, the applications will open. The next applications will open in December, and we will have a January award announcement. And if you want any more information on vExpert, you can go to vexpert.vmware.com, and you can also email vexpert@vmware.com. I personally manage the account and I reply to every single email. So if anyone has questions on the vExpert program, please feel free to reach out, and I'm more than happy to help. Other than that, thank you very much. I appreciate your time.
All right. So, what we're going to talk about here for about a half hour or so, maybe.
Give or take.
So, all right. So I'm Jay, and that's Silent Bob. That's how we become to know each other while we were architecting the truck. No, actually, what we want to do is we want to talk not about the truck itself. We want to talk about a lot of the design decisions that went into actually building a data center in the back of an 18-wheeler that was described to us as a 6.0 earthquake for 6 hours constantly as it drove down the road. That was all the information we had. And we had to start with basically a blank slate, right?
Yeah.
So for real, I'm Chris Galati. This is John Hildebrand.
Hello.
And we wanted to, if you have questions or things like that, if we have a way to take that, we can. But so why did Cohesity actually build this thing? Does anybody know about the Cohesity truck besides us? Because we lived there for 8 weeks. No? So we actually, last year, I'll kind of give you the story. At our sales kickoff last year, our CMO announced that she was going to get a truck. And I met her a week after joining the company. Mm-hmm. She had a couple of glasses of wine and looked at me and said, "So you're Chris?" And I said, "Yeah." And she said, "You're going to build a truck." And I went, "What?" So what we wanted to do is we wanted to build a rolling EBC, basically a briefing center. So this thing goes around the country. It has stops throughout the year. How many did it do so far? Do you know?
It's been up to around maybe like 70-ish. Well, and I will say, you said the country, it's also gone through Canada as well.
Yeah, that was a whole different story and interesting. But what we wanted to do was we wanted to bring it to customers who couldn't come to the EBC. We wanted to use it for events, for VMUG events, for partner events, for places where people hadn't been exposed to the technology. I think the first place we went, one of the bigger ones was Tech Data. We actually brought it to Tech Data shop in Phoenix, so that all the folks at Tech Data could actually learn about the technology. We wanted to get more engagement, and honestly, it's a mobile billboard. I mean, anybody else, a NASCAR fan or a race fan, you know, when you see them moving around the vehicles, you know whose team it is. You know it's Roush, or you know it's Stewart Haas, right? It's a giant billboard going down the highway. And it was scheduled to do about 120 stops a year. So with this information, we had to figure out a bunch of stuff, right?
Yep.
Anything you want to add to this?
No, so the one thing we should mention about the stops is the fact that the data center goes on and then it goes off. So for anybody doing any data center design, a lot of the times you never architect for the off part of it. It's usually a mad scramble.
Yeah, does anybody actually turn their data center off 20 times a month? Well, besides you, because you work with us. This made my head hurt, okay? We're gonna get into some of the stories and the anecdotes, but yeah, this was the biggest thing. So since we're at VMworld, we wanted to kind of cover what is actually running in the back, because we get this question a lot. People see a picture of the data center and they're like, is it real? Is there actually servers back there? Is there really equipment? Yes, it's a ton of ESX servers. We've got Dell running the ESX nodes. We've got a couple Hyper-V nodes. We won't talk about those here. Well, some VCD nodes.
Yeah, and I should already state that we should already update this because we've replaced the storage array.
Sorry, Pure. There's no more Pure array. There's a Nimble array. Politics are a beautiful thing when you build one of these things. We could get into that too. But we used all Cisco Nexus switching. So there's a lot of gear that you don't see. It's actually on the back of the racks. It's all covered up. But we wanted to design it not only to be functional, but to be kind of visually pleasing. So we could have done this with a lot less gear. We don't use half of the compute power in the back of this thing. It's more about walking into the truck and seeing the racks and seeing the layout and having it be as much of a showpiece as it is a functional. So there's literally N plus probably 4 in some of these nodes. There's just not a lot of work running.
More like N plus 14 at that point. But so one of the things I wanted to point out, so the GPS time servers.
Oh, we'll get into that.
So we will get into that? Okay. So, but pay attention to that, because we've got a very interesting story that both of us just kind of looked at each other and went, oh, we have to solve that problem.
There's a reason both of us have no hair on this project. So it's just a little bit of a logical architecture, because we wanted people to understand, as we were designing this out, we said, okay, we can have a data center, we can have demo stations. How do we deal with, let's say, demo user A trumping demo user B, doing the same demo, how do we work with that, right? And we do it a lot differently in the booth. We actually let them all run amok because we can support it. When this thing goes down the road, we let it go, like it's gone. We don't touch it except for once every quarter. So we'll get into the maintenance part. So we had to figure out, if something happens and a demo station goes down, how does it not affect everybody else? So what we actually did was we built a pod-based architecture. So we actually used NSX for this and NSX gateways. So every demo station, when you're standing in a demo station, it's a completely isolated vApp from the next demo station. So each one is an exact clone of each other with the same IP addressing sitting behind an edge gateway. And that's how we get them to be isolated. But what we can do is if one pod goes belly up, we can literally deploy and clone that vApp from a template. Pretty easily, a couple minor configuration things. We haven't had it happen yet, but we didn't want either user on a Wednesday before the next stop on Thursday to basically have to get an admin out there to go fix it, right? So this was just one of those small decisions we had to make at the beginning. And I think this was great for you because you didn't have any exposure to NSX before this.
No, so even though I came from like a service provider background where I should have probably known more about layer 3, this, just having to get used to this was something that was I felt like I was underwater most of the time until I actually started to figure it out. So for those of you, if you haven't started doing anything with NSX, if I can figure it out, you definitely can figure it out.
Well, when we get into the PowerShell stuff, that's where the roles got reversed. So one of the things that was really cool for John and I both was we had known about each other. We hadn't really worked together. We came to the same company. We figured out really quick who had which skill set and where we complemented each other, because we had 8 weeks, by the way. We were told the truck is here, it needs to roll on this date, and that was an 8-week window to go from bare metal, nothing in the racks, to fully functional and on its way to Las Vegas. So the time crunch on this was insane. So we'll talk about some of the pressure situations of some of this. So this one's a little bit of an eye chart, but we did want people to realize that there is multiple VLANs. There's a spine leaf architecture on the physical switches. We built it just like a real data center. We didn't want people to walk in and think that it was smoke and mirrors. So it made it a little bit more to manage for us. But one of the other design considerations we had was, okay, if we're going to run NSX, how do we get to the out-of-band stuff? How do we actually get to the iDRAC cards? How do we get to the cohesity nodes that have IPMI cards in them? So we had to develop a way for us to have VPN access without an NSX gateway as the VPN endpoint, because if for some reason vSphere or something in the stack blew up that was on the virtualization layer, we needed to get to the physical backend. So there's actually 2 dedicated VLANs that we have access to over a VPN tunnel with a 4G connection at all times. So in this thing, not when it's rolling down the road, but when it's parked, we actually have 4G access, we'll talk about in a second. So the more we started to think about this, the more our heads hurt, the more we lost sleep, the more the time window got smaller, and we had to really start drawing this out. And NSX was a big piece of it, as well as we have like some Ubiquity stuff running the edge gateway and whatnot. But when it's at the yard, we actually have a hardline internet connection. We can plug it into an actual public IP address. Okay, so we're gonna sit on this slide for a while and kind of talk through some of this stuff. This is John's favorite emoji, by the way. We use this at an internal company presentation. But when we started to think about this rolling data center, it's one thing to call something a black site. It's another thing to say, let's take the black site and put the black site on wheels and drive it to different areas of the country where you may or may not have internet access, 4G access. You may have it from Sprint. You might have it from Verizon. So how do you deal with multiple carriers? Is satellite an option, right? We would literally make lists of things we could do for connectivity. Latency. I mean, what were some of these things we sat at the whiteboard for hours in one day?
Yeah, so especially the latency part of it, because if you figure with a VPN tunnel, for us to be able to remote into it meant that we had to at least be able to provide some sort of mechanism to connect to it. So that's where we added the view environment in, so that we could do things over kind of a clunky gummed up internet connection, so that it really didn't matter from our endpoints if we were getting high latency. Things would still perform relatively well when we were interacting with the UIs inside of the truck itself. Yeah. So the view environment, which is something that I hadn't been exposed to either, on top of NSX. So him having to tell me all the view components that had to go into things, that happened. So.
So we also sat down and we said, well, what about power? How are we powering this thing? So does anybody run their entire data center on a generator 24/7 with diesel fuel? We do. And guess what? The tanks run out of gas every once in a while. The generator fails. It's happened 4 or 5 times. It's ran out of gas once. That was when we were in New Jersey. But how much do we need to have battery backup? So if you actually look in this thing, there is literally probably the 2 biggest UPSs I've ever put in racks. 19U APCs. We calculated it out to run about an hour of runtime, because we also wanted to give the driver enough time to troubleshoot the generator issue before we said, time's up, start the shutdown procedure. And how long is that shutdown procedure gonna take? I think when we had the first conversation, somebody said, how long is it gonna take to power this up? And we had no idea. We literally took a silly wild ass guess and went 2 hours. And they looked at us and said, why so long? And we said, because we don't know what the hell we're dealing with yet. Like, we literally had no gear. We were going off of just paper and thoughts and theories and hypothesis and all of these things. And I think, what is it at now? What is our startup time and what's our shutdown time?
Startup's roughly around 30 minutes. Shutdown can go down in about 22.
So once we started figuring that out, we knew how much we could have for a battery backup and how far we could go, right? So John wanted me to talk about the time synchronization. So we're standing at the whiteboard one day, and actually all these stories are true. So we go to Power Up vCenter and log in, and nothing's working. And so we quickly figure out it was a time sync issue. It wouldn't connect to AD, everything was AD integrated. And I sat there at my laptop and I went, all right, it's time issue, all right, wait a second. And I looked at John and I said, so let's suppose we get no internet where we're going. Where the hell are we gonna get NTP services? Because we had configured it to get NTP from time.nist.gov, and we're sitting on a hard line and we're at the shop and everything's happy. And he literally turned 5 shades of white. I thought he was gonna pass out. Because he processed it and went, I don't know, because every data center I've ever built, the time came from the time servers that the network guys ran in the back of the shop. So how do we do this? We struggled with this for about a day. I took a trip up to Seattle for the weekend. I was sitting there having a beer with my best friend, and he starts Googling it, and he's like, did you Google it? I'm like, no, I didn't Google it. I haven't had time to Google it yet. And we actually found a company called Time Machines. If you open up the back of the racks, there's a 1U plate, and it has these 2 GPS time servers, and that's all they do. They run off of GPS antennas, like a Sirius satellite antenna, and they do nothing but dish out time. And we have 2 of them because we did everything redundant, because you don't know if you're gonna have a building on this side and nothing on that side. We wanted to make sure, we were not gonna take any chances. So everything in the truck, when a network stack starts up, when they throw the breakers, the network switches come online, those GPS servers come online, and we wait about 20 minutes for everything to get booted up. And at that point, we can start his scripting procedure to do the startup.
Well, and I'll mention also, not only that, but the storage array also comes up. Because especially on the shutdown procedure, especially with a couple of vendors that we've worked with, the realization was once you shut down all I/O to those storage arrays, you can basically pull the power all day long and no problem. I mean, we've literally been doing it for almost a year now against 2 different storage arrays and have had 0 storage array problems.
We had this question, and I DM'd, I don't know if you guys know Cody Hosterman at Pure when we first bought the Pure. And we said, I hit him up on Twitter, I'm like, hey, hypothetical situation. How do you kill the power to a Pure like 20 times a month? And he goes, what? And I said, well, long story, but I just need to know, like, what's the shutdown procedure? He goes, honestly, once the I/O's gone, just pull the plug. And I said, what? He goes, no, it's perfectly fine, just pull the plug. So we tested it about 4 or 5 times, and sure as shit, comes up every time. Now there's an HP, and it does the same thing.
Yeah, so, but that was the big thing when we were talking with HPE about that same storage array, we were like, have you tested this?
Yeah, and they kind of looked at us like, no, nobody's ever asked us before. So apparently we tested that for them.
Yeah.
Rack stabilization was a big issue, so that the trailer came to us with the racks. So we didn't actually build the racks. The company, you have to understand how this stuff works. We learned a lot about the trucking industry. So the trailer company, they build custom trailers, but this one had been built for someone else that leased it. So we actually leased the trailer. The driver owns the tractor. So he tows it, and we wrapped his truck, and we have to unwrap his truck, which we've already done once and then rewrapped it. But we started to load gear, and what we figured out was when they built the racks, they must have built it like 8 or 9 years ago. And we started putting in hyperconverged stuff that weighs a lot, and the rails started to bow out as we were racking gear. So we stopped, and we said, okay, new problem. Got any pipe clamps? Because we got to bring this stuff back together. I mean, we literally lived in this thing for 8 weeks in the truck shop. We were in the shop. We got to know all the guys there. Like, we were one of the, actually, we go there now, and they're just like, hey, you guys are back. What are you doing?
So to kind of dovetail into more rack stabilization, you remember the first rail kits that we got for the Dells?
Yeah.
So you got to remember, the motion for usually in the back of a truck is up and down. So the rails we got were more gravity based. You didn't secure them onto it, they just sat on something.
Nobody makes those front to back rails anymore. It's just like a shelf, and then you bolt in the front.
Yeah, so we were looking at it and going, what are we going to do? And just kind of like the whole time thing, we Googled a couple of things and realized you could get these cross stabilizer bars that basically screw in on each side and can kind of hold it in place.
We did some reverse shelves, some short shelves, and reverse mounted them on the back, and somebody leaned on it and we bolted it in and then just tried to lift the servers. A lot of it was just, can I grab this and move it? Like, can I do stuff with it? The list goes on and on and on, but this is just a high level of what we dealt with in probably the first couple of weeks of building this thing. So I mentioned it was 8 weeks start to finish, and we'll have a couple more anecdotes and stories, but we actually took a lot of pictures as we were building it. So we had to literally muscle, now there's a door, right? And you have to get everything in through the side doors and then maneuver it to get it into the rack and not break the glass doors in the process because they don't come off. So somebody's always had to hold the glass door. And a story on the UPSs. So those are the two UPSs, I think, that you can see. I think there's one of me. No, that's a different picture. But I'll explain the whiteboard one. That was an interesting day. But we had to figure out how to secure the batteries. So if you've actually ever used one of these UPSs, it blew my mind. The power supply stack on the left-hand side has a retainer pin with a screw on it that holds it into the chassis. The batteries on the right side, no retainer. You can grab the handle, pull it out. And we're looking at that going, there's a big glass door in front of that 60-pound battery, and there's 4 of those batteries. So if he hits a really good bump or slams on the brakes, we got a problem. So we went to the guys in the shop, and we gave them like, these guys were great. I mean, because you're dealing with a bunch of fabricators. So we asked them stuff, and I'm going to lose the bet on how many times I drop a profanity, but, and we would go to them and say, hey, this is the problem. How do we solve it? Can we fabricate something? And they said, yeah, well, we found out that there's like this little tapped area on the top of the chassis that they could put a thumb screw in. No, they tapped that out. They actually drilled that, but there was a slot in the bottom, and they built this strap and put padding on it. And when the driver leaves, he inserts this and locks it down. And we've actually had an instance where I went in there and one of the batteries had popped out and hit that bar. So we can go back in and reseat them. And this is all stuff you have to figure out before it rolls down the road the first time. Because we didn't want to have an instance where it just shattered stuff. So that was the batteries were an interesting day as well. So you want to talk about the network stack for a minute? We call it the Thursday. No, it was a Monday, right?
Oh.
The Monday of doom.
So just like any major project, there's always something right near the end of it where you're supposed to get completed, but then something that tries to unravel the project. And in this particular case, I love our network guy, but this was not a good time to perform the operation in question.
Why don't you explain what we had for a while on the network side?
So, as we explained earlier, we had Cisco switches, and we're doing your standard leaf spine networking. The 9Ks were not available for us until later in this project.
Back-ordered.
So we actually had started off with a single Arista switch, and we gave him explicit instructions. When you get here and you want to replace those, let me know, and it gave me an opportunity to test the shutdown procedure, because I want to shut this down because it's going to cause impact to the entire network stack, and because iSCSI storage and everything else, things are going to go haywire. He didn't tell me. All of a sudden,
we're in the conference room.
Yeah, well, I am. You are. Yeah. You were on phone because I was working with something with you, and all of a sudden, nothing was working. I started hitting some of the ESX consoles. And they always tell you from a storage perspective, there are certain error messages you never want to see.
I saw
4 of them. 4 different types of error messages that basically...
All storage related.
Yep, all storage related. So as you can imagine, every virtual machine in the environment was inaccessible. So at that particular point...
you hung up on me.
Well, yeah, I hung up on you because I had to go back there and find out that he was ripping the switches out and putting new ones in. So nothing was working at all, period. Even after we rebooted multiple things.
The long and short was he was putting the 9Ks in, didn't tell us, got them all racked, said he had them configured. You shut everything down and brought it all back up.
Yeah, and still nothing was working. And of course, he had to tell us, oh, I have to go back to headquarters and work on something else.
Yeah, I'll see you tomorrow.
Yeah, I'll see you tomorrow with only 48 hours to go before we ship this thing out, and nothing's working. So we're in panic mode.
Chris swore a lot that day.
I could feel his blood pressure rising on the phone call as we started to talk this through, and we immediately identified I'm not a network guy. You've been into it.
I know enough to be dangerous.
Well, MTUs. Everybody knows that if you don't set your MTUs properly globally across the board, you're going to have some issues.
We were using NSX. We needed, we had everything set to MTU 9000. When he ripped the switches out, he swore he set the MTU, and I said, no, you didn't. He's like, no, I did. And I said, no, you didn't. He said, well, prove it. And I went, okay. So I was like, ping, 1500, works fine. 1501, no bueno. It's an MTU size. So he had to actually go research it. Apparently on the 9Ks, and I don't know the 9Ks, but there was a QoS policy and some other stuff. We lost. So it had to roll on Friday. John was actually testing the scripting, the shutdown scripting, and the test. You lost 2 days. Literally 2 days of the final testing phase. So we had to follow the truck to Vegas. He was working on the scripting while it was at its first show, while I was actually in the back working on something else. Like, we actually traveled with it for the first couple weeks because the bugs and worked some stuff out, and did the retainers work? Did stuff really fly out of the racks? Are we gonna have issues? And yeah, that was, we had some tense times. I mean, I've worked on a lot. How many guys have worked on projects that you thought you were gonna kill the guy you were with or girl you were with? Like, there was actually one day where that day I almost killed. We were trying to figure out how many ways we could disassemble Michael, the network guy, and hide him in different areas of San Jose, because we thought we weren't sure if we lost everything. Like, it was 7.5 weeks worth of work, and we thought it was gone. I mean, we had backups, we had Cohesity running, we had stuff there, but we didn't know what the time frame was going to be to bring it all back, and it had to be in Las Vegas. Like, I actually prepped Brian at one point, our project manager, and I said, just in case, you should have a way to go tell Lynn, the CMO, that the entire truck is broken on its first trip. And he said, I don't want to have that conversation. And I said, I know you don't, but you should process how you might have to have that conversation. Just prep yourself.
So to kind of wrap this up, I will state this. This has been one of the most interesting projects that I've had to work on. I mean, most folks don't get it.
That's one way to put it.
Well, well, let's just say that for the most part, we definitely got an introduction to each other.
Yeah. You learn a lot about each other when you spend 8 weeks in the back of a trailer.
Yeah. Plus also, we never really got into it, but the maintenance, we've had to travel a couple of times but again, with the trucking industry, there's some things like driver resets and forced time off, and we've had to do some updates because 4G connectivity is kind of unreliable for gigs and gigs of patch downloads.
Or when, somebody wants you to rip a pure array out and put a nimble array, you kind of have to be there. Yeah. By the way, that was fun because we had to tear our entire storage platform out in 2 days so that they could bring it here.
Yeah. I definitely know it's definitely a resume thing for me, especially for anybody who's into edge data centers. It's a very unique use case, and from some of your perspectives, hopefully you get an opportunity to do something as unique as this, although maybe not with either one of us.
No, because we'll never do it again. But if you want to know where the rig is, cohesity.com/tour. It just started its loop again. So if you're a VMUG leader or you're a partner, there's actually a page at the bottom to request it. So it's actually been, a couple of partners have actually had some really good success bringing it to a partner event. So we won't be there. Sometimes we're there. If we're there, we do a little Q&A and stuff with people like this. But come see us at the booth if you want to ask more questions or just get some more information about it.
All right. Thank you.
Hi, my name is Olive Power. I'm a Kubernetes architect at VMware, and today we're going to talk about operators, a rough guide to Kubernetes operators. So we're going to keep the agenda pretty simple, the what, why, how, and what next in and around Kubernetes operators. So first we're just going to do a little background just to set the context. So as you probably all know, but we're just going to go over it again, Kubernetes is a platform for managing containerized applications. And all the information about the platform is stored in a distributed key store called etcd. So all the information about the cluster that is relevant to the cluster is stored in there. So it's the memory of the cluster, if you like. And the interaction with Kubernetes it's all API driven. And you can interact with that API through a module called kubectl or kubecontrol, depending on how you want to pronounce it. So you can form commands like, get or create or delete, and I've shown a few examples there. But it's just important to remember that it's API driven and you can interact with it through kubectl. And the final point that I'm going to sort of raise about in terms of background is that it maintains a desired state. Now this is a very important concept of Kubernetes, and it's kind of how the whole thing rolls, really. It's a declarative system where you tell it how you want your system to look like, and Kubernetes will maintain that. So it's all the time trying to converge on the desired state that you want it to be. So when we talk about Kubernetes and we simplify that statement a bit, you say to it, I want my application A, or in Kubernetes speak, a pod, to run X number of times, let's say. So this is a simple sort of a declaration that you've made as a user. And you want Kubernetes to keep checking that it makes sure it stays that way, so X amount of instances of your application. And you want Kubernetes to reconcile it or remediate it or fix it when it falls away from that. Whether it falls away because something gets broken, so breaks one of your instances, Or indeed, if somebody tries to add an additional one, it will put it back to your desired state. Let's say x equals 5. So we'll always maintain it at 5 instances of your application. And so it's all the time doing what we call a reconciliation loop. So you tell it what you want it to look like. Kubernetes will check it for you, and it will fix it if it's not at the desired state you want, and it will keep looping through that all the time. And the functionality within Kubernetes that does that are called controllers. So controllers are a software loop that basically monitors your resource of interest. In our case, in this example, is the number of pods. And it's all the time comparing that desired state to the actual state and taking remedial action. Sorry, that's dropped off the bottom there. So it's continuously looping in Kubernetes all the time, as I say, trying to converge on the desired state of what you've said to Kubernetes that you want it to be. So I talked about objects of interest, and in our example, we're talking about pods. So the number of pods we want it to be 5. And that's an inbuilt resource. And Kubernetes has got a lot of inbuilt resources. And it's got a lot of controllers that are inbuilt that monitor those resources to make sure they're at desired state. But the thing is, Kubernetes is extensible. And this is a really good thing, because this means you can add your own resources, stuff that doesn't come out of the box. Because Kubernetes doesn't know anything about your own custom application, for example. So how are you going to get your application into Kubernetes and get Kubernetes to manage that external application the same way it manages its own internal resources? And that's the concept of custom resource. You can create custom resources in Kubernetes, your own custom resources that has custom attributes that describe that resource. For example, Olive. Olive might be a resource that you're interested in. It might be a complex database application called Olive. And it's got various attributes like color, users, location, something like that. And once you add these as a custom resource and define what that custom is in terms of attributes, called custom resource definitions, so CRDs, it's now part of the Kubernetes API, and you can interact and query with that custom resource through the API, again through kubectl. So you can now go kubectl get Olive color, because you have extended the API to include your new resource and the new attributes related to that resource. So this means that this leads us onto what an operator is. So an operator are a class of controller. Remember, the controller is the thing that keeps looping around to check whether your resource of interest is at the desired state that you want it to be. Operator manages your custom resources and with your own custom reconciliation logic. So remember, Kubernetes has got inbuilt resources, inbuilt controllers. Operators are the controller that look after your custom resources. So basically, it's your code that's reconciling your custom application to be the way you want it to be. And it's basically a way for packaging applications for Kubernetes. So when you talk about operators, it's like a way of packaging up your custom, perhaps complicated application in a way that Kubernetes understands. So in terms of custom resources, CRDs, extending the API. So Kubernetes is now talking and remediating your custom application the same way that it's remediating its own inbuilt resources. And so when I say packaging applications for Kubernetes, I really mean that in a way that we have ISVs now who are packaging up their applications and delivering them and making them available as operators. So maybe I've kind of come from a Windows background, and I remember we used to always repackage stuff as MSIs or as .exes. There's always, any platform that comes along, there will always be vendors who will make sure that their application is packaged so it works nicely and is easily installed on that platform. So, you use software tools like Wise to create MSIs so they would install nicely on Windows. You've got RPMs, package up software so they install nicely on Windows. Here we have operators. We have software vendors packaging up their applications as operators so that they install nicely on Kubernetes. And indeed, why wouldn't any software vendor do that? Why wouldn't they package up their stuff so that it can be installed easily on that platform? And perhaps you use their version of the software rather than somebody else's who doesn't play nicely with Kubernetes. So there's a thing called Operator Hub. Go check it out. There's a lot of applications in there packaged up as operators that you can just download, run, and apply, and they will install on Kubernetes. And they are crafted and created in such a way that that application is maintained in the same way that Kubernetes maintains its own resources. So it will check and make sure it's at its desired state. If something changes, like you notice on the bottom right there, there's CockroachDB. So that's a database. Databases always have their own sort of finicky when you install them. Like if there's 3 instances of a database and you need to add a 4th one, sometimes you have to do stuff to the other 3 to maybe stop a service, maybe flush a cache, maybe do something to add the 4th instance into the cluster of the databases. These are all steps that you define to Kubernetes, and it will do them for you, basically as code, because they're specific to that application. So now if Kubernetes sees a change to CockroachDB in terms of number of instances, for example, the operator has been coded to react and do all the necessary steps that the admin would have had to do manually to make that managed in the way that you want it to be. So why would you want to do this, right? Well, as I just said, you're extending Kubernetes to manage custom resources and custom applications in exactly the same way that it manages its own internal resources, which is a very powerful thing. And so you're making it easier to deploy your complex applications on Kubernetes, stuff like database, and stuff like that Kubernetes doesn't know anything about. So for example, like ServiceNow, if something happens and you want something written to ServiceNow, you can craft an operator, like a ServiceNow operator that watches something in Kubernetes, like maybe an instance of a certain application is spun up, and your operator then will write maybe an entry in ServiceNow, because maybe ServiceNow is your single source of truth for licensing, so you wanted to know every time an application is spun up. So to deploy that, you'd figure that maybe the ServiceNow folk would produce an operator for that. Otherwise, you craft the code yourself and package it up as an operator. And how you do that is, most of the operators are written in Go, purely because Go is what Kubernetes is written in, and usually it's kind of a nice thing to write your extensions in the same language that the actual thing is written in the first place. However, there are other languages that you can use, like Java or Ansible, because if you remember, the operator is going to be the application code that's going to do the logic, can be in Go, but it's deployed as a pod, right? So it's a containerized application, so it can actually be in any language you want, really, because it's segregated from the underlying OS, so you can have it in any code you want. Java is obviously quite a popular language, but Go is kind of the language that most of those ISVs that I showed you in the previous page, that's the language they're packaging their operators up in. So how do you do this? So a great place to start if you're kind of beginning your operator journey is to have a look at the operator framework. So this is an open source project and has many things inside it to help you build your operator, the main one of which is the operator SDK. And that provides the tools to build and test and package your operator. And the URL is there. Okay. And basically, when you sort of fire up the operator SDK and have a look at it, it basically takes you through the 5 steps to build your operator. So you create a new project for it. You define your custom resources, maybe your custom database or your ServiceNow. You define like the attributes or the custom resource definitions, like how that custom resource looks and what attributes are relevant to it. So that's your custom resource definition. So that's now the extension to the API. So you now have to tell the operator, well, what do I actually want to watch? What is it in this application that I want to like detect when it changes, either when it's deleted or added to or removed? What do I want to watch? And then what do I want to happen? Point 4, what's the reconciliation logic that I want to happen when something changes? So again, that's what your database administrator or your ServiceNow administrator, they're the steps that those kind of folks know, so that needs to be coded into your operator. And then you build the thing and deploy it into Kubernetes. Okay, so there's a couple of resources that I wanted to point out to in a what next scenario. The first thing is there's a great article written by the CoreOS guys who originally came up with the term operators, actually. So that's a really great article to have a read to kind of get more of a broad view on what operators are. And then the second resource I want you to have a look at is the operator framework / awesome operators. So basically, if you fire that up, you'll kind of land on this page, which is awesome operators in the wild. So these are, again, open source operators that have been built by various teams, and sometimes the vendor itself, sometimes other people who are just building packages. And it's a great place to start, not only maybe to get the actual operator so you don't have to do it yourself. So for example, if you were looking at Airflow, thinking, oh, how am I going to build that? You can just go and get it from that page, so it's like pre-packaged operator for you. Or indeed, if something's obviously not there because it's something in-house that's only relevant to you or your enterprise, it's still a great place to go because it kind of shows you how these things were built. And so like anything, when you've got like a template to work from or an example to work from, it's kind of easier to build it as you go along. Okay, that was it, short and sweet. If you've got any questions, I'll take them on the side. But if not, please fill out the survey, etc. Thank you for your time.
Good afternoon, everyone. My name is Brent Meadows. I currently work in the Solution Architecture Group with Expedient. And today we're going to build a Kubernetes cluster using vCloud Director and CSC in about 12 minutes. So we all heard a lot of interesting and exciting news earlier in the week that Kubernetes has actually become the core of vSphere in the future. But we do have the use cases today where we need to use Kubernetes. And we're looking at a way today to actually make that a little bit easier in automating that process. So the way we're going to do this is really look at the architecture of what that entails. First, we're going to start with the foundation. In this case, we're using a vCloud Director foundation. With that, NSX across the foundation as well, along with VROPs, multiple data centers. Then as a cloud administrator, and whether you're Expedient working on this or you're building your own cloud and you are the administrator for your environment, you're going to install Container Service Extension on top of it. With Container Service Extension, it is available through GitHub, so we can go in and install it from there, and we'll walk through some of those steps in a little bit. But it also includes CSE templates. So you're going to choose which templates you want to install as part of that deployment. Most of the time, you're going to have an Ubuntu and a Photon template that you can use, and we'll kind of go through part of that as well. Then from a virtual data center, we create the virtual data center, and then hand off access into the infrastructure admins. Now these infrastructure admins could be the same people that are running your Kubernetes cluster, or it could be a dedicated admin that's just running the virtual data center. From there, we install all of the prerequisites for the CSE client, and then from that point forward, we can automate and utilize just CLIs to create clusters, add nodes, delete nodes, or delete the whole cluster itself. And this is all running directly through that end client. Once that's in place, then we can spin up the Kubernetes cluster all through one command line. It'll spin up the number of nodes that you need, along with the master to control it. It's able to spin up an NFS mount as well, but normally that's going to be a single instance, so you want something that's a little bit more robust for your persistent data. Then once that's all set up, you can hand that access over to your developers or whoever's doing the kube control to actually manage the Kubernetes cluster. Now we're going to go through a couple steps of how you actually get this in place once you have it. So from an admin perspective, the client itself is going to have a couple of prerequisites. You're going to install Python 3.6 or later. I've included all of the links to actually go through the installation pieces on here as well. Then you're going to install VCD CLI. For those that aren't familiar, VCD CLI is actually the command line access into a vCloud Director interface. With this, available on GitHub, then you install the CSE client. One thing that I found as I was going through here is to make sure that your client CSE version matches the version of CSE that's deployed on the infrastructure. Installed a newer version of the client, was having a little bit weird issues that just went away with the matching version. So one thing to keep in mind there. Then once you have the CSE client installed, you register that as an extension of VCD. So when you go into the CLI, we're actually going to move over in a bit and actually show you that extension. Then you have to create an organization user that has admin rights. So as a security best practice, we normally want to only deploy user rights with very limited rights just for what they need. And in the future, the CSE releases will include that pieces of rights to limit that access. But today they advise just to do an admin account. So in that case, you probably want to create a virtual data center that's specific to your Kubernetes cluster so that you don't have to give admin rights to maybe something that they don't need access to. And then once you have that, you want to create an SSH key. So that SSH key we're going to pass into the Kubernetes cluster, and that's actually going to be how you connect to the Kubernetes cluster later. So now we're going to kind of walk through those steps to actually create the Kubernetes cluster once you have the foundation in place. So the first command we're going to do is we're actually going to log in to the vCloud Director interface. So you can see here we do a VCD login, and then the provider name, so expedient.cloud could be one of those, the tenant name that you're under that platform, and then the VCD user that you created earlier. Once you're in there, you can see all of the VDCs that you have available to you via the list command, and then you choose which VDC you want to use if you do have multiple data centers under there. Then you can list the CSC templates, so that's going to show you the Ubuntu version or the Photon version that's available under the current CSC implementation that you'll pass into the next command. So this is the big command that's actually going to do that one-line configuration of a Kubernetes cluster. So we're just going to walk through it a little bit. In this example, we're going to create 3 nodes with 1 master. So the first thing we're going to do is do the command to create the cluster and give that cluster a name. So anything we have here that's in bold and italics, those are the variables that you're going to pass through that will change for your implementation. Next one is the network. So with this, we have an NSX network that is stretched across multiple data centers. It could be an NSX network, or it could just be a local VCD network as part of that. This is something that you have to create on the front end. It doesn't create the network automatically. So you could use VCD CLI to create a new network, or you can just use an existing network to pass that through. Then you specify the number of nodes that you want in your cluster. It could be 3, 4, however many you need to support your applications. And then for each of those nodes, we're going to configure the amount of RAM and CPU in each of those. We're going to pass the template over and then give the storage profile. So if you are using multiple storage policies in your platform, you'll want to figure out which one you want to place this on, whether you have like an all-flash tier, a spinning disk tier, whichever platform you want to use from the storage perspective. And then you're going to pass that SSH key that we created earlier so that you can authenticate against the cluster. So once this runs and you have the cluster in place, there's a couple things you can do with it. If you need to add an additional node, very similar command. You're just going to, instead of creating a cluster, you're going to create a node. You're going to tell it which cluster you want to add that to. And then same thing with the configuration of the node itself. Create memory, CPU, which template you want to use, storage policy, and the SSH key. You can also remove nodes from a cluster. So pretty simple, you can do a VCD CSC node list command, and it's going to show you the name of the virtual machine that's running each of those nodes and master inside the environment. So we can see here the results of that command gives us our master and the 3 nodes. The thing about this command though is the application in the Kubernetes itself is not aware that you're getting ready to remove the node. So it's basically like powering off a VM. So if you are going to remove a node, you want to evict that from the Kubernetes cluster, just make it a graceful removal. So you're not basically pulling the plug on some applications that are running. Then once you know which cluster or which node of the cluster you want to delete, we just pass a VCD CSC node delete command to it, and it will remove that node. And then if we just want to blow everything away and try again, we can delete the entire CSC node using a VCD CSC cluster delete command. Now the reason you would want to remove the complete cluster is because of the automation built in here, it becomes a lifecycle management for your Kubernetes cluster. So as you want to release new versions, instead of having to go in and upgrade the version of existing clusters, you just create a new cluster, migrate all your containers over to it, and then blow away the old one. So it really just becomes a consistent delivery model through the Kubernetes clusters. And so now we're going to walk through a demo. Because of all the prerequisites that we just walked through, we weren't able to run it from this laptop, so it is a pre-recorded demo. But if you guys want to see it actually live and in action, let me know later and we can definitely walk through that. So the first thing we're going to see is kicking off that cluster create command. And the one thing you'll notice in the bottom is we're going to start this at about 1048, and we'll see how long it takes to actually complete. So the first thing it does is creates that cluster. Then it's going to go in and create the vApp that in vCloud Director it's going to put all of the VMs in. It's creating the master node, and you'll see in a second on the background it creates the master node in vCloud Director. As it's doing the configuration of the Kubernetes cluster from there, it'll power it on, finish everything on that, going through the configuration of the Kubernetes cluster master right now. Then it's going to start deploying all of the nodes. So it's going to deploy the 3 nodes simultaneously. So you'll see in the background as well, those get created. And once it's complete, we can do a VCD CSC cluster info, and it will show us all of the configuration information for that specific node. So you see your when it was created, CSC version, the nodes that are available, the master name, and you can see all of that information as part of that. And then, so as you go and do that lifecycle management of your Kubernetes clusters, you just kind of rinse and repeat those commands and migrate the workloads over to it. And just as an example, we do have this running in production. So we have a client called homes.com that utilizes this for that lifecycle management of their Kubernetes environment. So they run a real estate, both a search for homes that are getting ready to be bought, homes for rent, or just home values. So they run their platform on top of a vCloud Director with Container Service Extension installed. So we have this available as well as part of kind of that proof that it works as it should. And with that, that's how you build a Kubernetes cluster in 12 minutes. At the end of that video, it was actually finished in 12 minutes and 30 seconds. So a little bit over the 12 minutes, but actually probably worked out best. We had a pre-recorded demo, and since I only had 12 minutes available. But thanks again. I'm Brent Meadows with Solutions Architect with Expedient. And any questions, feel free to hit me up later, Twitter, or we're back at the booth this week as well.
Hey everybody, my name is William Geller. Welcome to another brush up on HCI for Kubernetes. If you missed the announcements on the keynotes or had not get a chance to get to our booth during the show, PKS is now available on VMware Cloud Foundation, which is now available on VxRail. And we've worked together with VMware to produce a consistent operations and infrastructure for enterprise-ready Kubernetes. And I wanted to bring this back again for those who might have missed it. Very quickly, the application journey, a lot of folks are trying to embrace containers and Kubernetes, but despite all of the hubbub that's been going on along this show, a lot of the customers that we've been speaking to, a lot of the other companies, they're still at the layer of just virtualization. About 85% still sit in that area. By 2022, that's when we expect a real huge mix. This is going to swap over. And you're going to see a lot more people in embracing containers of all types, especially Kubernetes. Know how real these numbers are, but they're pretty darn close, and ones that we've been seeing from just speaking to a lot of our a lot of people out there in the field. The thing is, companies want to have Kubernetes. They're not sure how to embrace it, if you will. And developers are going to try to get that Kubernetes dial tone. Whether the IT gives it to them or they find it somewhere else, they're going to get a Kubernetes dial tone. So it's best that IT sort of find a way to give it to them so they can control it, make sure they have all of the resources that are necessary managed properly, which causes often a lot of the problems. And the problems are, as enterprises are trying to develop it, it's getting from the monolith architecture into a cloud-native architecture and dealing with all the security and compliance and also the technical infrastructure. So balancing out security, balancing out the compute, also the networking, everything across the board has been the biggest problem that developers have said they've been reaching challenges with, and IT has been dealing with those challenges to also support them. And we've figured out a way to do that by placing VMware PKS together with VCF, which is already integrated in with VxRail, together to take care of all of those issues, basically fix these so developers can get back to doing what they do best, and that's just developing. So for our offer of HCI for Kubernetes, we have two actually. They come from a trusted, mature, and proven platform. It's because we didn't just get into developing solutions for Kubernetes. We've been doing that for a while because we worked together with VMware, we worked together with Pivotal for quite a long time, well over 3 years. And these design tenets that we've been working on have been proven out through something called the Pivotal Ready architecture. We have that reference architecture that allows us to have that collaboration and to develop those tenets, and we've been able to adopt them into VMware PKS, which you now see. So these solutions together provide the scalability, gives intrinsic security, also high availability. So whether you want to have a full hybrid cloud platform that supports Kubernetes workloads, or if you want to have just a standalone cloud native infrastructure that you could just develop cloud native applications on, we have a solution for you. So both these solutions, I mentioned VMware PKS on Cloud Foundation, VxRail, this is the integrated enterprise-ready platform. And as I mentioned before, the integration between VMware Cloud Foundation and VxRail goes all the way down to the APIs. So the SDDC Manager actually calls out those APIs within VxRail Manager. So one pane of glass, able to manage the clusters, deploy workloads on top of those, as well as automated lifecycle management. If you're looking for something that's just, you want to build it yourself with a reference architecture guides, you can do that as well. PRA, still out there despite the announcement that VMware is purchasing Pivotal. This is still a viable option, will continue to be for going forward. It's for customers that are looking for just to get started. It's a separate unit. They don't want to bring this into their data center, but and have it be absorbed into infrastructure that already exists. Maybe they have legacy infrastructure they don't want to touch, or they just want to get started small within like a POC and then build up to a high availability. Either way, that's also an option. So I have two different flavors that best for what your needs are. So I'll talk briefly about VMware PKS Cloud on Dell EMC. This is a production-ready Kubernetes platform, and it's built on a Dell Technology Cloud platform. Basically, VCF on VxRail is the foundation for Dell Technologies Cloud. What we give with this, with VMware PKS, is an automated infrastructure deployment. So as soon as you press a button inside VCF, you're able to deploy that Kubernetes supporting infrastructure out, makes all the connections to the resources. This allows developers to get up and running very quickly, as opposed to putting out tickets to IT constantly, waiting for resources to be developed, or even going out into the public cloud, which we don't want to have that too. Single consistent platform for any application. Did you notice up here, it's we support both the traditional applications and cloud-native applications, same infrastructure. Deploy those workloads anywhere across an infrastructure, core, edge, or cloud. Bring them down, deploy them elsewhere, closer to the data. That allows you to have the flexibility of workload deployment, but also get it closer to the data so you have more data sovereignty, more data security, less of an attack surface for cyber attacks. And of course, I mentioned it's a trusted, mature cloud platform. We've been doing this for years. As you walk through the show for the past couple of days, you probably notice there's a lot of technologies out there. And I won't mention any by name, but they're very new. They're not totally proven. They're still going through some of their bugs, and they're trying to match how companies are trying to embrace it themselves. And they're not sure how they want to embrace Kubernetes containers. But we have done it already. We've been working on this for years, and we're already adopted by some of the largest IT organizations in the world across energy, manufacturing, banking, retail. And Pivotal Ready Architecture being the reference arc, this is just a guide that allows us to put together VxRail infrastructure, vSphere, IaaS on top, and then PCF, the Pivotal Cloud Foundry on top of that. So you can take either the PaaS part of Cloud Foundry or the Pivotal Container Service part, or even both, just deployed on top of this stack here. And it's tested, validated every 90 days. Pivotal throws out, updates this, we take it into the lab, test it, validate it, throw out a new guide. So you're sure that if you're using this guide to build this yourself, it's going to work. And it does, and that's one of the one of the marketing slogans that we say for it. It just works. You power it up, everything is together, and you're ready to run. They have different setups for high availability as well as high security and scaling out. So no matter how you want to get started, you have the option to be able to start small and then branch out to something very, very large. If you want something like this, all by yourself within your own lab, and you manage it yourself. But lifecycle management, that's automated for VMware and VxRail, still in there. It's intrinsic. It's going to update at a push of a button because we push those updates out to you from Dell EMC. And Pivotal has their own updates as well through Bosch. So you can always embrace those updates when they become available, and they're always updated to make sure that security and availability are the utmost. So one of the successes I wanted to sort of talk about, you probably heard about the success with Raytheon and the United States Air Force. They were over here at theCUBE. They were also in our theater presentation during the week. These guys, for $2 million, was able to build a system, stand it up in just 90 days. Today, they save the US government, they save us, $1 million a day. This was deployed for the United States Air Force in a refueling, jet refueling center. And because they made this change, they've managed to greatly shrink the amount of time that they were able to develop the apps, update the apps, get them out, and actually just using the applications have made a big difference. In fact, the United States Air Force never talks about the technology that they use. They don't like to play favorites at all. They could not shut up about this. They were out at a lot of our shows and constantly talk at Spring One, at Dell Tech, at here at VMworld as well. So this is what it actually looks like. Working with Raytheon, they were able to, Pivotal was able to deliver on a deadline they thought was absolutely impossible. Because the government, they start a project like this, it's 2, 3, 4 years and millions of dollars. Maybe it works, maybe it doesn't. For them, it worked, and it worked very quickly. So from 5 weeks, from the time the hardware arrived, these guys already had applications starting to run on PCF. They're running 12 VxRail nodes. It's 3 clusters. That allows for the multi-AZ configuration and high availability. We had an external storage that allowed them to have backup in case any of the applications went down, and also the networking. So they had, because they had such success with this, they're continuing to replicate this all the way across their different refueling places across the world. So I would urge you for additional information. If you have anything on HCI for Kubernetes, certainly go to our website, dellemc.com, Kubernetes/Kubernetes. If you want to learn about Pivotal Ready architecture, again, dellemc.com/PRA. Thank you.
All right, how's everybody doing today? Good. All right, woo! My name is Justin Sider. I am the Chief Information Officer, Chief PowerShell Officer at Belay Technologies. Today I'm talking about Report Card PS. This is a PowerShell module that kind of incorporates PowerCLI and VMware Clarity. I'll get into what those things are in a couple seconds here. Should be a pretty short presentation, so hold on to your pants. Here we go. All right, so what's inside? We're going to go over an overview. We have the components, how it works, how you can get started, creating your first report, some best practices, advanced options, and how this expands to things other than just VMware. So here we go. This all started from a request from another vExpert in the community saying, man, it would be really cool if I could use PowerCLI to create the vCenter homepage. So I took that request and I actually did it. So this is actually generated from PowerShell using VMware Clarity, HTML, and JavaScript libraries to create the vCenter homepage. So you can see the headers are not like your normal VMware headers. Those are my headers from the PowerShell module. So a card is one of those little blocks. So those little blocks, as you move the window smaller and larger, those little blocks, those cards, will actually reorganize themselves. The order is a little funky. It actually goes 1, 2, 3 going down instead of across. I don't know who wrote VMware Clarity, but apparently the normal English doesn't really work with them. So I don't know if I don't know what language that is. But just know that the card in this module is all about creating cards. So the borders and stuff are all customizable, but I'm really focused on, you're going to write a function, you're going to create a card, and we're going to plop the card onto the HTML report. All right, so the components, we have Clarity PS. So as I started writing this guy, I found that I didn't want to write Report Card PS to incorporate Clarity PS, because at some point you might want to pull in Bootstrap instead of VMware Clarity. So I actually wrote 2 modules when I went through this. So I have Clarity PS, which just wraps the VMware Clarity UI components, and then Report Card PS, which is a wrapper for the functions that you write and the organization of creating the cards. Included in Report Card PS, we have the example vCenter homepage and the local CPU report. I did that for a PowerShell book that's coming out. All right, so here's how it works. So the big things to focus on are the loop in the middle, but as you start the process, we're going to create the basis for your HTML document. If you ever looked at an HTML document, there's a bunch of headers at the top, and then you get into titles, and then we'll get into creating the card. So all these things are contained within a Flex container, and that's what allows the auto resizing of the boxes. And I'll show a couple pictures of that in a minute. So we create the HTML document, we add the header information, add a title as you need it, and then we import the JSON from a manifest file. So all these reports are going to be based on a manifest file, and we're going to walk through those sequentially. We go through each function, we execute it, we take the output of that function and put it into HTML, and then we add that HTML to that document in memory. Once the document's complete, we return that back to the pipeline. I'm not sending an email, I'm not writing it to file or any of that. That's up to you guys. I don't care what you do with it. All right. So here's an example manifest file. It's pretty simple, JSON. You have a card title, you have a card function. So one thing that you're going to want to know is that that function needs to be present in that PowerShell console or that session that you have. So you are going to have to write functions. Functions are not that difficult. You can really just put a one-liner in a function and you call it a function and everybody's happy. The other things are arguments, so you can actually pass arguments in. Just know that these are going in as a string, so encapsulate them correctly. Watch out for spaces, they're really not nice. And then you also have the option to do an order. So by default, if you don't provide an order, it's going to go first in, first out. Otherwise, if you have a long list of cards that you want to create, you can actually order them as you wish. All right, so getting started, open up a PowerShell console, set your user, install module, name, report card PS, import it, and then we can run this get report card template set. So these are the ones that I'm including for you. You can also pass in a path to get report card template set if you have a set of these templates for the report, if you have a set of these JSON files. So here's an example of what it looked like when I did it on my machine. All right. One thing I should mention, I haven't tested this on PowerShell Core, so Windows PowerShell 5.1 is what everything was tested with. Cool. All right, so when I said I returned it to the pipeline, I truly meant that. So for the vCenter one, if you connect to your vCenter and you run new report card, give it a title, and then the JSON file path that's included in the module, this is the sweet output that you get. And if you know HTML, this is pretty much what it looks like. So I would capture that and do something with that file. Output it to you can email it, whatever you guys like. Some quick best practices. A card is just a single custom function that's capturing specific information, right? Keep it simple, stupid. You don't need to pack a whole lot of information. And then functions are also going to return just HTML output. So it doesn't always have to be a table, but generally a table is pretty much what you're going to be doing, right? You're going to be querying vCenter, you're going to be querying some machine. You want to get that into some kind of format that you want, and then use convert to HTML and use this dash fragment, and that removes all of the extra header and footer information from that command. And then here's a quick example you can run. Here's the top CPU processes, and this is the card that you'll see when we get to a next slide. All right, so a sample function, I removed all the comment-based help, but what you see here is a pretty simple thing, right? We have a one-liner that's capturing CPU data from my machine, and then I'm converting it to HTML, right? So from my aspect, when you look to build cards, this is what you're responsible for. A one-liner and convert it to HTML. Building the HTML card below that is where I'm using the Clarity PS module to create the card, giving it a title, you can add icons, and then you're just closing the body and returning that back to the HTML document. So pretty simple. You can see that one line of code essentially creates this cool little card. All right. So the advanced options, if you want to get into customizing the header and footer of your report, you want to take a look at Clarity PS to pull out all the elements from the VMware project Clarity HTML, CSS project. Here's an example of all the components that they have available. If you go to their website, it'll be on, I think, a further link I have, or a further page I have down. you can get all the different elements and how to use them so that you can add little widgets or wingdings or whatever things you want to your web pages. All right, so not just VMware. Here's a sample CPU report. Again, this is just using the one that's included, and you can see how easy it creates them. Anything PowerShell related. Let's see. Let me go back one. All right, so the other thing that's included with Report Card PS is a built-in dark and light theme. So I don't necessarily recommend the light theme. It's actually very bright and annoying. By default, everything will come with dark theme. So I wouldn't be doing myself justice if I didn't talk about other reporting tools for VMware. So we have vCheck, and please check these things out. And you're probably asking why I wrote this. And you know, all of these three other reports are doing so much for you. Report Card PS is really just allowing you the control, right? I'm just a framework to deliver the content in HTML. I don't care what you write. I don't want to write those things for you. I mean, reach out to me if you want some help. But I don't want anything to do with your infrastructure or know how you want to get your information. I just want to present it to you using the VMware Clarity UI components. So vDocumentation is a tool by Ariel and As-Built Report. You should know that for the last two, I'm actually working with them to get their output into a Clarity format. So you might see something come along the line that vDocumentation now has an output of HTML and a Clarity UI. And same thing with As-Built Report. I'm working with those guys to see if we can get their output using the Clarity UI versus generic HTML tags. All right, so here's the light theme. Like I say, I'm not a huge fan of it. And then there's a theme switcher in the top right. There's a cog out there. I don't know if you can, I'm going to point to the screen here. Can you see that? Yeah. Up in the top right, there's a cog. That'll actually take you out to Report Card PS. And I think with that, that's it. So to the principal's office, I want to thank the vBrownBag guys. They're awesome to allow us the opportunity to come up here and speak. Can't thank them enough. You can reach me as I'm JP Sider pretty much everywhere and anywhere. You can find me. My blog's up there. There's the links for Clarity PS and Report Card PS. Google Project Clarity and you'll find all of the tags and information you need to build or use all of the elements from the Clarity project. So that's it. Sweet. I think I'm just on time. Good.
All right, everyone. Thank you for joining today. My name's Sean Massey. What we're going to talk about a little bit here is I get the opportunity to work a lot with Horizon 7 on VMware Cloud on AWS, and we're going to talk about some of the lessons that we've learned here at VMware, having deployed this in our lab. So first off, a little introduction about who I am. There are JSON errors hidden in there, so if you find them, you are free to tweet them at me. It's a fun little game that I've started since I've actually did that accidentally at a VMUG. So I am here on staff at VMware, and I work in our cloud business unit, where I focus almost entirely on end user computing. And you can find me on social, my blog, and etc. So who doesn't know what VMware Cloud on AWS is, right? It's not like they didn't talk about it today in any of the keynotes, or there's no sessions on it or anything. So there's only a couple of marketing slides in here. I promise I will keep them short, just because I know I'm standing between you and free beer just down the hall. So VMware Cloud on AWS is a strategic partnership between VMware and AWS, right? It takes everything that VMware has on premises and combines it with the cloud-based consumption economics and as-a-service offerings that Amazon can provide. Right, so this isn't just taking some bare metal workloads or bare metal nodes in AWS and slapping ESXi on it and saying, here's a service. We're actually jointly engineering this with AWS, right? So you can kind of see just a little bit of what the service what the service offers. You know, we have an SDDC running on AWS bare metal, but that's sold and operated by VMware, jointly developed with Amazon. Gives you everything that you get on premises, but with the benefit of cloud consumption economics. So when we take Horizon 7 to that, right, you get the simplicity of that with the ability to stretch your end user computing environments from on-premises to the cloud. So, all right, I promise that's it for marketing type slides, right? Those are just basically to lay a little bit of groundwork on what it is. So how have we deployed Horizon 7 in my team's lab, right? So this is kind of a production-ish lab environment where we have Horizon 7.8 deployed in 4 NSX-T-based SDDCs spread across the globe. We're also utilizing the Horizon Cloud Pod architecture so that as members of my team travel globally, they're still able to get back to their desktop regardless of where they are. Right. So we have supporting this, we have a global Active Directory and file services environment that's in place to support all of this, and we utilize global load balancing built on Amazon Route 53. Right. So what's really cool about this is Route 53 allows us to actually do some geolocation based on the Amazon region that we've placed our SDDCs in. So it makes it really easy for us to set this up. We don't have to worry about what country they're coming from or what part of the country they're coming from. We could just say, okay, whatever gives me the best latency based on these regions, you know, Amazon, you figure it out and point people to the correct place. So it also actually allows us to actively monitor each site. So if we take them down, Route 53 will actually handle the failover for us. We don't have to worry about any of that, building failover rules into the service. So here's kind of a visualization of the environment that we have. So we have, again, 4 SDDCs scattered across the globe, a good geographic distribution of them with Route 53 placed in front of them. And then here's how our lab kind of looks from a logical perspective. We have a kind of on-prem environment that's actually based in Rackspace that we use to simulate an on-premises environment. Other members of my team have HCX set up, so we can actually simulate HCX and some of the stuff that they talked about in some of the keynotes today. So, now that's been about 5 minutes out of 27. So what are some of the design considerations and lessons learned for placing Horizon in VMC? So there's a few key things. So first off, just because there's a cloud service available doesn't mean you necessarily need to take advantage of it, right? There's a lot of possibilities and a lot of features out there. It's not necessarily always a good idea to use them just because they're there. And we'll talk about some of those options as we go through some of the design considerations. So when we look at platform deployment considerations, there's kind of 5 key things with Horizon 7 on AWS that we need to think about. So the first is Active Directory, right? Active Directory is kind of one of the most important pieces of the puzzle in any enterprise environment. It's kind of that cornerstone that everything is built on. And when you start talking about Active Directory in the cloud, there's a lot of different considerations that you need to take into account. So we'll spend a couple of slides on that. Windows file shares are another big consideration. VMware Cloud on AWS is built on vSAN. And vSAN is block-based storage. So it doesn't have any native capabilities for hosting files. So you need to have some sort of SMB or CIFS share to host data on. Now this isn't just regular file data that we're talking about. This is also profile data. And when you start talking about stretching Horizon between an on-premises environment and a cloud environment, or across multiple cloud environments, there's some considerations that you also need to take into account there. So DHCP is another one. And now this one is not as big of an issue since this earlier this year. Generally speaking, the DHCP in NSXT for VMC is somewhat limited, right? I can set up a subnet, I can assign a domain name to that, or a DNS suffix, and I can assign some DNS servers, and that's about it. So when you're talking complex EUC environments, you don't have a lot of options to set, other DHCP scope options. In one of the last releases of VMC, they actually added DHCP relay support. So I can now relay to a Windows-based DHCP server or a service like Infoblox. However, that's kind of an all or nothing thing. If I turn it on, I have to do it for all of my subnets that I use DHCP for. Image management's a challenge, right? You know, since we're talking about syncing between cloud environments or from on-premises to the cloud, you know, we have to keep our images in sync. And so there's challenges to that as well that we have to work around. And finally, app volumes. So app volumes has a multi-site reference architecture. That reference architecture actually requires a shared data store. So the problem with this is today in VMC, you only can use vSAN. There's no method to bring in additional storage, such as an NFS share from your on-premises environment, or even third-party storage from Amazon using something like EFS. So there's no really good way to automatically replicate app stacks. So if you're doing app stacks, today it's kind of a manual process. You have to export them, copy them up, and then import them manually. All right, so let's talk about Active Directory, right? You know, I mentioned Active Directory is kind of one of the most important services for any end-user computing environment. And there's a number of factors we have to consider when designing Active Directory for VDI in the cloud, right? So availability is a big one because Active Directory has to be available. If Active Directory is not available to our cloud service and users go to sign in, well, they're not going to be able to sign in, right? There's nothing there to authenticate them against. It also could be a problem because Horizon actually utilizes Active Directory as part of its desktop provisioning process. So when we're creating instant clone desktops, for instance, it's pre-creating the computer account and then it's doing a domain join when that instant clone is created. If Active Directory is not there, the provisioning process itself will fail. So if we're considering a solution like this for DR, we have to design Active Directory to make sure that it's going to be there in the cloud, right? Another challenge with this is performance, right? So depending on where we have our domain controllers, that's going to have a big impact on how the Active Directory service performs, right? So having domain controllers remote to our service is going to impact login times, right? You know, if I have my domain controller in a different site, I go to log in, it's got to go over the network, process the login, come back, and then it also has to do things like group policy and pull that down. If I have file servers there as well, then it's got to pull that stuff in. So you end up with a bad user experience when it comes to authentication and login. And the same goes for group policy replication and applying group policies. Again, if that domain controller is in a remote site and I go to apply that group policy, the experience is going to be bad because it's going to take longer to pull down group policy and apply them. I'm going to come back to security because that's every security person's favorite topic, Active Directory in the cloud, and talk a little bit about manageability. Right, so there's a number of different options which we're actually going to talk about on the next slide and as to how you could design an Active Directory environment for the cloud and what different customers are looking at. The challenge with some of these environments and some of these designs is that there's design consideration trade-offs that can impact how you apply group policy and the challenges with managing group policy, as well as how you troubleshoot when things don't work properly. And there's a number of different architectures that involve multiple forests and multiple domains that for some organizations that are used to their typical, hey, here's my single AD forest, they wouldn't be used to. And they wouldn't know where to start with or how to manage it. And then there's group policy implications for that as well. If I'm doing group policy across a trust for VDI, there's certain group policy objects I have to turn on in order for my user policies to apply on a desktop that's not in my domain. So those two kind of go hand in hand because there's a lot of troubleshooting that can go into that when things don't work properly. And for organizations that aren't used to that setup, it can be a burden to overcome. So now let's come back to security. Right? One of my favorite things is talking with organizations and saying, and hearing that they want to put VDI in the cloud, and then the security person going, but we can't have a domain controller up there. Full stop, right? Again, if VDI depends heavily on that domain controller. So if that domain controller is not there, there's alternative designs you have to come up with, but most of those designs won't necessarily stand up in the event of some sort of outage. So let's kind of go over what some of those options are. So obviously the best option is to put a full domain controller into either EC2 or VMC. So it's right near where my desktops are. That's the best option because it's a full read-write domain controller. It can do everything that you need, and you don't have to worry about it. If my on-premises location goes away, I still have a domain controller. Another option that gets kicked around, and this is actually in our official Horizon 7 onboarding guide, is using a read-only domain controller in VMC. Now the challenge with using a read-only domain controller is that it still relies heavily on a full domain controller. And if that full domain controller is, again, off-site, well, in the event of a disaster of some sort, a network outage or a full DR event, that read-only domain controller can't provision computers because it's going to refer that domain join back to the full domain controller. Authentication also falls over in those cases because while a read-only domain controller can cache passwords, it kind of defeats the purpose of having a read-only domain controller with a copy of all my users' passwords sitting in the cloud. Right? At that point, why not just have a full domain controller? So there's a couple other topologies you can consider as well. Right? Resource domains or a resource forest where I have an Active Directory environment that is connected to my on-premises Active Directory through a trust. Now, this actually may be a really good architecture depending on what you're trying to do. So some environments, if you're looking to use the VMware Cloud on AWS environment for like a seasonal workers, for instance, right? Where those are workers who are going to be there temporarily, they just need some access to some applications back on premises, that could work really well because I can just put all their accounts in that forest. I can put all the computer accounts in that forest. If my on-premises environment fails in some way, if my network connection fails, they can still sign in, and depending on what applications they're using, they can still work. Right? If I'm looking at this from a disaster recovery perspective, on the other hand, I may end up in a situation similar to a read-only domain controller environment where my on-premises goes away, my cloud environment is functioning, I can provision desktops, but users can't authenticate, right? Which again defeats the purpose of having it as a DR environment. Now, kind of a subcategory of that is that Amazon has a managed Active Directory service that runs fully in EC2 in the customer environment that's connected to VMC. There's a challenge with this though, right? So this environment requires a little bit of special configuration, right? They do something different in how Active Directory is structured. So computers don't go into the default locations, you don't have full admin rights on that domain, and you don't have the ability to fully manage everything. The other thing is if you're looking at doing something multi-region in VMC, where you have Horizon in 2 separate regions, the Amazon Managed Directory service is region specific. So I may need to have 2 different ones depending on what I'm doing, which again adds to a little bit of management overhead. And finally, the last one's a really bad option, which is don't put any domain controllers in the cloud, and that's just kind of like rolling the dice. That's the one where once you do it, it may work when you test it, but something bad is definitely going to happen and your whole environment's going to fall down. So networking and Active Directory service availability kind of go hand in hand, and these can be 2 of the biggest challenges in designing an effective Active Directory environment, or excuse me, an effective VDI environment, and they can also be huge design drivers because whatever the security team says is probably going to be what your design requirements will be. So now let's talk a little bit about file services, right? File services are another big option or a big design consideration, right? Because file services are where user data is going to live. And user data needs to be accessible and quick. Now, this can be in two different ways, right? First off is going to be user profile data, which is going to load at login, and if that's not local and easily available, you're going to have a bad login performance, which is going to turn people off to the service. The other thing is the other type of data over the wire may not be as big of a deal, but still, if there's latency there, a bad performance could turn users off to the service. All right, so what are some options here that we can look at? The first, obviously, or you may have to make a trade-off between having storage available for persistent desktops and storage available for file servers. Right? If you put stuff in EC2, there are potentially some network limits that may impact your performance. Right? Every EC2 instance has a network throttling on it. Right? There's so much bandwidth that you get per instance. And while you can contact Amazon support and have that increased, you may not know to do that until you run into issues. And finally, if you're using DFS replication, you have to know how much bandwidth you're going to use replicating files. Replicating into AWS is free, right? They want you to bring stuff into the cloud service. But if you want to replicate back, say you're doing a two-way DR type thing, or you have active file shares, everything that gets replicated out will cost you money. So you may have unexpected bandwidth charges. So there's another option also available. This is kind of more of a native cloud services option, Amazon FSx for Windows File Server. So this is a service that is tied to a specific region. It will work in multiple AZs, but it's not truly multi-region. You can connect it across regions, but again, you still have that outbound bandwidth problem where you're paying for data that's transiting between regions. It doesn't replicate with on-prem content. Again, you can replicate content in, it's not very easy to get it out. And finally, this service requires Amazon Managed Active Directory. So if you want to take advantage of a native file service in the cloud, you have to also have Amazon's Managed AD. So that might mean network trust, or excuse me, Active Directory trust between on-premises and the cloud. All right, so multi-site image management, right? There's a couple of ways you can do this, right? Automation, though, is the key, right? And this goes for on-premises VDI as well as cloud VDI. You want to automate your image management, especially now with Windows 10 and the fact that Microsoft releases every 6 months, right? One of the easiest ways to kind of handle replication between sites is to just export your ODF or OVF and import it in VMC or your remote site. You could also utilize content library for this. However, we actually have a not supported but works nicely option of using S3 as a content library. So if you're interested in learning more about that, I have a link to a blog post up here. And also, now that we support DHCP Relay, you can look at things like using Microsoft Deployment Toolkit or SCCM along with Power CLI to kind of automate some of your image building. So load balancing in AWS. So one thing about VMC is that NSXT does not have built-in load balancing for VMC. Right? It has it for on-prem, it's not available in the cloud. Right? So there are two native AWS load balancer options that you can take advantage of. Elastic Load Balancer does HTTPS only, but you could utilize this to load balance any of the Horizon components. We also have an application load balancer service that's more of a full service load balancer, but your resources that you're load balancing have to be deployed in the VPC with the load balancer itself. It won't work across the connection between VMC and the customer Amazon environment. If you're going to do any of the load balancing in native AWS services, you do need to have an internet gateway in your VPC. And you also have to make sure your firewall rules are set up to work both ways. That is not set by default, either in VMC or in AWS. And AWS security groups in particular are the strictest by default. So you're going to have to make sure you manage those security groups. And again, this can incur additional AWS charges for bandwidth and additional service utilization. All right. So one other thing I want to point out, you can utilize native Amazon services, other native Amazon services besides Route 53 and the load balancer services. You can utilize RDS, for instance, for the Horizon services, like the Horizon Event Database. This is fully supported. It works great with the free tier. So if you're doing a POC of some sort, you can spin up a free tier database service and use it for testing. Key thing to keep in mind here is when you provision this, in all the testing I did, the first time I provisioned that database service, I would tell it specifically what AZ I wanted it in, and then Amazon would go, no, you really didn't want it there, you wanted it over here. So you'd have to tear it down and redeploy it. The second time, Amazon seemed to listen. So you also want to make sure that whatever AZ you deploy it in is connected to your VPC, or excuse me, is connected to the SDDC. Right, so you want, if you have your VPC, you want to make sure you have a subnet in that availability zone that's the same one as your SDDC environment. And I have a walkthrough on my blog on how to do this that is fairly detailed. So if you are interested in learning more, we don't fully support every Horizon feature in VMC. We have a KB article out there that covers what we support and what we don't support. So finally, here's that KB again. And if there's anything else you want to learn about this, we have some great resources. We have a Horizon 7 on VMC guide that's a reference architecture and high-level deployment guide. And we also have our VMware EUC Tech Zone site that is all sorts of deep information on all of our EUC products. All right, so I think I am almost at time. So no time for questions. So, all right, free beer is that way.
All right, thank you for coming. We're going to be talking about PowerShell, beginning PowerShell from commandlet to function. And just to warn everybody, this is going to be the basics of PowerShell. It's nothing advanced. vBrownBag has always been enhancing your technical knowledge, but I'm going to be going back to basics a little bit. So my name is Mike Nelson. I'm a technologist at Rubrik, a Microsoft MVP, Azure Advisor, vExpert, all that kind of good stuff. The main point of this slide right here is you can reach me on Twitter at NowMedia. Have any questions, anything you want to ask me, that's the way to get a hold of me. So the first thing we're going to talk about is what we're going to talk about, PowerShell basics and creating your first script and function. We're going to make this a lot of fun. So the first thing I have to talk about is the versions of PowerShell that are available, because it's kind of a mismatch of different versions that Microsoft has been putting out. The first thing is 5.1. 5.1 is a native PowerShell that's included in a lot of the operating systems. So when you install Windows 10, you install Server 2012, 2019, 5.1 is what comes with it. Well, it does. So, but then they've come out with Core. Okay, so PowerShell Core, if you haven't heard of that, that was Microsoft's first attempt at going open source with PowerShell, which is really cool. So that is the version 6 that you can install. Now, what they're going to do next is they're actually getting rid of the term Core. Okay, and they brought this new kind of logo, which is really kind of cool for PowerShell. But they're getting rid of the term Core, and they're coming out with just PowerShell 7. So the next version will be PowerShell 7. That's how it's going to be named, and that'll be available. Right now it's in preview, so you'll be able to pick that up. Syntax, very basic syntax of a PowerShell command. When you first learn PowerShell, this is the key component right here. When you take a look at a PowerShell command, this is a basic command right here, and I'm going to take this apart piece by piece for you. The first thing is this is a commandlet. Okay, this is the heart of PowerShell. When you are given the option of working with different providers, working with different things like Dell, HP, software installations, all that, they usually have commandlets. All right, so a commandlet always consists of two things: a verb and a noun. It's always a verb and a noun. So you always want to do a get something, a set something, a install something. It's always verb and a noun in that sequence. Okay. And then this is a positional parameter. This just says that this particular parameter is what it's looking for in that position in the command line. So a positional parameter always has to be in that spot. Finally, we have a name parameter. A name parameter is something that the commandlet takes as a parameter, so it's defined inside of the commandlet itself. In this case, it's a filter. It wants to filter on something, and we're doing it on star sys. And then lastly, a switch parameter. Switch parameters can be varied between commandlets. They can, sometimes have customs, but usually they're a set default. There's like verbose, okay? There's a couple other ones, if I can remember them off the top of my head now, debug, things like that. Those you can find whenever you look up commandlets. That is going to be one of the switch parameters. Okay, so that is a basic PowerShell command right there. The key thing to remember here is verb and noun. Now, there are 4 actual commands that are really critical in learning PowerShell. There's get help, update help, get command, and get member. Notice it again, verb and noun. Now, I've added a 5th one down there, and that 5th one has actually disappeared from PowerShell. Hopefully it's coming back. This is one of the things that's been upvoted to bring back into PowerShell 7, which is called show command, which I'll show you a demonstration of. But if you know these 4 commands, then you can create your own scripts and functions within PowerShell. And of course, you always have to go back to the developer side of things. Create documented and reusable code, you will, according to PowerShell Yoda. That's just good DevOps. That's a good way for people to understand what you've written and why you've written it. So functions, this is going to be the last slide, just second to last slide. But the main thing about this is going from commandlet to function, right? So I have to explain the function is just basically a list of statements you define. That's all a function is. All right? And an example of that, this is hello world, okay? All you're doing is you're telling it, whenever a function of hello world is called, do a write host hello world. It's just going to write it on the screen. That's it. That is a function right there. Okay? It's a basic function, but it is a function. And then you simply just call the function. You just, somewhere in a script, somewhere in an API call or something, you just call that function as long as it's inside of that session, which I'll talk about a little bit later. And the statements inside of a function run just like you typed them. That's exactly what they do. So functions can be in scripts, modules, profiles, and called from other scripts. Okay, so what we're going to do here is we're going to go ahead and create an alarm clock. All right, just a basic alarm clock. All right, and I did this on video. Hopefully it works well. So in this environment, what I'm going to do is I'm going to show you how you start out first with the basics of PowerShell and then building the alarm clock. It's very simple. So the first thing I'm going to do is I'm going to start something called a start demo. And what it does is it automatically types for me so I don't mistype anything or do any crazy syntax stuff. So what it's going to do is I'm going to show get help, one of those first commands. When you do that, it's going to output a whole listing, of screen of everything you can do with the help. All right. Now, get command was another one. So these are all the commands, okay, commandlets, functions, scripts, so on and so forth, that you have available on your machine during your PowerShell session. Get process, get member. Remember, get member was one of those commands. What I'm doing is I'm just doing a get process, which pulls all the processes, and then those are all the member objects that you can query against. And then finally, the show command. The reason why I brought show command is actually brings up a UI, a graphical representation of the commandlet. So folks that don't like the command line, they can go through and enter it in here and click on run or copy, and it does it for you. So modules, these are the modules, okay, that are in my system, but a module is a component of PowerShell that allows you to interact with a certain, piece of software or interface. Now I'm actually installing a module. This is how you do it, our rubric module. After you install a module, you have to do an import. I'm doing it verbosely here, with that switch parameter verbose, and it lists all the things that you can do with that module. So again, verb, noun, everything I can do with that module. Now here's the concept of drives. So PowerShell drives actually allows you to see, you know, different aspects. Like you see my C drive, my D drive, functions, registry, all that kind of stuff. And that's given to you by providers. These providers are what is populating that besides the physical drives. If I add another provider like Active Directory, like I just did, and then I do the same command again, it actually shows new commands underneath just for Active Directory. So that's how you get the ability to expand your scripts and your functions to be able to do those things. Now here, right here, I'm just doing a get process, okay, but I'm doing a pipeline. I want to show you what a pipeline is. And I'm piping a get process, which is all the processes running on my computer, into a table format. Okay, if you remember from the old DOS days, you used to take DOS, you know, a command and pipe it to more. Okay, you're doing the same thing in PowerShell, you're pipelining. Now, in our alarm clock, we're going to talk about sleep. And that's the main function of the alarm clock, start sleep. This is basically the command of start sleep. It gives you everything about it. Remember, get help. This get help on the parameter of seconds. I want to understand what I can do with the seconds in the sleep. And finally, is there an easier way to call that than actually typing start sleep? Yes, it's called an alias of just sleep. So here I did a sleep 2. It slept for 2 seconds, came back to a command prompt. Here I'm sleeping 2 and it beeps. That's the first alarm clock. Now it's going to keep beeping 2 seconds. Ready? 1, 2. Okay? That is your alarm clock. That's a basic alarm clock. That is the command for the alarm clock. Now if we took a look at that, you just took that command, you could put sleep X amount of seconds, have that thing go off and that'll wake you up. Basic alarm clock. Pretty cool, huh? All right, let's take that. All I did was took that function and I added a PS1 extension to it. By adding PS1, it turns it into a PowerShell file. So I'm going to take that function, and when I load it, it actually loads it into memory. It sits there in memory in your session, so you can call it from any script and use it at any time during that session. When I do a dir function, that's bringing up that PS drive. So when you look at it, you can see all the functions that are available to you, but I want to narrow it down to just what's in alarm. Okay, so when I do the just alarm, it's only going to show me that one that I have there, which is the alarm clock, that function, that start alarm clock. And then finally, I'm going to look at what I can do with that start alarm clock and what it does. Exactly the same command we had before. Finally, I'm going to add a parameter to it. So instead of doing start alarm clock with the definition of the seconds, you can just put a parameter in there of how many seconds you want, which is really cool. So I'm going to load this whole function, and then you can see below, I'm going to do a start alarm clock for 2 seconds. And that's exactly what it'll do. It'll run all that code, just like a function's supposed to, okay, with 2 seconds. And I'll run it right here. Okay? Now, what if we were to take that, and they're like, hey, I want people to understand what you do, what this thing does. Well, you create a comment called a synopsis. And by doing that, okay, I'll add this function to memory. That's what I'm doing. I'm taking this and I'm adding it to memory at this point. All right, and now you can do a get help on that function and it'll return what you put in the synopsis. So if you wanted to put in that synopsis, hey, you know, this is Mike and I don't know what the heck I'm doing, that'll show up whenever they do a get help on it. And you'll see me scroll back here. It'll show you. I'm trying to keep up with my demo here. So sometimes it's not that easy. So what I've done here is showing you that all PowerShell scripts have to be what's called .sourced. You have to have a dot and a slash in order to start a PowerShell script. Here I'm doing the start alarm clock with seconds 2. That's calling it a function from memory. And now I've done something really crazy. Watch this. I've added voice and I've added music to it. So this is how crazy you can get. Check this out.
May the force be with you. Wake up.
How cool is that?
May the force be with you.
That is like the perfect alarm clock. So, just in closing, thank you very much for watching this session, listening to me. I really appreciate it. Again, reach me on @NellMedia, and I hope this was beneficial to anyone that wants to really learn PowerShell just starting out. Thanks.
All right, good afternoon. My name is Demetrius Malbro, and I am a technical marketing manager with Rubrik. And today I am going to be speaking with you about breaking habits. And I'll share 3 tips to transform your company. And the purpose today is for me to prove to you and show you that habits really do matter, okay? Whether you are a backup administrator or a solutions architect, whatever your current position is today, I would like to tell you that whatever habits that you already have are basically the multitude of everything that you have done today. And whether you are aspiring to be CIO or Chief Technology Officer, it is definitely something that goes along with habits. So, the situation is as follows. That IT environments are built on habits, some good habits and some bad habits. So, if you have accumulated good habits within your IT environment, then it allows you to be more proactive. For instance, let's say for backups, from a backup or data protection perspective, let's say you have a product that you are able to capture and take sufficient backups, and in the event of a disaster, or you need to recover that data, that you can do so quickly and you can do so simply. That is a good habit to have. But a bad habit is where you are more reactive, right? Something happens, you're stressed out, you can't recover that file that you need. Let's say, for instance, there's ransomware or something like that, and you're not able to identify what data changed and to also be able to recover that data quickly. But the end result of all of these things is that you can either continue with your bad habits and stay in mediocrity, or you can take your good habits and walk toward what I like to call excellence or world class. Now, rolling into tip number 1. First tip is to, along with your backups, it is important to leverage a SaaS or software as a service platform to unlock your backups. Now, I am specifically speaking with, let's say, a data protection specialist or a backup administrator. It is very important that today we are managing data across a multitude of environments. You have your on-premises environments, you also have data across multiple clouds, and you also have many, many applications that you're dealing with. So now you have data fragmentation, right? We all love data fragmentation. It's something that we're trying to wrap our arms around, and it's beginning to become a more complex issue just to manage this data. But if you have a SaaS platform that's sitting on top of your current backup platform, now you're able to have that global data management. You're able to have that visibility into where all of your data is. Let's say you may have a data center in the US, you may have one in Asia, and you have multiple clusters running on your premises, and let's say you want to know exactly with one view where all of your data is. So having a SaaS platform, you just log into your browser. Now you have that global visibility, and so you can organize your data. You can even orchestrate that data, and that data will also be secure. So tip number 2 to transform your company is to, on top of that SaaS platform, you can also demand that you have end-to-end security. Now, I'm primarily speaking to security professionals right now, but backup professionals also need to be concerned with security because it's very important today. And that SaaS platform, let's say it's in the cloud, of course, and you are running containers, and you have a couple Kubernetes deployments out there, and making sure that you utilize those local cloud services to protect against DDoS attacks, also scanning for vulnerabilities, and also it has some type of key management system that you can actually manage your cryptographic keys in that environment as well. So just to kind of tie this all up into a bundle, making sure that your connection between the on-premises appliance or your cluster on-premises and your SaaS platform, that you have that information encrypted and that you're also utilizing TLS, at least version 1.2, and that data is secure as well. And you're not sending the data itself, you're only sending the metadata, so you do not have to worry about that platform actually peeking into your data. That data is actually on premises, it's intact, and only the metadata is sent. There's only an outbound connection to that metadata. And also making sure that that data is isolated. Let's say you have multiple customers, and let's say you would have multiple independent databases to keep that data separate. And last but not least, data residency, making sure that if you're in the US, that data and that storage is in the US, or if you're in the UK, that it stays local based upon compliance and regulations perspective. So tip number 3, and this is everyone's favorite, is dealing with ransomware. It's in the news often nowadays, you know, cyber threats, cybersecurity. This hospital was hacked. This person got ransomware. It's a really, really hot thing right now. And the most important thing is that your SaaS platform also is able to allow you to recover quickly and also to be able to detect anomalous behavior in case that you do have some type of changes in your backup data. Because if your data is encrypted, if you were backing up yesterday and now you're backing up today, ransomware hits, there's a huge change rate because now all of your files have a different extension, and you can now detect that. You will get an alert to say, hey, there's something going on here. So now you have that information in one location, and you can actually recover that data pretty quickly. So just making sure that that extra step of prevention, that holistic ransomware response and that resiliency is built in, so you can minimize your downtime and you can recover quickly in case you do have that ransomware to hit, and also go a step further to make sure that your backup data is also immutable as well. So there has to be some type of machine learning or some type of deep intelligence that's involved as well, making sure that that is a part of the platform so you can actually understand what data has changed and to be able to identify where that change happened and to also be able to recover quickly. So now that I've shared the 3 tips to transform your company, now I'm going to take a step back and kind of put a little personal spin on this. So how do you break habits, just period, like bad habits? You all know your bad habits, right? You know, some of you may have your cell phones in your hands right now. You're not paying attention to what I'm saying, you know, and you're like, okay, I got to get to this next session. But anyway, so I am an avid reader, and I love a guy named Robin Sharma. And there's also a study that's based on this called it's from the University College of London. It's called the 66-day protocol, the 66-day habit or 66-day minimum. And it's broken down into 3 different components. So it's a little hard at first in the first stage, it's a little messy in the middle, and then it's gorgeous at the end. So when you go through these actual 22-day cycles, the first stage is what you call destruction. So let's say you wanted to get up at 5 a.m. in the morning, right? So day 1 is very hard, you know, you're sleepy, you're tired, you don't want to get up. But let's say you stick to it across your first 22-day cycle, and you're able to continue to gain a little momentum. It's getting a little easier, and now you're rolling into what we call stage 2, which is the installation stage. That's another 22-day pocket, gaining that momentum. You've made it past the hard part. Now it's getting to be a little easier to implement that new habit, and now you're into integration, where it's really like you're getting the hang of it. And after that 22-day pocket, there's your 66 days. Now you are at the automaticity point where willpower is really little, and you're now operating almost automatically. So that new habit should be installed, and it should be much easier for you to do, you know, whatever you set your mind to, right? So let's go ahead and tie this all up into a neat little bundle. The 3 tips to transform yourself and also your company. The tip 1 is to leverage the software as a service platform on top of your current backup solution so you can unlock the global visibility across your entire environment. Also to make sure you demand that end-to-end security, because security is very important. Things like encryption at rest, and also let's see, TLS 1.2, and just other security measures that you might use. And then there's the last one, be able to recover quickly from ransomware. And that's it. Thank you very much.
All right. Good afternoon, everyone. My name is Karthik. I work as a staff engineer within VMware Global Support Services, and it's been like close to 9 years debugging, troubleshooting, anything around vSphere, and especially around anything to do with storage. And that includes vSAN, which is the core area where I work as well. So coming back to today's session, it's about the vSAN performances, best practices, where as part of our day-to-day job, where we work with quite a lot of customers around performance and its areas. And that's where we thought, okay, there is something where we need to have a lot of all these details which are missing when we work with the customer. That would really help all other customers as well. So this presentation was a trigger with all the work that we did with our customers. So in the next 30 minutes of time, right, we're going to be discussing about quite a lot of details around how the components or the nodes are designed, especially around the compute area, around the disk groups, and to an extent we will be covering something on the network part as well. So before I move on to all the performance and other details, the first and foremost thing, the documentation. I know pretty much everyone overlooks the documentation, but they got ton of details, and all we speak in any of the sessions, in any of the tech talks, everything kind of boils down to our documentation. But unfortunately, there could be certain issues in here, but do take it a point to review those documentation, especially around performances and around the design guidelines as well, because those are two areas ultimately everything boils down to on how a setup is going to be. So what does it matter? So before we get on to our session, so there are certain things that I want to kind of set very clear so that you know what to expect out of the session. So we're going to be going in detail, okay, and that's going to be touching upon many of the design considerations as well. And when it comes to design, there is nothing good or there is nothing bad. It all boils down to what kind of environment that you have and what is the expectation or what is it kind of meant, or it is configured for. Those all boils down to whether this particular option that is something will be useful for you or something that you can even ignore them. So which means not everything that you need or not everything that we're going to be discussing, maybe it would be applicable for you, but some may not as well. So with that ground rules, let's get going. All right. So why does performance matters? There's nothing to kind of explain, it's self-explanatory. But the first thing is the old age says, right? A slow and steady wins the race, but these days it's like marathon plus sprint, so you can't go ahead with like kind of a slow performance any down that can bring down your entire business as well. And being a storage, the impact could be magnified into multiple things that your entire business comes down to a grinding halt. So why does it matter? So that's where all these best practices will help you to ensure you take a right choice and the decision going to help you in terms of your performance for vSAN specifically. First thing, CPU. When it comes to CPU, right, people usually don't bother much about it because it's taken for granted. Anytime when you order a node or order a server, you take it for granted. Okay, it comes with the, flashy, the new CPU that are, kind of coming with your any individual node that you kind of buy with them. But there are certain factors that can have an impact on your vSAN performance as well. So many people first they kind of think, okay, how many like 1P, 2P servers? The reason why we highlight all these 1P or 2P is that these days people always go for a dense server, means like kind of 2 socket servers with like say 1 or 2 TB of RAM, which is kind of super dense, right? These kind of decisions can have an impact on vSAN as well in an indirect way. I'll tell you why and how. So first thing, when you have all these things, right, so there are a lot of factors like NUMA and other considerations that comes into play. So usually we see with the explosion of number of cores in a single socket these days, those days of like kind of beefing up with 4 sockets or like kind of 8 sockets, those are all gone days. With single socket you can do much more things than you were doing with like kind of quite a number of hosts actually. So with that in mind, 1P in certain conditions, especially with AMD and other the latest EPIC processors, they run much better. So you have to decide on which or the configuration of your node. Is it going to be 1P, 2P? Second thing, about the frequency of it. It looks very simple at a higher level, but it's like how fast your CPU can kind of charge up itself so that it can get the job done in a shorter span of time. So the higher clocking is something that we recommend. And finally, when it comes to performance, so make sure your BIOS is set to high performance. That's the power policy that we expect with our customers. But most of the servers or OEM vendors provide with the balanced performance, which is something not we recommend, because a lot of other things like C1E and other states, or even for that matter Turbo Boost, which helps you to kind of scale up your performance for vSAN, that in turn drives in increasing the throughput as well as decreasing the latency that you see with them. So that's very important. And when we come to memory part, nobody have a look, or like they don't consider that much at all into this particular section. So they kind of take it for almost like granted. Like all they care is like how dense it is. Is it, am I getting a 1 TB or like 512 GB or like it's a 2 TB? That's all they look at. But there are two important things that I want you to take note of. Once you know what it is, then it makes really sense on how it would have an impact on vSAN. But most likely your OEM vendors would take care of it, but it's always good for you to know so that you could take an informed decision. The first thing is about the kind of DIMM that you're going to be kind of placing in the platform. There are like kind of two DIMMs broadly classified. Like there are other type of DIMMs, but I've taken two which are most commonly used on 99% of the systems. That is LR DIMM and R DIMM. So what kind of DIMM? Because LR DIMM is something which starts from 64 gig and is a little bit costly as well. And but when it comes to performance, they give you superior performance, and the density also goes high. But when it comes to RDIMM, they perform much better, but their range is very less. Like the max RDIMM that you can afford in the market is maximum 32 GB, which means if you're populating those memory DIMMs, your memory on the individual node comes down drastically. So that's where you kind of take or you decide which is suitable for you. If you want a more denser server and a faster server, it's LRDIMM that you go for, right? And the second thing that is very important is how you populate these memory in your like kind of in the platform. That is very important. We have there is another slide which speaks more in detail, which we will be covering later. And the final thing, Intel Optane memory is something which we don't support, so that's going to be coming on down the lane in another like few releases later, just for an FYI kind of thing. So this was I was like kind of speaking about like how you populate your DIMMs. This is really important. For that matter here, in this case we have a single socket. On both the sides you have channels like A, B, C, those are the channels, and then you see the slots where you put in your DIMMs. So if you see them, in total you have 8 channels, and every individual channel has got 2 slots in them. So if you kind of fill up one slot on both the sides, that is 8 DIMMs, right? So what would happen is that the CPU or the DDR RAMs or the DIMMs that you have got there would kind of clock in at 2,666 MHz in that particular range. So which means somewhere if you are placing all the 8, not instead of 6, you will be like working at a range or a bandwidth at about close to 21 GB per second, gigabytes per second. And now let's say this is at 2,666 MHz. At that frequency this operates when you populate this model. Now when you step back, okay, I want a much denser server, meaning like I want 1 TB or 2 TB of configuration. So you go ahead and populate the other slots. So what would that mean is it would increase the operating frequency from 2,666 to 21,333. That is 2,133 megahertz, meaning your theoretical throughput or the bandwidth that you're going to be affording is kind of much lesser. Back then in 2,666, remember it was 21 gigabytes per second. It comes down to 18 to 19 gigabytes per second. And there are certain other configurations as well. Let's say in case of 2P and other things, like say 2 sockets, when you keep populating every slot that is available for you, you would be reducing the operating power. It can come up to almost like 15 to 16 gigabytes per second as well. So that's the one which affects on how fast you access or how memory is being accessed, and that can have an impact on memory. So in some of the testings we did, the LR DIMMs, especially with AMD EPYC processor, which are like high on number of cores, the LR DIMMs actually perform much better way. So have these things in mind when you kind of do it, but most likely your hardware vendor would usually take care of it, but you just have a check with them. That really helps you. Like it's a hidden benefit that you can easily get, but there are some cost factors will be at play. I'm not saying no to it, but at the end of the day, as long as you get a faster like kind of operating or like kind of a working vSAN cluster, that's something that you expect and that's what you want for, right? So this is very important. Have a look. Similarly, like in case of Intel, also Intel Cascade Lake, that's the latest one, the flashy one, which also has certain bits into it, like the same way the channels and how they are distributed, how you populate the memory, everything also comes in here. So have a conversation, what kind of DIMMs and what is the performance that you want. So when you have those conversations, the OEMs or the vendors would be able to explain you much more in detail. Yeah, so that's something good to know. And coming on, like compute, okay, moving away from compute when it comes to disk groups, right? That's where the entire, like the actual heavyweight or heavy lifting happens. So the disks, right? People ask, okay, how many disk groups is something that is optimal? Because any customer with whom I have kind of worked with, or they kind of work on like, okay, hey Karthik, I have a cluster here, this is working, it's fine, but I have other projects where I need to create or I need to kind of set up a bigger clusters. What do you suggest? This is a common question what we get from our customers. So based on the internal experiments, what we have done, what we see is that if you have like say 1 disk group, that's a bare minimum. Max of 5 disk groups you can have for every individual node. What we see is the most customers prefer 2 to 3 range, 2 disk groups or 3 disk groups range. And when we tested it in our labs, when you have like 2 disk groups, right, your performance doubles. And similarly, when it comes to 3, it doubles. Like basically the IOPS gets increased with the same set of latency when I mean. Now, when you increase it more than 4 and 5, right, the linear or the improvement in the performance is not so linear, which means the sweet spot is at 3 disk groups. This is some performance angle as well. And the other angle is, let's say there is something that's going to go wrong, right? There is something called a fault domain, so which also comes into play. So if you have more than 1 disk group, that is 2 or 3 disk groups, it's always better. So go for a configuration which has like more than 1 disk group, but unless and until you really need anything more than, I mean, like kind of 3, go for it. Otherwise, stay between 2 and 3. That's the recommendation. And if you are using not so flashy kind of a beefy config for all flash, make sure you have your storage policy, which includes a stripe width. Basically, you are trying to split objects into multiple components, spreading across your entire cluster, so that all your IOs are not going to go into one single caching layer or one single node. It's spread across the cluster, making use of the clustered resources. That's something we strongly recommend our customers to do as well, right? And have in mind, when you're going for the latest version we have from, recent versions do support RAID 5 and RAID 6 concepts as well. And when you're going for RAID 5 and RAID 6, you have IO amplification, which means every single reads and writes will be amplified by 2x or 3x in this particular configuration, or if you set this particular policy to your virtual machine. So when you do that, what would be the impact? Do not change that dynamically as and when you need. Yes, you can afford to do it, but if you know what you're doing, then it makes sense. But if you're not sure of what you're doing and you just, okay, hey, I want to just change this particular policy from RAID 1 or RAID 0 to RAID 5 and RAID 6 dynamically, and you have a lot of VMs and they're like kind of heavy VMs, obviously you're going to be pumping a lot of IOs, and that's going to impact your performance for your virtual machines as well. So make sure you time it appropriately, like during the like kind of a low watermark period, or like kind of a weekend or anything, like where you don't really get impacted, or the number of IOs that are generated by the VMs are pretty much less. And finally, big data applications, that's something we have seen with many customers as well, because of a lot of things coming into on the vSAN platform, right? We see people usually go with the default policy of FTT equal to 1. You don't really need to, for 2 reasons. One, space savings and other things. And coming back to our context here in terms of performance perspective, you really don't, because the redundancy is all kind of taken care at the app stack or application level itself. So you don't have to really do that. And most importantly, you are not letting your IO hop out into the network. So the network hop is cut down on here. So which means you save, or the application runs even much better when you have in this particular configuration, especially for big data applications or any application that has redundancy built in at the application level. And Intel Optane NVMe disks are like something which are fast performing. I mean, Intel claims it's more than like 20-30, I mean at least 30% faster than the fastest SSD. But it is definitely, I'm not disputing that number, but if you are looking for a faster performance, or at least the cache layer, go for NVMe kind of devices. I don't want to be a vendor specific, but in general NVMe is much better. And congestion is something very important. If you start seeing congestion, means basically you are trying to kind of pedal back and say, okay, hey IOPS, go ahead and stop. I mean, you are pushing back to the guest OS and back to the application, slow down. That's the message of what congestion is in a nutshell. And it can come for multiple reasons, but you can broadly classify in 2 buckets. One, it could be a hardware problem. All right, the hardware problem could be a bad or a failed disk or something which is about to fail, or the controller has some issues or anything of that sort, or under the hardware bracket itself, your hardware is not properly configured for the amount of data that it's going to give you, right? That's the hardware. Software side is something like maybe some of the components has a known issues or like kind of a bug or something of that sort. So those are two things when you see. And when you see congestion, that's at high time that you kind of trigger the alarm, and then either you kind of start looking into it to figure out what is causing it, if not raising a support request with VMware support to help to identify what it causes. And the reason I'm highlighting again this congestion, it doesn't like, it's not like it improves your performance, but basically it increases or decreases your kind of a performance, and it can be at times severe that it can entirely bring down your cluster as well. So it can be very dangerous. I mean, it's always, I suggest nip it at the bud. All right, network. All these things what we saw, right? So if you look at the VMware HCL, like bring your own device kind of concept, where you can build your own vSAN nodes and stuff. You will see SSD, hard disks in terms of a hybrid configuration or a HBA controller, but you will never see a network card. But network being a networked storage is kind of a backbone to how your vSAN cluster is going to perform. And if you are using all flash, make sure it's 10 gig, nothing less than that. And if you're using NVMe of those sort of devices, always go for a 25 gig or above. The reason I'm saying is these faster caching devices like NVMe can easily kind of overwhelm the underlying storage, I mean the networking stack or the bandwidth it gets. So they are super fast that you can easily kind of fill up or throttle or kind of get the NIC card to stop dropping packets. And when you drop packets, right, that is equally dangerous, and I mean in terms of when it comes to performance as well. The more the packets drops, the more the degradation that you would see. So it can be even the latency what you experience because the packet drops can go up to almost like 500 or even a second for every single IO. So which means that's very dangerous. So getting a sturdy network and enough bandwidth for your workloads is very, very important. Trust me when I say this. And we see a lot of customers, the moment they start seeing, so that's the area where we look at, okay, what is the configuration, is all the components in the HCL of what we define. If everything looks good, the next thing that we logically look at is, what is happening with the network? Is it the network stable enough? Because that's where we see many a times customer runs into a problem. And when it comes to network, so it could be not a properly sized NIC card that's in place, or the IO that has been pumped is too much, and quite a lot of other things. And finally, a couple of things we noted, like one is traffic shaping. Traffic shaping in itself doesn't help you or decrease the performance, but what happens is it doesn't allow you to scale when you really need to. Let's say there is a situation where the bandwidth is already congested, so it stops, which means if it's going to restrict your vSAN, so the performance, everything is going to come down, the IOPS and everything. This was some time back, but these days you don't really have it, but there is something called Cloud Health that we use it. So those health checks actually verifies all these things and tells you, yes, if you have configured, this is something you have to, that is causing a problem, or this is something that you have to kind of go ahead and disable or kind of alter it. If at all we are kind of reaching to a point where the congestion starts kicking in and reduces your performance. So this is no more something you have to do it manually these days, it's automated, but I wanted to highlight that there are quite a lot of configurations. So it's not because there are configurations and you can configure, you can do that, but unfortunately you shouldn't be shooting your own foot. That's very important. Jumbo frames, yeah, so it doesn't have a direct impact on the vSAN performance, but it has an indirect way. So when you have your setup, everything configured in jumbo frames, then go for jumbo frame configuration for your like VM kernels and the uplinks as well. If you have jumbo frames, it helps you to reduce the CPU cycle. When the CPU cycle reduces, that's used by other threads and things to fasten up. So it's a kind of an indirect one, it's not a direct performance. So if you have it, go for it. If your setup doesn't or isn't configured for jumbo frames, then it's okay. It's fine, you can ignore them. And the last thing, right, driver and firmware, it's very, very important, okay? Trust me when I say it's very important. There are a few areas, something which are really critical for vSAN. When it comes to drivers and firmware, whatever we spoke all this while, like CPU, memory, all those things are static. So you configure it one time, you get it right at the beginning, that's it. You're not going to change that pretty often. But this is something that keeps changing. It's very dynamic. Like when you update or when you patch a server, there are good chances this can be changed or modified. So when you change different versions or like kind of drivers and firmwares, make sure 3 things you have in mind. It's up to date, it's compatible, and when I say compatible, it's compatible with the version that you're running as well as compatible with your firmware as well. because some of them may work with any kind of firmware, but some of the driver versions specifically work with the minimum set of driver or a firmware version. Only with that it is compatible. And we have seen a lot of issues with the customers, like it could be performance, it could be packet drops when it comes to NIC cards, or when it comes to HBAs, there could be devices where it kind of bails out when the I/O is too much, wherein the disk gets kind of disconnected or kind of goes offline for whatever reason. So it's very important you get that right and always verify them. And so the last option, right, when it comes to NIC card, it's something people tend to overlook. At least for HBAs, I mean, I see usually customers are concerned on what version they are going into. But when it comes to the NIC card version, right, they just update, they don't really look through a lot of things. There are quite a lot of features when it comes to a driver that are like kind of helps you with the performance of vSAN as well. How? Let's say there is something called NetQ, or you have like RSS, they help you. So sometimes some of the driver versions what you had may had the RSS enabled by default, but in the later versions it could be disabled as well. So verify what is available and what is not available for that particular driver. And how do you get that? The shortest way and easiest way is look to the release notes that gets downloaded automatically when you download a driver. This is something not many of the customers look at all. They just take it for granted. When you download the driver has in a zip format or something which also has a text file. Just open up once. If you're using like say Intel i40 or Broadcom NICs or like kind of Emulex or anything of that matter, look through it. It will have a known and resolved issues. Apart from it, it will have what features does it support. That's very important when it comes to the performance of your NIC, and especially the buffer. Many times we see the packets are getting dropped because they didn't have enough buffers or the rings were getting full. So that's an area where I would request you to focus before you start even the activity of patching or modifying the drivers. Very important. Alright, so these are all things we have seen. So if you look at, we've been focusing more towards the hardware side, but we haven't come anything on the vSAN software side of things, right? Let you know that vSAN is built in such a way that it can dynamically adjust to the kind of underlying configuration that you have. So which means if you have like an all flash, it knows that this is all flash configuration, it adjusts accordingly so that you get the optimum performance. So that's already built into it. So that's where you wouldn't see much of focus on what do you do or fine tune things, but it will be all in terms of suggestions. Okay, how do you set up or how do you configure every individual node in a vSAN cluster? And the most important thing when we say keep your vSAN versions up to date, I usually get a giggle from a customer when I'm speaking on a phone. Okay, hey, it's okay. I mean, every vendors or every support asks me to keep an update version, but there are two reasons to it. One, there are known issues which we want to do it, and second thing is there are a lot of improvements on vSAN that could help you as well, like some of the components. Let's say resync is something important that's been modified. Let's say if you are on an older version, it's time for you to upgrade. And there are improvements that resync and snapshots and other things that adds to your performance as well. So stay up to date with the latest version. And last point, do not make configurations on the fly, or make sure you're kind of streamlining them. That's very important. The moonshots would be like stale objects. This is something where we don't usually see with customers, but if you are in POC and you're moving your POC environment into your production, so that is when you get to see this particular problem coming up. So stale objects helps you to occupy space as well. So when you delete them, that helps you. When it comes to performance, they don't impact them directly. This is also an indirect benefit. What happens is that your component distribution gets skewed because of the stale object. So which means all your IOs somewhere which was supposed to be distributed is being pumped into one single node or one single capacity disk, which is like something that's not so great or not so good to be in, right? That's one. And yeah, log snippets, just to tell you like when a congestion happens, right? These are the log snippets that you need to be aware of. If you're anytime seeing this thing, that's a time for you to kind of hit the alarm button, right? And these log snippet is very important, and especially the 2 KB articles that you find here is something I would suggest you to bookmark. It's not for vSAN as such specifically, but it includes for anything on the vSphere storage stack as well. If you see any of these devices like highlighted ones X028, that is a read command in SCSI terms. And if you're seeing like getting a check condition, right, HDP, do you see there X0X0 D02? That's important for you to note. If you're having it, something is not right. Device drivers, firmwares, that's the area you're going to be focusing next. Yeah. All right, that brings us to the end of this particular session. So make sure you always stay up to date with the versions. Configure your nodes in the right way so that you don't have to relook at it down the road or down the lane, one. And finally, when you are dealing with performances, be methodical. There's nothing that helps you. If you are like trying to change a lot of things, you don't know where you start, what happened, what that ended up. So make sure you make one change at a time and go in a proper fashion. Okay, this is the numbers that I got before the change and this is the number that I got. That really helps you. And pretty much when it comes to support, I'm sure if you have already worked, they would be following through a methodical process, and that's what we go by. So, and definitely that's something I would suggest, don't mess up there at that particular one, because a lot of things get skewed easily if we miss that one important thing, right? Right, so finally, those are the additional resources I would suggest you. Those are some of the VMworld videos as well, and you have some documentation landing pages. They have a ton of information, whatever we discussed, and a lot of other things that helps you to build a successful vSAN cluster. Yeah, right. All right, that's pretty much I had for the day, and thanks very much for taking time and joining this particular.
Hey everybody, welcome back. Hopefully you guys got to see some great things in the keynote, some good conversation. We are back at vExpert Daily for day 2. So how many people feel like it's day 22? Okay, good, it's not just me. That makes me feel much better. So I am Mike Letcha, I'm one of the principal technologists at Cohesity, but more importantly, I have been a vExpert all except for the first year. So I think I'm at 11. Wow. I think it's 11 years now. And we've been doing this, I think, for, well, 11 years. So I started quite a few years back, and really we just want to get into a great conversation about what's going on with the show, what activities have happened, announcements, keynotes, and pretty much anything we feel like chatting about for a few. So I brought a few of my friends up here that are also fellow vExperts. I'm going to let them introduce themselves, and then we will dig into it. Start with you, Matt.
Sir, good morning. Matt Langeth, Manager of Information Systems with an automotive accessory manufacturer based out of Central Pennsylvania.
And automotive manufacturing.
Automotive accessories
Accessory manufacturer.
Yes, sir.
Can you not say the name?
I'd rather not.
Oh, okay.
Is it aftermarket or is it OEM?
Aftermarket, sir.
Ooh, performance parts.
I'm confused by him saying sir to you so much. That's already confusing. Well, okay, very nice.
Yeah. I'm Dee Abson. I'm an infrastructure architect for a company up in Canada called AFSC. We provide financial services for agribusiness.
Okay, and Sean.
I'm Sean Tulane. I'm a senior V-architect at Dell EMC.
Okay, well, thank you guys. Welcome. Make sure you guys with the sticks nice and close, otherwise they can't hear you. It gets still. Don't do that. Nobody wants to see that. So normally I kind of do this chronological, and we'll start, and then we'll get into some tips on it. So we'll start with yesterday. So we had this early yesterday, but then there were sessions throughout the day. Floor was open, events last night. Let's start with maybe some sessions, or did you, well, I'll ask this first because it's always an interest. Did you go to any sessions yesterday?
Yes, absolutely.
How many did you go to?
3.
Okay, so you probably went to more sessions than I will go to the entire time I'm here.
Probably.
Any sessions?
I got to 1 yesterday.
So you're about where I'll probably, well, I have to give 2, so I have to go to at least 2.
Yeah. One on the regular schedule, one that I'm not supposed to talk about.
Oh.
Yeah.
We'll try to talk about it. I'll try to talk about it. We'll see if it happens. So what 3 did you make it to?
vSAN, and there was also some new initiatives that they were trying to do with CI/CD development and PKS, and then more robo deployments for vSAN.
So vSAN, a little bit of vSAN.
vSAN Square.
A little more vSAN, okay.
PKS and CI/CD.
Was yours a vSAN one too?
Well, sort of, because I did the VCF session, so of course it's got vSAN layered underneath.
Okay. So what did you think of the sessions you were at? Good content? Good
content.
Were they worth going to?
Sessions are always worth going to, even if it's just
That was a very political answer.
to go and just have the time at the end of the session to get your questions answered directly by the speaker. I always think that's valuable.
So that was the best part of it, was that, and I think that's something we often talk about up here, that the value is not always in the presentation, but being able to talk to those presenters for 10 minutes after the session.
Or listen to the questions that are being asked by the fellow attendees, something you might not have thought of.
Yeah, my session was actually at the end of the day, so it was 5:30 to 6:30.
Oh, that's a rough time slot.
It is a rough time slot. You're getting
I think Alistair put me on one of these for 5:30 on Wednesday. Yeah.
But
I really appreciate that one, Alistair.
the presenter even stayed like beyond the 6:30 mark to make sure that everyone's questions were answered.
That's very nice of them, but that's
Yeah,
cutting into drinking
that
too.
was
Common
major
theme. I
props
really
to
see
them
that,
there.
that a presenter will take as much time as they possibly can
Yeah.
to answer everyone's question.
If they're not running right to another appointment or another meeting or something else,
Within
most will
reason,
stick around.
Absolutely.
Yeah. My session was one about validated designs and VCF, how they're kind of bringing them together.
Were you in the same session?
No, mine was earlier in the day.
Oh.
Yeah,
Mine
I think
was the VCF deep dive.
Oh, so
Yeah.
he was smart enough to go to an early session in the
I did
day.
a shallow dive.
Oh.
Yeah.
That hurts. Be careful.
It can. You have to know what you're getting into. But it was really useful to be able to focus on what's important to you. And even if it's not something that you think, well, is this worth my time? Am I going to be able to go back later and just watch the video? Taking time out to actually sit down and focus, you know you can do it while you're here. So if you pick some sessions that you think a topic is really important to you, then I find it valuable to even just spend the time. And then of course being able to access the expert after and ask some more pointed questions, things like that. It's really useful.
So I'm going to take a stab into that shallow pool discussion. So hands down, the best exhibit that is anywhere near VMworld right now is not on the exhibit floor. Has anyone walked from here to Moscone West?
Well, I mean, that's where the session was.
Okay, so you've gone from here to Moscone West. Did you stop on the corner and go to the puppy therapy space?
No.
There's
Not
puppy
at all.
therapy. Have you guys seen this yet?
Mike, tell us
You
about
go play.
puppy therapy.
You go play with puppies. You literally, they're little puppies. I took pictures. There's a whole space you play with puppies.
Yeah.
That talk about getting out of like this for a few minutes.
For
I mean,
sure.
you can 10 minutes to just sit there and play with a puppy. Who doesn't
Yeah.
love that? I mean,
And they were considerate enough to have it outside where if you love puppies, but your allergies don't, you don't have to worry too much.
yeah, that's true. But you should go see the puppies.
Unless you're
Everybody
like
loves
me
puppies.
and You're allergic to everything outdoors already.
Oh, well, let's not go outdoors then.
I'd be very happy if there was just a tunnel to connect us over to West as well.
Next time.
Okay, well, you suck then, because everybody else loves puppies.
Such as
Does anyone in the crowd not love puppies?
Is anybody here a cat person? Oh, we got one.
One hand, one hand.
We'll talk later.
It's harder to pet other people's cats, though, and walk away unscathed.
This just really went
We
completely off the rails.
Okay.
Okay, we're gonna bring this. I'm gonna try to bring this back. So we'll go back to the. Let's talk on the exhibit floor. Solutions change. Anything that jumped out at you guys? Have you walked around there? Had time to walk around?
Yes. NVMe over F, NVMe over Fabric. Some of those new vendors that are coming out to see where that storage space is going. Really, really neat technologies.
That was not the answer I was expecting. Anything for you?
I only got a glimpse during the welcome reception, so it was, you know, the zoo like it normally is. But there was an interesting vendor in kind of around the periphery that had sort of a hardened little unit that you could take and put inside EMS vehicles or other areas where your technology might be at risk, and be able to bring sort of like a little mobile data center with you. It's this little orange metal encased box, like a little tiny DC in a box. So that was quite interesting.
Okay. Sean?
I spent some time over in the VR and the AR labs at the back of the VMware booth there. That was really, really kind of interesting, and they're just starting to get into it. But they had some kind of demo set up that you like. Say you had to replace components in a server or something like that. They had set up the augmented reality lenses, the Magic Leap ones, so that it superimposed the images as you were looking at the server. So it like highlighted like, hey, here's a fan, and it showed you like exactly where in the server it would go and how to orient it and drop it in place. I mean, it's very rudimentary at this phase, but I see a lot of potential for this in the, basically in manufacturing or in the service fields. Like, think a managed colo, okay, where you're paying the colo provider to walk around, look for red lights, do disk swaps, stuff like that.
Yeah.
They could have these lenses on, which would like highlight the floor and tell them what cage they would need to go to, identify the disk that needs to be pulled and stuff like that, all using the AR glasses there. And I could see real world potentials out of this demo.
So I see a lot of reasons and things that could work for her. Here's my question. How does that relate to VMware?
Well,
where's it pulling the service data out?
That's where I was thinking.
Yeah, that's I wasn't trying to throw you under the bus on that question. I was seriously, I was like, that's awesome, but
no, and especially when we started to see some of the demos today in the keynote about the machine learning and the intelligence platforms and how they're pulling in all the telemetry data from the various things and they're automating it. And the ones that we saw in the keynote, they were automating literally changing settings to get your KPIs back up. Right. But one of them, was like a threat intelligence thing. And one of the things that it did besides, lock down the rogue process and everything like that was issue emails and Slack messages to the IT team to alert them on these things. So that platform could easily push this information out to someone who would be running around the data center there.
Okay. So let's jump into this morning. Pretty busy keynote.
Absolutely.
So Sean said his hand hurts from writing notes. Too fast, typing too much.
Oh yeah.
Carpal tunnel in the thumbs.
Photos.
So
maybe needs some puppy therapy.
See, if you do that, it will help. It strengthens the hands too. More petting.
Yes.
So, what jumped out at you in the demos? Any of you? Pick one.
Oh, geez, where to begin?
Well, I said pick one. That's where we're going to begin.
Well, like I was saying, that
the
some of the stuff that I saw was rather interesting. That whole threat intelligence automation piece there. So I don't want to make sure, because so many of these things happen so fast, I want to get the right product in there. There was an NSX intelligence platform that was monitoring the web traffic there. And it would then use Carbon Black as well to look at rogue processes. So the demo they had was all of a sudden they're seeing a spike in network traffic. And they looked and they figured out what servers were doing that using the network intelligence. Then Carbon Black was analyzing the servers and found a rogue Tomcat process. And so it went through and it locked it down, and it, you could see the traffic, subside there. And then again, it was issuing the tickets out, a Slack message to the IT team that says, hey, we've seen a suspicious process on here. So it's automating that stuff, because if this happens at 2 in the morning, I mean, even if you have someone on call, and a pager goes off, it's still an hour or so before someone gets into things.
Your own call team still has pagers?
Pager duty is very popular these days.
Huge deployment.
Yeah.
As we saw in the keynote from yesterday.
Pagers.
Yeah.
DAP was using PagerDuty as a huge platform.
PagerDuty, yes.
Yes. Pagers.
I want to see him walk around with a pager.
Physical pager.
An actual pager. Like,
well, the pagers still run on. A lot of them still run on satellite coverage. They have better range than cell phones.
And they'll still be around.
How many people in the audience have a pager? Anyone still have a pager? Do you even have a pager like in a drawer somewhere that you? A couple of you? Wow, you're old.
Are you a sysadmin? Yep.
Yes.
There you go.
Wow.
Yeah, and exactly. Healthcare especially.
Do you still have to carry it?
But
somebody on your team does?
Yes.
Well,
okay.
Who knew? I didn't. I wouldn't have guessed that anyone was still actually carrying a real pager. I was just giving him a hard time. Okay, wow. That threw me for a loop there. That was not what I was expecting. Mm-hmm. Anything in this morning's keynotes jumped out at you?
Well, along the lines of looking at some of what the Carbon Black technologies allow for, it was interesting seeing sort of that end user anomaly protection. So fictional Alice, if you're actually out there, you're not alone. Other people click phishing emails too. And having been in that situation where the security team shows up and says, we're taking your laptop, here's a loaner, like, what did I do? It'd be really nice in the future when the Workspace ONE and Carbon Black technologies work together to proactively deal with that, so I can hang on to my laptop, or at least it just disappears for a few moments rather than a week at a time. That's going to have a big impact on the end user space, especially where you've got really keen security departments.
Your turn.
Real-time cross-cloud provider vMotion. So that demo that was announced was really, really impressive.
Using the one between AWS and Azure, leveraging HCX.
Correct.
Yeah.
I don't know if we've branded that as an organization of what we're calling that, of vMotion Plus, vMotion Enterprise, but it was a very impressive one.
So then we went from a whole bunch of demos to a conversation. I thought the conversation was fun. you guys like?
He's a great interview. He just has that charisma to drive questions out of people.
I think you could tell that he had a relationship. It felt like they had a relationship with them on it. So what'd you guys think? I mean, a lot of times you come here, you want to see the announcements, you want to see the tech of it. The personal interview side of things isn't always what people. Some people are really happy because you get to hear it, you hear the celebrity, you hear the talk about it. Other people are like, great, that's not why I came here.
Right.
What'd you guys think? Which
I mean, it's
side of the
good
fence
that
do you
they-
land on?
That they break it up with something like this here. I mean, they've been doing it every year. Last year we had Malala up on stage. This year, Lindsey Vonn and Steve Young. I mean, I'm from.
No, you don't get to go there. Nobody, we're moving on.
We're gonna leave it at that.
We already know your answer.
The banter was good. The jokes were funny. It's definitely clear that they had, like you were saying, they had a relationship before. They know how each other is going to react, which made the whole thing flow very smoothly. I mean, they asked them at one point what the definition of HCI was, and they just blanked.
Yeah.
What'd you get? Which side of the fence? Good or bad?
It was nice to leave the keynote on a lighthearted note. Everyone walked out smiling. Personally, I miss sort of the more sciencey, here's some technical innovation keynote speakers they've had before. Sports isn't really my bag necessarily, but I do like that everyone got a good chuckle and it was a lighthearted approach to end the keynote with.
I thought maybe with the pro athletes, we would have seen more information about some of the tech behind sports nowadays.
Well, you're hoping to see skiing timers and stuff like that?
Like maybe talk about how it impacts their training or how how the tech has changed the way that they approach the game, the sport. I thought there would be more of that.
But they also have trainers for that, so let's get some of those trainers on stage and ask them how the tech works.
Yeah, I mean that would have been good too, except would you rather see Lindsay or her trainer?
Would you rather see Lindsay or her trainer? I don't want to answer that. Moving on.
Both at the same time. Have both of them up on stage because they're going to have.
I'm going to go with Lindsay. Sorry, you guys can be political. I'm gonna.
But to Dee's point, they're going to have two very different perspectives on the same thing.
Yeah.
And this way you can see both sides of it.
I just thought it would have been nice to have a little more tie to something tech to it. You can still have it.
With as much focus as there was from AI and ML today, with gathering that data.
Wait, was Lindsay an AI? Did I miss that?
That wasn't actually Lindsay.
Oh, yeah, that's what I thought.
It was weird though when they were like talking to each other and the clap seemed weird.
Yeah, it was a little off.
So we'll move on from the keynote here. Now we're into day 2.
Yeah.
You had some sessions you went to yesterday. Do you have plans for some today?
I'm show floor this afternoon. Solutions exchange.
What's your approach? If you're going to tell people the approach, how to attack the show floor. It's a big floor. How do you go about it? What's your approach to how do you see as much and learn as much as you can?
Start with existing vendors and work out from there.
So you go middle out?
Yes.
Oh, it's interesting. A lot of people do the opposite. A lot of people suggest doing the out-in.
Yeah, like the grocery store. You're supposed to go around the edges where produce and all the natural foods are, and then if you want to, you wander into the center of the grocery store where all the processed food is. So same on the show floor. As soon as you get closer to the middle, there's a little bit more marketecture and less actual tech.
A lot brighter lights too.
Probably.
So how do you approach? So you go in, you see these vendors. Obviously, you can walk around all you want. How do you get information out of those vendors that you're looking for? Do you wait? Do you just kind of stand there and wait for somebody to come up and start pitching you? Do you go and approach somebody, ask questions? Do you just work with what the hell do you do?
What's specific use case? Approach them with a specific use case. What are you trying to accomplish? How can your particular feature set accomplish my business goal? Challenge them with that. Walk in, don't let them start with a sales pitch. You have a business application or you have a business need. How is your product going to help me accomplish that? That's where I start.
Okay. And you start with the big vendors in the middle to do that.
Okay.
And then go out.
So
if you go into a vendor, do you go to vendors that you already use first?
So that's
and then ones that in your environment?
Yes, in my environment.
Okay. So do you often go see the competitors of the ones that are in your environment first?
Yeah, if I'm not seeing the answers that I need to out of those particular incumbent vendors, absolutely.
So they should be worried.
Maybe.
Good. Yeah. Keep them on their toes. How about you guys? What do you got planned for the day?
A couple of meetings and lunches with various groups as far as...
You have a couple of lunches?
Well, meetings and lunches.
Oh, okay.
Not a couple of lunches. But I think there are a few sessions. I mean, honestly, right now I'm present in the moment and I'm here, and I have to look at my schedule later.
That's fair.
Yeah.
That's fair. How about you, Sean? You got any sessions planned for today?
I'm going to actually try and attend a couple more of the breakout sessions today. Just a little bit more. I do want to do a vSAN deep dive on what the changes are, in the last update that they've had.
673?
Yeah. Just kind of the things that have changed a little bit in there. I'm hoping to spend actually a little bit more time here, like in the square, talking to people. I feel like I spent so much time walking around yesterday that I didn't get enough time to socialize and see what's going on in various people's lives. So I'm hoping to sit here, maybe work a little bit on a blog post.
Sit here, let people come to you?
Not necessarily come to me, but they're welcome to sit down next to me.
Anybody doing any hands-on labs? Are you planning any hands-on labs while you're here?
For me, they're usually, my approach is I know that a lot of the hands-on labs, if not most of them, will be available after. So if I find myself with a gap and I don't have somewhere else to go or people to talk to, then I'll consider going and sitting and taking hands-on labs. You also have to listen to your legs too, right? You do a lot of walking, and the hands-on labs are a great way to take a moment and sit down and still get to absorb some of the technology. Give yourself a bit of a physical break.
Yeah. I'm hoping to get there either today or tomorrow. I do want to do the VMware and AWS one just to refresh myself on it.
For that, that's one of those ones it's nice to be able to do because a lot of people don't have access to it outside of here. I mean, you might after the show, obviously, but it makes sense as hands-on lab. A lot of people don't have that in their lab or connections to it in their lab. You're shaking your head. You don't.
Even as a 30-day resource or to set yourself up in a trial, to have that ability on site, it's a great resource.
And even if you get that trial, you've got to have that time to get into it out of your day job. Yeah. Where here you do have a little bit of time outside of your
Plus you can put your
job.
hand up and say help if you actually encounter a problem, where if you're doing it later at home, you put your hand up and you're just sitting at your desk with your hand up.
So tonight there's a few events going on. I'm sure there's a company or two that you've talked to that may have an event. Plans for tonight that you care to share?
The expert party, I think that's an obvious one.
Yeah, the expert party.
You looking forward to that?
Yeah, of course. Yeah.
Some people
Get
are.
to mingle with a lot of the other vExpert folks and
So I said I've been one for 11 years. How long have you each been a vExpert?
This is my second year.
Yeah, year number 6.
Year number 5.
Okay, so you guys have been doing a few times.
Yeah.
Pretty new for you.
Yes, sir.
Why? What made you decide to try to become a vExpert?
So I was involved with the community way back in 2007, 2008, and then left and did a career change. Worked in steel production, oil field, natural gas services, and then made a career change again to come back to technology. And knew VMware was where I wanted to get back into because that's where my passion was when I left. And got introduced to the vExpert program and right back into it.
What 6 years ago, why? What were you doing?
I was fortunate enough to attend my first VMworld. That was the 2013 VMworld, the 10th anniversary one. And in the square of its day back then, it wasn't called the square, came across a booth about Cloud Cred and wondered what it was. So got involved with Cloud Cred, Cloud Credibility, which is sort of a gamification where it encourages you to go out and learn more about various VMware technologies and things, and you get points and what have you. And a bunch of the activities there were start a blog, get involved, and that led me to the the vExpert path. I haven't looked back.
I was on the social media team for EMC running a sister program for EMC then. So once I left that role from professional is when I decided to join the other organizations. I didn't want there to be a crossover.
Okay. And you have found value in the program?
Oh, absolutely. Without a doubt.
What's the biggest benefit you think of the program?
Being able to have a large resource pool of connections professionally and personally to whatever problem that you would come across, whether it's on internal network resources or professional development, the network to reach out to, those resources, that's by far the biggest.
That's a good answer. I like that answer.
Yeah.
How about you? What biggest benefit?
likewise, it's about the community and having access to those resources, but beyond the vExperts themselves, you actually find that there's a few extra inroads to vendors. Some of the vendors are in the vExpert community, some of the vendor representatives are vExperts. So being able to draw from those resources and have conversations with folks that are a little less formally structured. You're not sitting in a boardroom somewhere. If you don't have the opportunity to come to VMworld, it's a way to keep up with everyone and reach out and maintain those connections over time.
Sean?
I find that there's like strength in numbers here. There is a lot of people in the vExpert program now compared to years past, which means that there are a lot of knowledgeable resources out there for you to learn from. Chances are there is someone in here who has done already what you're looking to do. And I'm not saying like using it as, your own alternative to opening up a trouble ticket,
right,
but more for personal growth and development. There's, whether it's, learning a new technology, career help, something like that. It's such a large community, and a lot of people, I feel like you get out of it what you put into it. The more active you are in the community, the more you are going to get from it.
Good. So I'm going to open up. So I have a tile for somebody. Who has a question for the panel? None of you have a question? Seriously? Nobody can come up with one question, or you just not want the tile?
Steve has a question.
What was the thing you saw this morning that was most exciting?
Well, for me, this morning's keynote was more about, okay, yesterday we saw all the all of the ingredients. I spoiled it. All the ingredients being brought out, all the new announcements. And today it was like that old Julia Child's cooking show. They pulled out some examples where here's the ready-made turkey. We took all the things that were announced on Monday, and here's what you can actually do with them. So that, to me, is always a really interesting way to see how all of the announcements converge and can potentially turn into a practical solution that people can get value from.
Did anybody notice that VMware has a new CTO today?
How about it?
Yeah.
So Greg is in there. Ray is going to go head up the the whole cloud development piece there, and now Greg is going to be in as our new CTO. So he was up on stage, and Pat came up modeling the T-shirt there.
Tanzu tees.
Yeah, the Tanzu T-shirt. And then introduced to Greg as VMware's new CTO. I'm assuming effective immediately.
I think if they do it on a big stage like that, it's pretty set.
It's probably,
I think it would be weird otherwise, because if they decide not to now, it's awkward. There's video.
Yeah. So that was good, because it shows growth and everything like that within the company, and that you can go from various roles within there and still be a part of the future of the company as well.
Okay, to you.
The evolution of where we're at now with ESX on ARM that was announced last year, and now we're actually seeing it more in a production environment and where it's going to be used on the edge. Again, more of that theme today that we saw of AI and ML and how all of these data points are now being turned into useful, actionable items.
I would agree on that. I think last year that was exciting to see them actually do something with it. I think was that you're seeing it come to fruition is nice. It had a lot of potential. They got to do something with it. So I thought that was cool.
And today I learned about SmartNICs. Who knew that was a thing?
Yeah.
Okay, well, I think we're going to go ahead and wrap this up. So thank you all for coming. Thank you guys again for another great vExpert Daily up here. And there's a whole lot more going on the rest of the day up on the BrownBag stage here. So stick around, see some other panels, and thank you all. Have a great rest of the show. See you tomorrow.
Welcome back to the VMware Community Roundtable Tech Talks powered by vBrownBag. First vBrownBag Tech Talk of the show. Thank you everyone in the audience for joining me today. Thank you everyone online for joining me as well. My name's Tony Foster. I'm a technical marketing engineer at Dell EMC, and today we're talking about VDI by day and compute by night. So really interesting concept, and let's go ahead and get started rolling right with that, because there's a lot to cover in 12 minutes. So this will be a high-level overview for the entire topic. And let me tell you, it's coming. That new project, your CEO or CXO, whatever the case might be, came to you and said, hey, guess what? We're going to do AI. You are going to be in charge of setting it up so that we can start mining customer data or whatever the case might be. But the budget's tight. We're spending $500,000, $1 million, whatever the case might be on these data scientists. So you only have a little bit of budget that you get to play with to actually build the infrastructure they need. What's the thrifty admin to do? Well, let's start out with the basics. First, you're going to make a plan and figure out what you need. You're going to work with your data scientist and all the teams that are working on your big data and everything that these different groups are going to be touching. You're going to make that strategy. Then you're going to build an AI infrastructure. And I'm not going to get into how you build that AI infrastructure, but you're going to build that AI infrastructure, even if it's only a small AI infrastructure. And lastly, you're going to enhance that with spare resources. Spare resources from within your environment. And you're probably going, what spare resources? Let's take a look at your VDI environment. Here's a rough curve of what many people's VDI environment utilization looks like for a typical day, Monday through Friday. You see that down at the bottom of the graph, from 1 a.m. all the way to about 7, it's fairly low. About 3 hosts are in use to provide the virtual desktops that people need. Then it spikes up, is pretty high throughout the day, and then it drops back down. And you can see the table there with the active host and everything in play. Well, that also means you've got a bunch of idle hosts during those times. So we've got that represented here on that orange line. 22 hosts just sitting idle over the night. You can really gain some powerful cycles, especially when you consider that each one of those hosts can probably hold 3 or more GPUs. That's 66 GPUs sitting idle in your environment. Why not gather those resources? Why not pull those in and make those something to extend your AI infrastructure on? So let's dig into how you can actually do that. So I actually came up with a fairly simple approach. This is actually the flow chart that I use for some scripts that we're going to talk about here in a few minutes. Basically, if there are spare resources, let's let our AI workloads consume those resources. And if there aren't spare resources, let's start suspending, and suspending is an important idea here, suspending our AI workloads and letting VDI or whatever other areas that we're harvesting from have those resources back so that they can continue to function like we expect them to. And the whole plan of that is to maintain a steady state throughout the environment. So once we can do that, then we can make it repeatable and just put it in a while loop and let it sit there and run continuously in our environment so that we can pull resources in and out as we need them. So it's going to look something like this. We've got an imbalance here. VDI keeps growing. Our compute resources shrink down. It gets to a balanced state. Life is good. Then as we continue going, all of a sudden VDI is shrinking throughout the evening hours. Our compute, let that grow up and start consuming those resources. Start pulling those GPUs in and running those projects. Giving our AI additional resources, giving our data scientists the ability to really expand their capabilities at night and possibly get more done, driving more value for the company. So that all sounds really simple, I'm sure. There are some caveats people need to be aware of with this. So here we have 2 scenarios that are really important to think about when you're doing this. With NVIDIA virtual GPUs, which is what I do in the script, you can't mix vGPU profiles. Basically, the virtual graphics card that you provide to your virtual machine. So for example here, I have two T4 4Cs. Those two are perfectly fine on a single GPU. But if I try and start a T4 8Q profiled virtual machine on that vGPU or on that physical GPU, it's actually going to fail. So we can't mix those. So you've got to put some logic in there to pay attention to where you're starting virtual machines. Now, one of the cool things that is in vSphere now is the ability to do vMotion with your virtual machines that have vGPUs in them. So you can start figuring out and consolidating your loads onto a given set of hosts, and then not have to worry about, am I going to be mixing profiles? So it becomes a very powerful tool for people. The other part is vGPUs lock a slot on the GPU when they're powered on. So even if you have a machine that's powered on and it's not doing anything, it's going to consume a slot, so you can't get those resources back. That's where the suspend comes into play, which I mentioned was important earlier. You can suspend a VM that has a running GPU in it. That means you can suspend virtual desktops if need be, or shut them down, especially if they're automatically composed for you. And you can also suspend your AI and machine learning workloads. So you can go through, suspend them, release the GPU resources back so that your VMs come in, or your VDI comes in and consumes those resources. And when they come back online, when they are resumed, you can go in and actually grab hold of right where you left off and not have to kill jobs, not have failed jobs in your AI environment or your ML or DL or HPC environment. Lots of power comes with this. So those are the two things that really stand out that you need to be aware of, and the two advantages that go along with them. So you're probably wondering at this point, what methods do we have to do this? A lot of data scientists like Slurm, and there's a great presentation on using Slurm to do VDI by day and compute by night, and the link is right there, wondernerd.me, VDI by day, compute by night. You can go there and watch this wonderful presentation that was done with VMware and NVIDIA at the GPU Tech Conference earlier this year. The other option, the option I've done and made publicly available, is to do it with PowerCLI. PowerCLI, most everybody in the space is familiar with PowerCLI and how it works. It's a free software tool that comes with vSphere, so you can go in and do this however you want. You can go in and modify my code and knock yourself out. And that gets us to really the approach I took with this. So I did this in a two-phase approach on PowerCLI. I went through and built a control plane that does all of the logic, if this is busy, release. If not, go ahead and power up another machine. Otherwise, it's in a stable state and life is good. Just keep looping and wait until my state changes. What I use to do the state is actually a capacity function. So there is a capacity function that sits there and looks at your environment, queries how many GPUs you have in your environment, how many hosts, and calculates the total number of slots, and then says this is the spare capacity with this vGPU configuration. And you can see that formula right there on the bottom, and it's actually a little more complex than that. So because I don't have a whole lot of time, I'm not going to actually delve deep into the script, but you can actually go out, pull down the script from my blog. So script is out there. You can go to the GitHubs and pull all the code and everything. I try and keep it updated. It's a little out of date right now, so there should be an update coming for it shortly after VMworld this year that'll add the T4s and some of the exciting things that have been announced or will be announced. So that is where you can get your hands on this, and you can actually play with this in your own environment, try it out, and do tweaking and stuff. It's all documented there in the details. One last thing to really wrap this up is you can't forget about the licensing though. So first off, you have to license your vGPUs correctly. You can use the Q series and C series. That is typically what you will see in this space. The Q series is a new series from NVIDIA that is focused on the compute workloads. And if you go by the NVIDIA booth today, they actually have some really cool stuff associated with this. And the other thing is vSphere licensing. So VDI has a special license where you don't license the ESXi host. You license based on the number of concurrent users. Because of that, they have very specific instructions about what your workloads can be. So you want to make sure that you're following those specific requirements on what you can use. VMware vSphere Scale-Out is one option for that. So I'm getting the thumb to go. So here's a wrap-up of really what it does. We're going back and forth as things move. Be sure to catch these VMworld sessions throughout the week. They're really important and really have good tie-ins to this. And if you have questions, catch me after the end of the session. I'm happy to answer them. Or you can catch me on Twitter, Facebook, or wherever else Wonder Nerds are found.
Good afternoon, everybody. My name is Nathan Ness. I'm a senior staff SE on the Kubernetes team at VMware. And today I'm going to talk about Git, or version control for infrastructure, right? So a lot of people use standardized tools like Terraform or Ansible, and if you want to track those changes, you would use something like GitHub or GitLab or some type of version control system. And so I'm just going to go over the kind of the introductory basics and very common Git commands to use just to kind of version your infrastructure as code as you progress down this. So what is it? It's a distributed version control. It allows the coordination of work between different developers or different platform operators or infrastructure teams that can collaborate and commit and not step on each other's toes as far as what's happening within a single source control repository. You can revert back at any time, so if you make a change, it's obviously self-documenting by the bare nature of committing the code and creating these snapshots. And you can use either this on local or local and remote repositories. So you don't need an internet connection to use Git, you just need to install it. You can have all of your repos be completely local if you want. You don't have to push them out to a remote repository, even though if you're collaborating with other folks on your team, then you would use a remote repository to push and make sure that you're not stepping on each other's toes and have that single source of truth stored in some remote location. So it keeps track of code. Like I said, we can create these snapshots in time at any point that you want by making a commit. And that will just basically take whatever's in that commit message and create that snapshot, which allows you to, again, then to revert back at any time, look at the changes that were made from an auditing perspective, and you can also stage the files prior to committing and show like a difference. So you can see what's attempted to be committed, what the changes are before you commit them to your head repository or working space. So kind of the benefits, you never lose your work. It's always tracked. You always get this great history. You get blamed for bugs, right? It's built into it. So you can see like who did what and why did the system go down or up, or impacting new features without impacting production with the use of branching, which we'll go over. And collaboration, right? The ability to work as a team into like a single repository or a single branch and have all of that being tracked. And again, without the stepping on each other's toes is huge, right? If you guys are doing duplicating work and try to push that to a remote repository, you're going to see a conflict there, and you can resolve that conflict on, all right, who's right, and merge that in safely. For the managers, you get documentation, right? I mean, everyone, I think, requires this, even though it's probably the last thing that's talked about or even discussed. You know, it's never documented properly. Version control is documentation by nature. So I'm a huge fan of things like Terraform and CI/CD and driving infrastructure through code because you can tell the exact way that the underlying system was provisioned and was installed. Because that file, whatever it is, whether it's a Terraform file or whether it's a parameters file in a CI/CD pipeline, that's exactly how the end system was provisioned. And so you kind of have that single source of truth as long as you remain on that track and don't do any like out-of-band changes, right? So unless you're doing something out-of-band, you're always going to have that documented system, right? So for new team members, maybe someone left, they can actually just go back to the repo and see exactly how everything has been provisioned. They may have to get used to a new tool set, but at least within that tool set, everything is documented. Progress tracking, so you can see, you know, who's doing what and when. Obviously, with every commit, you can kind of see a graph. GitHub graphs it for you around how much you're committing, the number of commits that you're making a day, and kind of gives you this nice progress around what's being done. It's super easy to get started with it. Like I said, you don't even have to have a GitHub or a GitLab account. You can do everything locally if you want. It's not very common. But on a Mac, you can just say brew install git, Ubuntu, apt-get, Red Hat, CentOS, or yum. And then on a Windows box, you SSH into Linux or a Mac, and then do what's above. I'm just kidding. Obviously, Windows supports Git as well. So let's kind of talk through the workflows of Git. And again, I'm going to talk about 1% of Git, but it's absolutely the most common commands that I use personally in my lab environment and with customers as well. So on a local computer, when you actually create a repository, this is actually what's being created kind of under the covers. So you don't necessarily see these folders minus the working directory. And so then also, when you create or when you want to push into a remote repo, then you can actually create the remote repository as well or sync with what's on your local computer. But essentially, there's these three spaces. The working directory is what you're changing code in as well. There's an index that acts as just that. It's just a staging environment, and we'll get through what commands actually add into the staging environment. And then head is where your last commit is stored. Right? Like I said, the only thing that you're probably going to interact with, you don't really see index, you don't really see head, you're just going to interact with the working directory in the workspace, typically. Okay. So to check out one, most of you, if you've used Git in the past, you've probably done this and like cloned a repo, right? So I can say git clone, which is going to basically grab the remote repository and then clone it into your working space. So that allows you to work on it locally on your laptop. And then also if you own that repository remotely, you can also work on it locally and then push back up into the remote repo to push all your changes. So to create a local repository, if I want to create this local repo, I can just say git init. And in this particular case, I'm creating a repository called network profiles. And this will create that directory structure. So if you look at that saying git init, this is on my local laptop here. It's actually going to create a directory called network profile and initialize that repo with those three spaces. Okay? So as we're adding files to the network profiles repo, when you start adding files, they go into basically what's called an untracked state, meaning you're not tracking them in underneath version control. You actually have to add the files to Git in order for Git to track them. Okay, so after they've been added, then you can do your commit, and you can attach a message to it, like, hey, this is the change I'm doing, some very small message that says changing network profiles, adding a load balancer, so on and so forth. Whatever type of code that you're tracking, just put in a simple change message to kind of go through like an audit around, maybe it's tied to a particular change request in your CMDB. You could add that into the commit message as well. And then obviously, if we do want to push that remotely, we can push it to the remote repository, right? So it's as simple as that. Is when I do a git add, it adds it into index. When I do a git commit, that puts it into head, right? And then when I do a git push, it's going to push those local changes to that remote repo. And you repeat that workflow over and over. So the kind of the goal here is to make a lot of smaller commits, not necessarily do a whole bunch of changes and then do one massive commit, because it's going to be really hard to try and, let's say you're testing something and it's not working. So you'll want to test something, commit it, try the code out. If it works, great. If it doesn't, then you can repeat this process again, right? But the goal is not to make a whole bunch of changes and then make this massive commit into the repo. It's certainly allowed. You can make these snapshots whenever you want, but the more snapshots you have, the easier it is to roll back to a known good state. And we can talk about branching here in a second to even be more safe in this regard. So when we add files, right, we create these files, and here I'm creating a README file, right? It's just going to be basic documentation for the repo. Basically, every repository has a readme.md, which explains the repository's purpose. But when I create the file and say git status, you can see that README is not being tracked. So I actually do have to add it into a track state for Git, and it's a simple git add command. So I can git add particular files and cherry pick them, or I can say git add dot, and that will add every file in that directory to be tracked. And now you can see that I can say git status again, and you can see that I have a new file that's going to be tracked underneath my Git repository. And that's going to add it to the index, so kind of that middle layer there. Okay. So now that it's in index, I need to commit it, and again, that committing it is going to make that particular snapshot with a message, right? So again, we can just say git commit, add a message, which is saying, hey, I added a README file, all right? Which will then push those changes and make that snapshot in time and put them into head, all right? Creating the remote repository, there's several ways to do this. I can either do it via the CLI, via like a curl command, which is using GitHub's API, or I can just go more simply and go to github.com, log in, and say I want a new repository, and you can initialize it with whatever you want. I should note, like, there's some files that you don't want to be tracked, right? So there's some, like for instance, if you use Terraform in your environment, you don't want to track TF state. It's typically not a file that is tracked, or TF state backup. So GitHub allows you to create what's called a git ignore file inside your repo, and it will always ignore that type of file. So I don't have to cherry pick. So I can say git add dot, which is going to add all of them, but it will ignore the ones that you've specified in your git ignore file. And there's many examples of this around, like, hey, maybe there's a secrets file or a passwords file that I don't want to add as well. You could add that into your git ignore file. Obviously, you don't want any type of passwords going into version control. And there's other methods of abstracting those as well, right? You can use things like Vault from HashiCorp as well to say, like, just because it's inside the version control, it's just pointing to a secret in Vault, right? So when we push it, obviously it's going to push that to the remote repo. And again, just because I added this to locally, when I initialized this locally, not from GitHub, I actually need to set the origin. And so when I created a repo or initialized the repo, everything is going to be tracked as on the master branch, it's called. And it's the default branch when you create every repo. It's the only branch unless you branch out. which we can talk about here shortly. Okay. But once I have that, I can push, and it will push all of my files that are currently in head to master. Okay. And it'll sync that up. So now I have a sync between what's locally in my working directory and in head to my remote repo. So what if I have this production system that's using the master branch? I have this tree that's going along, and all of those little blue dots are commits, and that's running fine. But now let's say I want to add a new feature. Right, so maybe I want to add a different load balancing feature to network profiles, or I want to add some more code to a Terraform template. I can actually create a branch and not disrupt master. Because if people are actively using master for their workflow and I'm trying to do something new, I can actually just create a new branch, which is going to take the snapshot of wherever I choose, and then I can start working on the new feature without disrupting what's actually running in master, right? So all they are is pointers to whatever commit that you branch off of, which allows me to work independently of what's happening inside the master branch. To do this, you can say get checkout -b whatever branch that you want to create there, and then when you say get branch, you can see what branches are available to you. To go back to master, you can say get checkout master, right? And so that will put your working directory into that particular branch, right? And then I can actually set my pushes to load balancer test instead of master. So now when I'm making commits and adding additional features or additional files, now I'm actually going to push into the load balancer test branch. Okay. So when I do a get pull, I can update and merge from my remote repository. Let's say other team members have been doing work inside that repo, and I want to catch up to what they're doing so I don't step on their toes as well. So I can actually do a get pull, and it'll actually pull all the changes remotely and update my last commit and my working directory to all the changes that have been taking place, right? And so it will show you which files have been changed. You can actually do a command that says what is actually changed in the files, but it'll kind of show you, just give you a little graphical layout of what files have been added, changes to those particular files, and then it'll actually create those files in your working directory and update your head as far as the commit. So this is actually going to pull and fetch down all the remote changes and put it into your working directory. So get fetch is used again to fetch the changes, but it doesn't actually merge them into head. It's just going to fetch them, and you can also merge them as well. It's not very common to use that. Most of the time I just use get pull to catch up what's happening remotely. And then I can set my local changes up and start creating and adding additional changes as well. So adding code to the different branch, we talked about it a little bit, but again, I can start adding different files. There's a pretty cool Git extension. So as you see, like as I'm changing and modifying files, my command line actually prompts change. So you can see, like when I created the load balancer test directory, I have load balancer test, everything's green, so that means I'm caught up with master. But then when I start adding files, like I added a JSON for a small load balancer. So then I see that I actually have changes that need to be added and committed. So now when I created that file, I added it in. So that's great that I added it, but now it's just waiting for me to commit it. And so when I commit the file, I just say I'm adding a small load balancer profile to the repository. Then that commit message aligns me with head, which actually puts my prompt back to everything's good again, right? So it gives me a very nice local, quick reference of where I'm at within the repo, whether I'm caught up or whether I need to add something, or whether I need to commit something. Okay, and then I can push it into the remote repo, or set my origin to that branch of load balancer test, and then push it in there, which will push the small load balancer JSON file into the load balancer test branch. So let's say now I want to merge that, right? Everything, all the changes were good. I can say, hey, this load balancer test branch worked out fine, and now I want to merge that back into master. And it's as simple as git merge load balancer test, and that will merge this branch into master. The load balancer test branch will not go away. It'll remain there. You can always go back to it. You can always switch branches to continue, adding features to that, and then merging them back in as well. So here I have the master branch. I checked it out, but then when I do the git merge, then it's going to basically align those commit messages. And when it does this, it's actually going to look for conflict. So if there's conflicts in my master branch that are conflicting with what I'm trying to merge, it's going to show you that and say like, hey, there's an error, and this is where you need to look because this is a conflict between the master, which is great, right? Because now I can see like, if I'm going to step on someone's toes, who's right, who's wrong. You can talk through that and collaborate around like, hey, should we merge this or should we just merge part of it? Again, very simple workflows, but allows just the complete tracking and history of work being done. So replacing local changes, everyone makes mistakes locally. So sometimes you got to pull from what's in the remote repo. And you can do this locally by get checkout file name. So if I screwed up my load balancer, small load balancer profile, I could say get checkout that JSON file, and that will replace what's in head back into my working directory space, which is fantastic. So kind of reverting back work. Yes? Yeah. Yeah, you can. So typically what you would do in that regard is you would do a get pull, which will pull down all of the changes, typically in the remote repository, right? Or if you haven't done any work locally yet, then you could do a get clone and clone that entire repo down. But if you already have it locally and you want to catch up on all changes that have been committed, then you would typically do a get pull. Okay. Yep. So replacing local changes from a remote repository. Let's say you really screwed up your local workspace and you actually have to pull from the remote repo. You can actually pull remotely with the get fetch origin, and then you can reset your working directory with what's in master or whatever branch you're using, right? If it was origin load balancer test, then you could replace those local changes. If it's just on the master branch, you could replace those changes and pull down what's locally if you've screwed up everything locally. So this is probably the picture slide here because it kind of illustrates the entire Git workflow. But again, creating a repository creates these working spaces. Doing a git add adds the local files to be in a tracked state and puts them in a staging area. Doing a git commit is going to add them into head and create this snapshot in time around what is in that particular commit. You tie a message to it, giving it a simple name of like a change log. If I want to push, I'm going to push it into a remote repository with a git push. And then again, if I'm doing a git pull, I can sync down my remote changes to update my latest commit and my working space or my working directory. And then finally, a git clone. If I want to pull down the entire repo and I don't have it locally, will update everything, right? And so these are the very common commands. Yes?
At what point would a file stay in the staging, not be committed? Every time I've looked at Git, there's always a git add, immediately followed by git commit.
Yeah, totally. Oh, sorry. Yeah. So the question was, when would the file stay in staging? Why would you just do a git add and never do a git commit? And that's typically never. Like it's always that way. Like a lot of times, if they're not in a tracked state, I need to add them and then commit. I don't have to add them again. Once they're tracked, they're tracked. So it's only kind of a one-time thing that they need to be added. Because after that, then you can just do commits, add a message, and done. So they're very rarely long-lived in index because at some point you are going to want to make a commit and utilize version control to that. It's not clicking save. I would say like it's to track it. It's to start tracking that file underneath it. So I would say the save is more on the commit message where, yeah, the commit is actually the save and the snapshot in time. And there's some files, like if I have a lot of files in my working directory, I might not want to add all of them into my index. So that's the purpose of add in the beginning, unless I want to add all of those files into a .git ignore file, which is probably not the case, right? So any other, yes, sorry.
So what happens if you have an entire folder structure? You start by adding it all at one point.
Mm-hmm.
You're doing a bunch of work and you decide, no, I want to move files and move it around and so on and so forth.
Mm-hmm.
How do you deal with that? Is there a way to be able to say, just get caught up with all the changes that are made?
Yeah. Yeah, if like initially when you start off and maybe you already have a huge file subset folder system that you want, you can dump all those in there. And typically I git add however many I want, maybe it's all of them, and do a git commit, and it's just I put my commit message as initial commit, just to get the file structure up there. But if you do change it, and if you do make a lot of changes without committing, then your git commit message is going to be really large. Like if you're moving files around and changing a bunch of different things, all of those are not going to be in a commit message unless you do commits as you're kind of going through.
My question was more about, is Git smart enough to realize that the moving file?
Yes. Yes, it is. Yep.
Hey, thanks guys for showing up today. This is my story on automating VDI and kind of what I've done to cut down on some of my daily mundane tasks. I'm Chris Hildebrandt. Marketing got a hold of my title. I work for a large pharmaceutical company. vExpert, EUC champion, blah, blah. My blog, GitHub. Everything I'm talking about today is on the GitHub. So realistically, why do you look at automating things? It's extremely fast, it's reliable, it's repeatable. You can keep reusing it over and over again. You can enhance your logging, reporting, and maybe eventually you can automate yourself out of a job into a better job. So who's here has automated any parts of VDI, from image creation, going on forth like that, optimizing stuff? Good. So that means the rest of you do stuff like a normal pick worker where you're just walking up, picking orders, where for me, I wanted to do something more like Amazon. Just sit back, watch it go, pretend like I'm actually doing something from day to day, still magically get paid. Stepping back, we looked at our processes, what we were doing, how we were doing them, and what took the most amount of time, and what realistically was the most time savings we could come up with the least amount of effort into automating. So that way we could step in and continually automate other things on top of that. From master image creation, which you don't do very often, the update and refresh cycle. I know everybody spends a massive amount of time doing that. For us, updating Horizon environment, depending on what your rules and regulations are, that takes quite a bit of time, especially to test. Creating app stacks, updating app stacks, so on and so forth. So the first one we chose to tackle was update and refresh cycles. So looking at a realistic method, saying it takes 2 people 2 months to update 50 pools 6 times a year. That's on top of your daily work and stuff and going on that realm. Basically, it's a hand-checked list. You occasionally run into missteps. You have your little checkbox saying, hey, I updated a job on this image. I think I updated it on this image, so I'm just going to go ahead and check it because I don't want to go back and then go on and then come find out you deploy it and you missed the update on Java, and now you've got a ticket, and you have to fight through them. Go back, re-image, refresh, blah, blah, you're wasting more time. So what we looked at is, creating a plan. Setting down, laying down what you're doing, what's going on, how it works, where it's coming from. Why do you need to do this? Why do you need to do that? Does it really need to be that way? What tools do you already have in your environment to help you through this? Do you guys have like Kubernetes, or you're using something like Jenkins to automate some other stuff on the back end? What other tool sets do you have available to you, like SCCM? And then if you need any additional tools, just sitting there looking at it. Again, think outside the box. We threw together a plan, kind of rough, or I threw together a plan, kind of rough. Coded some things, basically wrote things out in PowerShell, and just basically set some places where I knew what I could do, what I couldn't do. So I kind of outlined some stuff, realized that there are some bad things. You can set one-time logons. I don't know if you guys knew this, but this was one of my bad ideas. When you set the default password in registry for a one-time logon, because that's how we were trying to do a refresh cycle, it stores it in plain text. So, bad thing. Didn't realize that until after I tried it once or twice, and I was looking through the registry, and I'm like, oops. So, don't be afraid to fail. Talk about it. I mean, that's how everybody learns. And it's the reason why it's in here. So, scrap plan A. Go to plan B. Just go back, look through things, look at, does it really have to be that way? And I mean, seriously, look, don't be afraid of change. There are so many people that are scared. Just kind of brace it and go on, because automation is completely changing how you're doing your job. It's making it more efficient, so that way you can stand up and do other things. So, your standard update process. So most people have, you power on your image, you install Windows updates, you reboot the VM, of course you install more updates, because you can't do it all in one round. So, and then reboot again, install your third-party stuff, reboot again. Like if you're running Symantec, you run your SEP prep tool, run VMware Optimizer, defrag. We use customer edge keys, so we'd update our customer edge keys saying, hey, we updated this image on this date. Disk cleanup, disable SCCM services, update vCenter notes, same thing, just that way we knew where it was when it was updated. Power down your VM, take a snapshot, recompose pool, update your fun spreadsheet, and hope and pray that you actually did everything you said you did. So, looking at automation for this. So you're pondering what's going on. How do you update Windows? How do you automate updating Windows? How do you update, third-party applications? How do you cut down on, of course, the time to do this? How do you cut down on your wasted time from tickets, human errors, all that great fun stuff? So for me, this is kind of my answer. We chose to use SCCM. Most places have it in place now. You can use SCCM to push your updates. By leaving your VM powered on, you can automatically push updates to it. Your master image, leave it powered on. You can push updates to it via that way. It'll auto reboot when it's needed to, depending on how your deployments are set up. Same way with third-party applications. So any image or any software that we install on our master image comes from SCCM, and then we do forced updates. So we do it to that collection alone. So that way, when there's Adobe out there, it auto refreshes or auto pushes. And then the other part of this is literally automating the entire process. So I wrote a PowerShell script to do every bit of this. So from starting the script, we would create a ServiceNow incident, create a ServiceNow change. We'd start with a powered on image. So as I'm telling you, leave it on or turn it back on after you recompose. It'll make an API call to install the Microsoft updates if they weren't already installed. Install the third-party applications if they weren't already installed. It'll check to see if there's any up. Reboot the VM. Run the SEP prep tool. Run optimizer. Run defrag. Update custom reg keys. Disk cleanup. Disable SCCM services because you've got to disable that. There is a very good reason. It will actually, for like link clones, it will create a computer object every time a new VM is created. So you can fill up the SCCM database. Made that mistake once, so fair warning. Update vCenter nodes, power down the VM, take a snapshot, power back on the master because I want it to update faster the next time around. Recompose the pool, and then turn back on the SCCM services and the Nest Essential services for updating things on the back end. So that way when updates come available, it auto installs. Cuts down on the time for the script to run. Realistically, the script takes on average about 18 to 25 minutes per master to run. You can let it run like we more or less run it on Sundays. So updates on Sundays, recomposes on Sunday for a prod pool, and then updates, or it does a second update on Tuesday night. And that's how we're literally updating every week. Just kind of showing some of the completion status of the way things work. As we're showing it's publishing, this is completely 100% automated. For us, we're using custom nodes, tags, and also custom reg keys. They all match. So we can follow it within the image, tag it, however we need to do it, search it, find it, anything we can. So that way if it gets orphaned somewhere, we know when it was updated, when it was created, how it was ran through. So savings. It has saved so much inconsistencies. No more missed updates because we don't have the guesstimation of the human error. Creating log files that are uploaded into ServiceNow. So the entire running process, so every single command that's ran is actually logged and put into ServiceNow so that way you can go back and prove what changes you made versus your spreadsheet where you say you did something, but you probably didn't somewhere. Not saying that you would miss everything, but there's always something you miss. Pool refreshes are literally a scheduled task. And I see refresh because this works on both link clone and insta clones. Right now on Horizon or on Windows 7 and Windows 10. So basically you go down from 2 full-time or no more checklists. Now the big thing is instead of 24 tickets, we're getting an average of half a ticket or a ticket every other refresh cycle for just something stupid that, hey, we installed a Excel patch and it broke some stupid add-on, something weird like that, which is really hard to test for because it's like one person that actually uses it. We got to do some math, so you guys can read through this, but basically if you kind of lay out how things are going, you're saving a massive amount of time going through it. Just in unplanned hours, you're 60 plus unplanned hours due to tickets and random other stuff. Going down to 2.5 hours for unplanned outage. Realistically, I mean, you're about 945 hours saved a year. Now, if you go from 6 updates a year to 52, where you're starting to update weekly, you're realistically at 6,070 or 6,370 hours saved, flat out. That's if you literally watch the script run. If you don't want to watch it run and just let it run as a scheduled task and just carry on your day, almost 10,000 hours a year saved on 50 pools. Just figuring as you're running through things. It's just works phenomenally well. Man, I think I left out a slide or two. So other ways you can look at this, there's the VCheck for Horizon. I don't know if you guys have ever used it, played through it. It is literally the easiest little tool to compare what's going on. There is coming an as-built for Horizon. If you guys have heard what an as-built report is, basically it's every environment variable that you could have for like vCenter right now. I'm actually writing the one for Horizon. So you'll be able to run a PowerShell script that'll grab every single setting that you have in Horizon, throw it in a Word document that you can turn it in and hand to your boss and say, hey, this is every setting that you have set. You know, from every connection server, every little setting that's set within a pool, from the naming convention and on. A guy by the name of Chris Twist created a script on how to create app stacks. This is the old API model. There is actually an updated API model. I haven't had a chance to play with it much, but that's one of the next things on my list is automating app stack creations. Image builds. I think I left out that slide by accident, so I apologize. So I've been working with Packer.io as a home. Packer.io is a phenomenal tool, especially for building images. I am also about 95% done with, which I should be posting here in a couple weeks on my GitHub, is automation from Pixie Boots. So creating master images from a Pixie from Software Center or from SCCM, doing an image load built on task sequence, hitting the F12 key to do the Pixie boot from within the console, logging into it, running it all completely through, doing all the customization on the back end, so that way it's literally ready to throw into a pool. If you have anything extra, yeah, you'll have to tweak it to meet your guys' needs, but the framework's there. Another big thing is building insta-clones. You know, if you guys have ever literally looked at the API, it is one line of code to create an insta-clone pool. Yes, there's a lot of attributes off the back end, I'm not gonna lie, but it is literally one line of code to create an insta-clone pool. It is a lot quicker than clicking through the GUI, massively quicker than clicking through the GUI. So questions, comments, try to keep them short, concise. I would show a demo, but it takes forever. You know, like I said, it takes 18 to 25 minutes to run. I didn't want to just sit here, hey, you can watch this screen go by. Looks fancy. Yep, it starts, right now it's doing it sequentially, so it's doing one pool at a time, or one master image at a time. So it'll run through, update one master image, start the next one. I did start playing with doing, splitting it up so that we would once. I ran into some problems with some duplicate variables causing some problems within the script because of how it was feeding stuff back, because we're using PS Remote to connect into the master images. And as it's passing commands back, or the information back into the master, or into the scripting server, it was causing problems and dropping off, and I haven't honestly, I haven't had enough time to sit there and figure out how to fix it. But it's on my to-do list is to create it so that way you can set how many schedule or how many. I want to set it so that way you can at least run 4 simultaneous at a time. So that way you're not killing everything, because it is actually running fairly quick. But if not, all right, thanks everybody.
Good afternoon. My name is Caio Oliveira. I'm from Brazil. I'm part of the VMware Cloud on AWS team. And today I will be talking about integrating VMware Cloud on AWS with VMware vRealize Automation and Cloud Automation Services. Better, integrating VMC with VRA and CAS, right? So I'll be using the terms VMC, VRA, and CAS during the presentations, right? So my plan here during this session is to guide you through a little recap about VMware Cloud on AWS. Then I go through how is the integration between VRA and VMC, and then the integration with VRA, with CAS and VMC. Okay? So let's go. A quick recap on VMC. So this is a joint engineered solution between VMware and AWS to deliver the best of both worlds to our customers, right? What are the main benefits here, right? The first one, we are delivering the SDDC, our soft-defined data center, as a service on AWS infrastructure, right? First point, we will have the same technology, so the consistency and the familiarity between the technology are the same. Also, I can easily migrate the workloads to have hybrid capabilities, so I can do a vMotion from my data center to VMC and also return this workload if I need as well. But this is not only a hybrid solution with VMware technology. We are enabling customers to have a direct access from the workloads that are running on VMware Cloud and AWS with native AWS services, right? And here you can leverage or use your traditional workloads or even your new workloads in VMC and consuming AWS services, right? So what we have in VMware Cloud and AWS, we have our three main products, 3 main solutions. Is vSphere, that creates an abstraction of the compute, vSAN for the abstraction of the storage layer, and NSX doing the abstraction of networking and security. Okay, this delivered as a service on AWS. Okay, what's the architecture of this solution? To create a hybrid solution, the minimum requirements is that on my data center, I should have vSphere and vSAN. vSphere and vCenter, okay? Inside AWS Global Infrastructure, what I'm gonna have? I will have vSphere, vSAN, and NSX, and we created we developed a technology called hybrid linked mode, so you can link the 2 vCenters to have a single pane of glass to operate and support your environment, right? And we also create an integration with AWS native VPC, so I can have a connectivity between my workloads, my VMs that are running inside the SDDC and AWS services. Of course, here, all of our ecosystem and also our solutions like the vRealize suite work seamlessly in both environments, okay? What are the main use cases that we target with VMC? First one is data center extension, right? Even if I have a limitation on my data center, or even if my strategy to move from a CAPEX model to an OPEX model, right? Another point, really interesting, I can leverage VMC as a disaster recovery site. We have DRS as an add-on to the solution. For cloud migration, if I want to migrate something that I have in a data center to the cloud, a full migration or a partial migration, doesn't matter. And of course, I can leverage that for next generation applications, right? This is really important. VMC is a service that's delivered, operated, and supported by VMware. But both VMware and AWS can sell this service, okay? And right now, we are almost in all AWS regions, right? In Q1 and Q2, we did a lot of improvement, especially in LATAM, my area. We have now available in São Paulo data centers, but also we span over Canada, Europe, and Asia Pacific as well, okay? So this was a really short overview about VMC, because this session is all about the integration with VMC now to automate the workloads, right? VMC brings a lot of automation for the infrastructure piece, but I still need automation for my workloads, right? So first part, integrating with VRA. What's VRA in like really summary VRA? VRA is our automation and cloud management solution that I can create. Even if I have a private cloud or even using public clouds, I can create an abstraction and do that for IaaS, infrastructure as a service, or PaaS, platform as a service. And then I can create an access layer, then I can expose as a catalog for my IT, for my administrators, or even I can expose that as a CLI or API directly for my developers, right? For the purpose, if you want to take one slide for VRA integration, this is the slide, right? Since on VMC we are running vSphere, the integration that I have is the same one that I do in my data center, right? What I need to do, I create a VMC endpoint as a vCenter server, right? Then I add the URL for my vCenter and the credential. Then it's done, right? I would dig into that step by step on how to do it, right? So let's go. Let's do. I have a lot of screenshots here, so follow me. So the first part, as I pointed, we have to go to infrastructure, get to endpoints, and create a virtual vSphere vCenter endpoint. Next step, you put a name that you prefer. You can put vCenter, VMC, or just vCenter. Put the URL and your credentials. Here on VMC, we have the cloud admin at vmc.local credential that I have to use to link to VRA. Next step, and here just a screenshot that this is done. Next step, I have to, if I don't have yet, I'll create a fabric group. So inside infrastructure, fabric group, I create a new fabric group. I put a name, I select who will be the administrators for this, and then I will select the compute resources that I need. On VMC, I can have on my SDDC one or more clusters, so here I can select one or more clusters the way I want. So done the fabric group part. Next step is to create a network profile, right? Right now, we don't have the same integration that we have with NSX on premises, so we need to have pre-built all the networks. So here I'm creating an external network. I'm putting a name, giving a gateway. I can add also other information related to network range, DNSs, because I will associate that with a logical switch that I can see on VMC, right? So I have here created my external network, and the last point for the infrastructure piece is to create the reservation. So the reservation, I create the same way I created on the, if I have a traditional vSphere environment on my own premises. So new vSphere, then I will put the name, I will select the business group that I want. On resources, I will select one or more clusters that I want, and I will decide which will be the reservation, especially for memory. Storage is really important. We always need to use the workload that store that we have. vSAN that store is for our management VMs, okay? And also I have to select the resource pool. the resource pool should be the compute resource pool or a sub-resource pool that is in this environment, okay? And here, this is the important piece. I can select the network and then associated the network profile. So here, I'm associating with a network, a pre-built network with an external network profile, right? And here I have my reservation created successfully. Next step is go to create the blueprint itself, right? So I go to the design tab, blueprints, new blueprint, and give a name. The name here, I use it VMC. And when I got the canvas, get into the canvas, I can select a vSphere machine, drag and drop, put an ID name, and in this case here, I'm cloning a template that I have, right? So here I have a template Ubuntu, and what's really interesting, the same customization specifications that I have on premises, I can leverage here because it's vSphere on both sides, right? But here, this is really important. On the properties, different from the on-prem that you can create the machines into the root folder, here you cannot. On VMC you cannot. So you have to create a custom property, is vmware.virtualcenter.folder, and put a value. Here the default value you should add is workloads or a subfolder inside the workloads, okay? With that, I have my blueprint done. Of course, don't forget to publish this blueprint. And the next step is to add this blueprint to a catalog, to create a service and then add to the catalog, right? So coming back to the administration tab, go into the catalog management service, create new service, then you put a name, the status active, of course, and we need to manage to include the items, right? So here I will include the blueprint that I just created, the VMC blueprint, and we are ready on the service part. Last step is to create the entitlement. So new entitlement, the name here, I'm being very creative here, VMC all the way, right? So VMC on the name of the entitlement, I choose the service, the VMC service that I created, and all the entitled actions. Since this was like a lab, my lab, I put it all the actions, but of course here you can be more selective. Now, everything is ready. What I need to do is to go into the catalog and do a request of this blueprint, right? So I will do a request, I will select the number of the deployments that I want and hit submit. With that, VRA will start the provisioning of this blueprint, and in some minutes I will see my virtual machine power on in my traditional vSphere environment. That's the same technology that we are running on VMC, right? I know that's a lot of steps, but the idea here is to show you that's the same way that you do into your environment today, we are going to do in VMC as well, okay? So, next part, integrating now with cloud automation services, CAS, right? CAS has the similar principles and similar ideas that I have with VRA, but CAS is composed with three components. I have Service Broker, that is my multi-cloud catalog. I have Cloud Assembly, that will do the multi-cloud and application automation piece. And I will have also CodeStream for the pipeline, for continuous delivery pipeline, right? This is like a brief summary if you want. There's a lot of sessions regarding cloud automation service that I strongly recommend you. But here I'm gonna show you how is cloud automation service integration with VMC. Those two slides, this one and the next one, are the most important you to understand how is the integration between cloud automation service and VMC. Inside infrastructure, on connections, I have cloud accounts. And I already have a VMware Cloud on AWS cloud account there. With that, I can add my API token, put a lot of information regarding the names, my credential as well, and we need also to deploy a cloud proxy. This is a virtual machine that will be deploying on your environment to get connectivity between Cloud Automation Service and your environment in VMware Cloud on AWS, right? This is a simple OVA. You put some simple information and you can do the connections, right? So here, as we did for VRA, we are going to do the same for VMC and Cloud Automation Service, CAS. Here, okay, again, in Cloud Assembly, I go through infrastructure and then go to cloud accounts. Here I will put my API token and now my credentials. With that, I have linked my account in VMware Cloud on AWS with Cloud Assembly, right? Next step, I can create a new project in Cloud Assembly or just edit an existing one. For example, I can have this lab one that was a project for my private data center and for AWS, for example. I can add VMC as another cloud zone. How I do that? I go into provisioning, add cloud zone. When I do add cloud zone, I will select exactly the data center that I have in VMC. I click add, and here on the compute, this is interesting. I can create a capability tag to associate that directly to VMC. What can I do is just to select the clusters. Here, really important. Remember on the VRA that I need to use the compute resource pool? Here's the same. Or the compute resource pool or the pools or the sub-pools that are part of the compute resource pool. And then I create a tag. For example, here, cloud VMC tag. Okay? Next step is to add the flavors. I can create a new flavor or I can edit a new one. Here I already have a small flavor that, for example, here I can see I have T2 micro for AWS. I have details for my on-premises implementation. And here I can choose, for example, 1 CPU and 1 gig of RAM for my small on what I consider on VMC, right? Next step, the same, really similar. I can have like a lot of image mappings. I have a Ubuntu mapping here. Then I can use a template that I have on VMC, right? And as I did on VRA, I have to create a network profile as well. So new network profile here. I will select exactly the cloud zone or the regions that I have. And then I will add the network, right? Here I can select the networks that are created on VMC, and I can edit and add more information related to domain, default gateway, DNS service, everything that I want to when I provision in this will have this information, these properties, okay? The infrastructure part is ready. We need to go to the design part. On the design, I go to blueprints, new blueprint, and I created here the name, VMC demo, and I choose the project that this blueprint will part of. Here, I can drag and drop vSphere machine, right? And on the right side, I can type my properties. For example, the image, remember, I'm using Ubuntu image. The flavor, I'm using small. And here is really important. Remember on the VRA, the custom property, here I have to do the same for the folder custom property. But here we can just type folder name and see workloads or a subfolder inside workloads, right? The number of instances here, count 1, and also the constraint for Cloud VMC that will entitle and force that to be provisioned on VMware Cloud on AWS, right? So with that, we can deploy. So I put here a VMC deployment name and hit deploy. With that, Cloud Assembly will start creating everything. We start provisioning this virtual machine inside VMware Cloud on AWS, right? So after a few minutes, I will have my Cloud vSphere machine with all the properties and everything that I did on the blueprint side, right? And here it took about, depending on the size of and all the customizations you do, this in case for me it took like 2 to 3 minutes to create this virtual machine, right? And just to finish this and to summarize, both vRealize Automation and Cloud Automated Service can be your automation platform for even private cloud, for VMC or any other cloud that's running VMware, and also public clouds, right? Of course, one, you have VRA, you consume that as on-premises with license-based. Cloud Automation Service is a SaaS solution that we have, right? With that, I would like to thank you very much, and if you have any other question, I'll be around here. Thank you.
Hi, my name is Susan Wu. I'm the Senior Product Marketing Manager in Network Services, Network Security Business Unit. I actually handle service mesh, and prior to this I was at CNABU for Kubernetes, and then many eons ago I worked at Docker and OpenStack and CloudStack. So actually I'm here to tell you a little bit about implementing persistence in Kubernetes. It's not for the whole Kubernetes talk because I only have 10 minutes. So there are a lot of sessions about Kubernetes that you can go to, a lot of Tanzu sessions. So this is only about implementing persistent storage. Very quickly about the applications. Architectures are changing. I started my life in Java, so it's monolithic. The whole team, I think 200 of us, all use the same IDE. We only check in code once a week, and then we have peer review, and it was pretty much impossible to kind of dictate the type of architecture that you want to do. And it's a little bit unflexible. We used to use the waterfall method, so we would code, and then we would find something at the very, very end. And we've seen even showstopper bugs. But now, fast forward 10 years, about 2000-ish timeframe, many companies started adopting microservices, smaller teams. They get to choose their stack and also their favorite backends, all of it connected with REST API. And so this is really changing. People can revise their application. They control that stack. They can iterate on their own intervals. That's kind of how it's happening. But in reality, not every application in the enterprise is in microservice pattern. VMware, we still have quite a bit in Java. We still have some LAMP. But we started moving a lot of our customer-facing services like myvmware.com to microservices. And so with that, moving the microservices is prompting the use of containers and moving to Kubernetes. We've been meeting a lot of customers, and generally they've been faced with similar problems before they adopted Kubernetes. They've had failed applications in production. They need a lot of lead time before they could deploy. And what was really common now that I'm in networking is they're looking for a common set of APIs to provision infrastructure, network infrastructure, and other infrastructure as part of even like a CI/CD pipeline. So just for the product that I work on, NSX, it actually exposes the REST APIs, and you might be familiar, that actually you can actually provision like a distributed router or a VPN, all using the REST API. So there's some sessions here where some VMware engineers coded Python Django, including the NSX APIs, and then show how to provision, auto provision the VPNs. And they also show doing that same cycle onto, say, VMware Cloud and also on-premise. And then they also use the same kind of pipeline technology to seamlessly connect their security policies on-premise as well as on the public cloud. So that's what's happening. So on Kubernetes, why do you need persistent volume? Of course, to run stateful application. If everything's stateless, you wouldn't even need to do that. And so Kubernetes itself actually has ways for you to write to a file system. So you can write to a container file system, but the problem with that is the container, when that dies, that file system's gone, the data is gone. And of course you could write to a volume, and then it's tied to the life of the pod. When the pod dies and restart it, you lose that data. So Kubernetes started out including something called persistent volume, which actually survives the life of a pod, a container, and even the node. It survives the life of the cluster itself. So how do you do, oh shoot. Okay, so stateless application, everything's configured separately. You use something called deployment, which creates the replica sets. And then the replica sets, let's say you chose 3, Kubernetes would check the state. If the state has fewer than 3, it's meaning it has less than the desired state, Kubernetes would create that replica set for you. But the challenge is that this is a kind of written to a remote storage. And if you have multiple containers and you try to deploy persistence, then all the containers are talking to the same store, which is not ideal. With stateful applications, you have something called stateful sets. I think in the past this was called pet sets in Kubernetes. So this is information that's stored locally by the application, and you have read-write access. It's commonly known as pets. How this works is, let me switch to the next slide. How this works is actually it creates pods with its own names, and then a user would request the storage using something called persistent volume claim. And then what happens is then the persistent volume is actually tied to a backend storage. In the case of vSphere, it's tied to vSAN data store. So it's actually backed by a persistent volume. And then the users would request it using the persistent volume claim. And then the same situation happens is if there's a if you have a desire for a certain number of pods and the state shows that it's less than the desired, then Kubernetes would actually replace that pod for the pod that has failed or it's been evicted. And then actually it would actually associate that new pod with the appropriate resources that you've defined. And then it's how it works is when you the storage administrator first backs up that Kubernetes with the type of backend storage. In the case of vSphere, it's actually block storage. And then the storage administrator or the container administrator would define the storage classes and then expose that to the users and to vSphere. And that is my last slide. If you have any questions about persistent storage. We also have another session that's given by Gopala. He's a PM for vSAN storage about container native, and I think it's tomorrow morning. You can look for that. Sure. I'm sorry? So in the case of vSphere, it's actually backed up with the VMDK and then written to the vSAN data store as a file system. And then of course backed up. So you back up this is a container running on a VM. So the information is backed up to the VMDK, and that VMDK is actually mapped to the vSAN data store. And then of course you have the real disk. Thank you for the question. Yeah. Any other questions? Oh, okay.
What goes into deciding between Kubernetes persistent volumes and the external storage?
Oh, so mainly it's the applications. So if it's a stateless application, it would be sort of like you would use a model called deployment. So there were like 2 methods. One's called deployment, one is called stateful set. And so if you use the deployment model, it would back up to the remote, and they would access it through the remote protocol.
So it's stateless versus stateful from a Kubernetes standpoint?
Yeah, from an application standpoint. Yeah, correct. Absolutely, you're right. Yeah, so the state is persistent.
All right. Good morning, everybody. My name is Boski Savla. I am a technical marketing manager in VMware. I work a lot on our cloud-native solutions around Kubernetes, like PKS, Olympus, or Tanzu that you heard yesterday. And for today's session, I only have 15 minutes, but what I wanted to do was quickly go over why Kubernetes, or how does Kubernetes sit on top of vSphere. Most of us have vSphere somewhere in our data center, and Kubernetes is this new thing that's coming up. Everybody's talking about it. So let's see how can we fit that on vSphere. As a background, I've been a Linux system admin. I moved on to being a VI admin, a solution engineer, and then I've been at VMware doing various roles for the last 8 years. All right. So, Kubernetes is something very similar to what vCenter does for ESXi hosts. So, if you have a bunch of ESXi hosts and a bunch of virtual machines to run, you need something like vCenter to orchestrate all of that, to create a cluster so that you can load balance your virtual machines, etc. So think about Kubernetes as doing the same, but for containerized applications or container images. So if you give Kubernetes a bunch of hosts, it's going to distribute your containers across those bunch of hosts. So it's an orchestrator. That's one of the functions that Kubernetes does, but it does more beyond that, and we'll get into that a little bit. So why developers love Kubernetes is it brings together infrastructure in a way where developers can define a requirement in a simple file, give it to Kubernetes, and then Kubernetes takes it, talks to your infrastructure, and makes it happen. It's kind of like magic. Today, if you think about how developers work, most likely there's a ticket-based approach to, I need a virtual machine, or here is my app, I want you to run it, throw it around to IT. IT has to figure out how to manage it, how to load balance it, how to secure it, so on and so forth. With Kubernetes, the idea is that you're creating a single framework where developers can come in and say, here's my app, it's containerized, please run it for me. Make sure that you have 5 copies while you're running it. Make sure you're load balancing it. Make sure this is the port that you need to load balance it. And maybe it has some security elements that they can define at the same time. And what Kubernetes does is it takes those configs, or it's very similar to like what Puppet does to configuration management. It maintains states. Kubernetes does that for orchestrating containers or applications in containers. So a classic example of Kubernetes is, let's say you have an Ubuntu image that has an app that you put in a Docker container, and you give the container along with a YAML file to Kubernetes, and you say, here is my container image, my app is already in it, run it for me. Kubernetes will go talk to vSphere. If your infrastructure is vSphere, it will deploy it as a pod in a virtual machine, and then it will have it running there. Similarly, if you need a persistent volume, containers, the thing with virtual machines is we tie the two together, a virtual machine, operating system, application, and the storage needed for that. With containers, you're kind of separating all of those requirements. So a container image, when it's running, it has ephemeral storage. It won't save data. If you have a database that you want to run, you have to define a persistent volume. So there are multiple things that you can do with Kubernetes, but essentially the point is, Kubernetes is only passing those parameters down to infrastructure. It is not doing any magic at that layer except passing parameters. So what that really means is that your infrastructure that you're running on that Kubernetes is running on top of has to be fluid. It has to understand what Kubernetes needs. When a developer comes and says to Kubernetes, I need XYZ, Kubernetes or the infrastructure that's running on it has to figure out what do I do to it. Like if there is a persistent volume that it needs to be provisioned, Kubernetes is just going to go down to the node that is hosting the pod and say, get me a 10 gigabyte of persistent volume. The pod is then, the pod doesn't have storage. So the infrastructure, for example, if you're running on vCenter, has to create or carve out a VMDK disk of 10 gigabytes and then mount it to the corresponding virtual machine where that pod is running. All of this is automated, but that's what needs to happen, and in terms of the infrastructure. And Kubernetes has multiple. So what it does is, if you have an application requirement, for example, if you want to deploy an app, you want to figure out what the replicas should be, what high availability you have, what load balancing or network requirements you have, what security requirements you have, what upgrade requirements you have. Today, we are really looking at the infrastructure APIs, whether you're in vSphere, whether in AWS, whether you're in Google Cloud, you're really talking directly to that cloud's infrastructure API. And then you're managing your applications around that. Sometimes we also use things like Ansible, Chef, Puppet to manage all of that or automate all of that. And what Kubernetes does is it sits right between your application requirements and in front of your infrastructure and defines those requirements in standard frameworks. So for example, if you have replication needs where you need an app to be replicated multiple times, there is something called as a replica set in Kubernetes. It's an API endpoint. You define that, and when you define a replica set, Kubernetes will create 5 replicas for that, right? So you're only going to, and it doesn't matter whether you're running on vSphere then, or whether you're running on Google Cloud, or whether you're running on AWS. You're defining it once. You can change your infrastructure, and correspondingly, Kubernetes will implement it still the same way, but using another infrastructure provider. So the way Kubernetes does that is it has plugins for different resources that are needed. Essentially, an app always needs compute requirements, network requirements, and storage requirements. So Kubernetes has plugins by which it understands how to work with an infrastructure provider. So if you look at the open source project today, there are multiple vendors, multiple systems that integrate with Kubernetes. From a cloud provider perspective, Google, Azure, vSphere, AWS, they all integrate with Kubernetes to provide compute resources to a container. From a network perspective, because Kubernetes is running like pods that are in a virtual machine, and there's some nesting going on over there, so you need container networks to operate. So there are multiple network providers that integrate with Kubernetes, and so on for storage. With VMware, let's say if you have to run a workload or Kubernetes on VMware, what we have done is we have created, working within the Kubernetes community, these plugins that help you implement Kubernetes cluster with all the automation that comes with Kubernetes natively within vSphere. So as an example, if you have persistent volume needs, the automation where Kubernetes is going to talk to vCenter, and then vCenter is going to provide a VMTK disk and mount it to that virtual machine, it's all automatically done by the vSphere cloud provider that sits on the Kubernetes cluster. And this cloud provider, again, it's something that the VMware engineers are working within the open source community. It's all free, it's openly available. Similarly, if you have NSX, there's something called as the NCP plugin, which is going to automate the build out of services, pod networks, container networks, all of that. Again, this is something that NSBU or the networking team has created specifically to make sure all vSphere workloads have that ubiquitous, seamless integration created. Now, let's look at what a Kubernetes cluster looks like in terms of how it's laid out. So you have a bunch of ESXi hosts that you're pooling together in vSphere with resource pools or clusters, and a Kubernetes cluster will land on that just like another application, but the worker nodes or the master nodes that comprise of a Kubernetes cluster are going to be virtual machines on top of vSphere. So from if you look at it, it just looks like another app running on top of vSphere, but a bunch of virtual machines together create the cluster for Kubernetes. And within those virtual machines, you will have all the Kubernetes components deployed, like kubeproxy, whatever Kubernetes needs to operate. You'll have the control plane as one of the virtual machine, you'll have the worker node as another virtual machine, so on and so forth. So the pods or the containers are going to run within those virtual machines. They're going to derive their resources from the virtual machines that they're hosted in. If you look at networking, the idea is that, because you have a container that's sitting in a pod that is sitting in a virtual machine, and that virtual machine is probably connected to a virtual vSphere switch, and then eventually to a ESXi host, there's a lot of network layers involved. and to operate a cluster effectively where a developer can have a seamless experience where if they want to deploy a containerized app, they don't necessarily have to go create a ticket to create a container network that they can land their workloads on. It's really necessary to have automated processes that can implement all of these together. So if you think about it, we need a pod network that's uplinked to the node network. The node network is where the virtual machines reside, and that virtual machine network should be uplinked to your vSwitch or DV switches. And then the DV switch again, of course, is through bridge to your ESXi host uplinks. And there should be routing between all of this. The pod network has to be virtual. It cannot be physical, because if it's running in a virtual machine, right? How do you define a physical network that's running in the virtual machine? And it has to be created in real time. So for example, if I'm coming in, I'm deploying a new Kubernetes cluster, I need a pod network created along with that. If I don't have that, I cannot really operate the cluster. So a lot of this has to happen in real time as people start deploying clusters. Routing also has to be in place. And the other thing is, if you want to expose your applications, you need load balancing to have in place. So logical switching, routing, load balancing, all combined together, that is aware of Kubernetes, that is aware of containers, and also works at the virtual machine layer. There are multiple ways to go about doing this. If you already have virtual switches and you're not using NSX, you can use open source tools like Flannel and Calico to do your open vSwitch, or sorry, the container networking. That is the overlay network for containers that can sit on top of vSwitch. If you are using something like F5, you can use that to load balance your services for Kubernetes. However, the idea is that you'll have to work through different systems. NSX has done all of that together in one place with NCP plugins, with the logical switches, routing, and load balancing that NSX has. So if you're running a vSphere, if you're not using NSX, you can still implement a Kubernetes cluster, but if you're using NSX, it's just going to be much more seamless. So that's how a network is handled within Kubernetes and vSphere. If you're, now let's take a look at how storage works. So let's say, if you have two pods running into different virtual machines, and they're going to access a virtual, a VMDK disk for persistent storage. If the pod moves to another virtual machine, and this is very common, it's like how a vCenter DRS cluster will vMotion a virtual machine to another ESXi host. Similarly, a pod can be moved to another virtual machine by Kubernetes just to manage the workloads. And your corresponding storage that was attached to the virtual machine has to move to the new VM now. So there needs to be some automation to do all of that, and that is where the vSphere cloud provider comes in. This is again a Kubernetes upstream open source. It was called Project Hatchway. It's available on the internet. You can download it. But what it really does is it understands how Kubernetes works. It understands how vCenter works. So anytime Kubernetes gets a request to creating a persistent volume, it goes, talks to the vCenter, it provisions the persistent volume, and matches or attaches it or mounts it on the virtual machine. Now, if the pod moves to a different virtual machine, it's going to do the same. It's going to move the VMDK, demount it from the VM that it was on, and put it back to the virtual machine or the VM where the new pod lands on. And all of this is really automated. So that's how the storage works. So I guess that's how vSphere handles Kubernetes in terms of network storage and compute. All right, thank you.
Hello, so I'm Alex Carver. I am a VMware Solutions Architect with Pure Storage. Today I'm going to kind of go over a topic of converting RDMs to vVols. So with the adoption of vVols and some of the great benefits that a lot of customers have been having, one of the lingering things that have been left on RDMs have been the Windows failover clusters, essentially, because initially with vVols, they didn't support SCSI 3 reservations, and that was something that was kind of holding back those parts of it. And with ESXi 6.7, specifically update 1 and update 2, they had introduced the support for SCSI 3 reservations. And so that you could actually get some of these Windows failover clusters moved off of RDMs and onto vVols themselves. Up there? All right. So can't be over there. Okay. So some of the text is a little bit small, so I'll be like doing that for it, I guess. Here we go. There we are. So I do have a Twitter handle and a blog. After this, I'll actually be adding some stuff to my blog, the more videos and demos of different workflows for running through these, because there are some different options that you have for it. And then what we're going to be going through, just a really, really super brief vVols overview, just in case it's the first time hearing vVols, which if this isn't your first VMworld, you probably have heard about vVols for like 4 or 5 years now. So, and then why move RDMs to vVols? What are your options? And then what about a Windows failover cluster? Just as a disclaimer, some of the stuff I may show may be kind of peer specific, but I try to make it as vendor agnostic as possible, right? vVols, it's going to be the same concepts vendor to vendor. So if you happen to have a vendor that's not Pure Storage, you know, you can talk to them, just double check with them. Hey, this process that I kind of went through, just making sure it's going to be perfectly fine with your vendor. And it should be. As much of this stuff here, just trying to be as vendor agnostic as possible. All right, so just a quick vVols overview. Really just what they are. So essentially, if you try to take a step back and take a full picture of it, vVols are the ability to have the vSphere environment have insight directly to the storage layer itself and to be able to communicate directly to that storage. And so if we kind of look at it, you have that control path or management path of that BOSA communication, which is a vSphere API for storage awareness. And then within there, there's the data path, so the actual volumes connected to the vSphere environment. And then what really happens is whenever a VM is created within vVols, is it just doesn't create those VMDK files in a VMFS data store. It's creating volumes directly on the flash array itself. Similar to an RDM, the VM has direct access to the device itself. There's no VMFS file system, kind of redundant there, I guess, or VMDK encapsulation on it. It is the guest OS writing directly to those devices, just like an RDM. And so it gives you some data mobility, but because vSphere does have that insight to what's going on there, you then are able to take advantage of storage policies and doing storage policy-based management, applying those policies to the VMs, leveraging array-based replication and snapshots. Managed snapshots aren't just a bunch of, you know, SE sparse files and Delta files on that VMFS data store. Rather, they're actually volumes on the flash array itself, or the storage array itself, I should say. So, kind of looking at it, you have those different volumes, and the one we really care about here is the data vVol. So this is an actual, your data volume is on the flash array, and whatever guest OS you have is actually writing directly to it. And then there's a swap if it's powered on, powered off. If you're taking a memory snapshot, it creates a memory volume itself. So why convert these RDMs? It's a good question. I mean, if they're working and everything's happy and your DB admins are happy, why change it? One of the big reasons, as I mentioned before, would be the storage policy-based management. And with those storage policies, being able to have that granular control, it's no longer a, well, all these, you know, VMs are going to share the same policy or same snapshot or replication policy on the storage array because they're on the same data store, but rather I can have granular control even at a VMDK level. Maybe I want one VMDK or one data vVol or VMDK in that vVol VM to have 5-minute replication, but that other one, you know, I can have a 1-day replication on it. You get very granular control at a per VMDK level rather than just, you know, a data store level and a group of VMs or a per VM level. So it gives you a lot more flexibility as the vSphere admin to help manage that. And you don't have to, you know, put in a request to the storage admin, or as a storage admin, you don't have to wait for the request from the vSphere admin to say, hey, these volumes and these devices need to go in that protection group. Rather, the storage policy automatically moves those volumes into that replication group or consistency group, whatever the vendor calls it. We like to give like 20 names to the same thing. It's industry standard. The other thing is insight directly from vSphere to the storage. So, and kind of vice versa. I mean, you're going to know what the VM name is if you're the storage admin, and hey, this volume all of a sudden exploded in 20 terabytes over the weekend. I know exactly what VM did it and who owns it. So another part is that utilize managed snapshots. So that is something that with RDMs you weren't able to do before. Now the caveat to that is if you have SCSI controllers that are doing a sharing, so physical or virtual, you can't use managed snapshots still. However, you can then leverage array-based snapshots and actually have the automation within vSphere. Prior to this, like if you had RDMs, you would still need to be into the storage array or have access to it to get those snapshots or replication kicked off. Now you can still, with storage policies or with integrations with vSphere, you can actually take those array-based snapshots and even restore from them and those sort of things, such as importing a data vVol to another VM or recovering it. So if you need to do a database refresh, you don't have to all of a sudden copy out that VMFS data store to a new volume, connect it, rescan, find the VMDK, or resignature it, find the VMDK, copy it over. You can actually do this stuff directly within the actual PowerCLI PowerShell scripting or from the UI. And then the ability to use PowerCLI or VRO to do a DR failover. So maybe you want to do a test failover or DR failover with these storage policies, and so that gives you the ability there. There we go. So this is just a screenshot from the vCenter UI, the HTML5 one, with the Pure Storage UI, or not UI, plugin that's installed on there. And so from this screen, you can actually have the option, boop, boop, come on. There we go. So to import a disk, so if there's another VM, you want to import a disk to it, or you took a snapshot of another one, you can do that. Creating the snapshot, overwriting one, so maybe you took you used some file QSing, or you persisted that down, you took a snapshot, you're like, oh, I need to roll back to it, so let's go ahead and overwrite it. Or someone deleted one accidentally, you have the option to then recover it. So some of those integrations, each vendor may have a different one or some different parts of it, but these are built right into there. So what are your options? So kind of the important part, how can I convert an RDM to a vVol? So there's a couple part of it. Thing to keep in mind, it's not really non-disruptive. There's not a way to just do this perfectly where you're online the entire time. That's kind of the cruddy part here. There is going to be some kind of downtime. Now, depending on how you are using RDMs, it depends on how long that could be. If you're not using virtual or physical sharing, the downtime is the amount of time it is for you to maybe offline whatever role or application or database you're using, remove the PRDMs, physical RDMs, add them back to virtual RDMs, and then online everything again. So once they're back as virtual RDMs, you can just storage vMotion it to vVols and you're done. And then it's on vVols and you're good to go. But again, if you're using SCSI controllers that are in sharing mode, you can't do that. So if you have a target VM that you can copy them to, so maybe you don't need the boot volumes, you can go ahead and just offline the role, copy those RDMs, and overwrite the target vVol VM data vVols, and you're good there. But if you need those boot volumes and the entire VM moved over, you're going to need to basically have a couple options that try to move it over and have the least amount of downtime. So the one that has a little bit more downtime is you remove the shared disks from the node 2, for instance, and then you go ahead and take node 1, remove all the PRDMs, remove the SCSI controller that has physical sharing, add them back as VRDM, storage vMotion it, and then reset it up as a physical sharing and all that stuff. That's going to take more time. It's a little bit simpler from like a multi-step process, but you're going to have a little bit longer. So if it's a really important application, you're not going to be able to sell that very well. Option 2, essentially what you'll do is you're going to create these placeholder vVol VMs, and then what you can do is you can offline one of the nodes one at a time, so your role's still up and your application or whatever's clustered role is still up, and you'll offline one of the VMs, and what you can do is then you can copy the boot VMDK over to that vVol VM, and then what you'll do is you'll add it as an existing disk, find the boot volume, and it's there. And so you copy over the boot volume, you can power back on that VM, and then add it back in, and you're good, and then repeat the same thing with the other node. So this allows you to keep the cluster role running while getting the target vVol VMs set up. Yeah, and after the boot VMDKs are copied over on node 1 of the vVol VMs, you can then kind of create those placeholder like witness or MS SQL data, log, etc. And there's not going to be anything in them, but they need to be the same size, because what you'll be able to do after that, come on, is you can make sure, and then make sure they're using a shared SCSI controller. You'll set it up just like you would normal RDM setup there. Here we go. And once that's complete and you're ready to copy over the RDMs and overwrite those placeholder ones, then you could offline the role and offline the witness disk, etc. And from there, you will then go to the array. So if you need to work with your storage admin or you have access to it, you would copy and overwrite those empty vVol data vVols on those VMs. And as you overwrite them, those roles will be there. So you can power on into an isolated network and make sure everything was there. Or if you know it's going to work, power off the old one, power on the new ones, and then make sure everything's running and good. While there are a lot more steps here, it is something you could orchestrate a little bit with PowerCLI or Python and PyVMami and those kind of things. I obviously don't have time to go through a demo of it right here, but it is something that I'll have on my blog and walking through those ones in detail. And tomorrow at the Pure Storage booth at 2 p.m., I'll be running through a demo as well of it, of actually running through this process. So it is something to try to show it. As a conclusion and closing thought, yeah, it's a pain in the butt to kind of convert those ones, and it's a hard sell, especially telling someone they're going to have to offline something or have change control. But once they're on vVols, you're not going to have to worry about doing that process again, and you're going to have a lot more flexibility and ability to have insight from one side to the other. But, yeah, resources, all of our vVol KB stuff at Pure Storage is public content, so you can just log in and look at it. And we should have more stuff that covers this as well in the future. All right, there we go.
Hey everybody, my name is John White. I'm the Chief Innovation Officer at Expedient. I'm really pumped to do this talk today because it has nothing to do really with my regular day job. So yesterday I did the VM Underground opening acts, and we were talking about career development there. And one of the things that I mentioned in there is there's always, some sort of technology or some sort of problem you're unsure of in your life. And you got to figure out how to get past that and eat it, because it's no use to you long term if you're afraid of it. One of those ones for me was cloud native. I've been in engineer for a long time, started as a developer, moved into infrastructure, and everybody was talking about this cloud native and what a cloud native application looks like. So I said, okay, I might as well go ahead and figure out how to actually build a cloud application, because that's the only way I'm going to learn what a cloud native application means. So today I'll talk to you my process of actually going and learning that, as well as then show you the live site, and you can actually play with it too. All right, so what's the deal with cloud native? Everybody's talking about cloud native. You heard it today in the keynote. Everybody's really focused on it. Why should you care? What do you care about? Why I cared at least. Well, on the business side, everybody's coming up and saying, okay, if you build a cloud native application, it's going to save you money because you get to use this cloud thing. Okay, that's one of them. On the resume side of it, from a personal development, if you start playing with containers, serverless, microservices, these are all things, the buzzwords that everybody wants to hear. This is an opportunity and a place for you to go and enhance your career. On the elite side of things, building infinite scale applications is obviously pretty cool. Everybody's been wanting to do it. That's something that we all need to do because we have a lot more mobile users. We have a lot more users than we ever have. And on the last thing, and this is the most important for me, why I wanted to do cloud native, because I could actually troll for less. By moving to an invocation model, I didn't have to set up servers to actually go and run my application. I could actually build an infinite scale application for pretty cheap, so I could make fun of the guy that I'll show you in my application a little bit cheaper than I would if I had to build servers for it. So the way I eat an elephant when I learn, I actually do two things. I obtain and I apply. And when I was obtaining this time, I really broke it down into three phases. So I needed to make sure I had a platform to develop on. I needed a cloud platform to go on. And I used AWS for this demo, this cloud native application I was building. And if you don't know, there's awesome self-paced labs out there on AWS's site. They're free. You can go and do that. So I spent a lot of time actually building things through those types of modules first and using their starter modules to get going. The next thing I needed to know is a programming language. I was familiar with writing C and Perl, and so I just chose Python because I said, okay, that needed to be, it seems to be a pretty popular language everybody else was developing in. And if you haven't seen it, Google has a whole developer education site that you can go to, and they have classes. So the Google classes here take about, I think if you do a few hours every week, they take about a month to complete. I think I finished it in about a week and a half. And it teaches you everything from the basic of understanding how to install Python on your laptop to start coding into actually developing Python applications. Again, that's all free and something they have out there. It's actually a lot of cool live videos and then demos that you can actually do inside of their environment. The last thing that I needed to obtain is actually, the core fundamentals of cloud native were microservices. So I watched self-service courses, and Kelsey Hightower from Google actually did this course that I showed here, and it talked to you all about microservices using Kubernetes, so I could learn kind of the frameworks there. Adrian Cockcroft, actually, one of the major tech leaders and visionaries of Netflix, he's inside of this as well, talking about his kind of journey and what he needed to learn to make sure that he could understand how to do cloud native. He actually built cloud native, so he's a great person to learn from. So you can take a look at all these links. They're awesome. I think they'll have this on YouTube as well, so if you didn't get a chance to copy them down, you can take a look at it. But it was my way to kind of obtain all the information and knowledge I needed to start to build a cloud native application. So the next thing I needed to do was apply this. So I needed an idea, and like everybody else, I wanted to build a website that inspires the world. And you'll see after I show you, it's a little tongue-in-cheek with the guy that I actually made fun of inside of my application. He's a very inspirational guy, one of my coworkers, and somebody who has a lot of fun. So my next phase that I needed to do is kind of sketch this out. So I had all this new tooling, all these new things that I learned. I needed to kind of build something out. So I knew I needed to build a website. I needed to have some randomization because I was actually going to go and bring in some different information. I wanted it to be a little bit more dynamic. And I knew I needed to, I was going to add video element to it, so I needed to figure out how to actually use a CDN inside of AWS. The last thing I needed to do was actually build it. So this is essentially what I ended up building at the end of the day, and I'll blow it up for you here. So if you see on the top, I'm saying, okay, we have an infinite scale users on the top side of things. So if you start breaking it down from the top down, we had a few different actually applications that I had to build. So I'm using Route 53, so that's DNS inside of AWS, and I broke that down into 3 areas. I have SAM videos, I have SAM, and then I have API. So I wanted to make sure I was building an application that I had a front-end interface for, but really anybody else could build a front-end interface for. So SAM videos is how you actually view the videos from the website and how they actually get served to you. They come out at the end of the day out of S3 buckets. And that's actually where, if you go to the SAM dot, which is actually the main home, so your index page for the whole website, that's actually being hosted out of S3. So I didn't spin up a web server, I didn't do anything like that. You can actually take an S3 bucket and actually apply it to be public on the internet. Now you can't do server-side scripting on it, it has to be all client-side, so I actually had to use JavaScript, and I had some help from internal teams at Expedient to kind of help me out there to actually create the rest of the website. Then on the API side of it, I use the API gateway inside AWS, and I use Lambda to actually provide serverless framework. So it's something that I was actually only using invocation based. If you're not familiar with that, I'm only actually being charged for it when I'm actually using and consuming that function. There were some other things in wrapper services that I had to have around it. So certificate manager for SSL, and then Cognito to basically, I have user identity on it, but right now I have it basically just turned on to anonymous so that anybody can view it on the public internet. So you can see, a cloud native application is somewhat complex. I have 2, 3, 4, 5, 6, 7 different services that I had to learn and understand how they work inside of AWS to kind of make this website work. So let me show you what it is. And you can actually, this is an audience participation as well, so grab your phones, grab your iPads, grab your computer. If you go to sam.askjohnwhite.com, you can actually see it, but I'll bring it up on the big screen here too. All right, so this is Sam, meet Sam. Sam is, like I said, one of my coworkers, very inspirational guy. He's full of quotes and one-liners like you've never heard before, so I wanted to make sure, again, like I said, I wanted to inspire the world with my application. I really wanted to make a difference in this world. And so I wanted to bring Sam to everybody out there, and I wanted to make sure that if I did a talk at VMworld, that it would scale and nobody would sit and have to wait for Sam because he's always available for you. So there's two different functions you can do in here. So there's quotes, and Sam's full of them. So most important, just cash the check. You can obviously tell that Sam's a little bit more of a sales motivated guy. All right, so we have another one, get out in front of our skis. Again, I'm not even sure what really that means. I'm not sure if that's a good thing or a bad thing. I feel like if you're in front of your skis, you might fall, but he says it on a regular basis. Buyers are liars. If there's any salespeople in the room, you probably know this one. So Sam's full of them. So I have a whole bunch of randomly generated Sam quotes that I'm actually going and presenting, and these are all living inside of Lambda functions. So there's a randomizer I wrote inside of the S3 function. It's in Python. It's very simple, but it brings and grabs these different quotations. Now, when I first built this website, I said, okay, the text is kind of cool, but it needs to be better. And what's real fun too, and if you want to do this, it's available. The API front end, if you just go to api.askjohnwhite.com, you can actually bring this into Alexa, so Alexa can actually say these back to you, which is really exciting. So if you want to start your day here, you can actually continue to develop off of this. But like I said, the quotes were one thing. I wanted to make sure that we got really the true vision of Sam out there. So we created all these little snippets, and you can't hear the audio. But if you go home, you're sitting, you're laying in bed, you're thinking, man, I had a hard day. You watch a few of these videos and you'll be inspired to really get going for the next day. But there's a whole bunch of these videos. They come in and you'll see Sam's a big, boisterous guy. And this is, I can't even remember what he said on this one, but it's comical. It doesn't show on this screen, but he's actually slamming a basketball into a basketball hoop at this time. So he's achieving his goals with whatever he said. So take a look at this, but this is all serverless. I actually have it, I was running some different dashboards inside a CloudWatch, inside AWS, and so I was looking at how long it was taking to actually execute this. So when I take and hit the quote button, it's going and calling a Lambda function, and it's taking about 0.28 milliseconds to actually bring this up. So it's extremely fast, extremely agile. Everybody at this conference could all hit this at the same time right now, and it would just continue to scale. And there's a pretty awesome cost economics benefit when you start to build things in invocation instead of just actually building servers. So check it out, sam.askjohnwhite.com, and I'm sure you'll be inspired. All right, so what did I learn here? Because you always have to learn something. Well, one, I'm not afraid of cloud native anymore. I get it, I understand it. I have an application that still continues to scale, and I have that out there and running. But I did learn that building a cloud native application is really tough. As you saw, I had to learn how to use AWS. I had to learn how to write Python. I had to learn how to write actually microservices frameworks because I'm talking to all these different things. And then I actually had to go and build it. And when I was building it, I probably spent, what you see there, which doesn't seem like a very complex application, right? I have probably a good 40 hours into building it, testing it, making sure it works. So I also, just to understand timelines, I built just a regular dedicated server running Nginx, and I built this website on it, and it took me maybe 40 minutes tops. So it's a significant increase of time that you need to spend, but by spending and investing that time in the front end, you can get that infinite scalability, you can get that economics of cost that's really different than what you're doing today. It's funny though, I talked with a lot of businesses though, and they say they're going to move all their applications to cloud native. You'll ask, they'll say, okay, we have 500 applications. So if I think about that in my estimation, we're talking about hundreds and thousands of hours to actually move those applications and get them in the cloud native. It's going to be hard to migrate. It's going to be a lot easier to build and go. So if you're running into that challenge inside of your business, I'd say maybe start at some of the basics and then figure out where you need to go in the long run. The invocation is super cheap. So I run this website. We use it internally, and I created IoT dot buttons as well, so that you can actually get these emailed to you if you want, so they're around the office as well. And it costs me a few pennies a month to actually run this website. Now think about it, if you were running a server, if I was running one EC2 instance or one virtual instance out there, it's going to be at least 10, 15 bucks a month to run the smallest instance that's out there, and it doesn't have the scalability into it. So doing the invocation, moving into Lambda functions, super cheap, definitely a ton of benefits there. And the last thing, one of my biggest lessons learned, and this is something that I think is going to be a big shift for a lot of people, the cloud infrastructure engineers of tomorrow, they need to be able to code and be able to understand infrastructure. So if you're a straight developer, you got to learn infrastructure. If you're straight infrastructure, you got to learn the basics of coding. That was the only way I was able to put this together. A lot of the knowledge that I had in my past was able to help me kind of build this out and make this a lot easier, but you have to have both of them together. And it reinforces the need to have DevOps, have all these types of new wave of trying to build an application to handle whatever business task you need, because you have to have a balance of both sides to actually make it work. The operational side is another thing about it. I mean, I went and was building, how do I monitor something like this and monitor an application? You don't know what's important yet because we never did it before. In building storage and building VM environments, to watch for latency and to watch for CPU queuing and ready and stuff like that. In this world, you have to worry about cold starts, and most people probably aren't even familiar with cold start, but that's the time it takes to actually get a Lambda function up and running to then send back whatever data that you need. And that's something that I'd have to start to think about if I ever wanted to scale this application up. So that's my talk. I hope you learned something. I appreciate the opportunity to be here and talk to everybody here. If you have any questions, I'm always available. I had my LinkedIn and Twitter in the presentation. You can check it out on YouTube. And I'd love to keep the conversation going. Thanks, everybody.
Cool. Thank you, everybody, for coming to my presentation here. It's day 5 of VMworld, so I hope everybody had a great conference. So. My name is Mike Martino. I work at Zerto as an SC. That's the only time I'm really going to mention my company or product, because I want to do this in an independent way. So I call this the art of recovery, and I'll get into why it's called that. But really, it's some of the things I've observed in the field, and I hope it helps you in your environments, in your situations, to be better when it comes to disaster recovery, getting your applications online. So just hopefully people can see that. Okay, good. So chances are you're using some kind of backup product or replication product. Whatever the case is, you're protecting VMs somehow. And you also have, from the same product, hopefully, the ability to recover VMs. And a lot of times that's going to get your VMs back into whatever destination environment it is, whether it's the same data center, it's your DR site, maybe it's the cloud. So you're recovering VMs, but are you done? Is that it? Everything works perfectly when you do that? Chances are no. And there's a point where you have to figure out, are you truly recovered? And most of the time you're going to get feedback from others that your services are back online, and your users ultimately accept and say, yeah, we're back online. So a lot of times it doesn't work, and especially can get really dicey when someone's standing over you or things are happening in an emergency situation, and you're not making clear decisions sometimes. But the goal of this talk is to get you thinking a little bit about what you can do to improve your chances, because there's things you can do ahead of time, and that's the goal, that's the key, ahead of time. So hopefully this will get you thinking. But first, this talk is dedicated to all of you who may have seen one of these screens at one point in your life, in your careers. Especially frustrating when you thought you got your VMs back online, and you see a screen like, oh yeah, the Windows system recovery screen. That's great, because that means I might have a corrupt image that I might have to go to a different point in time and do some kind of restore operation. That's painful. But maybe it's not clear cut like that. Maybe you have the VMs up, maybe it's pinging, but then you find out from your application owner that something's not working, and you look, and maybe trust relationship, maybe the SQL database is corrupt. Things are going to happen, and is that the right time to kind of discover what you should be doing next time? Probably not. The whole key of this talk, the art of recovery, if you think about what art versus science is, I mean, a lot of times, in a troubling situation like that, you're not gonna use a scientific method to just say, okay, let me try one change, see if it works. Oh no, it didn't work, let me roll back and try another change, keep all my other variables the same way. Chances are that's not gonna happen. You're gonna be under pressure to get your services back online. and you're probably going to be trying a lot of different things at once. You might reboot your VM 2 or 3 times, so sometimes that works, right? I might try a few different configuration changes. Maybe I'm going to make this one configuration change in one app, and then over here I'll do this other change. But ultimately, at some point, you're going to get the application working again. And it took some kind of troubleshooting miracle to get it going. Do you think you're going to document that during a DR event? Maybe you will. And I mean, maybe if you write things down as you do them, you'd probably be better off if you, especially, lessons learned afterwards. But if you don't, chances are this is going to happen to you again. You're going to just do the same steps. You're not going to know what you did. And then when another event comes up, you're going to not be any better for it. So the whole idea is that we want to make this more of a science. That's where the title comes in, because the art is, you're trying a million different things, somehow getting it working, but you're not learning from it. You're not incorporating it to make yourself successful next time. So one of the key things to start with is knowing your applications. And I don't want to get too much into it because my colleague Nick Scola did a really good talk yesterday, and you'll find it online on vBrownBag. But it's about upgrading your tech skills using a business approach, basically becoming a better architect because you understand what's in your environment and making good decisions based off of knowing that information. Because chances are there's applications that you're managing that are more important to the business than others. You have to know that. You have to know which ones are, because that's the one they're going to ask you to, someone's going to be standing over you to get that application up and running. And some things you have to understand is how much data can you lose? That's your RPO. How much time can they wait until you're restored? That's your RTO, your recovery time objective. And sometimes you're going to feel like that answer is 0 in both cases. Everyone doesn't want to lose data, and nobody wants to wait too long to get their application online. But chances are there is an acceptable amount of time, there's an acceptable amount of data loss that you can tolerate, and you have to go find that out if you don't know it, because then you can prioritize which applications you recover. But then more importantly, I think, besides that conversation, you have to understand what goes into that, getting that application back online and usable. I mean, because you might, for your purposes, get it back online and then hand it off to some application team, or maybe you're also the application team, and you're trying to figure out what is online and usable. Does it ping? Does my application have an acceptable response to some kind of query that I do? I don't know. You have to kind of understand that. And there could be that you even got all that right, but then there's dependencies upstream, DNS, it's always DNS, but Active Directory. Those types of things might be upstream that you may or may not know about. You have to know it. There's no other way to do it. But really, this is something you could start doing right after this talk, is thinking about this stuff, writing it down, scribbling it, and kind of just figuring out what's important to my business, because that's going to become important to you. And then once you kind of have an idea of what those applications are, you can kind of break them into different archetypes and kind of go online and search around and find out what happens in different DR situations. I mean, Active Directory behaves a certain way. Exchange behaves a certain way. Anything database is going to especially behave in a very particular way. SQL Server I use as an example. But then there's your app. And your app could be whatever custom business app. It could be some other line of business that's more obscure, that doesn't have a lot of documentation online. But it's your job to know it and know how it behaves. Because there's different behaviors for different types of apps. And if you think about it, there's really 2 different ways a VM can come online when you bring it back online and put it back into an environment. It could be crash consistent, and that might be the most common scenario. And that's where your VM was running and then someone literally pulled the plug. Well, not literally, but you know what I mean? Like they pulled the plug and then that's the state that you have. And some solutions can protect and give you a really good RPO because crash consistent might be good enough for your application. But the thing to know is just because you get that application back online doesn't mean that that's it. Because sometimes applications will behave really interestingly when they come from a pull the plug state. For example, database, you might have to replay some transaction logs, because what it means to be crash consistent is that there was things going on that might have been in memory that did not get written to disk. And what happens there? I mean, obviously you lose what's in memory, but it doesn't mean that the application shut down cleanly. You're going to have to fix it. You might have to clean up some temp files. You might have to go to the database, get it out of a suspect state, replay some transaction logs. Once you understand what your application is, what the different archetype is, then you have a better chance of knowing what you're going to do in that situation. So if you do have a pressure situation, you can actually go in and follow, say, a run book that says, here's how you recover this database to get everything else back online. Then there's application consistent, where if you have the time ahead of time to know that something's going to happen, you can get that application to shut down cleanly, take like a snapshot or some kind of checkpoint or whatever the case of that state, and then say, okay, cool, I have this really clean state that I can bring everything up. I know everything's going to work. That makes my RTO pretty good because I probably don't have to do as much troubleshooting because I know it's a clean state. But the problem, I'm not saying a problem, it's a trade-off, is that you're going to have a higher RPO most likely. You don't have time, especially a database application that might have a lot going on in memory, and memory is being used for performance reasons to give you better performance by caching. You're not going to know when to do that, and even if you do it too often, you're going to affect the performance of your VM that you're protecting. So you have to kind of understand, maybe there's certain applications that you can do an application consistent state where you have some kind of agent that runs and is able to tell the database or whatever server to cleanly shut down and give me a clean state. But you can't do that too often. So chances are you're going to be more likely dealing with a crash consistent state. And that's where the fun of troubleshooting probably comes into. So what do you need when you're going to have fun like that? You probably want a nice isolated environment to kind of learn and play and document lessons learned. Maybe you make design changes to that application or maybe to your virtual infrastructure to support some kind of improvement, so that way you minimize the troubleshooting that's involved. So there's solutions out there that can automate, orchestrate, bring up VMs, tear down VMs. You want something like that. It could be as simple as a Power CLI script that runs against maybe a backup or a replication solution that says, hey, bring up this point in time over here. And then the other key is being able to play around with it in an isolated way, and then just repeatedly learn about how to recover that application, coming from a crash consistent state, let's say. And then you might identify some changes, make those changes, incorporate them into production once you've verified those actually are valid steps, and then make sure to incorporate that into your design, and then repeat. Keep testing, get a good feedback loop where you're continually improving your application, so that way resiliency becomes even stronger for your app because you're learning about how to recover it, and maybe you're able to make design changes ahead of time that really simplify your life when it comes to a real DR situation. And then there's just a quick aside, there's this really great book that I'm using for the next slide to basically inspire this. Atomic Habits is some of the reasons why people don't test is because it's hard to do or it's not obvious. It's not something that they really look forward to. And I think one of the things that can make your life easier, and this is going to be kind of vary in every situation, but you're going to want to make it easier on yourself, make it more obvious to do certain things, whether it's you or some other team that's going to be doing this testing. So use this as inspiration and design with recovery in mind. So you can do things on your DR site to leverage the resources there to do this testing. You can create resource pools so you don't affect production, so you can limit the CPU and memory usage. You can spin up some extra data stores or carve out extra data stores and some scratch space so you can do your testing, rapidly restore, delete, but just have that isolated area, so you're not affecting the workloads of your other applications. And then I think the most important one is networking. If you can create an isolated test network, this is probably hard for a lot of people because you got to work with networking teams, and sometimes they're conservative traditionally, but if you can work with them to say, hey, can you replicate what looks like production but just make it isolated, then you can do more realistic testing. And then a jump box allows you access to that environment. And with that in mind, you can basically do restores as often as you need to, put it on an isolated network, and then just know you're not going to affect anything production. But meanwhile, you're improving your process by learning from the different scenarios that you want to test. And Tom Limoncello is somebody I don't know if anybody knows who he is. He's written some really good books on system and cloud, system adminning and cloud adminning, basically being a good administrator. He's got some really good books, but he has a thing where it says if a process or procedure is risky, you should actually do it a lot. That might be counterintuitive, but the more you can learn, the more you can kind of test these things and figure them out, the less risky it's going to become. You shouldn't avoid this. You shouldn't do a DR test, learn something, and then wait 6 months to implement it, and then find out in 6 months if it works. You should be testing over and over again and reducing the risk by learning from your mistakes, learning lessons learned, incorporating it into your design. And so my call to action, spend time understanding your environment, your applications, start small, do a little isolated test network, work with a few VMs, take good notes, and just have a good process. Build a process that works for you and allow yourself to incorporate these changes into your environment because it'll make you a better admin, maybe a better architect, and ultimately you'll win the day because your application owners will love you because you'll help get their applications back online. And I have some references so I know people online can see them, and if you want to take a picture of this real quick, this is my last slide. So I want to thank everybody for coming and appreciate the opportunity to present at vBrownBag. So thank you very much.
Good afternoon, everybody. I am Joe Hughes, the man, the hat, the legend. So I'm here today to talk to everybody about how to excel as a great mentor and mentee. Again, my name is Joe Hughes. I'm currently a solutions architect with Veeam. I am a community geek and becoming a semi-pro collector of tech communities. Basically, I just like helping people, and I ramble and love to talk. So hopefully we can cut this off at 12 minutes before I get dragged off the stage. So I want to ask everybody that's here, how many of you guys are actively looking for a mentor in your career? Anybody? Right? How many of you folks have actually thought about mentoring somebody else or are actively looking for someone to mentor? That's awesome. All right. It's good to see that there's actually a split in the audience. That's nice to see. So really, the biggest point of all of this is that, you know, you just need to define a goal for what it is you're trying to do, whether you're trying to mentor someone or you're trying to get some assistance and be mentored in this. It doesn't have to be complicated. All you need to do is just, you know, have an idea in your mind and have an open conversation with the other party that's involved on this and what you're trying to do, right? The best thing to do to make this effective is realize this is kind of, it's a partnership. It's almost a dance, right? You want to have some shared experience, some shared background on this, and have good interaction between mentor and mentee. A lot of times, especially when we're thinking tech and tech topics, if it's something that is totally net new to someone, it's really hard for them to understand if there's no context that they can relate new knowledge to what they already know. So if you have a shared interest or a shared background, if it's, you know, mechanics or something that's outdoor activity for those of us that come out of the basement, you know, or just any sort of interesting thing. If you have, you know, if you have interest in music or food or something like that, you know, you can explain automation to somebody by trying to describe recipes when cooking. You know, you can explain the pieces that go into a workflow when you try and explain to somebody that has some mechanical background, like doing vehicle maintenance and stuff like that, right? If you have something that you can build upon that's kind of a common base, then it's easier to pick up new topics and have an interaction and an exchange because you just have this kind of shared language that you can build upon. And then last of all, like, set a timeline. And it's not that you have to definitively, you know, say this is going to be, say, a deadline for a certificate. I must have this completed by X date because I'm taking a test. It's not that. You want to be able to gauge your progress. You want to be able to see if you're really, like, still moving in the direction that you want to go. Or you can just look back and say, oh man, I actually see this is how far I've come in X amount of time. And sometimes it's just a positive for you to realize that you are making progress that is for you and your career and for your benefit. Next slide here. All right. So starting with the mentor, in my mind, the most critical part of this exchange is the mentor, because you are far less likely to get a lot of benefit out of this interaction or be willing to help others if you have a poor mentor, right? If it's a bad experience and it really ends up being somebody who just tries to talk at you rather than work with you and help build you up, then a lot of times you're just not want to hear it. It's going to be like basically being back in formal education where you are the paid student in the room that is just taught to by the instructor and is not really there to do anything other than just regurgitate information, right? That's not what this should be. It's not memorization and feeding it back. This is for you to actually pick up skills and grow. My current thinking on mentorship, a lot of this has actually come out of a book by Don Jones. If anybody else in the room is a PowerShell geek like me, you'll know Don Jones. He was one of the leading PowerShell instructors for quite a few years, and he wrote a book called Be the Master. This all in the end goes back to like the core of thinking about, I think his story that he tells is blacksmiths back in the 14th, 15th century. It is apprentice, journeyman, master. And basically what this thing is that, you know, it's supposed to be a master, somebody who has achieved at least some success in what they do and what they know, that is trying to pass this on to the next person behind them, right? So this whole thing is basically what we would really like to see in the community that we have just get expanded, right? If you look at the vExpert community, if you look at any of the other tech communities that are out there, honestly, if you look at most of us that are on Twitter, when anybody needs help, they ask for it, and tons of people jump in to try and help them along the way, right? You're just trying to formalize this a little bit more and have a little bit more direction around it. So I challenge everybody to be a master, right? It's not about knowing everything. It's about the fact that you are willing to share, right? You don't need to know everything to teach others. A lot of times, like, the most effective tool that you have in this is your unique perspective. You may explain something to someone in a way that is new and interesting or different to them, and it just clicks, right? This might be the thing that makes some new piece of information stick for someone, even if they've heard it 100 times before. Don't limit yourself to technology, right? I'm trying to break out of my norm. Even as a guy who likes to talk, I am absolutely terrible, as you can tell, at giving presentations. I'm better conversationally, right? I like to talk to people and just never shut up. But I'm really bad at trying to extend beyond geeking out with people. So I'm trying to push myself to do soft skills like this. In the end, just be willing to leave behind more than you took, right? If you're willing to share with others, and I need to take my own advice on this one, if you listen more than you talk, a lot of times you're going to be a more effective mentor, because all you're trying to do is get someone, in the end, really, you want to try and teach them how to learn, and then you want to just kind of lead them down the path. They can come back to you if they need assistance, if they have questions, but in the end, you want them to try and figure out how to proceed on the journey on their own. You're just there to kind of help guide them on the path, right? And again, like I just said, teach others how to learn, but then enable them and encourage them to teach other people. Take that bit that they know, that they are now the subject matter expert on this thing they just learned because they just learned it and they're excited and they want to share it with others. Encourage them to do that. A lot of us do this in the end voluntarily anyway. How many of you guys blog? How many of you guys tweet out anything that you have? How many of you guys present at a local VMUG, This is stuff we do naturally all the time, so just expand that realm of influence and share with other people. That's all you need to do. So step 2, the mentee, right? This one is difficult for a lot of people. I myself am one of them. I am terrible at asking for help ever. I will volunteer and I will help someone else to the ends of the earth if they ask for it, but I never want to ask for help. And a lot of the times it's not that I'm stubborn, but I don't want to ask of time from other people. And it's not even so much that most of us don't want to admit that we don't know something. A lot of us thrive on that, and that's what drives us. The fact that we don't know encourages us to go out and learn more and figure things out. But a lot of us are just not very good at having that personal interaction with other people and saying, I need help. That's not a bad thing, right? Be willing to drive yourself and push for this. So commit to the journey, right? It's not about learning everything as a mentee. A lot of times it's just about learning how to learn and how to encourage yourself and push yourself on that path, but then be willing to share it with others, right? Currently, how many of you think you could walk anywhere on the show floor with these 20,000 of your best friends and teach someone one thing right now? Anybody, at least? Hopefully everybody would raise their hands, because honestly, I can tell you every one of you guys would have something you can teach me. As many user groups and communities that I'm in, I am far from the smartest guy in the room. Even in my past work roles, I'm far from the smartest guy in the room, but I enjoy being in those conversations, right? I learn stuff all the time, and I'm willing to say there's something I don't know that I know now, and I'm typically excited about it and want to share it with somebody else. Be open to coaching other people, because that helps you enforce your learning, right? Think about it in the way that a lot of us chase certificates, right? We chase that knowledge that way. A lot of the way that you can solidify that you really know what it is you're trying to learn is by saying, I'm ready to teach somebody else, right? If you're willing to share that, then most of us are to the point that we are afraid enough of passing along that information. We want to make sure we have it down 110% and we're ready to go, right? But all you need to do is share with other people. Most of us are open enough to learning new things and in new topics that there's always something that everyone can pick up. So being a good mentee sometimes is by going back and teaching things to your mentor, right? And also give them feedback, right? If a mentor doesn't know what works or what doesn't work for you, or if you don't have conversations about differences in personality or possibly a change in your goals while you're going through this process, then they're not really going to know how to redirect you on that path. Drive your career and don't be a passenger, right? Your job belongs to your employer currently. Your career belongs to you. If you guys have any desire to learn something new, to learn something different, to totally change job roles, and you want to know what it's like on the other side of some fence, go figure it out, right? Find someone to ask and go find somebody that can be your mentor, even if it's not a formal relationship. Just be willing to ask other people about their experiences And you can make yourself basically kind of, just an anonymous mentee. Resources are always available, right? Look or ask for them. You guys can find tons of stuff on people's blogs, on Twitter, all over the community pages we have everywhere. But this stuff is open and available, and honestly, all anybody has to do is just ask for even being pointed in the right direction. And typically, if it's a good mentor especially, they will even tell you there's a lot of times they don't know something or they don't even know where to find it, but they know someone else, right? A lot of times being a mentee even just means that you have access to a greater network because your mentor may just be better connected than you are. And everybody is willing to share in this community, so take advantage of that resource. So in the end, guys, there's not a whole lot to it. A lot of this is just that I try and encourage people to just make this a community and try and keep this interaction open amongst people. And then, again, just be willing to have conversations with people. Be willing to take feedback, even if it turns into something where your mentor has identified that you have a soft skill that you need to work on that's preventing you from being more effective in what you're doing in the technology side. It could be that you, like me, are very bad at public communications, and that's a skill you need to work on. It makes you more effective in delivering your technology knowledge if you can properly get that message across to more and more people. If you can explain it in a way where you have that common background, you have some context that you can link to something that they already know, it's more effective, that message gets delivered and is more accessible to more people. And then again, as a mentee, just be open to the suggestions and the advice that someone may have. It may even be that they don't want to spoon feed you information, but they want to show you, there's a reason I think you should not do this because I've had a bad experience or I tried this and it was bad for me. If you are just open in the communications and you don't have assumptions about what has gone before, or maybe that, things that you just think are correct just because you believe it's that, just by getting more interaction between mentor and mentee and open communication, you can find out there are reasons that they suggest you do something or don't. And again, give feedback to mentors, make them more effective to help other people down the road. And in the end, be willing to help each other. Don't assume that you've got to be a professional or that you've got to be an apprentice to be either a mentor or mentee. We all go back and forth on any given topic. There's a good chance that you switch roles all the time. Just be willing to share with other people and be willing to take a long journey with somebody. That's the big thing, is just ask for help and then help others. So thank y'all.
Okay. Can I stay here? No? Hello everyone, my name is David Santos. I'm an NSX engineer based in Brazil, and today we're going to talk about NSXT and what we can do about security. So the benefit of NSXT is that we can enforce security without changing topology. We can enforce security on VMs, we can enforce security on pods in Kubernetes cluster, and even in bare metal service. So if you need to enforce a policy, we do this in the closest communication within the application, whether a VM or a cluster, a Kubernetes cluster. This is delivered by the distributed firewall that we can deliver the features on-prem and also in the cloud. Today, we can deliver that on AWS and Azure using agents installed in the VMs. And probably next week, we're gonna do that using the native security groups that are available in Azure and AWS. We're gonna have the option to choose, either using an agent or using the native security groups. So, how does it work? It's pretty simple. We create a group that can be made of VMs, containers, labels, and networks. And basically, the group includes and excludes objects in the dynamic way. For example, we're going to create a group called Web that will have all the VMs with the secret tag the tag web and scope security. So here's the NSXT UI. We have two VMs here, Web 1 and Web 3. We're gonna apply the tag in the first VM, then we're gonna do the same for the second VM. And after that, we're gonna create a policy of membership, a membership criteria. We're gonna create a group and associate the membership criteria of this group with the tag. We can choose here either a VM, a logical port, which is a container, or a network, or anything. After that, we can see that our VMs are inside this group, and you can use that in our distributed firewall. The next demo, we'll talk about how the distributed firewall works. So here we have two VMs with the tags, and our group is already created. We're gonna create a rule that will block all the communication between VMs, allow external access HTTP, and block anything else. That's a pretty basic rule. So here we are in the Web 1. We are in the subnet 131 with 11.11 is my IP, and I'm gonna create a policy that will block the communication between those VMs. So I'm gonna reject everything. And the destination will be my security group. And I'll change here from allow to reject. I can also use drop if I want. At this moment, all the traffic will be rejected. Either the pings or the communication, the outside communication. We're gonna tune this rule now. We're gonna add two more rules. One, blocking all the communication between security group to security group. It's really nice that we have a drag and drop here, and it's really easy to manage the rules. And the second rule, we're gonna allow the external traffic HTTP. My communication between VMs is still dropping, but I can access the VMs now from external access. And if I try to do a SSH, it will drop too. Nice. And about Kubernetes, how does it work? So Kubernetes integrates natively with NSX. Basically, Kubernetes will deploy the pods, and NSXT will deliver the network components, such as firewall, layer 2 networks, layer 3 networks, like the full gator for these networks, NAT rules and routing rules when they are needed, and also the load balancing. So the tags are also native. So you deliver routing switching, SLB, distributed firewall, and visibility. In this demo, we're gonna deploy a Kubernetes. We're gonna deploy a namespace, and on top of that, application. So I'm gonna create a namespace in Kubernetes, and for each namespace that's created in Kubernetes, you will deploy a Tier 1 gateway, that is a router, and also a layer 2 switch, an overlay switch. After that, we're gonna log in the namespace that we just created, and we're gonna create our application. I have the application here within, with and without the labels. So here's the application without the labels, and now the same application with the labels that we are gonna use to deploy the microsegmentation. So with this single line, we can choose which group that pod will belong to. Here I can see that my pods are being created. And I can check those in NSX too. We can see that they are attached to the logical switch already. All the pods that we just created. And also they are part of the security group that we have configured here. Now we're going to create a service and ingress to load balance these containers, and all the components needed to this load balance will be done in NSX2. We're going to create a port on service on port 80. And with those labels, they are they will load balance, the ingress will load balance to the containers. We can check here in the load balance that our pods are already in the pool for load balancing, and we can check the application that's working. If I refresh the website, I can see the load balance among the pods. And this application has a port scan inside the pods. So I start a port scan, and we can see that port 80 is available. Now we are gonna enable the rule that will reject the traffic between the pods. And we run the test again, and you can see that we deploy microsegmentation between containers. That's really nice. And the application is still running. And the last part, we're gonna deliver the security on cloud native workloads in Amazon and Azure. For this, we need to deploy, in addition to the NSX Manager, a component called Cloud Services Manager, Cloud Service Gateway, which is the component that talks to AWS and Azure. Besides this component, we also need to deploy a Cloud Service Gateway on each of those public clouds. The first step, after deploying the Cloud Service Manager, integrate that with the credentials of the cloud. We're going to deploy here the NSX Cloud Gateway. It's pretty straightforward deployment. We choose the certification file. And then the network configuration, the availability zone where we're going to deploy that. After a few minutes, it will deploy. It takes around 5 to 7 minutes, depends. And here you can see that's already a managed VM on the cloud. After the deployment of this component, we need to install the agents on the VMs. So we're going to install the agents in the VMs. In the new version, it's not needed anymore. If you want to use the cloud native security groups, you can. You have the option to choose. And now we're going to create the tags on the cloud portal, actually in my AWS console. I create the tags in the cloud, and I'm going to consume these tags on-prem. So I can see here that my tag is already on NSXT UI, and I'm going to use this tag to create a security group. Now I'm the security group. 1 minute? Okay. I create a security group, create a membership criteria using the virtual machine, tag 2019, tag VMWorld, scope 2019. And here I need to include this and I need to include two parameters to identify that that tag is from AWS or Azure. After that, I create a rule using that security group that I just created. I'm going to do some tests here, try to ping my application, it will work, I will publish the rule, then at the same time it will drop the traffic, and also if I try to access the application, it will not be available. Then I'm going to disable this rule that I just created, and I can see that the application comes back and also the pings. So that's all that I have for you guys. Thank you very much. I hope that you enjoyed that.
Everybody, welcome back again for day 3 of vExpert Daily here at the, I guess, no? Are we not? Yes? I was like, I don't. Can I keep going? You want me to start over? Cody, you're killing me right now. Okay, we're just going to go. We already started. I'm not. So we're here at the social media and VMware community stage now because they needed a longer name to put up here. Again, I am Mike Letchen, one of the principal technologists at Cohesity, but as I've said many times, more importantly, I am an 11-year vExpert, I think, at this point. Well, there were 12, right? 12 is max, I think. I didn't do the first year, so I think it's 11. You don't, yeah, it hasn't made me any smarter. But so, as we've done many times, this is kind of a little chat with some fellow vExperts on what's going on, what they saw. And on Wednesday, the one thing we always do is what people at home that may be watching this should look out for, they should talk about, they should pay attention to, maybe some tips and tricks, or why they should be here next year, whether they could make it next year, as well as even into Europe. But before we get into all the details, it's introduction time, because you probably have no idea who these people are. Or you do and choose to forget. I'm not sure which. Jack, why don't you start?
Thank you, Michael. My name is Jack Benny. I work in the office of the CTO for IBM Cloud. Basically created what is now VMware on Cloud back a long time ago. I've been smuggling VMware into agencies and enterprises since 2001. I was VCP 5210. Back in the Elastic Sky days,
You're old. That's what you're telling us.
I have
you're
a
old.
beard. People say that I look like Santa Claus. I grant wishes sometimes.
Santa Claus? Your beard's not white enough for Santa Claus.
Well,
down the bottom maybe.
Give me another, couple months, and we'll get there.
Okay.
Yeah, glad to be here. Thanks for having me.
Well, thanks for joining us.
Appreciate it.
Shane,
hey,
you didn't tell people.
How you doing? Good to be back. Shane Williford, vExpert 10 years, I guess. 9 years. 10th. Well, I don't know. I've done just about all these.
Yeah, I think almost every year you've been on at least once.
So
I can't get rid of them.
Yeah, whatever. Senior systems engineer in the North Kansas City School District area. VCP, VCAP, Beam, kind of all
Blah,
the
blah,
above.
blah, blah,
Yeah.
blah. Gotcha. Dave?
I'm Dave Stevens. This is my first year as a vExpert.
Really?
Yeah, I've been doing stuff with VMware for ages, but first time I've just gotten off my butt and decided to
apply.
To be expert. So I work for a little bit about me. I work for HighTrust. I'm Chief Solutions Evangelist and Architect, so that means I do whatever the heck my boss tells me to go do, which means to do events like this, go to local vMugs, user cons, go present at different big conferences that aren't necessarily just about VMware, but they involve security, and so that's a little bit about me.
Awesome. Well, welcome, guys. Thanks for joining us. So we tend to do this kind of chronological, and we've hit the first couple of days, but we'll start with kind of yesterday during the day, I think. So did you guys hit anything particular jumped out? A session you went to, or a hands-on lab you might have done, or something in the solution exchange? Anything during the day that really jumped out? I wanted you to, that somebody should hear about or make sure you try to do?
Yeah, actually, a couple. First, certificate management. Who likes certificates? Why don't I see
You're a
any
weirdo.
hands, right? So Mike Foley did a session. Mike Foley did a session on Monday afternoon, late afternoon, on changes that are coming in certificate management. There will be one certificate to rule them all, just the SSL, machine SSL cert. And like the solution users, you won't have to worry about that. It was only tech preview, so there's no guarantee it's going to be in the next release or anything like that. But
blah, blah, blah.
This is beautiful. We might do this. I could be completely lying. There's actually no software behind this, so we're going to tell you about it.
But you know, making that tedious
You
but
laugh
needed
because you know it's
task.
true.
So true.
Making that tedious but necessary task simplified was pretty cool
Nice.
to see. Yeah.
Okay.
No, I'm not I'm not as special as you guys. I only have an expo badge, so I don't get to go see the presentations or anything that's going on. Kind of sucks. But
So what'd you see in the expo then?
I get to play a lot in the expo and do a lot of standing all day long. And
Your feet are killing you.
Yeah, my feet are killing me. My ankles are killing me. I'm looking forward to sitting down soon. At least when I get on an airplane tonight. But the one thing I did notice, I'm not an MBA guy, but Rubric had Clay, I don't remember his name, but tells you just how much I pay attention to
You're
NBA.
clearly not an MBA guy.
Yeah,
if you
yeah.
can't even remember the person they had.
Clay something, I believe. But
Does anyone know who they had? Clay Thompson.
Clay Thompson. Okay, so I got the first part right. But yeah, he was there.
I didn't see him. I only go to vendors I care about.
Yeah. And there's a ton of stuff going on in the expo right now. And the one thing I want to say, not necessarily about the expo, but if you didn't pick it up, and I haven't been able to watch what happened the first 2 days you guys did this, but anyone out there watching this, if you are not familiar with Kubernetes and you think that's something that's going away anytime soon, you are just kidding yourself. It was all over the keynotes, and so you need to start thinking about that. And
All over the floor. For
all
people
over
talk
the
about.
floor
Yeah,
as well.
for sure.
And a little plug for my own session I'm doing in about half an hour here. It's going to be a VM admin's cheat sheet to Kubernetes. So kind of take some concepts that you know about, that we all know and love about VMware and Virtual Center and everything that we know, and then kind of relate that to Kubernetes. So
Nice.
Kubernetes, start learning now.
So if they're around, where's your session at?
My session is going to be right here in 30 minutes.
Oh, like one of here. These.
Yeah, like here.
Oh,
Yeah, right here.
That's an easy one.
Nice.
Yeah,
It's
yeah.
easy.
You don't
Just
even
stick
need to go
around.
anywhere.
How about you, Jack?
All
What'd
right.
you see?
So what have we been doing? So one of the things that I noticed right away was, when you've been doing this a long time, you start seeing cyclical patterns, right? What particularly brought attention to my mind? So I did do a presentation. It was HBO 3381BU, which is applying machine learning models to day 2, reduce troubleshooting, headaches, etc.
I don't know if I'm more impressed that you remember the number for the session.
Yeah. So look that up.
Or to be able to do the session. That's
Yeah, did both.
learning.
Yeah.
I was probably just going to search for Jack.
Jack Benny. In akin to that, right? Like, there's a lot of really cool innovators, right? The innovator booths that are back there. I had a chance to kind of walk through and kind of see, what the bubbling up type of things were. That's impressive. We're seeing a lot with putting more eyes on security, compliance, and then, because we've kind of solved like automation, like actually deploying a platform, right? That's kind of, been working for a while across many different providers, including ourselves. But now it's getting back to the roots, right? Getting back to the, is this the right way to do things? Is this the best practices, et cetera? And I see that from different vendors coming in that are trying to address those specific markets.
I know of a company that can help a lot of folks out
Well,
there.
we've been.
Who would that be?
Yeah, we've been with High Trust right
Symantec?
since the beginning. So yeah,
Couldn't make it that easy on you.
honestly, in San Francisco, the one thing that you're supposed to do is go get some good Chinese food. So I did that.
That's what you think the one thing you're
That
supposed
was
to
the
do?
one thing.
That's what you were told?
That was the.
It wasn't go see the Golden Gate
My
Bridge.
wife
It
told
wasn't
me-
like see
my wife
Alcatraz,
told me-
the sea lions. It was go have Chinese
She's
food.
like, you can take a swim over to Alcatraz if you like. However,
Your life insurance was paid up, so go ahead.
So yeah, and I don't know. Have you guys been? Have you got any sleep at all since?
Yes,
No,
actually.
I'm running low. I'm running low.
By the end of last night, I was pretty struggling.
Oh, yeah.
Last night I got some sleep.
I'm looking forward. I usually don't look forward to red eyes. I'm looking forward to my red eye tonight. Nice.
Okay, so we had during the day, then you got to all that. You got some Chinese food last night.
Some Chinese.
What'd you guys get into last night?
Veeam party.
Veeam party?
And how was the Veeam party?
It was good.
I did not go to
As
the
a
Veeam
Veeam
party.
Vanguard, was able to
who
get
was playing?
VIP access. Andrew.
Oh, see, you guys all made fun of me for getting the name.
He was good. Well, I don't know.
The name I forgot was.
If they're not from the 80s or below, I don't know.
Who played the Veeam party? Anybody know?
It was some new band, right?
Andy Grammer?
Andrew Grammer, yeah. I was going to say
It's just
Graham.
Andy Grammer. I don't think he goes by Andrew, does he? Pretty sure it's Andy
well,
Grammer.
see, there you go.
Pretty sure it's Andy Grammer.
But he put on a decent show. It was a good show. It was a good show. Great venue. It's
Lot of
a
flashing
Masonic. So yeah.
Was that the Masonic?
It was.
Oh, that's a good space.
Yeah, it was a really good space.
What'd you do?
So who got to go to the V Expert party last night? Because I
had to go to. Cohesi had
stuff
Hamilton.
going
I went
on
to see
and I could
Hamilton.
not go, unfortunately.
So
yeah, that is the first time I missed
We
that.
went to the
in a
VXP
while,
party.
But
And
Come here.
good.
Come here.
You play ping pong, nice.
the expert
How
party.
was the V Expert party?
It was good. I mean, it was. Now I have to stand here.
Well, yeah, because that way the glare blinds them.
So I did go. It was cool. No, I mean, it was. It wasn't the pinball place, which was different.
Have you never been to a pinball bar before?
No, it's always at Pinball Hall of Fame, right? When it's in Vegas.
No, that's in Vegas. It was pinball.
No, but it was.
The mechanic was it the Mechanical Museum a couple years ago when it was here?
A couple years.
I think
yeah.
But it was. I think it was. It actually, to me, it seemed a little bit light because I think there was everything else going on. Because Veeam started at 8. I think Tintry had a party at 7. Hamilton was at 7.
There were tons of parties going on last
the
night.
same night.
So
But
it was
so
virtually
yeah, it
impossible.
actually it felt a little bit light, but it was good because you could actually talk to people, which was nice.
Well, good venue, good time.
Yeah. Spin wasn't bad.
I don't know why I brought you up. Your answers are horrible.
Well, I don't know.
Yes. Thank you for elaborating.
Like the honesty.
Thank you.
I did see pictures. Pat was at the party, so
Pat, yeah,
he made
Pat-
an appearance.
I've been trying, and there's like nothing I can do with this. I don't know. I know you guys haven't slept, but this is really hard when you're not providing anything.
I was the one guy who got 8 hours of sleep because I called somebody. I'm like, I'm going to bed. It's 10.
Well, what about you?
That's
What
also
what
because you're like
you do
80.
last night?
Yeah. So
What did you do last night?
What did you do?
I went to see Hamilton.
Yeah, he went to Hamilton.
Oh yeah, right. Hamilton.
Cohesi rented out, had a most rent out of Hamilton, mostly rented out theater for Hamilton. So
I heard it was a good show, though. I mean,
it was phenomenal.
If my wife was here, I'd have went. I just didn't really want to go.
I'm probably now going to have to take my wife to see it, but she wasn't that worried about it when I initially said I was going to see it. After seeing it now, I probably need to take her. It was really good.
Yeah.
It is as good. I had pretty high expectations, and it's as good as I expected, if not more.
Yeah.
So.
Good.
Okay, so let's get into more. You can leave now.
Wow.
You're done.
You can stay if you want, but you could probably leave.
So Billy Idol tonight? Is that what is that the
So
scuttlebutt?
here's my concern. I've heard, so it's One Republic and Billy Idol.
Yeah.
Yes.
I don't know.
So
what
number one, One Republic, I could care less. They had like 3 songs in like the early 90s, I think, right?
I never heard of him.
I know one song.
But it's
That's
Billy
it.
Idol.
Might be one song. Can you sing it, Shane?
Too late to apologize.
Oh, that is. Wow. The panel finally got good.
With a rebel, yeah. Oh, she wants more. No? That's way better.
No,
That was better, yeah. Okay,
Not
so
topping that.
We're editing that out, right?
One Republic, we clearly know it's. But Billy Idol, I heard Billy Idol's really good, when you see, but I always worry about when it's an act like that, and like, because it's never the same at a tech show.
Yeah, your expectations are
You
always
never
up
get the full show.
Yep.
Right.
Well, I've heard, my wife, she used to work at Amoeba Records in LA, in Hollywood, right? And
You were around the music industry. Shocker.
no, do say. Well, so anyways, Billy Idol is very well known for having a high performance packing punch and exactly what you would expect to go see Billy Idol. That's what you'll get. So I'm looking forward to it. Now, One Republic might leave.
I'm sure One Republic will probably be first.
Oh, they're supposedly the headliners.
They're
That's
supposed
why,
to be, yeah.
that's what blew my
I thought it was the
mind.
other way around.
Yeah, Billy Idol.
Tell
and
how
then
much I paid attention because
What?
I'm not going. I'm getting on an airplane and going home.
Hi, One Republic.
So a DJ first, then Billy Idol, then. Okay, so we're gonna move on. Anything else at the expo floor before it closes that people should go see, or what do you suggest? How should they attack that floor? It's a lot of floor.
Well,
I'd attack it from the center.
You go center out?
Yeah, center out.
This has
and-
been a debate over 3 days. Which way you go, center out or outside in?
I think always at the big shows at VMworld, you need to start at the center and work your way out. That's where all the big vendors are going to be. They're you know and love, and probably all of us have some of their hardware gear in our labs or in our data center somewhere. So start at the center, work your way out, and then at that point, my opinion is, what's the technology or the problem you're trying to solve this year or this month or this quarter, and then try to find the vendor that's going to be able to help you with that problem that you're trying to solve today.
Right. I mean, just to piggyback off that, there's advice given me several years ago. Have a plan based off what your company goals are.
And comfortable shoes.
Or recently
personal
somebody
goals.
told you that the best way to do it was have a plan? You're
Several
just now getting to
years
that?
ago.
It took them 10 years to figure it out.
Still trying to figure out what the plan is.
What a terrible strategy.
So based off what your company is trying to do or any personal tech goals that you have, go speak to those vendors. Certainly make sure you make your way to the outer rim vendors. They're really good.
There are a lot of small vendors.
They just don't have the money to
That's right.
have the big booths. It doesn't mean they don't have a good product. So make sure you hit the outer venders as well.
Yeah,
I
there's cool tech on the outside. There's a lot of cool tech. There are the smaller vendors, like you say. They're no one to pass up. You definitely want to go check them out.
I want to piggyback off the Kubernetes comment that he made before. It's like I always want to comment on SMBs because that's my background. That's where I'm at. Kubernetes and cloud is, even to this day, mostly for SMBs, is just still not mature. Just not something, a small infrastructure. I have a large org, but a small infrastructure, something that it's just not cost effective, it's not cost beneficial. But there are some little pieces that now that we're starting to look cloud solutions, a small vSphere Citrix-based VDI solution with Teradici maybe going to AWS Cloud. I have a couple developers. We don't do custom apps, but we customize the apps that we have from vendors. And so we were talking about, well, how can we deploy this faster? Kubernetes.
Yep.
So there are some things that you can look at to start learning. It may not be what the show presses and take the, I don't like how VMware or EMC or whoever presses upon people that, oh, this has to be it and this has to be whatever. Just take a step back, look at it from a different perspective. Again, going back to goals of your organization, and then see how you can best implement using these new tools and maybe for career advancement or whatnot. But anyway, I just wanted to touch base on that.
You
It's
always
not
do bring
necessarily
an
for
SMB
everybody.
spin, so it's not,
Yes.
it is a change. A lot of people come up here and they're very enterprise heavy.
Yes.
Which a lot, I think, of the stuff is focused on. too.
Well, it's part of that application modernization journey too, right? Like I think being able to quickly consume certain, container-based services or whatever for new applications that are being created, right? There's still going to be a lift, shift, transform for native or legacy type applications, but having the ability to have a landing zone for new creation is one of the methods of really taking advantage of that container space to have that consistency deployment
Right.
across the board and be able to scale up and scale down very, very fast. But that's all part of, looking at what applications are specific that leverage that, right? And then not only, a lot of enterprises, big, even small, they're hesitant to move off of applications because applications are the king, right? So they have certain things that they've modeled their business around. Being able to dip into containers now opens up a door, which was previously just OS, application stack, right? So that container, splitting away actually is very, very valuable from a development perspective, and including moving forward towards the future where it will all end up being.
Right.
Yeah.
Right. So you guys have all made a few VMworlds in the past. This isn't your first VMworld for any of you.
Yep.
How do you think it compares? Do you still think it's valuable for a newer person in the industry to be out here, and how do they get their most out of it for people that maybe aren't here this year and are trying to justify it for Europe or justify it for next year? Is it still as valuable many years later? Is it still valuable, do you think, for somebody new?
I think for someone brand new coming in here, if you're watching this and this is your first VMworld, look back on what you saw at the show. But I think if you're considering going to Barcelona for the first time this year, or you didn't get to go this year and you're looking to go next year, I think continuing to go at VMworld, even though if you've been going to it for quite a while, you may say, there's not much going on. I see a lot of same stuff from the vendors here that are here that I saw last year.
Same people, different color shirt.
People, yeah, exactly. I've been at this. I knew this guy. He's
true.
Yeah, and people moving companies all the time. I think the biggest thing that I get every year out of coming to VMworld is not only seeing friends that I only get to see once a year, see folks from the community, folks that you can learn a lot from. You definitely want to go online and get active in the V community and just the space where we are right now, social media space. No one can see behind the cameras here, but there's a huge area for folks to just hang out and interact with folks, and don't be afraid to make the first introduction to somebody. You never knew who you're sitting beside.
If they're still trying to get here, I think saying to your boss, hey, I want to go there to go meet people is a little harder.
It is.
But there are ways to try to get a spot standing up here.
That's right.
They can submit for. I think that's important.
Right, yeah. So my take on that is, I think conferences, just like technology, is cyclic, right? There's highs and lows. When I first started, this is my 10th VMworld, 10th year anniversary, yay. vSphere was it. That was it, just the basic stack. Then cloud came along, software-defined data center. Now we're into Kubernetes and containers and cloud. And so newer people that come to this show, they're coming into that. They may not fully realize what we came into. So yes, there is value in that, as well as community. The V community goes beyond VMware. It's beyond technology. It is a technology-based community.
I have a lot of people here. Still, some of my closest friends outside of this.
Yeah. Yes, are from
some
the
I want
community.
to punch.
So those two things, and then just to
It was Tim. It was Tim.
And then just to touch on your point, there are other ways to get here. Blogger passes, company raffles to get passes, and that kind of thing.
But I even think if you have something you're working on in your environment and you can show it,
yes,
and you're willing to talk about it, submitting to even, you get a 15-minute session up here, it's a lot easier to look at your boss and be like, I need to go, I have a speaking session.
Right.
It doesn't have to be a 45-minute full session.
That's right. No one says it has to be.
No one asks how long normally when you say that.
Massive technology. It can be something very simple. I remember last year, and I think it's still kind of going on into this year, is how to move up in your career advice. That's a huge thing going on right now, even on the vMugs.
So there's a 12:30 session, PD 3489 on work-life balance.
Yeah.
Just plug my own panel.
We just got the hand sign from Cody.
Okay.
Yeah.
I figured we were getting close. We were able to do one, and so Chris is on it. After we finally apparently have to do a panel with him again. Hopefully it goes better than the first one.
Thank you.
All about work-life balance, though, because that was part of it. It's such a big issue now.
That's right. Yep. Yeah, and piggyback on what Shane said, blogging. You don't need to be a blogger that puts something out every day. You just need to be willing to share what it is you're learning, because there are people in your exact same shoes. If this is your first time here, that are just sharing their information out there.
I started my blog to remind myself of what I did.
Yeah.
So I could go back and look at it after I did it once the first time. Because,
right.
I mean, much like Vic, my memory not so good. Okay, as we're wrapping up here, well, normally you're heckling me, so I figure it's more fun if I heckle you back.
You can tell that.
I'm sorry, do you not remember why you got into this discussion?
I've never seen reverse heckling before.
I know, I like this reverse heckling.
So much easier.
We'll have to make sure we do this next year.
Yeah. What's your one tip that you would give people that are either looking to come next year or here, or what to do actually from now until next year? What would you tell people to do that you can learn from your experience here?
Definitely go to the VMware communities, get involved with the VMUG group that's local to your area, and start just getting to know people. And that's one of the benefits of these type of conferences. Yeah, there's great sessions, there's great technology, there's great information being passed, but the relationships that we build here are what drive us and keep us sane.
And often drive our careers, to go back to that.
Exactly right.
I would say social media, Twitter. Get on Twitter, get active, start following community members, and then follow a path that you are interested in, some kind of niche. Maybe blog if that's your interest. Again, doesn't have to be every day. Could be just a reminder thing, but social media is huge.
Yep.
Last tip.
And then last tip,
I got 3 more minutes.
Don't be afraid to do one of these 15-minute sessions. There are longer sessions out there. Doesn't matter what the topic is. If you feel passionate about it, then you should come up here and do a presentation, just like many other folks are doing here this week.
Perfect. Awesome. Thank you guys so much. We're getting yelled at to wrap up. Thank you again for all coming for vExpert Daily. We will be back in Barcelona, and we'll probably be back next year if all goes well. So have a great rest of the day. Stick around the stage for.
Good morning, everybody. My name is Gina Rosenthal. I'm going to talk about Kubernetes myths in actually 13 minutes, I was told. That's all I have. We'll see if we can do it or not. I'm a product marketing manager at VMware in the vSphere BU. I've worked all over the place in the Federation especially. I used to be a sysadmin. I live in Austin now. I love my dog, Fred. I'm G-Minx, so if you have any, you want to comment, heckle me, whatever, you can do that there. All right, let's get right into it. Myth number 1, Kubernetes is magic. Is it really? Let's backtrack. I like giving definitions when I'm starting to talk about things and learning about things. What's Kubernetes? So according to the Kubernetes page, Kubernetes is a portable, extensible, open source platform for managing containerized workloads and services. Okay, that's great. What's a containerized application? Let's go there. So this is a definition from TechTarget. What they say is containerized applications are an OS virtualization method that allows multiple isolated apps to run or services to run on a single host and access the same OS kernel. So it's basically containerized applications are containers usually that make up an application. So instead of having a monolithic, everything's in one software package, you'll have a container that runs the login service, a container that talks to the database, a container for every single piece of it. What's cool about it for developers especially, and for us in the long run, is that if the application needs to be upgraded, you upgrade the piece that's in the one container. So if only the login service needs an upgrade or a tweak, they just fix that and it works with the rest of it and it's good to go. I guess I should stop really quick. How many people here are there any developers in the audience? Okay, good. So is everybody kind of like an IT admin, BI admin? Okay, perfect. So we can talk about the devs openly and it'll be okay. I won't hurt feelings. So containerized another thing to remember about containerized application is it includes everything it needs to run. So all the files, all the environmental variables and libraries that it needs. And that's because of the properties of how containers work, and we're going to talk about that in just a second too. But because of this, because this is really just an application built a little differently in a more modern way that makes it easier to upgrade and improve upon and run. It's still an application. It still generates data. It still is going to need data center hygiene applied to it. So we know how to do that as ops people. We have a lot of experience. We have all the scars from doing this in the past, right? So the big buckets are usually security, backups, disaster recovery, and monitoring. The way that we do those things may change a bit and when we support containerized applications, and the methods that we use may be different and call different things, but it's all data center hygiene. All the stuff we've had to do before is what we're going to have to do going forward to support these types of applications. So myth number 2, containers are more secure than VMs. Does anybody think that in this audience? No. And let's have this origin story of containers, right? Let's go through this just real quick. And of course, because I'm word girl, I'm going to do a little vocabulary break. What's a hypervisor? What's a container? The difference is, hypervisors virtualize at that hardware level. So one thing it will do is abstract the machine components and the OS away from the hardware. Abstracts it away, right? Containers virtualize at the OS level. It abstracts the application away from the operating system. So with that basis, let's talk about where they came from. Does anybody remember IBM MVS? Oh my God, 2 people. I don't. I wasn't around. So that was really the beginning of containers. They had a container technology with that. The very beginning from not x86, but from a not mainframe perspective, is Chroot. How many of you guys have used Chroot? Right? Usually you use Chroot to allow someone to log into your box. Lots of times for SFTP, that's how I always used it. You give them a specific place on the file system where they're allowed to be and specific things they're allowed to do. That is the beginning of where the idea of containers came from, was Chroot. Right there, when you think about that, you know that it can't be as secure as a VM. It just can't from the where it comes from. So everything since then, they've built on to that idea of isolating things in a file system, a section of the file system, allowing people to have access to that. They just started building things to it. So BSD jails were in 2001. They gave it a little bit more security. You got an IP address that you could reach instead of having to navigate a file system. Then after that, Solaris containers. You remember Solaris containers, right? This is really where containers started. It started segregating the file systems and gave more resource controls to zones. And what the resource controls did was said, okay, you can come in here and you can run these commands in this part of the file system, but I'm only going to give you 25% of my memory, or whatever the controls were. Linux containers, LXC, they were important in the history of this, because this is where the idea of namespaces came from. So you've heard of Kubernetes namespaces. This is where that originated from. And that just gives a little more segregation. And C groups further expanded on the idea of being able to control how much resources were allowed to run in the container, so the container processes didn't overrun the rest of the box. And then let me containerize that for you was Google containers. And this was an open source version versus Solaris or BSD. And this abstracted C group support even more, gave it some QoS, so it added more management features. Docker also came around in 2013, and this is an open source project that helped automate the deployment of apps. So this is where we started thinking, well, okay, if I can put all these different containers together, that's cool to make an app, but I need to make sure the login comes up before the database can. And so it has to come up in a certain way, and be able to add containers as the demand for the application grows. That's how all of this works. It started with Docker with an automation and deployment platform. And of course, Kubernetes is turning into the de facto right now. I just want to point out that it was back in a couple of years ago, it was Docker. And you look at the dates, Docker was 2013, Kubernetes 1 came out in 2015. So this is where everybody's kind of settled right now. So that's something to keep in mind too. All of the container stuff is new. It's such new technology. You're not that far behind if you haven't, really delved into this yet to figure out how am I going to support my developers and my engineers. So Kubernetes, I put 2015 because that's the date of version 1 that was available outside of Google. But this is how Google ran containers, so it was around a little bit more. And we know that the founders now actually work for VMware, which is pretty cool. But having said that, no matter how we deploy these containers, how we automate them, and all of this, it's still going to need some kind of data center hygiene, because the containers aren't going to sit up here, and even Kubernetes, even being when it gets put into vSphere, it's still going to sit up here. That's going to be this playground for the developers to build like they do in a public cloud. Somebody, even in the public cloud, ties that and nails that down to the ground, and that's what we do as ops. And so that data center hygiene, even if it's in with different tools, even if we call things different, that's what we're going to go with. That's what we're going to need to do. All right, so that leads to the final myth I want to talk about, that Kubernetes is just for devs. All right, so like I just said, we're ops. We manage the applications. We manage that infrastructure. We build the infrastructure for them, and we're responsible for the data that gets generated, because if something goes down and it's not available, who are they going to run to? Us. If the data is missing, who are they going to run to? Us. If there's an intruder that gets in, who are they going to run to? Us. This is why it's important to understand what the containers are, to understand what Kubernetes is, then to figure out how you're going to work that data center hygiene into your operations to support your developers. So it's important to understand it. And with the announcement of Project Pacific and having Kubernetes as a first-class citizen in vSphere, it's actually a pretty cool tool, right? Because now you have a tool to give everything to the devs that they expect in the public cloud. It might be a little interesting. You're going to have to figure out there's a concept of a site engineer or a platform engineer. Have y'all heard of that? Basically, that's the person that manages this entire containerized structure. And before, all they've been able to talk to, they've never talked to the IT people at the cloud, because you don't get to. Now they'll have you to talk to, and you can design this and make this platform just how they need it to be. Or maybe you'll turn into the platform engineer or the SRE. And this is the whole thing. It's all great, but you still have to protect everything we have at the same time. You're worried about how are we going to fit this into our current processes, but just put down the scotch. It's all good. Remember, DevOps, they want that agility, and now all of a sudden you have this tool with our discipline, our ITSM discipline that we've all got those scars from. You know how to keep that data center hygiene going. We have this shared heritage. The container the devs ran ahead and built the containers. We now have hardware and systems in place that can support it. We just have to remember that we're all in this together. And it'll be cool. I have to have lots of Momoa pictures, that's my thing. So that's all I have. So if you want to connect with me, I blog a couple of different places. Gminx on Twitter is the best. And I'll stick around if you have any questions. The end.
Afternoon, my name is Andy Banta. I am the storage janitor at NetApp. I am the actual only storage janitor at NetApp. So I'm here to talk to you a little bit about private clouds, how to build them, how to use them, whatever else you want to do with them. Ask questions along the way, however many of you are here. I'd be happy to answer them simply. So this is for you, not for me. Let's talk about what you need to actually build a private cloud. You're here at VMworld. I'm guessing you pretty much know about compute virtualization. Storage virtualization would be the next step, the idea that you can actually take some storage and divvy it up in a way that's meaningful to a bunch of different clients. Network virtualization, same idea there. To make it into a cloud, to make it serve up services like you do with AWS or Azure, you need to have self-service automation. So you need it to not have admins that are going to be doing IT ticketing for you, taking care of all the different things. You also need your IT department needs operational transparency into this. Since people are self-serving services and utilities for themselves, you need some way to make sure that the IT department can actually see what's going on. On top of this, you actually need some way to make sure that the customers that are using it are getting charged appropriately for it, and they're not overusing resources, not using more resources than they should. Let's jump into network virtualization. I'm pretty sure you understand ESXi and how compute virtualization works. I'll get into a little bit about how Element does storage virtualization, network virtualization. If you're using VMware, you're already doing a little bit of network virtualization with virtual switches. NSX takes this one step further, allows you to actually do software-defined routers and be able to segment out your system so a bunch of different tenants can be sharing it all at once without interfering with each other, without causing damage to each other, without causing all sorts of other things. So basically it separates it out into separate blast zones. In addition, it allows you to distribute this across your entire data center. NSX is a little bit of a pain to set up, so One of the things that we did at NetApp was actually build out a couple Python scripts that allow you to do it a little bit better. So one will deploy an NSX manager. This one here is deploying our NSX controllers. It actually spells out what various different arguments you need to do this, making it a little bit easier so you don't actually need to go out and figure things out as you're doing it. This is not something that's specific to NetApp. Anybody can use this. This works for any installation of NSX. It's intended to make things a little bit easier. On top of that, we could lay on the vRealize suite. So we actually have talked about how we do this in detail in what we call a NetApp verified architecture. If you're interested in seeing how we built this entire system out in detail, just remember NVA 1122, Google fans the rest for you, just nice and easily. Similar to the NSX script I just showed you, the vRealize Suite Lifecycle Manager allows you to fill in various different information to build out the vRealize suite. So we have vRealize Operations Manager, vRealize Automation, vRealize Orchestrator, vRealize Log Insight, vRealize Cloud for Business. This is a way to actually go in and fill in all the information you need to actually build out a complete vRealize suite. You can pick and choose the components you want or need or have paid for. You'll actually spend more time filling out this form than you will deploying vRealize Suite itself. This form probably will take you a little bit over an hour to get all the fields filled in on it. That's provided you have your network mapped out appropriately. And once you've actually filled out all the information, it'll do a validation check, make sure that everything you filled out in the form is correct. Once the validation check is done, it actually only takes about 40 minutes to deploy all these various different components on the system. So here we can see there's 13 different steps it's going to take. I have no idea why VMware likes these wavy little lines to show progress. Makes no sense to me, but that's what they show off. So that's how you can deploy vRealize Suite. vRealize Operations Manager is the IT component of the vRealize Suite. So the Operations Manager actually gives you a step beyond what you get from your vSphere web client. It actually goes down, shows relationships between objects, VMs, connections through various different network connections for your storage, that type of thing. It'll show you where there's potential bottlenecks or components that are being overly used. It'll show you if there's risks, like some firewalls not being closed up appropriately. It'll show you where things might be inefficient, where if you're not using things as well as you can. It does this through management packs for all of the various different components. So the vSphere and NSX management packs are available from VMware. Other management packs are available from the individual vendors for the individual components. So I'll show you one from NetApp HCI in a few minutes. The next component would be vRealize Automation. So this is really the heart of the vRealize suite. This gives you a role-based access to do a bunch of different things in a service catalog. The service catalogs are built up for the appropriate roles. So like for an end user, the service catalog might include deploying VMs, backing up VMs, restoring VMs. For an IT administrator, it might be creating a data store, laying out a new network, adding a new tenant to a system, all of those possibilities. So let's actually get into multi-tenancy here. One of the key things you actually want for a private cloud is the ability to have lots of different tenants on it. You don't want each organization in your company having its own private cloud. That doesn't really make sense. That still means an awful lot of IT work to keep it all up and running. The whole idea with NetApp HCI is that you actually can have a single data center with a single private cloud that the entire company can use, allowing all the different organizations to have access to it as they need. So one of the ways that we do this is we actually have a way to guarantee the number of IOPS to each one of the tenants. So you're not actually limiting, storage throughput limited for the various different tenants. And since we can actually set this guaranteed QoS for each one of them, it means that they're not going to interfere with each other. You can have a lot of different tenants in the same system and they all work together. In this case, we can actually see that we have a minimum IOPS of 15,000 for this tenant. And even as the workload increases, there's no drop in the IOPS. We do this at a volume level. So if you want, you can do this setting for an entire VMFS data store. Alternatively, if you need more granular control, you can actually set it for each individual VM in your system using vVols. So this would actually allow you to set it for each individual virtual disk on each VM, not just the VM itself. This way you don't end up with a noisy neighbor type situation in your VMFS file system where one VM is consuming all the throughput available to that data store. So let's actually look at adding a tenant to a system. Here we actually have vSphere Web Client, and we're showing off a system that has 2 tenants on it already, one named GlobalCAN and one named Warehouse International. What we're going to do is go through the process of adding a new tenant. So we're going to jump into the vSphere Web Client for NetApp HCI, and we're going to tell it we want to create a new storage container for vVol's data store. We're going to call this tenant Acme, and we're going to just give them the compute resources that it needs. At this point, we can actually see that there's a couple, GlobalCAN and Warehouse International have a few virtual volumes already. We can see those are out there in use. We don't have any for Acme yet. Next, we're actually going to go off and create some storage policies for Acme. So the only thing that we're going to create for storage for Acme would be a database VM. So let's go through and create some storage policy-based management rules for this. The minimum number of IOPS for the OS disk, 250 should do it. Let's go ahead and give a little bit more for the data disk. We'll set this to a minimum of 5,000 IOPS for the data disk, since your data disk is going to need more than the OS disk. And finally, let's go ahead and set a policy for the log disk of about 7,500 IOPS minimum, simply because lots of times the log disk needs more IOPS than the data disk. We have these policies set up. Now we can jump into NSX, and we'll go through the process of creating a couple logical segments in NSX for this tenant. So we'll set up a segment for, say, some DB servers, and let's go and throw a segment in for app servers just for fun as well, so we can show off a little bit more as well. Once you have these segments set up, you'll actually need to have an edge services gateway that these 2 distributed logical routers talk to be able to get out to the outside world. Notice that you can actually say that you want it to be highly available. You can set credentials for each one of these setups, so the individual administrators of that tenant can manage their own network. And the rest of this is going to turn into cartoon speed, simply because there's lots and lots and lots of stuff to set up for NSX. You need to go through, set up IP addresses, VXLANs, the virtual port groups for all the individual tenants. And here we'll actually go through the process of setting up a firewall for it. We're not actually going to show off the entire thing, just you can actually set up an individual firewall for each one of them. So let's jump into vRealize Operations Manager and take a look. This is the standard dashboard for vRealize Operations Manager, and here we actually have a NetApp HCI cluster overview. So this shows things like the CPU utilization, memory usage, IOPS, all the various different pieces for all the various different things in the cluster. This would be a volume heat map, so this isn't really showing anything wrong with the volumes. It's simply showing that some of them are more heavily used than the others. Here we have a NetApp HCI cluster overview. We can see that there's a warning on one of the node clusters in the node, and we can go in and drill down and see exactly what that warning is right away. And finally, we can actually take a look at the virtual volumes map, and here we can see that we have one volume that seems to be heavily used. We can also see what storage system it's on, which VM it's associated with, all the various different components there. So let's actually jump into vRealize Automation and show off how vRealize Automation works. We set up this tenant named Acme, so this would be a skinned vRealize Automation page that we made for Acme. And we have this user named Doug who's going to go in and do some things. So Doug seems to be a fairly boring person with nothing on his bulletin board, nothing on his calendar, but Doug has the ability to actually set up some VMs. So we'll go in and we'll actually create a new database VM, and give it a description. And here we can actually go in and set the policies for each one of the virtual disks on this system. So Doug will go through and do this, and we'll go through it. We can actually see that this goes through and has completed this operation that's underway. So what we're actually going to show is that Doug screwed up the setup of one of his systems. So we come back to vRealize Operations Manager and actually see that there's one vVol that's misbehaving. We go sort on this. We can actually see that that one VM is being heavily used, but the IOPS and latency associated with it are very low. So if we drill into vRealize Log Insight, we can actually see some additional SCSI errors associated with it. And if we actually search on these SCSI errors, we can actually go find that, come on, here we go, that we can actually find the VOBD deteriorated message in there saying, okay, the performance for this one virtual disk has deteriorated. We jump back over to our vSphere web client, we can actually go in and look at the VMs that were associated with it. And if we take a look at each one of the VMs, here we actually see the performance is low. We go in and take a look at the policies for each one of the VMs. We can see this one has 3 policies associated with it. Second one will have 3 policies associated with it. And then the third one will only have 2 policies associated with it. So let's actually drill into that a little bit better and see what's going on. Well, we misconfigured one of them to have the OS policy on 2 disks. So what we can do is actually change this immediately to be the policy we wanted. And when we say that, once we apply that, it gets changed automatically, and we'll see that this is immediately compliant, and that means that we've changed the IOPS for the underlying volume for that virtual volume immediately and fixed it up. And if we jump back into vRealize login site, we can actually see that we'll get the improved message as well. So this actually gives you a quick overview of what's available through vRealize Operations Manager and vRealize automation, and a little bit of what's available in vRealize login site. And I would have been able to run through the end of the demo, but they're back there waving frantically. So thank you very much for being here.
Thank you for coming to this session. I hope you had enjoyable VMworld party last night, and I know how difficult it might be to wake up the next day in the morning, especially if it's the last day of the conference. So thank you very much for coming. I really appreciate that. My name is Karol Boguniewicz. I'm a senior principal engineer from the VxRail technical marketing team at Dell EMC, and I wanted to talk with you today about VMware validated designs and how you can leverage them to simplify and accelerate SDDC deployment in your environment. If you have any questions, I'll stay for a couple of minutes after the presentation, so let's take them offline, and without further ado, let's get started. So VMware sees 3 different paths for adopting the SDDC architecture. All those 3 paths are leveraging exactly the same ingredients in general, things like vSphere, vSAN, NSX, vLive Suite. However, they all are different when it comes to the level of automation and integration of the SDDC stack, level of standardization versus flexibility, and also time required to implement and also to get to the desired outcomes. So you can build your SDDC using validated components, and this is the most flexible way. You just take the BOM bill of materials from VMware, integrate it on your own, but this requires really deep technical skills and might be very time consuming. The other option that we're going to talk about today are VMware validated designs, and it's really streamlined because you're using standardized architecture designs based on VMware best practices, and with that you can really do that quicker, faster, thanks to the automation, and also you'll get benefits of the operational guidance. The third option is really to buy a fully integrated platform based on VMware Cloud Foundation. And with that, you will get additional benefits, automation of the lifecycle management, and also automation of the day 2 operations. So you may ask, okay, so what is VVD? And the way that VMware describes that is that it's a family of solutions for data center designs that provide blueprint for SDDC implementation. It's really comprehensive, a very prescriptive documentation. It's available as a free download from the VMware website. You can see a link on the slide. And it's so comprehensive that actually VMware created a special map that allows you to navigate through this documentation. You can see that on the right. So what it covers? Well, it covers the whole implementation process for SDDC, starting with planning, designing, actual implementation, and also operational guidance, as well as different use cases and scenarios. It also covers various SDDC flavors. So you have a standard deployment, which is typical for a production environment. You have a consolidated one, which is more for the test and dev deployment and maybe smaller deployment in general, and also Robo, which addresses the remote office and branch office scenario. Now when it comes to the infrastructure, you have multiple choices here. There are several certified partner solutions. In general, you need to fulfill the HCL requirements and also minimum requirements for VVD. And one of these certified options is VVD on VxRail, which is actually a combination of VVD from VMware and VxRail from Dell EMC. And with that, you will get additional benefits in terms of accelerating the deployment, but also automating and simplifying the ongoing operations. We are certifying VVD on VxRail since version 4.2. It's an ongoing effort, and also tightly collaborating with VMware to make sure that the Cloud Builder automation is fully aware of the already built-in automation into the VxRail. So what you can see here is the logical architecture of VVD. You can see that it's really consists of multiple software components. You have a core platform based of vSphere, vCenter, vSAN, and NSX. Then you have additional operational tools and also cloud management layer, which is based on Virtualize Suite. And also you have the optional business continuity layer, which is based on Site Recovery Manager and vSphere application. And as you can imagine, this is really comprehensive compared to the traditional vSphere environment. There are a lot of moving parts. So what's really nice is that VMware not only simplifies deployment and design of such comprehensive solution with documentation, but also since version 5 provides an automated tool called Cloud Builder, which allows you to deploy this full SDDC stack automatically. So what is VMware Cloud Builder? It's the additional tool which is available in VVD and VMware Cloud Foundation. It's distributed as the virtual appliance, and it can provide you with the full automation of the SDDC stack deployment. It drastically reduces the time and effort required to deploy the SDDC stack because you can do that in a matter of hours. Because of the automation, you will have much less error-prone deployment, so you can de-risk implementation of the whole SDDC. And with that, you can also it also simplifies the VVD documentation. So in the past, you have deployment guides having hundreds of pages of manual steps. Right now, thanks to this automation effort, it's much simpler. Additional note here, just to make easier for you to differentiate between VVD and VMware Cloud Foundation. Cloud Builder does not automate the lifecycle management and does not automate NSXT and PKS deployment. So if you'd like to have those advanced features, you actually should better choose VMware Cloud Foundation, and those things are handled by the SDDC manager. This is the high-level overview of the process of deploying of VVD. This is on the example of VxRail, but the generic deployment is very similar. I will not cover that in full details because we don't have time for this. But basically, you need to start with fulfilling some of the prerequisites. The most important one is to fill the configuration file with all of the deployment parameters, which is in form of the Excel file. You need to create necessary accounts, etc. And when you complete those, you need to validate if all of those are met. If all of those are met, then the next step is to deploy the management cluster, the compute cluster, and at the end you will validate the deployment. And this process is highly automated. So this is great improvement since VVD version 5.0. In the past, it was a very manual process, hundreds of pages of deployment documentation. Right now, we measured that on VxRail, and if you fulfill all of the prerequisites, there are no issues. You can build the full SDDC stack in a matter of maybe about 10 hours. So great improvement here. It's also worth mentioning that VVD supports not only simple SDDC architectures, based on a single site deployment, but you can really build much more sophisticated architectures. So you can have multiple regions for different reasons, for instance, for disaster recovery between them. And if you'd like to, achieve maximum availability in case of a full site failure, you can actually use the multiple availability zones deployment, which leverages vSAN stretch clusters. and with that you can achieve maximum protection. Even more, you can combine those different options here, those different topologies we can see on this diagram is actually a combination of multi-AZ with stretch clusters, which is in one region, with the disaster recovery to the second region. So for your reference, I've included some information, what's included in the latest VVD 5.1 release from July this year. I won't go through all of these. There's no time for that, but probably the most important features is the upgraded bill of materials, because you can always, leverage the latest features in the component products. Integration with VMware Skyline for the proactive support, design and deployment guidance for VMware Enterprise PKS, and also migration of SRM deployment from the Windows-based deployment to the appliance-based deployment. And I'd like to end this session by providing, summary of the key benefits that you can get from leveraging VVD. In general, with VVD, you can really eliminate guesswork and deploy and operate your software-defined data center or hybrid cloud solution with confidence, thanks to the full-stack validation and thanks to the automation of the cloud builder. You can really simplify and de-risk the deployment. In general, if you implement the SDDC architecture in your data center, you will get benefits from better speed and productivity of your IT staff. You have better hardware utilization and better security. And because vRealize Suite, vRealize Automation is a part of that, you can really create standardized services catalog and automate IT services delivery, which will provide with increased agility, governance, and cost transparency if needed. Some additional resources for your reference. If you'd like to learn more, visit VMware website, download the latest VVD documentation. We do also provide 2 white papers. One is focused on VVD on VxRail specifically. The other one on a VMware Cloud Foundation on a VxRail. I think it's a good read, much easier than the typical technical documentation, so worth checking that. And if you'd like to learn more about VVD on VxRail, just Google VVD on VxRail and you will get access to the VxRail specific documentation. And with that, I wanted to thank you for your attention and have a great rest of the conference. Thank you.
All right. Hi, everyone. My name is Leslie Nispel. I'm a systems engineer for Dell Boomi. Today, I'll be showing you a project that I've had the pleasure to work on called Ocean-Bound Plastics. And this application is a prototype of how we can use Boomi to quickly create a series of applications to connect to emerging technologies like VMware's blockchain. So the goal of this application is to create an end-to-end integrated supply chain management solution that builds trust and transparency for every member of that supply chain, as well as for the consumer at the end. So the concept of this prototype is based on Dell Technologies' sustainability initiative. So that initiative is to have 100% recycled materials in their packaging, with 25% of that coming from an ocean-bound source. So what is an ocean-bound plastic and why is it such a problem? Well, a vast majority of ocean plastics come from discarded waste from land-based sources. So 75% of that is discarded on the ground due to lack of sanitation infrastructure or waste collection infrastructure. So these plastics wash directly into the ocean through rivers or drainage systems, or could just be dumped directly into the sea. The remaining 25% of these ocean plastics are actually escaped from the traditional infrastructure and become ocean-bound. And so over time, these plastics break down and are ingested by sea life, ultimately to be consumed by humans, causing health issues such as obesity and cancer as well. So the problem of ocean plastics is an incredibly important one to solve. And with corporate responsibility initiatives such as Dell's, we want to ensure that the initiative is actually being carried out as stated. So this means we need to ensure the provenance of that source plastic, as well as make sure that there's minimal corruption throughout the supply chain process. So what we've done is designed a series of applications built with Boomi, one for each step of the supply chain management process. And so as each member of the supply chain interacts with the applications, they're adding their data to a smart contract that is then saved into blockchain. At each step of the process, the member is able to actually load the information from blockchain in its current state and understand what the plastic's journey has been to this point in time. So how does Boomi come into play? So we're using two core functionalities, or core components of the Boomi platform in order to create these applications. We create a series of our end user applications with Boomi's low-code application development platform. And the data that's entered by the users through these applications is sent to our integration platform core, where we're able to quickly connect to your blockchain endpoints. And additional applications we have in order to do the lookup and processes in order to grab the data out of these blockchain processes and display it in a friendly user interface as well. Okay, so let's take a look at the application. What you're seeing here is the first of 4 of those supply chain management solutions. And this is the application for our first step in the process, which is for the picker here. So as the picker is collecting plastics from these ocean-bound drainage ways, they're entering information into the form, and then they're prompted to enter a picture for verification. So at this point, that image is sent to our integration platform, and it is uploaded to a bucket, and then it is run through Google Vision's image identification to determine what percentage chance that image or the contents contain plastic. So as long as it meets that set threshold that we have, the aggregator is able to continue to submit the submission and generate that lot number to start the process. All of the data so far is going to be stored in blockchain and start that process for this supply chain. So the responsive user interface means that any application you build with Boomi is automatically mobile friendly. And so this is an example of what the picker would actually be using in practice. So they would be collecting their plastics and entering the data through their mobile device, as well as taking a live picture for validation. Any step throughout the life cycle, a member of the supply chain would have a QR code affixed to some packaging materials in order to scan and look up the data that's currently stored in blockchain. So this is an example of our first example that was submitted, where we have some of the information from the aggregator, since it's completed the aggregation step. And we're also able to drill down into the aggregation log and see the address in the ledger as well. So this is an example of a lookup that's done for a plastic lot that's completed the entire process. So you'll see we have more information stored in here, but not only that, we also have additional log entries for each step of the process so that you can see at that point in time exactly the data that was stored. And finally, really the end goal is so that a consumer who receives their laptop is able to unbox their laptop and be presented with a QR code. And when they scan this, they can be presented with all of the information about Dell's corporate responsibility initiative, as well as where in the world the plastics for their packaging came from, the date it was pulled out of these the ocean-bound sources, as well as what the plastics are made of. So the architecture behind this application could easily be expanded to include other capabilities. So that could include IoT, mobile messaging, or reporting, to name a few. And Boomi's intelligent and scalable platform will allow you to quickly add additional integration points, such as a CRM, a data warehouse system, or an ERP, in order to connect and unite all of your data. So now remember, this is just a prototype, and this is just for a single use case that we were inspired by. So really any supply chain management process could benefit from this, from clothing manufacturing to organic farming, to build trust and transparency behind their brand. So Boomi is really quickly uniting all of these emerging technologies so that you can achieve these business outcomes faster. All right, thank you very much for your time.
Hello everyone. I am presenting today how to start hosting hackathons in your city. My Twitter is Ariel Sanchez Moore. A favor, please take a picture during this session. Tweet it out with vBrownBag and VMWorld. I really like seeing those pictures because I show it to my wife, who understands then that I'm not just lying that I went to a conference. I really like interacting with people on Twitter and the hashtag vCommunity, so make sure you reach out. I always love to hear what you're doing. A bit about me, I'm a Costa Rican. I live in Orlando now. I work for VMware, part of the CTO Ambassador Program, as Chindo over here. I'm a big advocate of the V community. Anything that has a V in front of it, I am a fan of. But more importantly, and one of the best things I've ever done is become a part of vBrownBag. I started using Twitter for VMware and for VMWorld and to further my career back in 2013. It has been one of the best decisions of my life. Make sure you do the same. And the reason why I'm doing this talk today is because I want to help other people do local hackathons. So this is our agenda. It's very simple. Why little hackathons work so well, how you can get involved and how you can create them in your local community, and the lessons learned that I found that help make them successful. So hackathons, right? If you go to my blog, you will find that I have a blog post that basically explored this idea in full. It's called My Love for VMworld Hackathons and Little Hacks. We just had the VMworld Hackathon last night. It was great. It's a very welcoming event that has a lot of free food, free beers. You can talk to people for 4 hours. You can actually sit down and learn something and learn from other people and make real connections. So VMworld Hackathons for me are one of those events you cannot miss. And if you want to find more information on that, you can just hashtag VMworld Hackathon and you'll see all the information about that event. But here's the thing. Those only happen once or twice a year if you go to Europe. We need another way to keep learning because we cannot just learn one time a year. Let's do little hackathons, meaning that let's meet together. So when you have smaller meetings in your community, you don't need a sponsor. It's not like a VMUG that somebody has to pay for the pizza. Come on, it's $10. Somebody can pay for the pizza this time. You just need power, a table, some chairs, and maybe a whiteboard. This is the typical office. Most offices are closed after 5 p.m. So if you set up that you're going to have a little hackathon at 6 p.m. and you get permission from your work or from the university or whatever it is, it's very easy to set up. So we actually have been doing this in Pittsburgh for a year. If you search for PGH Little Hack, you'll find every event that we've done the second Monday of every month. And in central Pennsylvania, in Blair County, we have the hashtag BC Little Hack, which is a similar event. So this is something that is very easy to coordinate. Now, I want you to understand this. The V community, the people that are involved with VMware and are on Twitter, we're a very helpful bunch. We want to help you. So if you're in your town, you start asking, hey, I live in Miami. Who from the V community is here? You're going to get responses. Same thing in Wisconsin, same thing in California. You're going to find people. And that's all you need. You basically just need to tell people, can we do a little hack one of these days? I found a space. That's the number one thing that you are probably going to have a little difficulty with. But here's the thing. When I talk to people about this, everybody tells me, well, I don't know. It's the same excuse of why they don't blog or why they don't want to do public speaking. Listen, you have to get past that. It's not that everybody knows everything and you know nothing. That is not the case. You are an expert in what you do every day. Whatever you do for work, you can probably teach someone else because you've been doing it for 2 years or more. So make sure that you understand what you're really good at. When I was a customer, I was really good at PCI environments because that was my job. Otherwise, I didn't know anything else, but I would sit down with other people that had other job priorities, and they will find out that they could teach me something and I could teach them something. So that's what you want to do. You want to have that interaction. Remember, failure is temporary. This is the way to learn. If you don't try and you don't fail, you will not grow. So make sure you do that, and especially make sure you do that with others. When you teach people how to do things, you learn again, because it's difficult to explain. You have to really understand it. So make sure that you do that, and you also take this opportunity to practice your public speaking. If you have a blog post that you did, and you think, hey, this is a pretty cool blog post, next meeting you come in and you say, I want to show you my blog post. So you go in and you say, hey, I don't know, it's a short blog post or a long blog post. You stand up and you explain what you're trying to do, and you'll get feedback. And this is the most important part. We're going to get into that. But the important part is that you just try to get better every time. And little hackathons are an excellent avenue to do that. Typical stages of participation that I see, and if you're leading the hackathon, you're going to run into this. People at the beginning, they just want to sit down and see. They lurk, right? And at some point, they are interacting. They're actually telling you. So it will be up to you as the leader and organizer of the little hack to say, hey, what do you do for work? You know, what are you working on? I don't care if you're just a Linux admin or just a desktop admin. You're doing something I can probably learn. You want to talk about it? So that interaction, look for that thing. And you have to create safe spaces. A little more on that later. But at some point, they're going to start contributing. And it's a really cool effect when you have a group of friends that start getting together and they're just trying to teach each other. So once you get to the point that you say, hey, my community is actually pretty healthy, mentor others. You know, make sure that they, like in our case with Pittsburgh, we had a satellite little hack that started because we started mentoring the guys, and they were driving 2 hours to get to the little hack, and they basically said, well, don't you start your own, and we'll drive the 2 hours. So it's not one-sided, right? So if you mentor others, it actually helps. You can make bigger events. So lessons learned to make little hacks successful. You got to make them for the right reasons. If you are an SE, this is not a sales exercise. You know, you really want to do something for the community to help the community learn. Remember that everybody brings something to the table. So if you think about your rules, right? If you're organizing the event, you're going to set some guidelines. Make sure that you have good attitudes. The most required attitude, positivism. Our first 3 little hacks, it was only the 2 leaders. And we just had the greatest time because we had finally a time to just explore ideas. My blog is on Hugo, and my blog would not be on Hugo if it wasn't for those times that I had 4 hours to figure it out. So don't be discouraged if you only get 2 people, 3 people, 4 people the first times. Our biggest was 12, and that was like the 5th one. Mostly because Kyle Rudy was in town and we convinced him to come. The other 2 attitudes that I want to showcase here, frankness and openness. We are here to help each other. If somebody is giving bad advice, you know, explain. You don't have to be mean about it. You just have to you do it in their best interest, right? Hey, I think that's wrong. Maybe we should research it. Hey, I think maybe that's true in this case, but remember that these other cases. We grow when we get feedback. And finally, always treat people with respect, you know? That is the #1 thing in this world. If you treat people nice, if you treat people how you want to be treated, you will always have a great time. So, some tips on how to start. Communication is the key. Your role as a leader is to make sure that everybody knows about this. I like making a blog post because that, for me, makes it official, okay? Make a blog post, say, we're going to do this. It's going to be this kind of event. You know, it's going to be a little hack. Bring your laptop, blah, 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 blah. It's going to be at this location. These are the times, this date. And give them, you know, a week or so. Don't just put it that we're meeting tomorrow. Give them at least a week, 2 weeks, hopefully, and then start promoting it. Every VMWorld chapter in this country has a page, a forum. So you can go ahead and talk to the leaders and tell them, hey, I'm trying to organize a little hackathon. I want to get, you know, more into scripting. I want to do different things. Can I put this event? And they'll be thrilled. They'll be thrilled because most people don't interact this way. And they'll be happy that users are getting together, and they'll probably want to come too. So make sure that they know about this, and make sure that you also tweet about it. Choose a hashtag. That helps a lot, especially when for example, today when I'm trying to show you things, you can search the hashtag and you will find every picture from every meeting. It's great. It's fun. Now, one thing once you actually get people in there, if you go to the VMware Code Slack, which is a free Slack, which you just have to put your email and it will actually send you the invite and you don't have to get approved, it's auto approval, you can create a private group in there and basically say, This is the Miami, I'm picking on Miami, but it can be anywhere, right? This is the Dallas Little Hack group, and you add everybody. So you now have a way to talk to people apart from the blog post, apart from Twitter, right? Not everybody's as enthusiastic on Twitter, not everybody reads their emails, but if you get it into the custom of Slack as a communication platform, the strength of Slack is to have collaboration with code. You can paste code in there. You can upload files. You can call people through Slack. Again, and the reason why I recommend this VMware Code Slack, it's also because the hackathon is kind of like what this Slack is for, right? There's channels for Ansible, there's channels for Power CLI. Every one of those things that you're trying to learn has a channel, and if you get everybody in there, it's so easy to go ahead and ask. So make sure that you leverage those things that are free and useful. Finally, if you achieve something, share it. That's the most important part. Make sure that people get accustomed to using GitHub or GitLab or whatever it is, but sharing what they are finding, sharing what they're doing. One thing that I love to do was bring down a Nook in case anybody wanted to test something that they were just trying to do. Sometimes people have home labs. Sometimes people have remote labs. You don't know who's going to show up, but more than likely you're going to get something out of it. So make sure that you share that, and that will help others get more into the idea of coming and helping and learning and teaching others. All right, so I want to talk about the benefits of this. The number one benefit that this is going to give you, you're going to make new friends. Friends that are very valuable. Friends that you can rely on when you have a problem, when you don't know. You're going to figure out that these people are really good with HashiCorp tools. These people are really good with Puppet or Chef. These people are really good with GitHub. You're going to expand your personal network, and you're going to continue learning. And you're going to get into this habit of welcoming people and basically learning as things come along. I find I am not a very good person for sitting down 4 hours by myself. But if I do it with others, I'm excellent. I can sit down and talk to others and learn and have a lot of fun. So make sure that you understand this. And also, we are going to help you. This is what I'm offering right now. If you start a little hack, I will make sure that it is a success. So having access to mentors in this big community is also important. But we just need you to say, I want to do it. Finally, I don't know how much time I have. I'm good, 2 minutes. But I want to show something real quick here. These are 15 tips that I gave to run your little hackathon. So make sure you find that blog post. And again, any other question, reach out to Colorado. Reach out to me. Thank you so much.
All right, welcome everyone. Thank you for joining me today. This is How to Build an IT Roadmap. My name is Steve Tilkins. I'm a VMware Technical Account Manager, and I'm excited to be here. So let's jump right in. So quick agenda. I'm going to do a quick introduction, talk about who I am real quick, and then I have essentially 2 goals for today. Number 1, I want everyone to leave with a good understanding that it's important to have an IT roadmap, and hopefully we'll all agree there. And then the other goal is going to be everyone should have at least a basic understanding of how to build a basic IT roadmap, right? We've only got a half hour, so it's not going to be a very in-depth, comprehensive roadmap. It's going to be pretty basic, but it may be, completely sufficient for what you need. So I'll talk about some strategy, tips, and tricks. And then the last 10 minutes or so, we're going to jump into kind of a more interactive deep dive where we kind of build one together. So that's the plan. All right, so a little bit about me. Like I said, I'm a VMware Staff Technical Account Manager, or a TAM. You may have heard that. You may have a TAM. If you do, hit me up after. I'd love to chat with you. So I am based out of Sacramento, California, which I'm spoiled. It's only about 2 hours from here, so I just took the train in. And I work primarily with state and local government customers, or SLED, you may have heard that, so state of California customers. I have worked in the past with some enterprise and some healthcare customers. From a social perspective, you can see my blog here, and then on Twitter, I tweet a little bit here and there, but there's my Twitter handle as well. And then more personal, from a hobbies perspective, I like to hike, I like backpacking, camping, and then of course technology. I have a home lab. In fact, I did a vBrownBag session maybe a year and a half ago where we kind of dived into my home lab, but it's perfect in the role that I'm in as a TAM because I get to, try out my customers' use cases and the questions that they have in my home lab, and play with the technology and things like that. So that's a little bit about me. All right, so let's jump right in. So why do you need a roadmap, right? So this is a pretty powerful quote. You've probably seen it, but a goal without a plan is just a wish, right? And I absolutely believe that. So let's use the example of, let's say you wanted to run a marathon. That's a goal. It's a great goal, right? But if you don't put a plan in place to get there, then it's just a wish, because it's never going to happen, right? So you should be breaking it down to say, okay, I've got 6 months to train for this thing. I should be running X number of miles, a month before, or something like that. So, and it's the same thing with IT. So if you have, some strategic vision from your upper IT leadership around, we want to be more mobile, right? We want to enable our customers from a mobility perspective, right? That's a goal. But if you don't put something in place to make that happen, it's never going to happen. So it's just a wish, right? So just keep that in mind. So I've broken down why you need a roadmap into essentially 5 main ideas and themes. So we'll go through that here real quick. So starting from the left, it's going to make you more strategic, right? So you'd be surprised how many organizations don't have any kind of an IT roadmap. And typically they act very tactical and reactive, right? So they come in every morning, they may have an idea of some of the things they need to get done, but really they're just fighting fires and they're firefighters, right? So having a roadmap is going to help keep you on track to focus on the things that you need to get done to reach your business outcomes, right? So you'll be a lot more strategic and proactive. It's going to help you prioritize. So the first step to building a roadmap is you're going to have to identify all the things you need to get done, right? So tasks, ongoing maintenance things, patches, projects, things like that, maybe enablement. And the next step to that is you're going to put them in a logical order. So you're going to be a lot more organized from that perspective. So you'll be able to kind of prioritize and then align that with the business, right? And then, good segue into business alignment. So once you have a basic roadmap, you'll want to socialize that with the rest of the IT organization, right? Because they may have some other team like the SQL department or the IT or the database team. They may have, a known Oracle upgrade, and you were planning on doing maybe a vSphere upgrade that same weekend. And by bringing it to light, you can now coordinate around that and make sure there's no impact to the business. So again, just making sure you're driving towards those desired business outcomes, right? A roadmap will definitely help with budget justification. So we all need money for projects, for services, for products, enablement, things like that. So if you go to your IT leadership and say, hey, I need $2 million, you better have some kind of a plan around how you're going to spend that money and what the ROI is. So it will definitely help in that aspect. And of course getting more resources, right? So if you have a roadmap and it's got all these different tasks and there's only 2 people in the department, that's going to be a pretty big red flag. Like, we need to hire some more folks here, right? And then the last one is just generally succeed or success, right? So there's 2 different aspects to this. From a personal perspective, if you are able to build a roadmap and then execute on that roadmap, your leadership is going to see that and be like, well, this guy here knows how to execute and build a plan and actually deliver, right? So when it comes time for promotion and upward mobility, you're going to get recognized for that. And then also from a business perspective, being able to build a roadmap and execute against that, you'll be meeting those strategic initiatives and the business outcomes. So there's probably a lot more here, but I kind of broke it down to just these 5. So let's move forward. Let's actually talk about the process. There's lots of processes to build a roadmap, right? This is the one I like to use, and I didn't invent it. I stole it from folks that I've met along the way and kind of tweaked it here and there. But it's pretty straightforward and it's pretty fun. So number 1, you're going to gather your team, right? So you'll want to get your leadership and your technical staff, get them in a room. Hopefully you have a whiteboard and a big wall, something like that. If you're a large IT organization, you probably don't want to get the entire IT organization into a room, right? It's going to get out of control real fast. So keep it small at first. Maybe meet with just leadership to get an understanding of their strategy and where they want to see the business going, and those IT goals and things like that. And then start breaking it down and going to the IT staff, the technical folks, because they're going to have valuable input. But you want to have that vision, right, from senior leadership. So why do you want to have a whiteboard or a large wall? Because what you're going to want to do is you're going to use Post-it notes, right? Different colored Post-it notes, hand them out, and hand out some pens. Everyone's going to start jotting down things that they know need to get done. So projects, routine maintenance tasks like firmware upgrades, security patching, maybe a vSphere upgrade or enablement, things like that, right? Don't worry about putting these in any kind of logical order. Just get them written down, right? Put them on the wall. And then the next step, obviously, we're going to start putting those in a particular order. So it's going to be different for every organization, but it should be in some kind of a chronological order. You'll definitely identify the dependencies, right? So if you need to do a vSphere upgrade from 6 to 6.5, for instance, but your hardware doesn't support 6.5, obviously you need to do a hardware refresh first, right? So those things will come up, and then you'll also have the ability to build into the roadmap the business priorities as well. So I used to support an accounting firm, and they essentially did taxes, right? So during tax season, they said no changes, right? We're not going to be upgrading SharePoint or something like that. So we focused on enablement and things like that. So that's where it comes into play, right? The business priorities as well. So that's it. I mean, that's pretty much the high-level strategy, and it's pretty straightforward, and it's actually pretty fun. So we'll get into a few tips and tricks here, and then we'll actually get into building one on the fly, and it should be pretty fun. So a couple of things to keep in mind. Number one, keep it fun. I've done this with a couple of my customers, and it's usually a pretty good exercise. It ends up being a pretty good team building event as well, right? Because in IT, we all have our roles and responsibilities, and we're pretty head down, focusing on the things we need to do, but we don't really care about what the other folks are doing. So it's great to get everyone in a room, and everyone has the ability to essentially talk about the things that they want to get done, the things that are important to them, and it's a real good team building event. So keep that in mind. So the roadmap is going to comprise a lot of small tasks and projects, and ultimately that's going to support a much bigger goal, right? So if you look at a roadmap, look at any one item, let's say firmware upgrades, that's pretty tactical, right? Not very strategic. But if you look at the roadmap as a whole, all these different things on there should ultimately lead to some much bigger strategic initiative, right? So we'll go back to the example of workforce mobilization, right? Having a mobile workforce. Firmware upgrades may not sound like it's in support of that, but if that follows, or if you follow that with like a Horizon upgrade and then Workspace ONE deployment, ultimately the whole roadmap is supporting that initiative, right? So keep that in mind. You're going to want to categorize the roadmap, so the items on the roadmap. That's where the different color sticky notes come into play. So I typically like to do it by team if it's a relatively small IT shop. So infrastructure team, database team, storage, VDI, desktop, and that way the items on the roadmap will correspond to who's going to be doing the work, right? You can also do it based off of related projects or however else you want to categorize it. Maybe you have one color for like an ongoing maintenance task or things that you're doing regularly, right? So use that. This is an important one. Establish realistic timelines. So you're going to have delays, right? You're going to have hiccups. You're going to have things that go wrong, and your roadmap is going to get changed, right? So make sure you're building the things into your roadmap so there's enough time to accomplish the task, right? Let's take the example of a vSphere upgrade, right? If you've got 4 vCenters and 100 hosts, maybe you could do that over a weekend, maybe, if everything goes perfect. But would you do it over a weekend? Probably not. You'd probably want to schedule it over a couple weeks, work with the business. You'll have different clusters that you don't want to impact applications, and just build enough time because there's always unforeseen delays, right? Your roadmap will never be quote-unquote done. So don't get frustrated because it's always going to be changing. There's going to be new business priorities that come up. You're going to need to shift things around. You may have those delays. Maybe there's a firmware bug or something like that, and it's going to completely derail your roadmap. But just keep in mind that that's going to happen, right? Also, you'll never get to the end of a roadmap, right? If you build an 18-month roadmap and you get 12 months in, you've completed all this, you're going to now add another 12 months. So you'll probably never get to the end. It's always going to be a rotating thing. This is a good one. So once you have a working draft of your roadmap, look for things that you can automate or improve upon, just general process improvements. So if you have your roadmap and you've got 3 months to do firmware upgrades and you've got 12 hosts, that's a red flag, right? Why is it taking 3 months to do firmware upgrades? So look for opportunities. They're going to be visual, so you'll be able to identify them a little faster. And maybe there's some tools or processes that you can put in place to help improve things, right? And one last thing, once you have your roadmap, and it doesn't need to be a finalized version that you've framed and put on your wall, but communicate that with the rest of the business. And I don't mean all the end users and stuff, but the rest of the IT organization and maybe senior business leadership, right? Because the more you do that, it's a feedback loop, right? They're going to have input, and it's going to change your roadmap, right? So the example I used earlier of sharing it with the database team where they're doing an Oracle upgrade, and we don't want to do both at the same time, right? So it also may put pressure on other departments. If you show them your roadmap and they don't have one, maybe they're going to say, well, maybe I should do something like that too, right? So, all right, so those are tips and tricks. So let's jump into an example here. And I wanted to do this interactive where you guys were telling me things we should put on the roadmap, but there were just way too many unknowns here, and I couldn't use my laptop, so I just recorded it, right? So, so I use a Mac, and what you're looking at here is just OneNote. I put in some swim lanes for quarters, the next 6 quarters, and then on the bottom I've got different colors for the different teams. So we've got infrastructure team, monitoring, automation, VDI, network, exchange, and patching. And hopefully you guys can see this. So Mac has a really great app called Stickies, which is essentially exactly what it sounds like. It's little sticky notes, right? And I think Windows has the same thing. So it's nice because you can move them around and you can resize these sticky notes to make it look like, okay, it's taking a quarter or 2 quarters, right? Whereas if you're doing it on a wall with actual sticky notes, it's not going to be as flexible, but it also gives everyone in the room an opportunity to get up and start moving things around as well. So this works pretty well if you've got a remote team and there's people all over the place. So what I've done is I've just started throwing things out here. So I'll read them off as we go in case it's too small. So we've got firmware upgrades. We'll keep that yellow with the infrastructure team. Maybe this organization just signed an ELA and we got the whole vCloud suite. So we got vRealize and NSX. That's not in the vCloud suite, but maybe they bought that as well, right? So we're going to do a VROPS deployment. And then after that, we'll do some customization. And then we want to put things like enablement in there as well. Of course, we have security patching, which is an ongoing thing. So that's with the patching team. And then we've got things like NSX, where we're going to go through the design. And then we're going to ultimately get to the deployment. And again, I'm not putting these in order yet. I'm just getting it down, right? All the things we need to do, and then we'll start moving it around. We want to also include the enablement for NSX. Maybe the team doesn't know it very well, and they need to come up to speed. We have a vSphere upgrade. We want to do some training for maybe we're running vSphere 6, and we want to learn about vSphere 6.7. We want to do a VMC on AWS POC. We have a hardware refresh. And then over to the VDI team, they need to do a Horizon upgrade and Windows 10 migration, so from Windows 7 to Windows 10. And then an Office 365 migration, so that's a pretty common one I see a lot. So that's going to be the Exchange team. And that's supposed to be purple, but it looks kind of blue. This one you may be familiar with, getting off of Windows Server 2012. That's coming end of life here in the next relatively soon. I'm not sure the date. So we want to migrate to 2016 or 2019. We have a VRA deployment, and then we're going to start building some blueprints. And then, of course, we want to include the VRA enablement so the team knows how to use the product. And then back to that workforce mobility, strategic goal is the Workspace ONE deployment. And then we want to include enablement for that as well. And then I think I've got one more. This was kind of an afterthought, but very important. If you're doing any kind of VRA or VROPS, you want to spend some time working with the business to identify the requirements for monitoring and what do you want to automate, that sort of stuff. So I put that in as well. So now Now we're going to start moving things around a bit. And this is a very aggressive roadmap, by the way. This is a lot of stuff going on, so don't think there's like 3 people and we're going to get all this done. It's not going to happen, right? But it's typical. I see it a lot as a TAM because a lot of customers do buy these products, and right, we need to put something together as far as how we're going to implement it all. All right, so we've got our vSphere upgrade, and we need to do firmware upgrades before that, so that's obviously going to come before it. We want to put kind of during the same timeline vSphere enablement. And then once all that's done, we'll start focusing on upgrading our guest operating systems, migrating or upgrading or whatever works for that application. Sometime in that, we'll also do a VMC on AWS POC. That's going to take about 3 months. And then moving over to the VDI team, they're going to do a Horizon upgrade, but they want to wait until after the vSphere upgrade. So that's going to be not till Q4. And then part of that, we're also going to kind of include the Windows 7 to Windows 10 migration. So they're going to build a brand new Horizon environment and then just migrate users from that into the new environment with Windows 10. And then after that, we'll do the Workspace ONE deployment. So it would have been fun to do all this interactively, but it would have also been probably a big mess, but it would have been interesting to say the least. Okay, and then we've got security patching. That's basically an ongoing thing, right? So every quarter we've got a patch cycle. That's just going to be across the entire roadmap there. Let's see. So let's say the Horizon environment is running on older hardware. So we're going to need to take care of that hardware refresh before we do the Horizon upgrade, right? So we'll do the hardware refresh, the vSphere upgrade, and then the Horizon upgrade. And then the network team is going to start working on NSX sometime in Q4. Yep, beginning of Q4. And that's going to take a little bit of time to do the design, and then the deployment will follow that. And that's going to take a bit of time because we want to do that in dev, QA, staging, prod, right? Of course, we have NSX enablement. So you can see the roadmap is starting to kind of come together and look more logical. And then over to the monitoring and automation team. So they're going to start defining those requirements fairly early, working with the businesses, working with the different application teams, things like that, to understand what they want to see, KPIs, what do they want to automate, things like that. And then following that, we will deploy VROPs, and we'll do that in dev, QA, prod. By the way, each one of these is probably going to have its own project plan because these are pretty big things to do. Where you're tracking the resources and things like that. And then we do VROPs customization, where we're building custom dashboards and setting up our role-based access control. We have VROPs enablement. And then once we have the VROPs deployment completed, we are going to install VRA. So that will be a deployment task. That's going to take about 2 months or so. And then we have a very long process of customizing VRA, developing blueprints, identifying the things we want to, automate, things like that, integrating with IPAM, maybe InfoBlock, something like that. And then finally, the Exchange team is working on their Office 365 migration, and that's going to take a while to get done. So that's essentially the process. I mean, we went through it pretty quick. We've got a few more minutes left. What you would do from this point then, right, take a screenshot, take a picture of what's up on the wall, and then come back to some other tool that's going to look a little bit more presentable. I like to just use PowerPoint. It's pretty straightforward. You could use Excel, you could use Microsoft Project, something like that. But ultimately what you'll kind of put together is something that looks more like this, right? So this is a nice format because you can update this maybe once a week or every 2 weeks, and you just move the current date marker here, and then you roll that up to leadership, and maybe put a little exclamation point next to any item on the roadmap that may have a risk or something's not going well, and then maybe another slide that kind of lists those out, right? So just a nice status report update for them. You'll notice I put in the security patching, once per quarter essentially. It's a kind of a revolving patch cycle. And then at the bottom I did include project management. You may not always do that, but it is helpful if you've got a large, very busy roadmap like this where you need to track the resources that are working on different things and the risks and things like that. And then finally at the bottom I have the enablement, so it's kind of called out all by itself, but it definitely helps justify getting training, right? If you're doing all this stuff and you've got all these projects going on, you're going to want the team to know what they're doing, right? So it'll help kind of get that, because usually that's an afterthought, I find. I don't know if you agree with that, but getting training is very important. So that is pretty much all I had. Is there any feedback from anybody? Any thoughts? Yes? So the question is, how would you communicate this once you're completed? Is that right? Uh-huh. So if a dependency, if a project, or if an item on the roadmap is a dependency for something else and it didn't go well, it didn't work out, you're not done? Is that the question? How would you update it? It's just going to be that same loop where you're going to come in, you're going to update it, you're going to push your timelines. And that's where it's important to communicate the roadmap with the business, because hopefully it's not a surprise and they don't have to come and say, why is this not done? They should already know because you've been communicating this, weekly or whatever, right? It depends on the organization. Of course, it's such a lame answer, right? But I mean, some leadership teams like to know about these things weekly. You're really gonna have to, I would start with weekly, and then once they complain that this is too much, then dial it back from there, right? I like to over communicate than under communicate, so. So you're looking for resources? Yeah, I have some stuff. Hit me up on Twitter, or we can talk afterwards. And I think this will be available on YouTube or something after the session. So, yeah, we can definitely get in touch. Yep. Anything else? What's that? I don't have a template. I mean, I guess I could put one together. There's one that I always use. But if you Google it, honestly, there's all sorts of stuff out there. But if you can't find something, hit me up. Because this is a nice format. It looks pretty good. It's easy to manipulate. You could definitely use project and get into Gantt charts and things like that, but that's not me. That's project management. They love that stuff, so I keep it simple. All right. Thanks, everybody.
Hello, everybody. My name is Dave Stevens. I'm here to talk about your cheat sheet to learning containers, learning about containers in Kubernetes. If you've been watching any of the keynotes online this week, you will see that there's a lot around Kubernetes today. I can tell you that if you want to do it from scratch, setting up your first Kubernetes cluster is a lesson in futility. It can be very frustrating, and some of the things I've seen in the keynotes this week makes that much easier. And if you really think that Kubernetes is going away, you are sadly mistaken. Just like in the old days, we had virtual machines and they started multiplying by like rabbits because people didn't need to spend a lot of money on physical hardware and get that purchased and go through the whole rigmarole of getting that done. I can tell you that containers are going to replicate even faster than virtual machines did. Containers are rising in adoption within organizations today. and they're very cost effective, and I'll get a little bit more about why they're cost effective and why they are starting to replicate across your infrastructure very fast. If we go back to the day like I was talking about, we have physical hardware. You usually only put one physical application on that hardware, and then we went to virtual machines or a hypervisor where VMs then started scaling across that individual hardware. Well, when you get to containers, the operating system, that's slightly different from a virtual machine. The operating system is not contained inside the container. And I'll show a graphic to really compare and contrast the two. And last thing, the lifespan of a virtual machine or a container, look at the very bottom. Containers spin up and spin down really, really fast. You're not going to get our virtual machines today spin up pretty fast, but there's usually some other software inside them that takes some time to get up and running. So it's powered on really quickly. Well, it turns out when it comes to a container, it gets powered on and it's pretty much active and ready to run almost immediately. So why is container adoption growing so much in the organizations today? Well, as you see on here on the slides, there's improved application quality and reduced defects from them because people are able to spin them up real fast. It's more of a CI/CD pipeline process. If you don't know what that is, that's a development process. I'm not a developer, but I can tell you that trying to just learn about this stuff, you're going to hear a lot about CI/CD, so I suggest you look some of that up. There's reduced application downtime. A lot of the applications, it's not as simple as taking a single, like in the old days. We took a physical machine, we did P2V in order to turn it into a virtual machine. When it comes to containers, you can't just take an app and turn it into a container. If you want to take the advantages of containers there are today, you need to rewrite portions of your application in order to take advantage of the scale and the speed at which you can deploy them inside your environment. And then there's the employee improved productivity. I'm not so sure if I really agree with that, but there is faster response to market changes because they've taken an application and they basically split it up. If you want to think of it in terms of layers, they can just work on an individual layer or a piece of a larger application and just change that, and then take any containers that are based off of those little pieces and shut down what they have running and bring it back up. And immediately they've got a brand new version of the application running. If any of you are Slack users out there, this is exactly how Slack works today. It's all based off containers. It's easier to innovate as well, and there's lower operational costs because it's not a big monolithic app that's typically running inside a container. It's just a little piece of an overall monolithic app that we're all used to seeing today. And then if you don't believe me and you didn't hear and you don't believe what you heard today or the last 2 days in the keynotes, well, these are numbers that are showing you that container adoption is growing and growing, and this is pretty linear. I'm sure we'll continue to eventually hit some sort of hockey stick, and it will take off and really increase inside people's organizations. So, and this is just another view of a similar one to show you just where containers are really taking off. I'm sure everyone has heard of AWS. If you're not, you're living in a hole somewhere. But here's some information around all the other providers out there where containers are running. Unfortunately, I don't have anything that talks specifically about VMware or vSphere in here, but that's what we all heard over the last 2 days at the keynotes. You can see that it's really taking off on premises, but it's really taking off more inside the clouds out there. And so if you were to add these all up, containers are just getting started inside our organizations. So this is where I'll get into the meat of how to compare and contrast a virtual machine to a container. So we all know, we're all familiar with VMware products. We've got the infrastructure down below. There's the physical infrastructure, the physical networking, the physical servers that our virtual machines run on. Obviously the hypervisor then where the virtual machines run. But where it really starts changing is at the VM level and the container level. You'll see in the picture up here that all of our virtual machines have an operating system, which means we need to keep those patched all the time, in addition to the applications themselves, to figure out what kind of security vulnerabilities there are for applications out there. And the difference is with containers, because they're really small pieces
of an overall larger application that's running, they share the underlying operating system. So if they need an operating system call, then they will make that call back down into the overall operating system or the runtime where that's running. And you'll see Docker here is usually the runtime that's running inside different Kubernetes and containers environments out there. And then we've obviously have the typical applications, binaries, libraries, if you're talking about Windows or Linux. And so that's one of the biggest differences is the operating system is basically stripped out of a container. It's just the application itself. So think of it, I'm an old Windows guy. Traditionally, you'd have to spin up Windows. You'd have to spin up Internet Information Services in order to fire up a web server. And then if you wanted to have a web app, you would run it on top of IIS in order to do whatever web application you're building out. Well, it turns out when you come to a container, the whole operating system, you don't need to worry about that anymore. You don't need to keeping that patched up. That's typically someone else's job, like an operations team that's taking care of that. You just need to worry about the application layer. And so that piece of it is where the big difference is for containers. So now I'll zip over quickly to this is going to be a very complicated slide. So I've kind of split it out. This is the things we're used to seeing in here. We'll see on the left-hand side we've got Virtual Center server. It's our orchestration, our management layer, and then underneath there is the Virtual Center database that keeps track of everything and makes the UI work ultimately. And then we interact with that through different management APIs, Power CLI if anyone's out there, or you can write your own PowerShell code itself and then use native REST APIs to call into Virtual Center to do things. And then continuing to move over to the right, we've got at the top, we've got the network layer. If you're just looking at an on-premises data center, you're typically going to be running something like NSXV. I'll talk about NSXT shortly. And then you've got different security and storage systems in there. And then inside the cluster itself, we've got the physical hardware, we've got the different ESX hosts, and then behind those ESX hosts are the data stores, the RDMs, if you're still using RDMs. And then on top of there are VMs, and then VMs, depending on what it is you're doing, if anyone's using the hands-on labs this week, it turns out you're taking a lab is brought into an individual resource pool or a vApp, and those VMs are all collected together, and I'll show you quickly how that relates to containers here. Then from there, you've got your vSphere cluster. You've got your HA, your DRS for stuff moving around and make sure your virtual machines and the apps in there are continually running all the time. And so that helps you kind of understand and kind of level set what it is we all know and utilize today. Well, when it comes to containers and Kubernetes, you've got on the left-hand side, you've got the Kubernetes master. So think of the Kubernetes master as your virtual center server. And obviously underneath the Kubernetes master, you've got this process called etcd. etcd is really what is utilized to have all if you're going to have multiple masters, communicate with one another, and they'll communicate through the etcd service. And typically you're seeing, it's showing here, I didn't show the little guys that are on here, you typically have an operations person or a virtual admin that's utilizing this. Traditionally in the Kubernetes space, it's been DevOps. The folks who are traditionally writing applications are the ones that are utilizing containers the most. But as you've seen of this, repeating myself once again, so over the last 2 days, that's going to bleed more and more into our world as virtual admins. So we're going to need to start working more closely with the application and DevOps folks out there. And then continuing to move to the right, I'll start talking about the Kubernetes nodes, the Kubernetes cluster itself. So the Kubernetes cluster is equivalent to the vSphere cluster. That's where all the HA and DRS processes are taking. They're not really called that inside the Kubernetes environment or containers infrastructure today. And then you've got pods. Pods are then broken up into namespace. It's kind of how you take a group of containers and you group them together so that you can bring up an individual application. So if you wanted to take, going back to my earlier example about running Windows, IIS, and then a web app running on top of there. Well, in the container world, what you would have, as we saw in the earlier slide, we have the operating system, so we don't need to worry about that. It's all taken care of. But then we need to move up a level at the web server. So now we'd have an individual web server container, and if it turned out that I started getting over capacity on those individual web servers that are spun up as containers that can't handle the load, I can easily just spin up more web server containers. That's independent of my application. So now then, at that point, my application is set up such that it'll run on top of all those web servers and scale it out. So I can scale out independently across the infrastructure. So that's really where containers really have a big difference. And then you'll see I've got the nodes that are equivalent to the ESX host, and then storage is kind of a mishmash right now behind containers. So this is my little summary of the cheat sheet of different technologies that we're all aware of. We've got Virtual Center Server, which is our Kubernetes master. We've got our ESX host, which is our sometimes referred to as an infrastructure node, but typically you're going to hear it referred to as just a node or a Kubernetes node. Then you'll have a resource pool. That could be a pod or a namespace when it comes into the containers world. Then we've got our HRDR cluster. That's a Kubernetes cluster. We've got the virtual machines where all of our applications run today. That's a container in the new world going forward. And then something I didn't mention, we've got templates. So when you create a template, which is utilized in the resources or building for the HLLs, you then spin those up. They sit on there, and that's what gets spun up into a container inside your environment. So with that, I'll end there. And I appreciate you guys all coming to hang out. If you have any questions, here my information's on the screen. I'm active on Twitter, and you can email me directly. So.
Hi, welcome to Dell EMC Data Protection for Service Providers. My name is Colin DeRoche. I'm a product manager in our data protection division. And among other things, I focus on service provider solutions as of about a year and a half ago. So today I'm going to talk about two solutions that we've introduced to market for backup as a service. But before I do that, I'm just going to give a light bit of context. So, what we're seeing is that increasingly our customers are outsourcing their IT, right? In a couple of years, more than 50% of IT is going to be delivered as a service through service providers. And those service providers really need value-added services, both to differentiate themselves against the hyperscalers, but also they need value-added services to turn on new revenue streams that are going to bring them, a decent amount of margin. And in order to do that, they need trusted partners, partners who have both, good technology as well as good sales capabilities. And I would submit to you that Dell EMC is that partner for a lot of service providers and can be that partner for a lot more. So the two solutions that I'm going to talk about today are our vCloud data protection solution that we introduced or launched at this show last year. And then Dell EMC Backup as a Service, which is a new one. I'm just going to briefly talk about it, give you a sneak preview. We're actually going to be formally launching it a little bit later this year. Both of these solutions are sold through VMware's vCloud Provider Program. Are there any VCPP partners in the audience here? No, nobody is? So VCPP is the program through which VMware sells software and services to their service provider partners. And one of the really great things about it is that all of the software and services are sold on a consumption-based basis, which means that we price our offering on a dollars per instance per month basis, taking out virtually all of the risk, right? As a service provider, you can introduce one of these solutions to your customers without putting any money up front. You do need a little bit of infrastructure on the back end, but there's no money spent up front on the solutions themselves. Both of these solutions are going to give you unlimited scalability. So if there are service providers out there with 20,000, 30,000, 50,000 instances that they need to protect, not a problem at all for either of these solutions. Of course, most service providers are a little bit below that. And vCloud Director Data Protection is an ideal solution for service providers who have standardized on vCloud Director as their cloud management platform. Anybody here standardized on vCloud Director or have services? Yeah, one in the back. Nobody else? Okay. So Dell EMC Backup as a service, which we're introducing later this year, is really for everything else. It's able to back up VMware workloads that are outside of vCloud Director, Hyper-V, application consistency for various databases, as well as DTLT or laptop desktop backup. So it gives you as a service provider the opportunity to address a lot of different scenarios, a lot of different markets, perhaps create a segmented set of offerings for your customers based on this one service from Dell EMC. Now, both of these solutions are based on Avamar and Data Domain. And I'm not going to spend a ton of time on this slide, but what I do want to get across is that a key competitive advantage of Avamar and Data Domain is performance and efficiency. So we've got tens of thousands of systems out there that are calling home every day with telemetry to enable proactive support. And through that telemetry, we're able to see what is the average dedupe rate that our customers are getting. And this, covering service providers as well as enterprise customers, smaller customers. The average over all of those is 55 to 1 dedupe. And that dedupe is not, it's not something that any of our competitors can touch. And from that excellent dedupe rate, we get a number of other performance advantages. So we're able to back up workloads in a backup window that's half as long and using less bandwidth than the competition. So these are advantages that go directly to your bottom line because you need less storage, less network, and you're at the same time able to offer a higher level of service to your customers because the backups are going to happen that much faster. Adding to that, and this is specific to these two solutions that I'm talking about, they are scale-out solutions. So although a single Avamar might top out at 5,000 VMs, these solutions make it seamless to have multiple Avamars, multiple data domains in the same location, in different locations, replicating to each other. It's all seamless, so you can scale out. And if the scale that you have is too big for a single Avamar, you can have 10 Avamars or 10 data domains. So to summarize, before I move to a demo, these solutions are powerful, simple, and seamless. Powerful because of the performance advantages I just talked about. Simple because as a service provider, you don't have to think too much about deploying these solutions. I mean, there's literally no risk to you. You can do it, try it out. If it works, awesome. We expect it will. If it doesn't work in your market, well, turn it off. It hasn't cost you anything. And they're seamless. So our vCloud Director solution actually extends vCloud Director itself. So it extends the UI, it extends the REST API, making the end customer experience really seamless. And to find out more about Dell EMC Backup as a service and how that's seamless, you'll have to either wait a few months or ask us for a meeting and we can take you through it. We can support POCs at this point of that solution. We just haven't made it generally available yet. So with that, I'm going to show you a demo of the tenant experience for our vCloud Director solution. Assuming I can remember the password. All right. Okay. So for both of these solutions, they're accessed through the web in terms of administration. And you see here that I'm logging in as vCorp admin. So vCorp is a Play customer that we've set up in this demo environment. And I'm logging into the vCloud Director tenant UI. I'm not logging into a Dell EMC product here. And when a tenant has been enabled for data protection, they will see data protection in the hamburger menu here. So they'll be able to go up there. And the first screen that's going to come up, it's a tabbed interface. The first screen that comes up is a dashboard that's going to tell you what your protection stance is, how many VMs you have, how many vApps, how many of those are protected and by which policies, and how are you doing against your various quotas. You can do that. You can select different virtual data centers. And that's the first tab. The second tab is going to give you a listing of all of your vApps, again, that are running in one particular virtual data center or another. For each one of those, you can access an action menu where basically it's going to lead you through the basic things that you can do. So you can manage which policy is going to back this thing up. You can do an ad hoc backup, or you can show the backups, which is going to allow you to access the restore functionality from any one of those backups. Up here, you can select from protectable vApps, which are the ones that are currently running, and restorable vApps, which are the ones that might have been deleted in the past, but you still have retention for those backups, and so you can still restore from those. And for those restorable backups, we see that you have fewer options. All you can do is restore. Obviously, you can't back them up anymore because they're not running. There's a policy tab where you can access details of your policies. Again, you're going to see how are you doing against quotas on that policy, what does the policy do, what does it mean in terms of retention, schedule, etc. What are the vApps and the VMs that are protected by that policy? As you can see, I think the theme here is that it's a very simple user experience. I mean, your users, it's almost self-explanatory, right? They're going to log into this and they'll immediately find their way around and know how to use it. There's nothing super complicated because it is delivered as a service. There's no real management to do. It's just you have policies that have been published to your catalog, go and use them, right? Attach them to vApps, start backing up. That's it. And then the last tab up here is the monitor tab. This is where you're going to see backups that are in progress, backups that have been successful or that have failed. You'll be able to, if they have failed, you'll be able to click on them and access additional details. But you'll get a view of what have been the backups in the last period. And so that's just what I wanted to show you again to get across how simple it is and give you sort of awareness of these two backup as a service solutions that we have either now or coming very, very soon. So I don't know how much time I've got left, but I'll stick around for any questions if anybody has any. Thank you.
Hello, everyone. Oh, sorry. My name is Anderson Dubach. I'm a cloud management engineer from Brazil. So hope you guys find time to go to Brazil. I know the Amazon rainforest is burning right now, but it's a nice place. We have other stuff going down there. So we're here to talk about Kubernetes observability and fundamentals about monitoring, tracing, and stuff like that. So let's get started. So fill out the survey, whatever. So we all see Lion. Lion has power, has a voice. So the developer is the same thing, right? They can be influential. They are not the decision maker, but they can influences, and they want speed. They want to be able to deliver, to consume, and to see things fast and the most fastest way possible, right? So we are down to the conversation about monoliths and microservices. So a monolith is an application that puts all its functionality into a single process. And a microservices architecture puts each element of functionality into a separate service. So when you have to scale a monolith, you have to scale everything. And when you have to scale a service, a microservice, you just have to scale that service. So looking at my monolith application here, I have a search, deliver, payment, inventory module, right? So if I need to persist data, I have a database. So if I need to scale that monolith, I need to replicate everything. Like if I need to scale my big rock, I need to scale, I have to have 2 big rocks of that, right? So let's break my monolith and see how things go from there. So my microservices are here. I start building out. That's a container now. That's another container. There's another container. And now they are talking on the network, right? And if they talk on the network, they have an IP. But before that, they may own data too. What is that? Because everything was persisting on the database, but maybe some service needs to persist data too. And now they have a database. And now, as they have an IP, they can receive connections too. So I can interact directly to them. So when I have a bunch of those, there's a network of service. That's a challenge, right? Because now I have more places to look, more infrastructure to cover. So that's a challenge. So microservices is distributed computing at all. I have a service that talks to another service on the network. That's it. And there are some fallacies on the distributed computing. So the network is reliable. Yeah, always reliable. So latency is 0, right? So bandwidth is infinite. So topology does not ever change ever, right? So there's one administrator for everything. Transport cost is 0, and the network is homogeneous. So when I have something like this, and I have a failure, so what happens? I have more stuff failing. So I need to monitor. So my microservice may look something like this. So I have a switch that I flick it and nothing happens, and I flick another one and I don't know, 3 lights go on, and that's my microservices. So Google has a really nice book about site reliability engineering that has an awesome chapter about monitoring and talks about 4 signals, the golden signals. So whenever you have a team taking care of a service, you have to think about their lives, because they don't want to be on call all the time, right? So when I want to call my team to act on something, I want to leverage those 4 golden signals. That is latency, right? Traffic, errors, and saturation. So easy, right? But why monitoring? So detect and prevent outage, easy, right? Everybody knows that. Entry price for chaos engineering. If I want to do chaos engineering, I need to be well aware of that. So auto scaling, now we're talking Kubernetes. How do I do HPA? So HPA, horizontal pod out scaling. How do I do pod out scaling using external metrics to Kubernetes and optimize costs and performance? So I have 3 pillars in observability. I have metrics, tracing, and logs. So what is metrics? Metrics are data combined from measuring events. That's it. Tracing are recorded events with casual ordering. So we have an order when you're looking at tracing. And logging is recording events, right? So there are different levels of monitoring and different approaches to that. So an infrastructure level, what I have, an application level. And I use use to do infrastructure level and red to do application level. And I'm gonna go deep on that. Infrastructure monitoring. So a use method is very easy. For every resource that you have, check utilization, saturation, the errors. That's it. So when we are doing infrastructure monitor, I use the use method, and that's it. If I'm doing application monitoring, I use the red method. What is that? For every resource, for every service, check request rate, error rate, and request duration. And that's when you introduce something like the service level objective of that. So I'm gonna go that. But what you monitor? Request time, rate. If it is fast, it works. Yeah, you have to be kept monitoring that. So connections, health check, database, pods, Kubernetes pods. I don't know who is using Kubernetes here. Nobody? Oh, so yeah, in production. Yeah, no, I'm joking. So there's a thing called crash loop backoff. Yeah, if you start using, you're gonna see it. Don't worry. So Kubernetes internal, it has so much components that we have to look up. Control plane, the kubelet, and infrastructure. That's the basic that we always do. Disk space, CPU, RAM, and saturation of network. So what is an SLE, SLO, SLA? SLE is service level indicator. So X should be true, right? A service level objective is that Y is a proportion of the time. So I want that to be how percentage of most of my time. So a service level agreement is something like or else, yeah. So when we look something like this, we can use Wavefront to be the first pane of glass for all metrics by all teams. Analytics, anomaly detections, dashboard, logs and metrics. So we can go microservice, application telemetry, container monitoring, infrastructure telemetry, custom telemetry, and public and private cloud. So we can use Wavefront for something like that. So that's it. It was a quick session, right? You guys have any questions? No? Yep. Thank you.
Well, welcome. My name is Ian Breitner. I'm part of Dell Technologies. I actually belong to the storage solutions team in Dell Tech. And I want to talk a little bit about what's going on with data center consolidation and the need for edge clouds, or edge computing if you like to think about it that way. So first thing is, what is the edge? Is it something like this? I don't think so. I think of the edge as the place where we're interacting with the digital world. And there actually is a definition about what edge is about. And it is the physical location where you interact with the networked digital world. And it's important that it be networked as well as digital. So one of the things that companies have done in order to support their employees, their contractors, their customers, is set up data centers, and these data centers proliferate around the world. They put them where they make sense for what that company's needs are. And they just multiply. There may be large ones, there may be small ones. They might actually just be a server in a closet in the back of an office, but it's still a data center. Some are unmanaged, some are fully managed. As processing power got more and more powerful, and as networks became more reliable and had higher bandwidth, all of these data centers started to consolidate down to a smaller number of much, much larger data centers. These data centers have enormous compute capacity, they have storage, they've got networking. The challenge then comes is that as people started to consolidate the data centers, these remote locations where users were actually consuming resources no longer have anything there. They're actually moved over into the data center. Now that may or may not be a problem, and we'll talk about that as we go through. And at about the same time this data center consolidation activity occurred, we ended up with public clouds coming along. And we ended up with hyperscalers like AWS and Azure and Google and so on. And they built out data centers in various locations as well. Their ones were intended to service their customers that wanted to consume compute on demand and pay for it as they consumed it. Distinctly different from the way things are consumed in a data center, but it's the same idea. Now, one thing that happened with these hyperscaler clouds is that they centralize what goes on, they standardize on the equipment, and they automate everything. That's the power that comes from these cloud vendors. You can apply the same principles to the data center, and if you actually wander around the expo show floor here, you'll find people that are talking about doing exactly that. But let's get back to where we started. We're talking about the edge. And most people, when they think of the edge, they think about my laptop, my cell phone, I'm in a Starbucks or a coffee house, or I'm wandering around somewhere, I need to access compute resources. I'm going to stop here a minute and simply go and look at, well, VMware has a vision of what's going to happen in the future, and that is any device running any application on any cloud. And then what I want to focus on is these tiny little clouds just here. They're edge clouds. And even though they're tagged as very small, they're actually very important, and they're going to be growing bigger and bigger and bigger as time goes by. So when people think about, well, what's it look like if I actually have an edge cloud or an edge data center, it looks something like this, is what people think of. Well, that's all well and good, but these things don't scale all over the place they need to be, nor do the hyperscaler clouds. They're not everywhere that you necessarily need them. They're in important locations, but not everywhere they are needed. So back to the definition. Physical location where things and people interact with the network digital world. Well, there's one important word here, things. And that's the thing that's changing, or that's what's going to be changing what people think about with edge clouds and edge computing. And it's the Internet of Things. We have these proliferation of devices. They're very small. They're all over the place. They could be security cameras. They might be the security system for your house that allows you to open and close the door remotely. It might be sensors in your car that's telling your service center that, hey, this car's going to need to come in. You better figure out some way to let the owner know. We end up with all of these different devices floating around. And these devices need to be serviced in some way, shape or form. And if you actually look at what the analysts are saying, they're saying with the Internet of Things coming along, you need to move the compute closer to where these devices are, where these things can be delivered, where they can deliver the value to the end users involved. Now, the example I keep on thinking of, you can actually put remote small compute platforms out where you need them, but they don't necessarily have the power and the storage required for what's going on. And if you actually have self-driving cars, you have to make a decision in milliseconds if something occurs. If something untoward hops in front of the car, I don't know what it is, a deer, a person, a telegraph pole, you need to make a decision within milliseconds about what to do. Put the brakes on, stop. When someone's walking at a front door and you want to unlock the door, well, milliseconds don't matter so much. Seconds probably matter in that case. So it varies from case to case. But the point here is that you need to have access to those compute resources to make the decisions that need to be done to actually make a change in what's going on. Some need to happen very, very quickly. Some can take a little longer. The quicker you need to make the decision, the more compute power you need to have available locally to deal with that. And that's where we get to this new paradigm of what does an architecture look like when we actually have to worry about edge computing. So we end up with, we still have our clouds, we still have our data centers, they're still providing service that's needed, but then out at the edge, out where these devices are located or very close to those devices, you actually need to have a different architecture, a compute platform, some storage, networking in order to deliver what needs to be done for those remote devices that need to take action at that time. Some of these things can be a little later in the time frame, but they have to be done. And these devices, they're not just a couple of them, they're not hundreds, they're not thousands, they're not even tens of thousands, they're millions of these devices out there. And this environment is growing rapidly day by day. The estimates right now are that 44 zettabytes of data will be produced by 2020. So we're like 4 months away. There's going to be 44 zettabytes of data. We're producing data at the rate of 1.7 megabytes per person per second. It's huge amounts of data that are coming in. You hear this from all around, but where's it coming from? Why is it coming? It's coming because we've got all of these little devices that are actually generating signals back to somewhere saying everything's okay or everything's not okay. And it's not just collecting the data sets that are coming in there. The frequency at which these data items arrive can also matter. So you may actually look at a jet engine, for example. It's always pinging back to home base, which is usually somewhere in the airline's main base. Doesn't matter where the aircraft is in the world. It's pinging back. It's saying everything's okay, everything's okay. But there's multiple sensors in a jet engine. There's probably something like 2,000 in a jet engine, always coming back every second with some sort of information. If you need to take action on that, you need to actually be able to get back to the pilot of the plane saying, oh, something unusual occurred. But after that's been taken care of, the maintenance people want to say, well, hang on, what exactly happened there? I know what broke. I know what we did to fix it. But was there something there that would help me figure out why it broke? And that's when you look at the frequency at which these data sets arrive, you can actually look at it and say, oh, it started to come in more and more frequent for this particular device. That's a trigger point to say there's a failure occurring, perhaps. But the whole idea here is that it's not only collecting the data sets and taking action, it's also preserving those for other analysis. And that's why the connection back to the cloud and the data center is also important. So what I see moving forward is data centers still in place, cloud vendors having cloud things available for people to consume. But what about if I want to do something that isn't handled by my large data centers or by the clouds that I choose. So I've got two examples I want to talk about, and because I'm from Dell, I want to talk about Dell stuff. So the first one here is I can actually run a software-defined storage platform in the cloud. In this particular instance, it's being used to support virtual desktops, where people need to actually have access to either corporate data that's back in the data center, or they're generating new data that also needs to be put back into the data center for preservation. So what we have here is a software-defined storage platform running in VMC on AWS, talking back to the data center. It's a bidirectional transfer, making sure that the data that people need is available for them to use. And the last part is that not all the data needs to be accessed all the time. So I can actually tier the less used data off to something like an S3 bucket. It can be brought back when needed, but it's there where the users are located, where they can actually consume it. And then the last thing about this is, so what if I don't have a cloud provider's point of presence anywhere nearby? What can I do? Well, I could actually go deploy my own private cloud in that location. And that allows me to actually get the benefits of cloud, produce edge computing out near where it needs to be, consumed by those devices that need to consume it. And I can grow this thing if I need to, if there's insufficient resources. And so what I see the future coming along is this mixture of data centers, cloud locations, and these private clouds being deployed for consumption by these Internet of Things devices and the people that are actually making use of the results from that. So I'm at time. If you are interested in any more information about this, drop by booth 1027, where you can actually talk to people about this. And I will be around. Actually, I won't be around because I actually have to go to another session in a few minutes, but I can actually take questions offline before I go. Thank you very much.
Hello, everyone. How's everyone doing this morning? My name is Gabe Mentz, and I'm going to talk to you a little bit about upping your automation game with VMware's vRealize and HashiCorp's Terraform. So a little bit about me. I live in Pittsburgh, Pennsylvania. Go Steelers. I tweet at gmentz, and both a vExpert and a certified Terraform expert, I guess. But probably the most proud thing I am of this slide is a founder of the vBrisket community. For those who aren't aware of vBrisket, that is a fusion of smoked meats, craft beers, and technology. So come talk to me afterwards. We can trade barbecue stories if you like. What we're going to be focusing on today is on two technology products in particular. One is VMware's vRealize automation, and the second is made by a company called HashiCorp called Terraform. But before we go into the technologies, let me tell you a little bit about my cloud provider. There's my cloud. Actually, my co-presenter, Tim Borland, is not able to be with us today, but this is running in his basement, believe it or not. It's a 3-node vSAN cluster running on some old Dell 420s, about a half a terabyte worth of memory, tons of flash, and tons of capacity. And he doesn't even send me a bill. So this is fantastic. You can follow Tim on Twitter if you'd like, or maybe you might see him later on in the conference. But everything that we're going to be showing you today is actually happening down in Tim's basement over in the Pittsburgh area. So Tim provides me access to his environment through a couple of self-service provisioning tools. The first one that he provides me is through VMware's vRealize automation in the form of a blueprint. So those who aren't familiar with vRealize automation, it presents a nice UI format for your users to be able to go ahead and provision a blueprint in your VMware environment. So let's take a quick look at what that is. I've got a couple of videos here on what that might look like. So this is the VMware VRA login. So I'm going to connect to Tim's network there. If you can see that on the screen, I'm going to go ahead and log in, and I'm going to be presented to a stack of different things that I can provision within Tim's environment. The stack that I chose is a simple Windows VM and Linux VM, both connected with NSXT. And I'm going to give these virtual machines a little bit of memory and a little bit of compute. And I'm going to hit the go button, And through the power of speed here, let's go 30x here. I can take a, say, 10-minute provisioning job here and really kind of crunch on it. And what I have at the end of that is, once it completes, look, see how that goes fast? Boom, 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 boom. And at the end of that, I have a couple of virtual machines that I can log into, one Linux and one Windows. So for those who aren't familiar with VRA, it's a really nice way to present to your users a set of kind of defined blueprints. But being kind of the geek that I am, I like to operate in what's known as infrastructure as code. So rather than always having to go to a UI for me to be able to go and provision resources that I'd like, I'd rather just be able to pull up some configuration, update some configuration, and then do a deployment. And the tool that I'm going to use to do that is called Terraform. So Terraform is an open source tool. It's created and maintained by a company here in San Francisco called HashiCorp. It is a series of configuration items which allow you to create, maintain, and provision your infrastructure. And because it's done within kind of a configuration mindset, it falls into this infrastructure as code category, right? So what the beauty of Terraform is that I can go to anything that's a modern day API technology stack and provision resources by simply just writing some configuration items. And Terraform is widely popular because of all of the providers that have written, all the companies that have written providers for them. So there's over 250 plus providers. In fact, if you can go to Terraform.io, and I'm scrolling through all of the different Terraform providers here, more than likely these are things that are running in your clouds or in your data centers. And if I scroll all the way to the bottom, yes, VMware has written some providers for me. And it happens to be some, like there's a vSphere provider, a vCloud Director, but the one that I'm going to focus on today is VRA. And it's very simple. This is a very common example of how you can just put together a small stanza worth of code and be able to provision, maintain, and update your infrastructure. So in this case, I'm going to use VRA. Here's the code that I'm going to use. Pivot over to my Terraform video here. And so what you can see, if my zoom works here, I don't know if it will or not. Okay. I hope that's okay for you to see, but I'm just going to go ahead and create this provider. Ignore the password here. I actually changed that after I recorded the video. But it's going to provision a Linux and a Windows virtual machine. I'm going to call that same blueprint within VRA, but I'm going to go ahead and give it what my CPU and memory parameters are there. And the way Terraform kind of works in terms of a workflow is that you issue, it's a single binary that you download. It works on Windows or Linux or whatever your favorite place to run a binary is. And you initiate this, you write your little stanza of code, and then you run what's called a Terraform init. And that initializes Terraform to download all the providers that it needs so that it can actually go do something meaningful. And then you issue what's called a Terraform plan. And Terraform plan says, okay, I'm going to go out to your environment, I'm going to see what's out there already, and check to see what I need to change based on the configuration you gave me. And perhaps there's nothing out there already, so I'm going to go ahead and build this kind of from scratch. And then once you have a plan in place, then you can apply it. So that's really the kind of the workflow of Terraform. Write the configuration, initialize it, plan it, make sure your plan looks good, and then perform and apply. So let's go ahead and do that in Tim's basement. I'm using VS Code here, and I'm just initializing a Terraform init. So that's going to go down and load that VRA provider or any providers that I've created in my configuration. There's ones for AWS and Azure and F5 and VMware and whatever providers I want to use. And then once I'm done with initializing it, I'm going to go ahead and run my plan. And so that's just a simple Terraform plan. And what that's going to go do is go out to my VRA environment and it's going to check to see if there's anything already been deployed. So it's going to go out to that RPT stack blueprint and it's going to say, hey, Gabe, you're going to go ahead and run this stack. You're going to build a Linux VM, you're going to build a Windows VM, and these are the specifications that you've highlighted within your configuration. This is what I'm going to actually do. So once I like the plan, I can issue what's called a Terraform apply. And what that'll do is it'll go plan that information out, make sure that I answer yes to go do that work, and as soon as I hit yes, it will go ahead and actually go provision my stack. And we'll go provision the resources that I specified within that configuration. So that takes a little bit of time here. Let's, for those who aren't real comfortable on the CLI, I will pivot over to the UI real quick just to make sure it is actually working. So I'm going to go back into my deployments within VRA, and you can see now that I have initiated a deployment. But I haven't ever logged into VRA in that case. I've just simply gone into Terraform. I've initialized, planned, and applied, and I never had to go into the UI at all within VRA. Very, very popular way to do things, especially if you're writing Terraform for like CI/CD pipelines or automation pipelines where you don't want to have to manually go into a UI. Very, very common for SREs and developers to just simply work from a CLI, go ahead and initiate and get that feedback. So in this case, I'm going to go ahead with the speed of time here. Once my stack builds, whoop, almost there. And what you can see is now it output to me, here's your virtual machine name for your Windows VM, your Linux VM, and here's how many resources you gave to it, right? So I never had to actually log into the UI except for my little sanity check to make sure things were working. And I could initiate and provision my infrastructure all right there from within Terraform. But say they come back to me and they say, Gabe, you really under-provisioned this virtual machine. How can I go ahead and make that change? So what I'm going to go ahead and do is simply just go right through the same workflow. I'm going to bump up my memory from a gig worth of memory on my Linux VM, and I'm going to double it. I'm going to give it 2 gigs. Before I do that, I'll just make sure everything worked correctly. I'm going to go back into the code. I'm speaking faster than my video. And I'm just going to simply edit one line. So line 14, I'm going to change the Linux memory from 1 gig to 2 gig. I'm going to save that. I'm going to commit that potentially into my repo. And then that's going to go ahead and I'm going to go through the normal Terraform workflow. Init, plan, apply. And now what this will do is because I've already got infrastructure that's been provisioned out there, Terraform is actually smart enough to say, hey, I don't need to redeploy the entire stack. All you made a change was some memory on a particular virtual machine. And so what the plan is coming back to me to show is that I just have to change this particular piece. All right? So because Terraform maintains state, it knows that. So then once I'm happy with the plan, I just simply go and apply that. Issue a Terraform apply. It'll go through and say, are these the changes you want to make? I'm going to answer yes to that. And then it's going to go in and it's going to go ahead and reconfigure my virtual machine. I can actually see that working here within the environment. One of the nice things about VRA is you can go back on the audit trail on this and actually see exactly what changed and what got re-provisioned. So once my apply is complete, I'll give it here 30 seconds. Question? Absolutely. So Terraform is very, very popular because scaling out and scaling in is really just a matter of changing some configuration. In fact, one thing I'm not going to show here is what's called a Terraform destroy. So if you're just building like some infrastructure quickly to do a test, you can destroy the environment. Now use caution because destroy does destroy. as easily as you can initialize, plan, and apply. Yeah, very common practice is to actually provision this infrastructure quickly, run your tests, do what you need to do, and then initiate a destroy to clean up after itself. So now I can see that my reconfigure actually worked, and everything, whether I'm using the UI or whether I'm using Terraform, I can now go ahead and I have complete control over my infrastructure. All right, and Tim never had to give me vCenter rights for this. He never had to give me, all he needed to provision was my blueprints and give me the ability to connect into, to utilize via Terraform. So let me just go ahead. Example of this I thought was pretty interesting. It's kind of crazy, but it really hits home about how powerful Terraform is. So let me read this. Has this ever happened to you? You're provisioning your cloud infrastructure using Terraform, and you think to yourself, man, I could really go for a pizza, but I absolutely refuse to open a web browser. Well, have I got a solution for you? Somebody wrote a provider for Domino's Pizza. Yes, Domino's Pizza's website is an API-driven website. Somebody abstracted that by writing a Terraform provider for that, and you can actually order a pizza by issuing a Terraform apply. All right? And what that showcases is that as we're going and growing and having more native API kind of pieces, we can utilize tools like Terraform to abstract those calls, really just write a simple configuration language to go and actually execute a body of work. There's a ton of information out here, both on-site this week at VMworld. Here's a couple of topics that I've talked on previous vBrownBag with not only Terraform, but a number of the HashiCorp products. I also showcased a little bit about VMware's or HashiCorp's Vault for secret management. So go check those out. If you do a Terraform, if you do a search on Terraform inside the session catalog for this show, here's all the different people talking about Terraform and how it integrates within their VMware environment. All right, some of these were recorded yesterday, but go, when you get back home, either go in person to see these or go check out the recording. And yes, all of this stuff I do actively blog about and write about on my piece. So if you are not a coder and you're more like a Google copy paste kind of person, that's okay. You can copy and paste the stuff off of my blog. I give you permission to do that. All right. Do you have a question here? Yeah, so that's absolutely correct. Yeah, this is all based on the access level. It honors the access level that I logged into. You saw in the provider the authentication that I had to provide. So I can't go destroy Tim's environment because he hasn't given me rights to do that. But yeah, absolutely, you can make use of the actions within the UI of VRA within the Terraform component as well. And that's it. Question? The Explorer window to showcase the code. It's called Microsoft's VS Code. It's a, let me find it here. Where, is this what you're talking about, sir? Yeah, so go out. It's a great editor. I love it. It's VS Code. Oh, and I'm done. VS Code. Thank you.
Boom. All right. Oh my God, guys, make sure that you find space for everyone here. You can come to the center. I'm joking. Cool. Welcome, welcome. All right, guys. So today I'm going to be talking about self-support. I'm actually going to walk around. Is that okay? I hope it's okay. Our community is as a self-support platform. So first of all, thank you. My name is Ed. I joined VMware a few months ago, and I'm actually part of the global support team, and what we offer, it's part of the supportability programs that we have at VMware. And you may be asking, so why is this dude talking about, communities and support altogether? So what I wanted to show you guys is a little bit of what's happening to the world of support. So that's a typical user journey. What happens is you have a feature discovery, something that you found out. So Pat just explained about Pacific, and you're like, wait, that's great. I'm gonna search a lot about it and start utilizing it. So you learn, you get happy, and then at some point you start to find some issues, or it's not that easy or that simple to deploy. And then you run into maybe some moment where something breaks, and you're like, oh shit. I don't know if I can curse, but sorry. And then you go and start ranting, and then you may go to social media, you may ask friends, and then you get to a point where you may get support from us in a few days or months, God knows. And then you're like, yay, this is great, I finally got my issue fixed. And then you have a happy ending, or a great end, should I say. So this is a traditional support, but the problem is we fail in many points down there because we don't know your journey. We don't know what's happening to you, what your expectations and learnings. And our support operation is pretty broken actually, because that's very traditional. That's how support works right now. You have an issue, you open an SR or a ticket, someone from our team is going to look at that, and God knows in maybe 5-6 days you get a response for that. So why is it broken? Because you have many people asking about the same question all the time. And then that single agent has to reply to all these questions. So what happens is, first, you cannot really size the silent majority because people may be concerned or looking for help elsewhere. The second thing is you always depend on the agent to get help, right? But we have an opportunity here because right now, if you look at the number, and this is proportionally the number of requests we receive in support, there's a big chunk of questions that are all based in troubleshooting, how-to questions, or product feedback. And this is what you guys all know about. Like, this is what you guys do every single day. You know the products inside out, you know so much about it. So there's an opportunity here for us to utilize this expertise that you guys have to produce this help to other users. I'll give you like a really basic example. If you need to go to the restaurant here, you can ask pretty much anyone here. You don't need to ask staff members because everyone here knows that. It's a very basic question. Imagine if you had to wait for a staff member every single time you had to get a question that's very basic. So how does that reflect our support? So let's think about peer-to-peer support. So you have an issue, and then that issue could be a thread, could be a tweet, could be a post, and then you can get people to start helping out in that single question. You don't need to be going to an agent. And then if you actually do that more and more, what you're going to realize is that there might be one person here, one person there, who is very knowledgeable about certain topics, and that's when you discover your experts, right? So most of you will know, like, you have the V-experts, you have groups, and you have areas of expertise you guys have in your field. So we can utilize that as our support operation now, because then we can build a peer-to-peer support. So think about a normal support journey that one we're talking about initially. So what if we translate into a normal support journey right now? First thing you do if you have an issue is you're gonna Google it. You may ask someone that you know, someone you find an expert in the area, or you go on social media. And when you Google, what happens is best SEO is gonna win. So it's not necessarily the best answer, it's the best SEO. You get some solved questions. So you go to Stack Overflow, you may go to the communities, and you find an answer that has been marked as correct, and you trust that. Or you see like a blog article that you guys have produced, you may see a KB, and that's usually what happens as well. If you ask someone that you know, it tends to be more conversational. It's also very honest. They're like, no, this is not gonna work, dude. Do somewhere else. And you can trust that, right? Because you're asking someone that you essentially trust. If you go to social media, you can get opinions, different opinions from new people, people that you don't know. You can get a lot of links like, hey, check this out, check this out, check this out. And it gets really political. So sometimes it's not that nice. So what if we could just combine all of it, right? And you can, because if we combine all of it, we have the communities. That's what you guys do. That's what we all are here for. It's a community of experts, people who know about products and love VMware and the ecosystem. And we can use that for our self-support and engagement. Because essentially, you guys are the source of knowledge. You have much more power and knowledge than we do. So what I'm trying to do now in my role is listen to what you guys have to say, hear your feedback, capture your feedback, learn from that, and empower you with the right tools, the right training models, whatever you need, so you can get inspired and start producing this content. So that's how we want to build this relationship with you guys. And for that, I have like a simple rule of 7 Ps. Not 2, not 3, but 7. If I was back in Ireland where I live, that would be like pint, pub, pissed. But right here, it's different. So it's people, purpose, place, participation, policy, promotion, and performance. What does that mean? People is getting to know you. So who are the guys here? Who is this gang here? What are you guys doing? Why does it exist? Right? What's the purpose? What are you guys trying to achieve? Place, where do you guys hang out? Well, I know that this is VMWorld, but maybe you're hanging out on Reddit. Maybe you have a meetup. Maybe you have something else going on. how do you participate? What do you actually do for participation? What are the rules of conduct? How does that work? What's right, what's wrong? How do we get this to grow? How do we actually help you guys grow and expand from your knowledge and expand from what you have? And essentially, how do we measure this? Because at the end of the day, we're a business, so we need you to say, is this going well or not? How do we measure that? So this is online communities on the support perspective. That's what I want to try and achieve. So I'll leave you guys with my email down here, so you can talk to me at the end. You can send me an email. You can do whatever you want. You can send me links if you want to send links, blog articles. But what I want to do is essentially help you guys be more successful with our communities and help you build the supportability programs. Thank you. That was like a 5-minute pitch, wasn't it?
Hi, welcome to the session. I'm super excited to have you here, and I know, as I just said to the people in the crowd, this is not a session you'd normally go to, especially at a conference like this. And to give you a little background, my name is Joseph Griffiths. I'm a double VCDX, so that should give me technical chops in the room, right? And I'm going to talk about operational debt. And there's a reason I'm talking about operational debt, because for the last 3 years, I stepped away from deep technology and started talking strategy with our Fortune 100 and 500 customers. And from those conversations, it's essentially led me to believe that there is a core problem at many of our customers. And I think you have the same core problem. And there's a pretty simple way to solve it, but we're not making investments into solving that problem. And it really is operational debt. So, you know, I like a little interaction. It's that time of the day. Raise your hand if you have debt. Yeah, there's nobody in the room who doesn't have debt, right? Thank you, appreciate that. Oh, I'm sorry, I should have raised my hand. I got a crap ton of it, right? So we all understand the idea of debt. So when I start to talk about the inside of debt, it's an interesting conversation, right? I want to talk about operational debt. Now, I think everybody throws around the word technical debt often. It's a regular conversation. But I think operational debt is a little bit different than technical debt. So for me, it really comes down to every time you do something, there's a tail of maintaining it. This is where our lean manufacturing process changes. Toyota makes a car, Toyota kicks it out of the factory to a dealer, the dealer sells the car to you, and who maintains the car? The mechanic, not Toyota. In our world, when development finishes their product or their development action and kicks it over the fence, we operate it for 3 to 5 to 10 years. We have to own the end product. So we incur compounding debt for everything that we do. And we're so focused on initial state that we don't solve that problem. So, you know, I like to think about this for people who really run into this problem. So for me, it's a simple story to use Google, because it's a well-published story that you've heard of many times before, right? So Google spent a bunch of time making a software-defined abstracted environment. Everything was software-defined. They used microservices, containers, all that stuff. And they started deploying all their services on this so they could have geoscalability. And they looked at their challenges. And the challenge no longer became, can I provision? Because you could provision 100 million of those, search, right, a minute. The problem was, how do I operate those? And so they started staffing people up, to operate and maintain search. And they realized that they were going to eventually become unprofitable just from the operational cost as they scale up. That it wasn't a linear, but it was a compounding challenge. Because as they start to scale up in different geos, if they start to scale up in different areas, their problem becomes compounding. I need a team there, I need people there, I need professionalism there, I need people who are trained in our unique method of doing everything. And so, you know, they decided that they had to make investments in automating operations, all the day 2 stuff. All of us have heard about SREs before, I assume at this point. That's where the SRE initiative came from, right? 50% of your time automating, while 50% of your time running. So you knew what the real problems were. What you do during the 50% of the time manually, you go automate that 50% of the time. If you think about this, it's really interesting because they projected that they would eventually be unprofitable within 2 years. So they started this initiative. They found out they were unprofitable within 2 months because of the growth model they hit, right? So much needed initiative, solved a lot of problems for them. Now, in a lot of enterprise customers that I deal with, the Fortune 100s, 500s, what I've identified is that most of them haven't actually automated the operations. They've gone a different direction. They go to other countries and hire lower cost people to be tier 1 operators, right? And this is even worse. Why is this worse? because they're going out and getting people who are paid to close tickets. There's not quality in that model, there's not benefit in that model, and there certainly isn't knowledge transference in that model. So there's no way for them to capture the data from that to figure out even what they should automate, because those people change in, change out, and regularly change. They lose all of that institutional knowledge. It's gone. Where the Google model, they were gaining more and more institutional knowledge, because what was happening was those SRAs were starting to tell the product teams, you know what, there's a problem with your API here on the software-defined networking. You got to fix this, because we can't automate fixing this problem right now. They started creating feedback loops that were extremely powerful. So the model that most of the customers I deal with are actually creating more debt. And it's exponential. They grow, the staff grows, right? It just keeps going up and up. So I like to think about the real impact of operational debt. Every single day I meet with CIOs. I've had 2 meetings in the last 2 days with CIOs, and they told me the same thing. You know what I really want? I want agility. Please raise your hand if your boss tells you you want agility. Yeah, there we go. So 50% of the room said they want agility, right? I hate that word. It's totally unmeasurable, totally unknown what it means. But as I've thought about the root cause of this problem with many of my customers, what it really comes down to is they want to be able to have staff that have the time available to pivot and take action, to do things. And what stops them is because they're reacting too much to all the operational problems. They're constantly reacting to everything that comes through. So they become the turtle in the world, right? And because they're the turtle in the world and they're slow, that's the real impact to our agility. If we can get ourselves out of those operational things, we start automating, we start making them go away, then we have the ability to spend the time